Hello guys, welcome to the new course Learn Data Analysis from Scratch. This is the first step towards learning the data science. In this course, we are going to learn various techniques of exploratory data analysis as well as data preparation. So guys, let's look into the topics. What are the topics we are going to cover? But prior to looking into the topics, I want to discuss one of the important question, that is why to learn data analysis. So to answer your question, I would tell that the first and the foremost reason is data analysis skill is one of the high demand skills within the market, and the candidate with data analysis skill gets very good package, and that is because we are having very limited resources available who is having data analysis skill set. So guys, this is the first reason. Second reason, data analysis gives us problem solving skills, as analytics is all about solving problems, and the ability to think in an analytical way and approach towards the problem in a right way is a skill that's always useful, not just in professional world but in everyday life as well. So guys, this is about why to learn data analysis. Now let's look into the topics. What are the topics we are going to cover in this course? So guys, this course is divided into 4 parts. In the first part, we are going to learn about tools for data analysis. In that aspect, we are going to first start with Python refresher, where we will cover all the important topic which is required for data analysis. So we are going to cover what actually the Ipython interpreter is, what is Jupyter Notebook, as we are going to use thoroughly the Jupyter Notebook. We will also discuss about the basic data types which we have already covered in one of my course, that is Learn Coding from Scratch with Python 3. We will also discuss about various collection types, that is list, dictionaries, sets, tuples, as it is required while writing the code for data analysis. We are also going to do the refresher session for function as well as classes and objects. Once we finish the refresher session, then we will proceed further and we will discuss about NumPy library, where we will learn about NumPy core concept that is used within data analysis. So in that aspect, we are going to learn about many concepts within NumPy and we will perform labs as well. So in that aspect, we are going to revisit the arrays concept. We will look into how to handle arrays within NumPy. Then we will also discuss about the NumPy internals, where we will understand that what is dimension, what is shape, what is strides. We will also discuss about the data type and the casting. We will learn about how to do slicing and indexing, where we will learn about indexing, slicing and indexing on 1D array, slicing and indexing on multidimensional array. Next, we will look into arrays operation, where we will understand common operations on array which we generally perform. Then we will also discuss about commonly used function for NumPy arrays. Next, we are going to touch upon the broadcasting concept, which is very important concept within NumPy. So we are going to cover this as well, where we will learn about array broadcasting principle as well as we will also understand the usage of the broadcasting. Once we understand the broadcasting concept, we need to understand what is vectorization. Once we understand the vectorization concept, then we will proceed further and we will look into the pandas library. That is one of the most important libraries for performing data analysis, and pandas library is based upon the NumPy library. So whatever the knowledge we gain over here, the same knowledge is being applied over here as well. So we will start our learning with what actually the pandas is. We will understand what is data frame. We will also look into data frames basic. Next, we will understand how to handle the missing data within pandas library. We will also look into some of the commonly used operations like group by, aggregation, transform. Once we understand these concepts, then we will proceed further and we will discuss about Windows function. That is one of the important function which is generally used to work with time series data set. Once we understand that, then we will proceed further and we will discuss about filter method within pandas. Once we understand that, then we will look into join, merge and concatenate, how we can join different data frame together. So within pandas, we are generally using 3 types of operations to join our data frame, that is join, merge and concatenate. So we are going to discuss all these 3. Once we understand that, then we will discuss about apply method. What is apply method and when to use apply method. Once we understand that, then we will look into some of the data frame reshaping technique, and at last we will discuss about the calculate frequency distribution. Once we done this, then we are done with part 1. Then afterwards, we are going to learn about part 2, where I have discussed about core concept of data analysis, where I have started the discussion with what actually the data is and what actually the data set is. Next, I have also discussed about types of variables, where I have discussed about different type of statistical data type, where we have done the detailed discussion on categorical data type, numerical data type. Once we understand the types of data type, then we have understand why data types are important. Once we understand that, then we have also discussed about how do we collect information for different data types. After understanding this, then we have discussed about descriptive statistic concept. So in that aspect, we have discussed various concepts like what is normal distribution, what is central tendency. We have also covered the concept of measures of variability, variance and standard deviation, Z-score, modality, skewness and kurtosis, and why it is important to understand all these concepts while learning the data analysis. Once you understand this, then this part of the course gets completed, and then we will proceed further and we will look into different types of tools for data visualization. This is covered in the part 3 of this course. And this is very interesting as we are going to learn about various kinds of data visualization technique within Python. So in that aspect, we are going to learn about matplotlib. We will also look into matplotlib architecture. Once we understand that, then we will look into another type of plotting library, that is Seaborn library, that is based upon matplot library itself. Next, we will discuss about parameters of plot whenever we are doing the plot. So what are the parameters which we have to consider for plotting? Once you understand that, then we have discussed various types of plot by their purpose. So basically there are 6 purposes we are using the data visualization. The first purpose we have discussed, the identifying the correlation with the help of data visualization. Then we have also discussed about how to identify deviation with the help of different types of deviation plot. Next, we have discussed about the ranking plot. With the help of ranking plot, we will come to know about ranking within the data set. We will also look into distribution plot to identify the distribution within the given data set. Next, we have also discussed about the composition task. When we want to visualize the composition, then on that time also we are using different type of composition plot. We have also discussed about various types of change plot which will help us to visualize the time series data. So this is about the plot and their types, but if you closely look into these purposes, then you will find there are various type of plots in this course. So I have given example for a scatter plot, where I have written the code how to draw the scatter plot, how to draw the scatter plot with line of best fit, count plots, marginal box plot, parallelogram, pairwise plot. So all these things we have covered in this course. Next, we have discussed about various type of deviation plot. So in that aspect, we have also seen that how to draw diverging bars, how to draw diverging dot plot. Next, we have also looked into the ranking plot, where we have written code for drawing the ordered bar chart. We have also looked into dot plot. After understanding various type of ranking plot, we have also looked into various distribution plots. So in this category, we have learned about histogram for continuous variable, histogram for categorical variable. We have also written the code for density curves with histogram. We learned that how to write the code for data visualization in a step-by-step manner, where I have performed code along walkthrough session. For each of the plot, we have looked into various examples of distribution plot with the help of different data visualization plot. Over here, we have covered box plot, dot box plot, categorical plots. Once we understand that, then we have also looked into various type of composition plot which help us to visualize the composition. So in that aspect, we have seen how to write the code for pie chart, how to write tree map, how to write bar chart, and at last we have also looked into change plot, which is used to plot the time series data. So in that aspect, we have learned about 2 type of plot where we can demonstrate how to draw the trends within the given time series data set. So guys, this session is very in-depth session if you want to learn about data visualization within Python. Once you learn all these things, then part 3 gets over. Then we will proceed further and we will be ready for part 4. That is our end goal. So in the part 4, we are going to utilize all the knowledge which we have gained in part 1 to part 3. So in this part of the course, we are going to learn about exploratory data analysis and data preparation workflow with the project. So first we will understand that what actually the exploratory data analysis is, what is the value of exploratory data analysis is, and then we will discuss about each of the steps within the data exploration and data preparation. So basically we are going to discuss about 7 steps. So these 7 steps generally perform whenever we do the data exploration and data preparation. So the process of data exploration and data preparation starts with the variable identification. So here I have covered various aspects of the variable identification, like how to identify the predictor variable, how to identify the target variable. Once we understand that, then we will proceed further. At step 2 we have discussed about univariate analysis technique. In that aspect we will come to know about how to do analysis on a single variable and what to analyze while performing the univariate analysis. Once we're done with that, then we are having a regressive session on bivariate analysis. In this session we will learn the technique of analyzing two variables together and how to identify the relationship between two variables that we have discussed in details. Once we are comfortable with bivariate analysis, we proceed further. We have discussed about missing values treatment in step 4, where we learned that how to identify the missing value within the given data set and how to handle those missing values within the given data set. And this we have done in the real-time project, that is Boston housing price. Once we understand that, then we have also looked into how to identify the outliers, and we have also discussed about what actually the outliers is and how to do outlier analysis within our given data set. Once we understand that, then we proceed further, and we have also discussed about variable transformation, where we learned about the techniques of variable transformation, when to use, why to use, and what actually the variable transformation is, as well as we have also looked into how to perform the variable transformation, and we have also discussed about the significance of variable transformation in this project. And at last we have also discussed about the variable creation, what actually the variable creation is, why we create the variables, and how we can create the variable. And at last we have also discussed about, once ready with the data analysis, what will happen next. And the best part of this step-by-step learning is we have performed all these things in a real-time data analysis problem that is based on one of the Kaggle competition, and we have used the data set of that particular competition to understand all these concepts. So guys, there are many things I have covered in this course, and this course is very detailed course that will give you first stepping stone towards learning the data science skills. So on this note, I am stopping over here. See you in course. Till then, bye bye. Take care. Hello guys, welcome to the another session. In this session we are going to discuss about prerequisites to learn this interesting topic, that is data analysis. So I am going to tell you about that, what actually the prerequisite required to learn the data analysis. The first and the foremost thing needed to learn the data analysis is your interest. And if you are watching this video, then I am 100% sure that you are interested in this topic. So now let's discuss about the technology which required to learn data analysis. So if you are starting the journey, you must have knowledge about the Python programming. But in case if you are not having any idea about the Python programming, then there is one course which I have created earlier, which is absolutely for the beginners who don't know about the coding. So you can search for this course in my profile and take this course, and after completing this course, then you come back to this data analysis from scratch course. So here you must be asking that why I have opted Python for data analysis course. So to answer your question, I would tell that Python programming language has a strong appeal and it has large community, and along with that Python has become one of the most popular interpreted language since 1991. And if you look into the technology trend, then you will find that in the last 10 years, Python has gone from a bleeding edge scientific computing language to one of the most important language for data science, machine learning, and general software development within the industry. But the major benefit of using Python is that it offers us various libraries for data analysis, as well as it also offers us interactive computing along with the data visualization libraries. So now we will look into one of the diagram that will help us to understand that what we are going to learn in this course majorly. So let's jump into the diagram. So if you closely look into this diagram, then you will find that to do the data analysis within Python, we are going to use majorly NumPy, Pandas, and Matplotlib. NumPy is very important library, and you can say that it is a core of Python programming. And this library helps us to perform maths as well as array related operations very easily. In the upcoming session, we will look into NumPy in detail. For a time being, you just consider that there is something called NumPy which we are going to use for data analysis whenever we want to perform any array as well as metrics related data manipulation task. So now let's proceed further and discuss about pandas. If I will say this, the major portion of this course is mainly related to the pandas libraries, then there is nothing wrong in it. And you can say that this is the course where we are going to use the pandas library very exhaustively. So that the reason we are going to cover major portion of the pandas. In a simpler term, I can say that pandas is the library which we are going to use for data analysis within Python. Don't worry if you are not understanding about this. We are going to cover all the aspects of pandas in this course in a step-by-step manner. Once you finish this course, then you will have a very good understanding about the pandas for data analysis. For a time being, you just understand that pandas is going to be used for data analysis within Python. Now moving further, and let's understand that matplotlib libraries. No data analysis is being complete without the visualization. So this is the library which offers us visualizations, methods and function within Python, and that we are going to use it majorly. So in short, matplotlib is used for visualization whenever we are doing a data analysis. So this is what I wanted to discuss in this session. In the next session, I am going to introduce Ipython Interpreter along with Jupyter Notebook to make you understand about all the concepts of data analysis using Ipython as well as Jupyter Notebook. And within that, we will discuss about all these topics. Once we understand that, then we will pick up these topics one by one. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome to the another session. In this session, we are going to look into Ipython Interpreter. So prior to learning about what actually the Ipython Interpreter is, we have to understand that how we can get the Ipython Interpreter. So once you have finished the installation of Anaconda software, then you don't need to take any further step to get the Ipython Interpreter, as it is coming with Anaconda software that I will demonstrate you in this session. Now coming to the second question, what actually the Ipython interpreter is? So to answer your question, I would like to remind you some of the points from my earlier course, that is Learn Coding from Scratch with Python 3, where I have mentioned that Python is an interpreted language, and the behavior of the interpreted language is the interpreter will execute the code line by line. Let's understand with an example. This is our Anaconda editor, and if I am going to run any program, so I need to write Python, and if I will press enter, so it will give me the interpreter, and here whatever I will run, it will get executed. So here you will find that it is giving us 2 plus 2, 4. If you will look into that, you will find it over here. It is returning us 4. The same way, if you write over here print, and within that we can write hello world, enter, so it will print the hello world. So this is normal Python interpreter, but this interpreter is good, but it not contains many of the advanced feature which Ipython interpreter offers us. So you must be asking what kind of powerful functionality Ipython offers us. So to understand it, let's understand with an example. Suppose that if we are going to have some random number, so we need to write import numpy as np, and over here we will generate some random number. For example, a equal to np dot random number, and I want the random number. And over here, if I wanted to calculate that what is the dot product and how much time it is taking to identify the dot product of this, so how I can calculate that? What is the execution time? If I will try to run, there is a special command which Ipython offers, which the normal Python doesn't offer. So that we are going to look into that. For a time being, you just consider that there is a magic command for time it that will help us to calculate what is the time takes for this execution. If I will run it, then you will see that it throws an error. Now we will look into the same example in Ipython Interpreter, and we will look into the power of Ipython Interpreter, which Ipython offers that Python Interpreter doesn't offer. And here you will see that there is no output given by normal Python interpreter. So now let's look into the Ipython interpreter. So first we will exit from here, Control Z, and now I will type Ipython instead of Python, and you will see the difference why it is powerful tool. So now I am going to execute the same example which I have executed over here, and you will see the difference, what benefit it offers us. So over here we will type import numpy as np enter. Now I am going to generate some random number np. We are going to discuss about this numpy in the upcoming session, so don't worry about that. So this is the method which is used for generating the random number, random, and over here we will specify 100 by 100, and now it has given us the 100 number. And over here we will look into what the time it is taking to calculate the dot product of generated random number. So let's write it. I'm going to run the magic command over here called time it. So it will return us how much time it takes to do the calculation of dot product of a comma a. So this will give us the dot product multiplication. Let's enter it. So let's look into the output. So over here you will find that it returns us how much time it takes to execute this program along with the looping information. So this is just a glimpse about the Ipython interpreter. In the next session we are going to discuss about Jupyter Notebook, and the engine which is running behind the Jupyter Notebook is Ipython Interpreter. So when we learn Jupyter Notebook, we are going to learn about some of the magic command as well as some of the special command which we are going to use all these commands throughout the course. If I wanted to explain you the Jupyter Notebook, I can explain in this session only, but I have kept it separate because I wanted to emphasize more on Ipython Interpreter as it is a base behind Jupyter Notebook. So if you understand this, then you can easily identify what actually Jupyter Notebook is and what actually the engine which is running behind Jupyter Notebook, which we generally use to do the data analysis, and after doing the data analysis we can keep it as a HTML page and keep it as a record. Don't worry if you're not understanding any of the thing whatever I'm telling it right now. Don't worry, we are going to discuss in the upcoming session where we will discuss about Jupyter Notebook thoroughly. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome to the another session. In this session we are going to look into Jupyter Notebook. If you look into this topic name, then you will find that there are two terms. One is Jupyter, another one is the notebook. So Jupyter is the name of the project and notebook is the application which is being designed within this project. So basically the notebook application is a type of interactive document for code, text and data visualization, which we are going to see in our upcoming sessions. So let's jump into the Anaconda shell and we will look into how we can access the Jupyter Notebook. To access the Jupyter Notebook, you need to come to the Anaconda cell and over here you need to specify Jupyter. Just mind the spelling of Jupyter Notebook, and over here we need to specify Jupyter Notebook and press enter. And once it will open, then you will find that it looks something like this, and if you closely look into this, then you will find that it is a web-based application. So let's create a new notebook. So to create a new notebook, you need to come here and click on new, and over here you can select Python 3. So once you created a new Jupyter Notebook, then you need to specify over here the name. So my first notebook, rename. Now suppose that if you want to run any of the program, then you can run it over here. So you can write 2 plus 2 and you need to press shift enter, then you will find the output. So now you must be asking that what actually happening whenever we are running this program. So let's understand it. So whenever you are running a Jupyter Notebook, then there is a kernel which is running behind the scene. So let's look into that. So if you remember that we have executed a command Jupyter Notebook, and the moment Jupyter Notebook gets executed, then you will find that this program is listening whatever we are typing into that web tool. For example, we have started a kernel and we have typed something 2 plus 2, and after that it automatically saved it, and this happened through kernel. Kernel actually listening whatever we are doing into that interactive cell, and as per our instruction it is performing those exercise behind the scene. For example, when we started it, we have created a new notebook, then this kernel listen that, and then it serves that whatever we have requested for. Now here I wanted to give you one point to remember is that Python's Jupyter kernel uses the Ipython system for its underlying behavior. In our previous session, we have discussed about Ipython Interpreter. So now let's jump into the Jupyter Notebook and let's look into some of the useful commands which we use frequently while working with Jupyter Notebook. So now let's look into some of the feature of this Jupyter Notebook. Over here you will find that this drop down, and it contains code, markdown, raw NB convert, and heading. So for example, if I want to make this line as a heading, so we need to write double hash, and over here we need to tell that we are going to learn the topic tab completion feature, and then I will choose over here markdown. Then it will give us this header text. It converted that particular line into a heading. Now we will press shift enter, then you will find that it has introduced this line as a heading. Now let's look into tab completion feature. So what actually it is? So suppose that if you are having date and time package, now we wanted to understand that what actually method it contains. So what we do, we will write date, time, dot, and after dot we will press tab. Then you will find that it gives us all the options, or say all the functions information which exist within this particular package date and time. Let's look into some other example. For example, if we are having a numpy package, numpy as np, shift enter, and if you will type np dot and press tab, then you will find that all the method and function information which numpy package offers us. So we can easily identify what are the functions and methods available within numpy package. So now let's proceed further and let's look into some of the other feature of this Jupyter Notebook. So for example, if we are having a list equal to some values, now suppose that if I wanted to know about this object, what actually this object is, then we can easily identify with the help of question mark. If we put less question mark, shift enter, then it will provide us this information. So if you closely look over here, it has given us this information what this object is. This is a list object and it is from a string form, look like something like this, and what is the length of this, and it is based upon mutable sequence. That means you can change it anytime. And over here if you will type, for example, if you close it over here, and same way tuple, if you are going to create a tuple, and if you specify 2 4 6 enter. Now let's look into what this object is. Then we can tell that top question mark shift enter, then you will find that it has given us the information tuple, and here the built-in type is immutable. That means you can't change this one. So this way you can easily introspect any of the object which exist in your program. So now let's proceed further and let's look into some of the other feature of Jupyter Notebook. So to demonstrate you the another feature of Jupyter Notebook, I am going to open a Spider editor where I will write a small program, and that program I will access over here. So to open the Spider program, I am going to use another Anaconda shell, and over here I will type spider. If you gone through my earlier course, then you will find that where I have introduced the spider program, which is basically an editor where we can write the Python programming. So it is opening now. So now it has opened. So let's write a program over here. So I'm going to write def function xyz, and within that I am going to tell return x plus y divided by z, and within the same program I am going to access it. So over here a equal to 10, b equal to 12, some random value for c 8.9, and over here I will call result equal to, calling this function a comma b comma c. Save it. So let's save it, and over here just specify a name over here. So any name, my script.py. Save it. Now this program I have written. Now let's access this program within Jupyter Notebook. So let's run it in Jupyter Notebook. So to execute that program which we have written in a spider editor, so we will write over here %run, and we will specify the name. So I will tell my script.py and shift enter. So now you must be wondering you are not getting any output, but it is not like that. The program is get loaded into your memory, so you need to run. For example, if you are typing result shift enter, then you will get the output of from that program. If you want to access the variable within the program, for example, we have written ABC. If you remember, if you go into that, then you will find that we have used 8.9. So let's look into that. So here you will type C and shift enter. Then you will find that it is giving us this output as we have specified the value of C is 8.9. So this is about running the program. Now suppose I want to access the program in this Jupyter Notebook. So what I can do? So let me explain over here. Select this one and press A, then it will give you this option, and over here I will type %load and the name of the program which I wanted to access, my script.py. Shift enter, then you will find that it has loaded the program which we have written into the spider notebook. Now let's proceed further and let's look into some other feature of Jupyter Notebook. So Jupyter Notebook offers us various magic commands. So if we want to check the what are those commands, then we can use something like this. We need to write %magic and shift enter. So this will give us the detail about the magic command, and which you will find it over here. So all those magic command you can execute over here. This I have already shown you, that is %timeit. So let me pop it out. So over here you will find that these are the magic commands available. For example, I have shown you earlier %timeit usage. It will return us how much time it is taking to execute a program. If you want to find out, then you can run it. For example, just take this one and come here, press A. Now you will get a new line, and over here you will paste it, shift run. Shift enter, then you will find that these number of nanoseconds it taken to execute this program and how many number of loops it has executed. So these number of loops is being executed. So now let's proceed further. You can go through the entire document. There are various magic command available, and we are going to use some of them in this course. So now let's proceed further. So one of the major benefit of using Jupyter Notebook is it displays the data visualization within this interactive notebook. So what it means? So for example, we are having some random number and I want to graph those random number in the same notebook. So how we can do that? So we can do it through the matplotlib. So let's look into some working example. So over here I press A and I will import matplotlib.pyplot. So this is the library as plt. Now I will generate some random number. So over here I will type plt.plot, and here I will generate random number and cumulative summation. So I will do that. So first let me generate this number. So this number gets generated, and now I want to calculate the cumulative summation with the help of sum. So this is a simple program which I have written, and it will plot the cumulative sum of 50 numbers and draw it in a graph. So to use it, we need to again add a line over here, and we will tell that percentage matplotlib inline. So that means we want to use it over here. Shift enter. Now let's execute it. Again shift enter. Then you will find that the number it has generated, and after that it has applied the cumulative sum, and then it has generated this graph. So this is the power of Jupyter Notebook. You can do the data visualization over here. That's the reason we are going to use Jupyter Notebook for data analysis. So now on this note, I am stopping.
Hello guys, welcome to another session. In this session we are going to do refresher for Python prior to moving further in this course. I have a detailed course available for Python, and the name of the course is Learn to Code from Scratch with Python 3. You can refer that if you want detailed information about Python 3. And this course is for absolute beginner who don't know about coding and he wants to learn about Python as well as coding. So to make everybody on the same page, I am going to take this session where we are going to discuss about following topics. We are going to discuss about basic data types, collection types, dictionaries, sets, tuples, functions, and classes. As we are going to use frequently all these concepts frequently in data analysis, so it is pretty much required to understand all these topics. So let's open the Jupyter Notebook and we will start understanding each of these topics on Jupyter Notebook. So to start the Jupyter Notebook, you need to come to the Anaconda PowerShell, and over here you need to specify Jupyter Notebook. Click enter. So it will open a Jupyter Notebook. So this has opened a Jupyter Notebook. I have already given the information about the Jupyter Notebook, what actually Jupyter Notebook is and what interpreter is running behind the scene. All these information I have given in one of the session. Those who are directly coming to this session, I wanted to give you information about the Jupyter Notebook. Jupyter Notebook is one of the application where you will write and execute Python code locally in our web browser. The benefit of using Jupyter Notebook is it makes it very easy to tinker with code, or say play with the code and execute the code in bits and pieces. And that is what we are going to do in this session. So to open a new notebook, you need to come here and click on New Python 3. So it will open a new notebook. We should specify a name over here. So currently it is showing untitled. We are going to rename it and we will tell that Python refresher. So rename it. So first thing we are going to learn about basic data type. So let's write it basic data type. Shift enter. Like most languages, Python has a number of basic data types which includes integer, floats, booleans and strings. These data types behave in a way that are familiar from the other programming language if you have gone through any programming language. So let's look into one by one. So first we will look into how to check the data type of any variable. Suppose that if you are having a variable x and if you are assigning some value and you want to check the data type of this particular variable, so how you can check it? You need to specify print function, and then you need to use a function over here that is called type, and here you need to specify the variable name, and when you press shift enter then it will return that what variable it is. So same way, if you are assigning any of the variable over here, like just copy this one, paste it over here. If you are specifying 5.0 and here you can specify y, and here you need to specify y, shift enter, then it will return float. So Python also support the complex number. So how you can create the complex number and assign into a variable. So suppose that if you are having a variable z, and to create a complex number you need to specify complex, and first one is the real part and then the imaginary part, and then you need to print it. So let's print z and let's check the type. So how we can check the type? We need to specify over here type z, shift enter. then you will see that it is a type of complex number. So this is about the variable. So you can assign whatever the value you will assign. If it is a decimal value, then it will return float. If it is a integer value, then it will return integer. Same way you can use the complex number. So now moving further, let's look into the operations. So operations, it supports addition. To do addition, we are going to use plus operator. So let's do one by one. It is simple thing, but I want to give you a refresher over here. So here we can tell that x plus 1 for addition. Same way we can use minus operator. Then we will look into multiplication. So for multiplication we use asterisk enter. To perform the division we are going to use the slash operator front slash. So x divided by 3 enter. So it will return this value. Now to calculate the exponential we need to use double asterisk. So let's look into that. For example, if I want to calculate the exponential term of variable x to the power 3, then how we can do that? We need to specify x double asterisk and to the power 3, shift enter, then it will return the exponential value of the variable. So now let's discuss about the Boolean operators. So let me give a heading. There is a shortcut for providing the markdown. You should press M. So it will change to code from markdown. If you want to get the code back, you need to press Y. So you will get over here in this is representing that it is ready for accepting the code or whatever the code which you want to execute. So in means input. That means it is going to accept the input. So I want to change it as a markdown. I need to select outside. If you select inside, then see it has changed the color to green. That means it is ready to accept the input. But if you click outside, then it changed the color to blue. Now you can press M. So you will see here it is changed to markdown. So let's write a heading. So what we are going to learn now, we are going to learn Boolean operator, shift enter. Now in Python, as I already mentioned in one of my course, you can use normal English word like and or say or as a Boolean operator. So let's look into that. For example, if we are having a variable t and there is a Boolean value true and there is another variable f that is for false, and now I am going to check the type of these variables. So first let's check the type of this variable. So write print type t, shift enter, then you will find that it has returned Boolean. Now suppose I want to apply the logical operator. So how I can do that? I can check print variable t and the AND operator. If I want to check the AND condition and F, then what is the output? So let's look into that. Then you will see that here true and false is become false. If we will provide print, introduce some other variable over here, m equal to true. Now let's check the condition t and m, then it will return true because true and true become true. So here it is throwing error because we need to execute it because it doesn't know what is m is and I have introduced just now. So let's run it, shift enter. Now again you will run this statement, select this one, shift enter. Then you will find that it has returned true. So the intent to show this example, simple example, to introduce this AND operator to you. Same way you can introduce, same way there is OR operator. So you can use T or F, shift enter, then it will return true. If any one of them is true, then the condition become true. So now let's proceed further. To make it not condition, so you need to use the not operator. For example, if you are going to use to make this true condition as false, so you need to specify the not operator and then you need to specify the condition, that is our variable name t, and shift enter, then you will see that the true become false. So this way you can do the negation. So now let's proceed further and we will look into strings in Python. So let's do it. Click outside, press M and specify a heading, strings in Python, shift enter. So now let's create a string variable. So you can type str1. And to create the string variable, you need to either you can use single quotes or double quotes, it doesn't matter. So for example, you can write here hello, and for string 2 you can specify str2 and double quotes. This time I am going to use hello world. And if you print both, print str1 and str2, shift enter, then you will find that output wise there is no difference. You can use any one of them. The way you are checking the type of other data type, you can check for a string data type as well. So if you will write print and then type, and over here you need to specify the name of the string, shift enter, then you will find that str. Now next, if you want to calculate the length of the particular string, then Python offers us a method called len. So you need to specify len, and within that you need to specify the variable name. Shift enter, then it will return the length of the string. Within Python, string data type offers various methods which will be helpful to perform various operations on a string. For example, if you are having this Pascal casing, if you want to convert it into the capital casing, so how you can do that? You need to specify, I will print it, so I am going to write print, and over here I need to specify str1 dot, and you can start writing it and press tab. Then you will find that it offers us this capitalize, so you need to select it. Let me zoom it. So now you will see that once you press the tab, then it will give you this option. So you need to select this one, tab, enter. Now let's press shift enter. So now press shift enter, as it is a method. So that's the reason it is telling that you should use the parenthesis. So here you need to use the parenthesis, specify parenthesis, shift enter. Then you will find that it returns the same output as we are having the hello as a capital case only. Sorry, I mentioned that it is Pascal casing, so it is not a Pascal casing. Pascal casing, if we are writing that hello world, then it become Pascal casing. So if we are removing this, then it is become a capital casing. So to demonstrate this example in a proper way, so we can remove this capitalize. There is another method which Python offers for string data type, that is lower. If we will specify lower, then whatever we are having over here, it is a capital casing, then it will print the lower casing. So shift enter, then you will find that it has changed to lower casing. So same way we are having upper casing, so you can specify upper, shift enter, then you will find that it has changed to the upper. So there are various methods available which I have discussed in my earlier course. If you want to refer, then it's good. In Python there are various methods available within string data type. So how you can search for that? So you need to write str1 and then dot and tab. So it will give you all the information about all those methods which is available within string data type. So you can try each one of them. So, and you can also get the help putting question mark over here, shift enter. Then you will find the information about method. For example, I have selected upper and then question mark. So it is returning what this will do. This method will do, it return a copy of a string converted to uppercase. So you can check for all those information by applying this syntax. So you can do the same thing for other one as well. Dot, for example, if you want to check what is case hold, select this one, question mark, shift enter. So this way you can verify that what this method actually do for you. So on this note, I am stopping over here. So this is our introduction for basic data type. This is a refresher for basic data type. In the next session, we will look into refresher of collection types, or say containers type. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome to the another session. This session is the continuation of the earlier session which we were doing for Python refresher. In the earlier session, we have discussed about the basic data types. Now in this session, we are going to look into the collection types or container types. Mainly we are going to discuss about lists, dictionaries, sets, tuples. So why I am doing the refresher for these topics? That is because these topics are frequently used topic whenever we are doing data analysis. So let's jump into the Jupyter Notebook and look into each of these topics one by one. As I already mentioned that there are various type of collection types or say container types in Python. So the first container type which we are going to look into is the lists. So in Python you can create the list by following this syntax. So you can write a variable name list1 equal to, and you need to specify the elements within the square bracket. So over here I will specify 2, 2, 4, 6 and shift enter. So this way we have created a list within Python. Now the second question is how we can access the element of these lists. So to access it, we need to pass the index value. So let's do it. Suppose that if I want to access the element 4, then we need to specify list1 shift enter. Then you will find that it has given us the value 4 as the list is getting indexed with the number 0 as it is a 0 based indexing. So if you have any question on lists and all these data types, so you can refer my course, that is learn coding from scratch with Python 3. You can go there and you can finish that course if you want more understanding about these topics. For a time being, you just remember that if you want to access the list element, so you can access it through the index value. So here we are having three elements. So the first element is represented with value 0. If you specify 0 over here, shift enter, then you will get the value of 0th position index of this particular list. Same way, if you want to access value 6, then you need to specify 2. Shift enter, then you will get the value 6. Now the second question is how we can add another item within this list. So there is a method called append. So you can use it list1. For example, if you want to append another value like 8, then you can write it like this, shift enter. Now print the list1, shift enter. Then you will find that the value is being appended to this list. Suppose that if you want to take any value from this list, then you need to specify print list1 dot pop. You need to specify pop and shift enter. Then you will find that it has popped out the last element which it has inserted. So it will always pop out the last element. So if you will again copy this one and paste it over here, it will take out the value 6. So see here, now just print the value. Let's print the list 1. Then you will find that it remains with two elements, so 2 and 4. And this list is not specific for the integer value. You can put any other value which is of different data type. So how you can do that? So let's look into that. So suppose that if you want to push any other value which is not an integer type xyz, shift enter, and when you print this, then you will find that it is being appended to this list. So this is of integer data type and this is of string. So we can keep both the data type within the list in Python. So now let's discuss about slicing of list. So how we can slice a list. So let's look into that. So this topic is going to be slicing of list. Suppose that if I want to grab the value 2 and 4 only from the list, but prior to demonstrate how we can slice the list, we have to understand that what actually slicing is. Slicing is nothing but a technique within Python by which you can access the sublist within the list. So what it means, let's look into with an example. Suppose that I am having this list and I want to grab 2 and 4 as a separate list. So how we can do that? We need to specify, I'm directly going to print it. So the real syntax is going to be list 1, and within that I need to specify like this. Over here I need to specify square bracket colon and the two elements. So shift enter, then you will find that it has extracted from this list the two elements from the original list. So this is also a list, but we have extracted the two values from the original list. Now suppose if you want to access the last these two elements, so how we can access it? So you need to specify the starting position list 1. So I want that from position 1 to all. So that means if I'm not specifying any value, so that means I want to grab all the value which is starting from 1 to all value. Blank means all value. If you press shift enter, then it will return you the position which is being started with. The index position is 1 and 4 is placed at index position 1 till the end. Now let's proceed further. Now suppose if you want to access the last value, that means last element, so there is a special index that is -1. So what you need to tell over here, you need to specify -1. Shift enter, then you will find that it has extracted the last element of this particular list. So now let's proceed further. So we are having a list 1, and suppose that if we want to replace the value of index 0 and index 1, so how we can do that? We need to specify that something like this list 1, and over here you need to specify that square bracket, and within that you need to specify 0 to 1, and over here you need to specify what element you want to place. So I'm going to tell that I'm going to specify over here 3 and 9 I'm going to place for 2 and 4. So shift enter. Now over here I will print list 1. Then you will find that the value is being replaced. So this way you can replace the value within the list. Now let's proceed further. Now the example which we are going to look into, so how we can iterate a list. For example, if we are having a list called fruit ball, and this fruit ball contains various fruits like apple, orange, grapes and peach. Now suppose that if you want to iterate this list, so how we can do that? We are going to use first for loop. So let's iterate with for loop. Then we will look into some other way to iterate it. So we need to specify fruit in fruit ball, and over here you need to print one by one. So we are going to tell that print fruit and shift enter. So this way you will iterate each of the element one by one. Now suppose if you want to access the index of each of these elements, so how we can access it? So let's look into that. So to do that, we are going to use enumerate, one of the built-in method of Python. So this way we can access so with the help of enumerate, we are going to access the index. So how we can do that? Let's look into that. For index value, and over here we need to specify fruit in enumerate. So we will specify the fruit ball within the enumerate function, and it will give us the index as well as the element. So here we will do the formatted print. So how we can do the formatted print? We need to specify that at number, to print the digit we need to specify %d, and over here we need to specify colon, and to print the string, to format the string, we need to specify %s. And now let's specify the value for it. So we need to tell that percentage, and over here we need to do index plus 1, so that it will add in each iteration, comma fruit. So this will go and sit at this place, and this will sit at this place. So the output will look something like this. So at number 1 we are having apple, at number 2 we are having orange, at number 3 we are having grapes, and at number 4 we are having peach. So this way you can access the index of each element within the list. Why I am telling all this? Because whenever we are doing data analysis, we are going to play with indexes in a very regressive manner. That's the reason I am going with the base concepts, so that you will be comfortable while learning the data analysis. If you are having good understanding about these topics, you can skip these refresher session and directly go to the NumPy session. So now let's proceed further and let's discuss about one of the important topic called list comprehension. So now let's discuss about the list comprehension. List comprehension is one of the easiest way to transform the data which we are analyzing. Sometimes we need to transform the data
within the data analysis. So we need a easiest way to transform the data. So for example, if we are having an array, say some num, and this list we are having some value 0, 1, 2, 3, 4, and this number I want to square it. So usually how we do, we can create another list which will hold the squared value, and we need to iterate the list. So we need to write for x in some num, and over here we need to specify that whenever we will iterate a value, we will append to the another list that is a square, and this value is the squared value. So how we will do the square? We will use the double asterisk for exponential term, x to the power 2, and now we will print this value. So let's print it, print x, and at last we will print the entire square. So we will tell that square shift into. So here you will find that it has squared all the values, but this is not the easiest way, and this is not the quickest way. So how we can build the same functionality with the help of list comprehensions? So how we can design the same function in a one liner? So let's look into that. So what we will do, we will create another list that is called square 2 equal to, and over here the syntax is something like this. We need to first specify for x in some num, and now you should remember that the output we need to, the thing which we want to process, for example, I want to transform this x and I want to store it over here. So you need to write it first. So you need to specify x double asterisk 2, that means exponential of this x, and it will calculate this value. This will be iterated, all the value will be iterated one by one, and then it will be squared, and now at last we will print the square 2 shift enter. Then you will find that we have performed all these operations in a single line. So this way of iterating the list is called list comprehension, and it is mostly used technique within the data analysis whenever we are doing any kind of data transformation, which we will use it whenever we start our data analysis part of this course. You can also specify the condition within the list comprehension. So what you need to do to specify the condition, suppose that if you want to create this square as a even square, so that it will hold only the even number. So let's write it within the same program. You need to specify over here if condition like this: if x value, that means this value, mod of 2 equal to 0, that means the number is even value. Now let's run it. Make sure that you are specifying over here. Now shift enter. Then you will find that it holds the even number only, and this way you can apply the if condition within list comprehension. So this is very handy technique. So here we are doing many things in a single line, so you should have to used to with this syntax, and however you want to interpret, you can interpret it. I generally interpret, I just suppose that if I don't have if condition, I write it like, let's iterate this sum num, and it should be coming to x, and whatever operations which I want to perform, that should go to the left hand side, and whichever we are iterating, that should go to the right hand side. And if we want to introduce another condition, so it should go to the right hand side. So this way you can interpret and you can remember the logic however you want to remember it. This session is going to be very long now, so I am stopping it over here. In the next session we will look into dictionaries, sets and tuples. We will try to cover all these topic in one session, but if it is going long, so I will stop there and I will create another session for each of these topic, because this topic is very important topic and I want that you should get a proper knowledge about these topics so that you can easily use these knowledge into data analysis. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome to the another Python refresher session. In this session, we are going to look into dictionaries. So in this session, we are going to look into some of the important aspect of dictionaries. So prior to looking into the example, I just wanted to tell you this part of the course is not mandatory. If you are having an idea about the Python programming language, you can directly skip into the part 2 of this course. And the student who is joining directly into this course and who doesn't have any idea about the Python programming, then I would suggest that you should go through one of my course, that is Learn to Code from Scratch with Python 3, where I have covered Python 3 in more detail. For this course, I am giving you the required knowledge which is must for data analysis, so that whoever is joining in this course directly without having an idea about the programming in Python, then they can easily understand that how to do data analysis with these tools. So now let's start our discussion on dictionaries. A dictionary stores key value pairs similar to a map in Java or an object in JavaScript. So let's understand that how to create dictionaries in Python. So first we will learn about how to create dictionaries in Python. How to create dictionaries in Python. So to create the dictionaries, for example, if you want to create a dictionary called grocery underscore bag. So how you can do that? You need to write the curly braces started and close. If you are using these two curly braces and assigning into a variable, then this variable become dictionaries. So let me prove the point. So here, if you will print type grocery bag and shift enter, then you will find that it is a dictionary. So how we can keep the data within dictionary? So we need to keep it into a key value pair. For example, if we are having a grocery bag, so let's assign some values over here. For example, if you are going for a supermarket and where you want to purchase potato, how much kg? It is 2 kg. Same way, for example, if you are having onion 1 kg, tomato 3 kg. So this way you can keep the information. Some error we got, and that is because we have directly used the name. Instead of that, we need to specify within the codes. So the same example, what we will do, we will put the single quotes over here as it is a key. So it is going to be a string over here. I specify a string. Now shift enter again. Then you will find that it has created a grocery bag. If we will print it, so let's look into that, what it is printing. Grocery bag, shift enter, then you will find that it has printed the dictionary. Now let's access the individual element of this dictionary. So how you can access the individual element? Suppose that if I want to access the potato and I want to grab this value, so how I can access it? So let's look into that. So we can access the dictionary through the key. So we need to tell that bag, grocery bag, and within the square bracket we need to specify potato. Now what it will do, it will return the value against this key. So let's enter, so let's print it, print shift enter, then you will find that it has returned the value how much kg of potato we have purchased. So it is 2 kg. Now this is the individual element you are accessing. Now suppose that if you want to iterate this dictionary, so how you can do that? So let's do it. So how you can iterate the dictionary? So you need to write for item in grocery bag. You need to specify that, enter, and over here we are going to get the quantity within a variable. And how we can access that? We can access through key grocery bag, and over here square bracket we need to specify the item and then we will print it, and we want to print it formatted printing. So we need to specify over here %s, that means the name of the item, and after that %d for the quantity, and over here we will mention that kg, kilogram, and over here we need to specify what are those. For the first value it is the representation of item, and the second value we will specify quantity. Now shift enter. So we did a mistake over here. So you will see it over here. We are not getting the expected output. So there is an issue. So we did a mistake over here. Here instead of comma we need to specify percentage. Now let's press shift enter. Then you will get the expected output. So this way you can iterate the dictionary within Python and you can store the key value pair within the dictionary. So now let's proceed further. So this is one way of accessing the key value pair. So with the help of
this syntax, we are accessing the key and then we are passing the key to the dictionary and then we are accessing the value of that particular key. But there is another way which Python offers us, and we can access the key value pair together. So how we can do that? So let's copy this one. I'm going to leverage this, and over here instead of this I can use dot items, this method which Python offers to access the key and the value. So let's remove this and we will tell that key and value, and over here we need to remove this one, and instead of item I am going to specify key and the value. So this syntax is very less number of line we need to write compared to the earlier one. Now if you will press shift enter, then you will find that it is returning the same output. So there is no change in the output. So you should remember that there is a method offered within Python. Whenever we are creating a dictionary object, it offers us a method dot items, and you can access the key value together. So this is what I wanted to demonstrate you in this session. In the next session, we will do the refresher for sets and we will understand that what actually sets is. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome to the another Python refresher session. In this session, we are going to look into another collection type, that is sets. So let's start our discussion. So first of all, we will look into how to create sets. So sets can be created by two ways. The first way, using the curly braces. For example, if you want to create a set called fruit ball, then you have to use curly braces and specify the element which you want to add within the set. So for example, I'm here adding some fruit, so oranges, and over here grapes. Shift enter. So now if we will look into the type of this particular object, so it is going to be set type. This is the first way. The second way is we have to use the set method. So here we need to specify another set, and this time I am going to use the set function, and within that I need to pass the tuple. So I'm going to add some another fruits. This time I am going to add peach, then over here banana, and then afterwards I can add pineapple. Shift enter, and this time I will print over here the type as well, fruit ball set1. Shift enter, then you will find that it created another set, and this time we have created with the set function. So this is about creation of set within Python. So now let's discuss about some of the important characteristic of set object. The first point to remember is that sets are unordered list, and when we are talking about unordered list, that means the items which we are inserting that is not accessible through indices. So what does it mean? For example, we have created two sets over here, and if you try to access any of the element using indices, like how we are doing in array, that is not possible. If you try to access the first element with this indices and try to shift enter, then you will get the error. See here, it's told that set object is not subscriptable. So let's proceed further. So you should remember that this is an unordered list. You can't access it through the indices. So just delete this line X. Now proceeding further. Now there is another point to remember, is that it is a mutable object. So what does it mean? So that means you can add and remove some more element within this object. So how we can do that? For example, if we are having fruit ball set and if we want to add some more fruit, then you can do that. So here you need to specify add. I'm going to add another fruit called mango. Shift enter, and if we print the fruit ball, then you will find that it gets inserted. Shift enter. See here, it has inserted. Same way you can remove the element as well. So there is a method available for that you can use it called remove. So you will specify whichever element you want to remove. I'm going to tell that apples. Shift enter, and if you will print it, copy it, paste it, shift enter, then you will find that it gets removed. So now let's proceed further, and you should remember there is another point you should remember. You can mix different type of information within set. So what does it mean? So it means that, for example, currently we are having the string value, and if you want to hold some numeric value, that doesn't happen most of the time, but in case if you want to keep the integer value within a set, then you can do it. So let's look into that. For example, if you want to add a integer over here, I'm going to add 1 2 3, shift enter, then there is no problem. And if you print, so copy paste it, that would be good, shift enter, then you will find that it gets inserted. And one thing you noticed over here earlier, when I have inserted mango, so it get inserted at very beginning and orange position was at last. But now the moment I added 1 2 3, then you will see that it entirely changed the position of each element, and we don't know which position belongs to which element. That's the reason it is called unordered list. So whenever we do any kind of a insertion and deletion, then Python interpreter take care of this as per the availability of the memory, and it places the element accordingly. So that's the reason it doesn't allow to access the element through indices. So now let's proceed further. So now let's discuss about, suppose that if we want to calculate the length of, or say how many number of elements exist within a set. So you can do this by using len method of Python. So you should specify len and the name of the object over here. I'm going to specify fruit ball set and shift enter, then you will find that it has written 4 elements. So now let's proceed further. Now discuss about, suppose a scenario, if you want to know about any element exists within fruit ball or say within a set, then how you can do that. For example, if I want to check that whether in the fruit ball set whether mango is exist or not, so we can do that. We can specify mango in and the name of the set. So it will return true or false. If it exists, then it will return true. If it doesn't, then it will return false. Shift enter, then you will find that it returned true. Now suppose if any of the fruit is not exist and we want to verify that whether it is exist or not, so we can use it. Suppose that if we are having avocado and if we want to check that whether this fruit exists within the fruit ball set or not, so I can specify like this, shift enter, then you will find that it has returned false. So now let's proceed further. Suppose that if you want to clear all the elements from the set, so how you can do that? So there is a method available. You can specify fruit ball set dot clear. If you press shift enter and now you will print fruit ball set, shift enter, then you will find that there is no element. So set is very important object or say collection type which we are going to use in data analysis. So that's the reason I kept this topic as a Python refresher. So this is what I wanted to demonstrate you in this session. In the next session, we are going to do another Python refresher, that is tuples. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome to the another Python refresher session. In this session, we are going to look into another type of collection type, that is tuples. So what is tuple? A tuple is similar to list. The difference between the list and the tuple is we cannot change the elements of a tuple once it is being assigned. Whereas if we are using list, then it allows us to change the element of the given position. So we will look into this example once we understand that how to create tuples. So next topic, we will look into how we can create tuples in Python. So it is pretty much straightforward. Whenever if you are using parenthesis and assigning into a variable, then that variable become tuple. So what it means? So for example, if you are having a fruit ball tuple, and if you are having a parenthesis and shift enter, then this object become tuple. So you can check the type. So how you can check the type? Write print type, and within that I am going to print fruit ball tuple. Shift enter, then you will find that it has returned us this object is a class type tuple. So now if you will put anything within this bracket, then that is an element of that particular tuple. So let's assign it. Let's copy this one and we are going to assign the same fruits, that is apples, oranges and grapes. Let's print that, print fruit ball tuple. Shift enter, we have spelling mistake, then you will find that it has given us the tuple. Tuple also allow us to access the element through indices.
So what it means? So you can access individual element through indices. So here if you will specify 0, just copy this one, comma 1, comma 2, shift enter, then you will find that it has returned each individual element. So let's look into one by one. So if you will accessing like this, then it will return the element which is at position 0. So now let me contradict one of my point which I have mentioned earlier. Whenever if you want to create a tuple, then you should put into the parenthesis. It is not like that. Suppose if you are having a variable called fruit ball tuple 1, and if you are assigning any comma separated value without the parenthesis, then it become tuple. So let's look into that. Suppose that if I am having some other fruit, peach, banana and pineapple, shift enter, then you will find that if you will print the type of tuple 1, fruit ball tuple 1, then you will find that it is a tuple, and that we have created without using the parenthesis. So see here, now coming back to the definition which I have told you earlier, that once you have assigned any of the value at particular position, and if you want to override that value with some other value, tuple will not allow that. That is not permittable, as tuple is a immutable object. So let's look into that. Suppose that within the fruit ball tuple 1, instead of peach, I'm going to assign avocado. For example, it is at position 0 and I want to assign avocado and shift enter, then you will get the error. Why? It is telling that tuple object doesn't support item assignment. So this is what I mentioned at the very beginning of this topic. So now let's look into some interesting fact of tuple. Suppose that if you are having a tuple and that we can tell that fruit basket and that contains a list. For example, you are having a list where first set of fruit is, for example, apple, comma, banana, comma, oranges, and the second set of list within the tuple is having another set of fruits. Let me copy that so it would be easy, and over here I will put it. Over here I will put that, and for banana I will change something, avocado. So now I am having a tuple called fruit basket that contains two lists. Shift enter, let's print it. I will tell you the trick over here, and one contradictory thing which I wanted to showcase. Shift enter, then you will find that we are having a tuple which contains two lists. Now suppose if you want to change this particular element of this particular list, then you can do that. So let's look into that. For example, if you want to do the change, then you can access that element through indices. You want to access 0th element of this particular tuple, and you want to access 0th element of this particular list, and you want to assign one value, new value, and you are going to assign grapes, then it is allowable. So let's look into that. Now let's print, and you will find that it is being changed over here. So in summary, what we understand that if you are having a mutable object within tuple, that you can reassign it, but tuple itself is a immutable. If you try to reassign the value, then it is not possible. For example, if you try to reassign some new list, for example, if you try to access this, and if you want to reassign it with some new fruits, I'm just typing some other values over here, sorry for that. To showcase that example, I wanted to show you. So now if you try to access this, so this will not get inserted as tuple is a immutable. Shift enter, so you will get the same error which we have already seen earlier in this session. So now if you want to access each of the individual element, so you can do that through the loop as well. So you can use for, and you can specify fruit in fruit ball tuple, and over here you will print it, or whatever you want to do, whichever operation you want to perform, you can do it. So let's do it. So let's access each individual fruit and convert it into uppercase and shift enter. Then you will find that we have accessed each individual element which exists within this tuple, and then we have converted their spelling into uppercase. So tuple is also one of the mostly used collection type whenever we are doing data analysis. So that's the reason I have introduced within Python refresher section so that you also aware about this object. So this is what I wanted to demonstrate over here. In the next session, we will look into one of the important concept of Python, that is functions. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another Python refresher session. In this session, we are going to look into functions. So let's jump into the Jupyter Notebook to understand this topic. So we are into the Jupyter Notebook. Now let's start our discussion on functions. So first of all, what is function? So in a layman term, you can say that a function is a block of code that contains a statement or say statements related to a specific task, and the statement which we write within the function which must have execution sequence. So we will understand this with an example. But prior to that, let's understand that how many types of functions exist within Python. So on a broader category, there are two types of function. One is the built-in and another one is the user-defined function. Built-in function which is already being provided within the Python. So what are those? So let's understand that what kind of built-in function we have in Python. So for example, if you are having a list 1 and you are having some element, for example, if I am telling that ABC, some XYZ and some PQR. So these are some elements we are having, and Python offers us some of the functions like length. Suppose that if you want to check the length of this list, then you can easily check with the help of length function. So list 1, shift enter, then it will return us the length of this particular list. That means how many number of elements exist within this list. So this is one of the example of built-in function. There are various functions available within Python that you can check it over here. So this is the documentation of the Python. So you can note down this URL, and over here you will find all the built-in functions. And if you want to get the detail, if you click over here, then you will get the detail about all those functions and how to use that also you will get those information. So this is about the built-in function. So now let's proceed further and let's discuss about the user-defined function within Python. So now let's discuss about the user-defined functions. Topic name: user-defined functions. So what is user-defined functions in Python? So user-defined function is nothing but the function which we generally define. So now the question over here is how we can define the functions within Python. So to define a user defined function within Python, you have to follow certain syntax. So let's look into that. So here we will define it. So how you will define it? You have to use a keyword called def, and over here you need to specify the name of the function. So you should remember that function name. So you should remember the syntax, and then you need to provide the braces over here, and over here you need to specify the parameters. Suppose that if you are having various parameters, then you can specify parameter 1. If you have multiple parameter, that also you can specify. So you should remember that. Then over here you need to specify the colon, enter, and then you need to specify the statement. So all those statements which you want to perform in this function, that you should specify over here. So this is the generic syntax of the function within Python. So we will follow the same pattern while designing the function. So this way you can define the function. So this is what we call it as a function definition. So we can tell that it is a function definition. Now how to call this function? So to call this function, we need to use the function name. So I will call it as function calling, or say calling a function. So to call this function, what we need to do? We need to call with its name. For example, you need to specify the function name, and within the bracket you need to pass the argument. So here you will pass the argument. So argument is nothing but the parameter which expecting, and we are providing these values over here to the parameter. So we will discuss about this. So let me first write the syntax. So this is the syntax of calling a function. You can tell that syntax for calling a function. So this is two things you have to remember. So this is very important. So you have to remember how to create a function and how to call a function. Whenever you are creating a function, the thing which you provide over here, that is called parameter, and when you are calling the same function, then the thing which you provide the value over here, that is an argument. So let's create a user defined function over here. Shift enter. So now follow the same pattern and we are going to create a function. For example, if we are having a fruit ball list, we are having a fruit ball list called fruit ball new list, we can tell that new list, and this contains certain fruits. So let's say specify apple, orange and banana. So what I'm going to do, I'm going to create a function which will accept this list and print the value what exists at item 1, at item 2, or say at item 3, and whichever or how many number of element it has, it will print those element one by one with the index value. So this is the simple function we need to define. So first step, we need to follow the pattern. So you can see here, we need to first specify def, and then you need to specify a name. So I am going to tell that print fruit bowl, and what it contains a list. So we need to specify over here list, fruit ball list we can specify. So now the first step we have done, we have written the function definition with the help of this thing. Now we need to write the statements. So how we can write the statement? So what we want to achieve? We will grab the each element of this fruit and put a index, and along with that I wanted to print that element. So we are taking the FB list as a parameter. So this list will come over here. So first we will iterate through the list. As I already mentioned, how we can iterate the list? With the help of for loop. So this is the statement which I mentioned over here, statement 1. So for this program, I am going to use for statement over here, and here I need to specify fruit in FB list, fruit ball list. Now I want to grab the index. To grab the index, there is a function and available called enumerate. So this will give us what are the index positions we have within the list. So it will provide the enumeration for those indexes. So that also I will get with the help of enumerate function. This is a built-in function, and so because of that we are able to get the IDs, index of that particular element. So now I have grabbed it. Now I will print it. So here I need to specify that item. So here I will write idx plus 1. So it will print that item 1 we are having. So here we will specify which fruit. So comma fruit. So now shift enter. So this is what we have written over here. So now we have defined a small function. What it is doing, it is taking this FB list and it is iterating through that list and printing the index value plus 1 because this is being a start with 0, and it is telling that at item 1 what fruit we are having. So this is what it is going to print. So let's call this function. Now the second step, we need to call this function. So to call it, we need to specify over here the actual list name. So this is going to be your argument. So this list we have created. So take this one and paste it over here. So shift enter, then you will find that the output which we wanted to achieve, we have achieved through this function. And how we have designed it? We have designed through the function definition, and how we are calling it? We are calling it through this function call. So this way you can design your user defined function as per your requirement. So this is what we are going to use very thoroughly in this data analysis course. So this is one of the type of user defined function. In this function, if you will find that there is no return thing. So what it means? Sometime you will find that some of the function has return statement at the last. So that means after doing the calculation or after performing whatever the task which it's supposed to perform, and after completion of the task, it will send the result back to the caller. So what it means, let's understand with an example. So another example we are going to do, suppose that if we are having a list called num list, and this contains some numbers 1, 2, 3, 4, 5, 6, however. So how many number you want to keep, you can keep it over here, and we are having a function which will square these numbers. So let's square it, and after squaring these number, it will return another list. So let's create a function for that, and that will become a return function. So to create a function, as I already mentioned, we will use def keyword, and we will tell that square it, square num. So you will specify whatever the name you want to specify, and it contains a list, or say number list. And now we will write the logic. To write the logic, we are going to write some statement. So for example, we are going to have a list that is called a square list. It is a blank list earlier. Now next step, we need to iterate through the number list. So to iterate the number list, I am going to take the number in number list. I will take one by one, and what I will do, I will calculate the square and push it to the list. So how we can do that? We can tell square, or we can tell that x equal to number double asterisk 2, and then we will push it to this list. So let's write it. So another statement, we will write it over here, square list dot append, and within that we will put the value x, which is a squared number of the given number. So this is what it will do, and at last it will return the square list. So square list. So this is one of the type of user defined function where after performing the task, we are going to return the result. So this way we can define the return function. So how we will call it? So let's look into that. So to call this function, we should assign the return value within a variable. So here I can tell that squared list equal to this function, and here we will take the name, and here we will pass the num list which we have created, and once we get the list, we will print it. So let's print it, squared list. Now what we will do, we will do shift enter. So let's do it. We got some error. Let's look into that. We are doing some spelling mistake. So if you will closely look into that, then you will find that here we have done some spelling mistake. So copy it, paste it, again shift enter, and this time again this one also shift enter. Then you will find that whatever we have passed over here, it is squared now, and this time we have created a user defined function which is returning the result. Earlier we have created a user defined function that is not returning the result. So this way you can create both kind of user defined function, where you can create a function which doesn't return any value and it will perform the task and print the information there, and you can also create user defined function which returns the result after performing the task. So this is what I wanted to demonstrate you in this session. So in the next session, we are going to do the refresher for classes. So this is going to be our last Python refresher session where we will discuss about classes. If you want to know about Python object-oriented programming, then you can refer my earlier course where I have discussed in detail. In the next session, I am going to discuss the class thing, how we can create the class, but the object-oriented programming concept, which you have to know about the concept. If you know that concept, that is perfectly fine. If you doesn't know, then I would recommend that you should go through my earlier course, that is Learn to Code from Scratch with Python 3. In this course, I have also discussed about object-oriented programming in Python 3. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another Python refresher session. In this session, we are going to look into classes.
So let's jump into the Jupyter Notebook, and from where we will discuss about classes and the objects. But prior to jumping into the Jupyter Notebook, I wanted to remind you classes and objects are part of object-oriented programming, and I have a detailed course on this topic, that is Learn to Code from Scratch with Python 3. If you visit my profile, then you will find this course. If you are new to the programming background, then I would suggest that you should go through this course, then come back to data analysis course. If you have idea about object-oriented programming, then you can directly jump into the part 2 of this course. I am taking this Python refresher session because we all be at same page, and these all Python core concept is going to be used very thoroughly within the upcoming sessions. So now let's proceed further and start our discussion on classes and the objects. So let's jump into the Jupyter Notebook. So we are into the Jupyter Notebook. Let's start our discussion. So prior to understanding about what actually the classes is, we must have to understand that from where it is coming from. So whenever we are talking about classes and objects, that means we are talking about the programming paradigm. So what does it mean by a programming paradigm? So basically, whenever we are writing any program, so that program falls into certain programming paradigm. There are various type of programming paradigm like functional programming, declarative programming. The same way we are having the object-oriented programming. All these concepts I have discussed thoroughly in one of my course which I have already mentioned. If you want to look into those, then please go through that course first and then come back to this course. So now let's talk about object-oriented programming paradigm. So whenever we are talking about object-oriented programming paradigm, in this way of programming paradigm, we basically organize our program around the objects rather than function and logic. The core concept of object-oriented programming paradigm is classes and the objects. So now the next question over here is what actually the class is. So if you go by definition, a class is a template for creating objects. So whenever if you are creating a class, then you define various properties of that particular object along with the behavior of that particular object in terms of methods. In this session, we will look into how to create classes and how to define properties for that particular class and how we can create the methods which will define the behavior of the class. So we have done enough of talk now. So what we will do, we will create a class, and within that class we are going to introduce some properties. Along with that, we will introduce a method to get the understanding about the classes and the objects within Python. So to make the example very simple, I am going to create a class called employee. So to create a class, first we need to write a keyword called class over here and the name of the class. So let's write it. So we are going to create a class called employee. Now this way you have defined a class over here, but this class doesn't have any property. So let's add some properties to this class. So we are going to create some of the properties over here. So let's create the properties over here. So we will specify that ID. So I'm going to specify __ ID. That means you are creating a private variable over here. After that, we will create every employee should have an ID. So we can have ID over here. Then every employee should have name. So we will keep it blank. And every employee must have gender to make this employee class simple. And I'm going to have a variable called age. So over here I will keep it these 4 properties. So these are the variables within the class and we will call it as a properties. Now, so the next step we have to create the constructor. So constructor is a special method which will be called whenever an instance of this class is being created, and instance of the class is also known as object. So over here I am talking so many things, so don't get confused. So let's go step by step. So next step,
we have to introduce the init method. Init method over here. Init is a special method within Python which is being called whenever an object is being created. So let's look into that, how we will create a constructor. To create a constructor, we are going to use init method, and the syntax to create the init method over here is you need to specify def, and then you need to use double underscore, and then init again double underscore. So this is the special syntax, and over here you need to specify self keyword and along with the parameter which you are going to pass whenever you will create an object of this particular class. So over here we are having four properties which we are going to assign whenever a new object will be created. So we need to specify over here what we are going to pass. We are going to pass employee ID, the name of the employee, gender, and the age. And over here we will assign it. To assign it, we can access these values. These are the private variable. So to access this variable, we need to specify self keyword dot underscore underscore ID, and over here we will assign the employee ID which we are passing whenever we are creating the object. So again we need to specify over here self underscore underscore name equal to name. Another variable, another properties you can say we are having is the gender, and gender over here we will specify like this. Same is the case with age. So here age equal to age. So now whenever we will create an object, so these value we need to specify, and these value get set within these private variables. So this is one of the way you can initialize the object with the values. So now the next step, we are going to introduce one behavioral function within this class, and that behavioral function is show data. So employee information, we can tell that. So we will specify show emp info, and this will print the detail about the employee. So how we will create it? So let's look into that. So as I already said that it is a part of this particular class, so we must have to specify a special keyword so that it will understand that this is a method within this class. So you need to specify self over here, and after that we will print all these information which we have passed through the object. So how we can print it? So let's format some of the print statement over here. So we need to specify print. First thing we are going to print is the emp id. So type employee id, and then I am going to print over here colon. After that the information self dot underscore underscore id. Copy paste it so that we can save the time. Control V, Control V, Control V. And this time here we will tell that name, here we will tell that gender, and here we will tell that age. And same will be replaced over here. Same is the case with gender, and same is the case with age. So this way we have defined this particular method within the class. Now the next step, so we have created a class called employee. Now in the next step, what we are going to do, we are going to create the object of this particular class. So first shift enter, so that we have created a employee class. So now let's create an object of this particular class. So how we will create it? So it is also pretty much straightforward. So to create an object, you need to specify the variable name. I am going to create employee1 equal to, that is going to be employee class. And when we are creating the object, we need to pass the value of these particular properties. So we are going to pass some values. So here I am going to specify this value. This is my employee ID, and name is Oliver, and gender is male, and age
we can tell that 45 years. So now shift enter. So an object is being created. Now let's check the type of this particular object first. So let's type it emp1 here type. So let's look into that what type of this object is. Shift enter. Then you will see that here this object is a type of employee which we have created. Now this is about creation of the object. So now I want to call this method. So how we can call this method? With the help of object. So we will tell that emp1 dot type show. So the moment you will type show and click tab, then it will take the entire name of the method. So now you can put the parenthesis to call this method and shift enter. Then you will find that it has printed all the information about the employee. So this is the beauty of class object paradigm, or say object oriented programming paradigm, where you can create your own data type, like we have created employee as our custom data type, and this data type contains some properties and some behaviors. So with the help of method we are defining some behavior over here, and with the help of these private variables we are creating the properties. So this concept is very important whenever if we are going for data analysis or any kind of a machine learning or say data science learning. This comes very handy. We need to create so many classes while designing the models. So we must have good understanding about this particular programming paradigm. So that's the reason I wanted to introduce classes and the object in Python. And this is what I wanted to demonstrate over here. And this is our last session of part 1 of this course, that is Python refresher sessions. From the next part onwards, we are going to look into NumPy core concept for data analysis. NumPy is one of the important package within Python which we will be using within data analysis. So we must have a thorough understanding about the NumPy package. So that's the reason I have kept it into this course. One of the important point which I wanted to tell you about the NumPy is the package which we generally used for array manipulation. So there are many concepts within array manipulation which we will look into in the part 2 of this course. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care.
Hello guys, welcome to another session. In this session we are going to look into what actually NumPy is and why to use NumPy. This session is mainly going to be the conceptual session where we will try to understand the concept of NumPy, and once we understand the usage of NumPy, then it is very easy to understand that how to leverage this library for data analysis. So let's jump into a diagram where we will start our discussion. So we are into the diagram, and this is the diagram of an array. So before going into the formal definition of the NumPy and their usage, I wanted to tell you in a very simple line that NumPy is related to the array operations. We are using NumPy for array operations. So you should remember that whenever anything related to the NumPy is coming, so it is related to the array operations. So now let's start with the formal definition is, so what actually the NumPy is. So NumPy is a fundamental computing library for Python. NumPy supports n-dimensional arrays and provides simple and efficient array operations. So you must be wondering and asking that if there is a Python, then why should I use NumPy library for numerical computation? So to answer your question, I would say that Python was not initially designed for numerical computation. That is because Python is interpreted language and it is slower than compiled language like C. So now you must be asking that how C language coming into the picture. So then I will tell that NumPy is a library of algorithm written in C language which stores data in a contiguous block of memory. So that means if it is written in C language, so arrays of NumPy uses very much less memory compared to built-in Python sequence. In the upcoming session, I will demonstrate that there are various other advantages of using NumPy arrays, like NumPy arrays provide efficient multi-dimensional array operation both memory and computation wise. It provides fast mathematical operations on entire arrays without need to use loops. And in the upcoming session, we will look into various examples. Another feature of NumPy which makes NumPy very powerful, is that it provides various support for scientific calculation. Like if you want to calculate linear algebra, or say if you want to perform linear algebra operations on array, you can easily do it. Even you can also perform a statistic operations like mean, median, mode, that we are going to use in our data analysis session when we discuss about the exploratory data analysis steps for feature creations within data analysis. Then on that time we are going to use features of NumPy, which is mainly for statistics. You can also do calculation of Fourier transformation like mathematics very easily using NumPy. So these are some of the usage of NumPy. So this is about quick introduction of the NumPy and their usage. In the upcoming session, we are going to look into array types. That is a revised session of my earlier course, but I am going to introduce it again so that everyone will be on the same page while doing the lab on NumPy. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome to another session. In this session we are going to look into arrays. I'm hoping that you are aware about this topic, but again I wanted to revisit this topic so that we all be on the same page. So let's jump into the Jupyter Notebook to get the understanding about this topic. So we are into the Jupyter Notebook. Now the question over here is what actually the array is. So if you go by a definition, then array is a data structure that contains a group of elements. Typically these elements are all of the same data type. So that means either you can store integer values or a string values. So now the question over here is why we actually use arrays. So arrays are commonly used in computer program to organize data so that a related set of value can be easily stored or searched. So this is about the formal definition of an array. But how actually it look like? So let's look into that. Suppose that if we are creating an array called fruit ball, so how does it look like within a memory? So the diagram which I am going to present, which is a representation of the memory whenever if we are creating any fruit ball array, so how it is being stored within memory. So let's look into that. So here I am using a Ipython display package which contains this image module. So I am going to use it. So you need to write, you can also use it, and over here you need to specify file name. I have already created an image to represent this, and I am going to call this image, and for that I need to specify over here the name of the image is 1D array dot jpeg. Shift enter, then you will find that this image gets displayed. So now let's discuss about the concept. So whenever if you create any kind of array variable, so this is the representation within the memory. For example, if you have created an array variable called fruit ball, which we have used earlier in our refresher section. So whenever you are creating, so the array is being created like this. It is into the contiguous memory location, and it contains two information. One is the indices, another one is the element. So indices is the position of the array. For example, if you want to access the apple, so you need to access like fruit ball and the 0th element. So this will return us this element. So this is the representation of array within memory. I hope you must be aware about this thing, but I wanted to again revisit this topic. So this is the representation of 1D array. In next session, we will look into how we can convert a Python list as an array within NumPy. So this is about 1D array. So now what is the case if you are storing information within 2D array? So how it is being represented? So let's look into that. For that, I am going to copy this one, and I am having another image for the same, that is called 2D array. If you will shift enter, then you will get the representation of the 2D array. So within 2D array, you will find that we have two axes.
The first axis is zeroth axis and the second one is the axis 1. Zeroth is representation of the row. If you want to access the row value, then that axis is called axis 0. And if you want to access the column, then that is being represented as axis 1. In the next session, we will also look into how to create 2D array within NumPy. So you have to just remember that whenever we are discussing about 2D array, so that means it is the representation of row and column, and data is also being stored within memory within contiguous block. So now let's look into the another type of array, that is the 3D array. So let's look into that. So how the data is being represented within 3D array. So it will be look like this. Here I will replace 3D array. Then you will find over here something like this. So here you will find that there is three axes. One is the zeroth, another one is axis 1, and third one is the axis 2, and it contains more complex structure. One thing you should remember that within memory we can keep n-dimensional array which can be easily handled through NumPy, that we will learn in this part too. So you must be asking that why actually it is needed to keep the data within array. I have already mentioned that whenever if you are organizing your data within array, then it is very easy to sort the data as well as to search the data. And you all aware that the digital information will be kept into the matrix form, and matrix is nothing but a representation of an array. If you are going into deep learning or machine learning where you are doing some of modeling for image analysis, then on that time the data is being stored within the memory as an array, and that data is being stored in multi-dimensional, and that is not limited to 2D and 3D. It contains more than that, that can't be represented through the direct visualization like this. So there is different technique which we will learn when I will come up with machine learning as well as deep learning course. There I can explain the details about the machine learning modeling as well as deep learning modeling. For a time being, you have to just remember that array is one of the efficient way to hold the data within the computer memory so that we can easily perform various operations on those data, and we can easily analyze the data and get the information from those data, and with the help of the extracted information we can easily take the decision for a specific problem. So that's why array is being used within data analysis, so that we can easily perform various operations to extract the information from the data. So now let's proceed further and let's discuss about some of the important concepts within array. So first we will look into what actually the indexing as well as what is slicing. So let's discuss about that. So first the topic which we are going to discuss about is indexing and slicing. So what does it mean? So whenever we are talking about indexing and slicing, that means extracting the subarray from the given array. So what does it mean? So let's look into the pictorial representation. Shift enter, and over here I am going to again use the image function, file name, and I am having a file over here, file name indexing and slicing.jpg. Shift enter. So then you will find that we have an array called data where we are containing three elements, and at position we are having the element 1. So if you want to extract the element 1, then you need to access like this. You need to specify over here which element you want to extract. In this case we want to extract the 0th element. In the same way, if you want to extract the element of position 1, then you can extract it like this way. So it will be accessible with the help of indexing. So here we are accessing the element through indexes. So now moving further, so what is slicing? Suppose that if we want to extract the sub array from the given array, so we need to specify like this. If you want to extract the element from 0th position, you want to extract the 2 element, and over here you are specifying like that.
Same way, suppose that if you want to slice the array over here and you want to take out all the element from the position 1, and after that you will extract all the element after position 1. So you need to specify like that. In the first case of slicing, you see that you want to extract the two element starting from the 0th position, and over here you are extracting the element from the position 1, and after that you want to extract all the element from the position 1. So you need to remember this syntax. So this is about indexing and slicing. We will look into how to do indexing and slicing in NumPy in the upcoming session. In this session, I have just introduced the concept. Now let's proceed further. There is other concept which we are going to discuss is about aggregation. So aggregation is nothing but the operations which we apply on given arrays. So let's look into the pictorial representation what actually it is. So over here we are going to learn about aggregation. So what it means. So let's look into that. So I'm having an image for that. The file name is aggregation.jpg, aggregation.jpg. Shift enter. Then you will find that over here, if you are giving this array and you want to find out which is the maximum element, which element is having the maximum value, so you can do that with the help of max function. Same way you can identify the min, which element is the minimum value, so you can extract that also. There is other aggregation method that is called sum. If you want to sum all the values of the given array, then it will return the single digit value, that is a result of summation of these elements. So this is about aggregation. So that means we can apply aggregation operation on array. So now let's proceed further. Let's discuss about another concept that is called transposing of an array. So what actually it is, let's understand it. So first let me give the topic name. So we are going to learn about transposing. Shift enter. So let's look into the diagram what actually it is. Whenever if you are applying the transposing operation, then what will happen, you will come to know about this diagram. We will look into the actual implementation in the upcoming session. So over here we will tell that file name equal to, I have a file called transposing.jpg. Shift enter. Then you will find that if you are giving an array called data and it is being represented like this, over here the row become column and the column become row whenever you apply the transpose operation on array. So you must be asking that why actually it is required to do such kind of operation whenever we are talking about arrays. This is because we are in a process to analyze the data and find the information within the data. So there are certain technique, by applying those technique, we are trying to identify the data within data analysis to grab the information from the data so that we can easily apply the data modeling on the given data. And once it is being done, then we can easily take the better decision from the extracted information. If you are not understanding all this concept, don't worry, we are going to do the data analysis very thoroughly in this course, in the part 5 of the course, that is exploratory data analysis, where we will learn about EDA with the help of real-time project. We are going to do a real-time project where we can apply all these techniques as well as exploratory data analysis workflow while learning the data analysis. So this is about data transpose operation. Now let's proceed further and discuss about reshaping. Reshaping is another technique by which you can manipulate the array to make it into a different shape and size, and that is also used for different purpose within the data analysis. But here the intention is to show you what actually the reshaping operation is and how we can do this. So let's look into that. So the thing which we are going to learn is reshaping of an array. So let's look into that. For this also I am having an image. How we are going to actually do this thing we will learn in next session. So this is just understanding of the concept I am reintroducing this concept, reshaping.jpg. Shift into. So reshaping means changing shape of an array. So over here you will see that we are having a data array which is looking like a list, but we have converted into two-dimensional array and we have represented the same data into different shape. Over here we have given the shape where we are having 2 rows and 3 columns, and if you look into another diagram over here, then you will find that we have reshaped into 3 rows and 2 columns. And if you will closely look into that, then you will find that the element remains the same, only the structure of the data gets changed. So this is another technique we use most of the time while analyzing the data.
So these are some of the important concepts which I wanted to revisit for arrays topic. From next session onwards, we are going to do various labs where we will do our hands dirty with the help of NumPy package, where we will perform various operations on arrays. We will learn about how to create arrays. We will do all these operations, whatever the operations which we have seen here. Along with that, we will look into some of the advanced concept as well in the upcoming sessions. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome to another session. In this session, we are going to look into ways to create arrays in NumPy. In our earlier session, we have already revisited the array concept where we have discussed about 1D array, 2D array and 3D array. We have also looked into what actually the indexing and slicings are, as well as we have discussed about the transpose operation. We have also seen aggregation on arrays, and we have also discussed about how to reshape the arrays. So these are the concepts which we have discussed on arrays. So now in this session, we will look into what are the methods available within NumPy. With the help of that, you can create arrays. So let's jump into the Jupyter Notebook and look into what are the ways we are having to create arrays within NumPy. So we are into the Jupyter Notebook and here we will start our coding. So first step, to use the NumPy, we have to import the package. So you need to write import NumPy as np. So this is the standard line you will find in many places whenever if you are learning Python, or whenever you see that any project is there and if NumPy is being used. So you have to specify like this industry standard say, or say this pattern you have to follow, where you can import the package, name of the package, and you can create an alias. If you are providing as, that means you are creating an alias for this package. You can press shift enter. So now that means the package is gets imported over here. It is still running. That's the reason you are seeing a streak over here earlier. Now it become 1. That means it is being loaded. So now the first step we are going to learn about here, we need to first look into create from Python list. Suppose that if we are having the Python list like list1, and this I want to use to create the NumPy array, for example 1 2 3 4. Now to create the NumPy array, we need to specify np.array, and here tab I will press np.tab, and here you will get that we are having a method called array, and we need to specify the list name list1, and we need to specify how much bit you want to allocate for this array. For example, if you want to allocate 16-bit integer, so you need to specify dtype equal to np.int16. So this way you are creating the array with the help of Python list. So if you will run it and let's assign into a variable, tell that NumPy array equal to this statement. Shift enter, and now if we will print NumPy array, then you will find that it will print. Now we will check the type. So how we will check the type? We will type
and within that we will pass numpy array, and we should print, and over here shift enter. Then you will find that it is a type of numpy.nd array, and it is one dimensional array. We will look into in next session how to identify the shape and the dimension of a given array. So that we will look into in the next session. So now let's proceed further. Now we will look into how to create multi-dimensional array with the given list, or say how to create two-dimensional array with the given list. Suppose that if we are already having over here list 1 and there is another list, I am going to create list 2, and this list contain another element like 5, 6, 7, 8. So we are having this list, and now I want to create two-dimensional array by combining these things. So how we can create it is pretty much very straightforward. So again you can use it, this statement, and this time you should specify list 2 over here, list 2, and here you can specify 2D. Shift enter. We got an error over here. So make sure that you should be specifying within a square bracket, else you will get the same error which I am getting over here. Shift enter. Now you will check that if we will print this one, let's print it and specify print and the name of the array, shift enter. Then you will find that you are having a two-dimensional array where we are having rows as well as the column. So now let's proceed further. Again, if you want to check the type, then you will copy this line, copy it, paste it over here, specify the name 2D, shift enter. Then you will find that it is a type of numpy and d array. That means n-dimensional array. So now let's proceed further. Now we will look into various method which is being used within NumPy to generate some arrays. So what are those methods? So we will look one by one. So the first method we are going to look into arrange, that is called arrange method. So let's write it, arrange method to generate NumPy array, shift enter. So now here we will generate the NumPy array with the help of np.arrange. So let's write it. We will have a variable over here, arrange array equal to, we will generate with the help of arrange. So if you will provide over here arrange, then you need to specify some value, or say better to specify the longer range. I am going to specify 50. So what it will do, it will generate a one-dimensional array from 3 to 50 numbers. So let's look into the output. Let me increase the size of this so that it would be easy for you. So now over here you can shift enter and then we will print it. So let's print it, arrange array. Now shift enter. Then you will find that it has created a one-dimensional array and it is starting from the range 3 to 49. So you should remember that whenever you want to generate an array for a sequence of number, then you can use this method. Now proceeding further and looking into another method of NumPy array that comes very handy. Suppose if you want to generate array of zeros, so how we can generate arrays of zeros? So let's look into that. So NumPy offers us, there is a method called zeros. So let's look into that. We will tell that zero array equal to np.zeros. We need to specify over here zeros, and within that you need to specify what is the dimension you are looking for to generate the array. So here you need to specify the dimension you want, 3, 3. That is, you want 3 rows and 3 columns for this array. Shift enter, specify print, and here you should specify 0 array, shift enter. Then you will find that it has generated two-dimensional array and each element is the 0 element. So this is the another way you can create the array with 0 element. Now proceeding further, same way, however, we are having zeros method, we are having the method called once. So once is used for to generate the array with value 1. So let's look into that. copy paste it, and you can say it over here, one array, and over here you need to specify ones, and this time I am going to generate 2 comma 3 and shift enter, specify the print one array, and over here shift enter again. Then you will find that it has generated a two-dimensional array where we are having 2 rows and 3 columns. So let's proceed further now. So now let's proceed further, and we will discuss about another method of NumPy which is also being used for array creation, but this time it is used for very special array that is called identity matrix. The attribute of identity matrix is that every diagonal element is having the value 1. So let's look into that. So we will tell that iArray equal to, and this time I am going to use a very special method that is called np.I, and I want over here 3. So let's look into that, how it is coming. Shift enter, and you should specify the print, and here I am going to print iArray, shift enter. Then you will find that each diagonal element in this array is 1. So this is the method which we use to generate the identity matrix. If you are not aware about the identity matrix concept, I will suggest that you should go to Google and search for identity matrix concept, which is part of matrix algebra, and revisit the concept, as matrix algebra we are going to use very rigorously in data analysis as well as data science as well as machine learning topics. So it is going to come in the upcoming session as well as the upcoming course. Anyway, let's proceed further. So now let's proceed further, and next thing which we are going to discuss about generating a equally spaced array within the NumPy. So what it means? So let's understand with an example. Suppose that if you want to generate an array within range of 1 to 5, that is going to be a decimal values, and you want to generate 20 elements, and these 20 elements is equally spaced. So how we will generate it? So there is a special method also given in NumPy that is called line space, that is called spell like this. So let's look into that. First we will write the variable equally space array, and this is going to be np.lin. Here e is not there, and you should specify lin space, and within that you have to specify the values. So first value is the starting range, the second value you have to specify from where to where, and how many elements you want to generate. So I am going to generate almost 20 elements, and this time I am going to press shift enter, and now let's print it. So let's print it e space array, shift enter. Then you will find that it has generated this number. So how we can verify that these numbers are equally spaced? So I'm going to use the matplotlib that is used for visualization of the data within Python. So this is the library which we are going to learn as well in our upcoming part of this course. For a time being, I'm just going to use one of the thing to demonstrate that it is equally spaced. So first we will specify import, and this time I'm going to tell that matplotlib dot, there is a special module available within this package. So you can tell that pyplot, and again you need to create an alias. I'm going to use it as pp, shift enter, and here we need to specify pp.plot, and within that we will specify the name of this array, e space array. Now shift enter, then you will find that it will draw a graph over here. So how you can verify that it is equally spaced? Then you will find that the range is going into the straight line. So that means the range which we have generated over here, that is equally spaced. So that means each point is equally spaced with each other. So this way you can also verify your generated array within NumPy. So now let's proceed further. What we will do, we will use another method within NumPy that is called random. So we are going to learn about the random method which will be used to generate the array. So let's look into that. So this is going to be NumPy random method. So it offers various methods to generate the array. So first random method which we are going to use to generate the normally distributed random numbers with a mean of 0 and a standard deviation is the 1. So let's look into that how we will do this. So let's look into that. So first what we will do, we will tell that normally distributed array, and this time I am going to use np.random.rand, that is rand, and over here you need to specify the length. So the length means you need to specify the specification for the matrices or say array which you want to generate. So 3 comma 2. So let's run it, and over here print it. So and this array shift enter. So you will see that it has generated 3 by 2 dimensional array where it has generated 3 rows and 2 columns 2D arrays. Now let's plot it and let's look into the shape, what kind of shape it is giving us. So you remember that how to plot it. As you know that we have already plotted over here. We have created a alias over here called pp for py plot, and this time we are going to use pp dot plot, and we will specify over here and this array shift enter. So let's look into that. So this way you can also plot this. So now let's proceed further. Within the random method we are going to, so now let's proceed further. We will look into another method within random module np.random module where we can generate the array within the range. So let's look into that. For example, if you want to create a random integer array, so how we will create it? So int array, and I'm going to use np.random.randint, and over here we need to specify the range. I want 6 to 11, and the size, the value is going to be in between 6 to 11, and the size I want 2 by 2 array. So here I need to specify row I want 2 and the column I want 2. Shift enter. Now let's print it how it is coming. So int array, shift enter, then you will find that it has generated a 2 by 2 array, and the value for this array is fall in between 6 to 11. If you will change it, for example, if it is going to change between 30 to 50, so that it will give us the range between 30 to 50. So let's look into that. Shift enter again, then you will find that it has given the value with between 30 to 50. So now let's proceed further. So guys, we have seen that various methods to create arrays. So I am stopping over here. In the next session, we will look into how to identify the dimension, shape, and strides. So what actually the strides is, we will look into. We will also understand that how we will get the dimension of an array whenever we are creating any array. So how we will identify the dimension. We will also discuss about the shape of an array along with the strides concept. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome to another session. In this session we are going to look into NumPy array internals. So let's look into the topics which we are going to cover in this session. So in this session, basically we will understand that how to know about what is the dimension of an array. Then we will also look into how to get the information about shapes of NumPy array. And at last we will also look into what actually the strides is. Strides is little bit complex topic. Initially you will find it difficult to understand it, but it is very important concept. That's the reason I brought it into this session. So let's jump into the Jupyter Notebook where we will understand with the lab. So we are into the Jupyter Notebook and we are into the same notebook which we have created in our last session, where we have learnt about how to create array within NumPy. Now I am going to use the same notebook for this session. So the first question we are having over here is what actually the dimension in array is. So in a layman term, I can say that dimension of an array is the number of indices or subscripts that you need in order to specify an individual element of the array. So what does it mean? For example, suppose that if you are having a 1D array or say a list, so I can tell that array 1D equal to, this is also known as list within Python. If you are having some element within that, and if you want to access these elements, so you need to use one indices. So what it means, so to access the first element you need to specify 0 as an indices to access this number 12. So shift enter, if you will print it, print, and over here shift enter, then you will find that it is returning us the number 12 over here. Same way, suppose that if we are having a 2D array, and just take an example of the above one over here, I am going to take this one. So take it and put it over here. So it is going to generate a 2D array with the range between 30 to 50. So shift enter. Now let's look into what it has returned so that we will access the individual element. So shift enter, then you will find that it has returned us these element. Now suppose if you want to access these element, the element 49, so how do you access? So to access this we need to access two dimensions, that means two indices. So you need to specify over here 0th position and again the 0th comma 0. So over here I am telling that can you please return me the element which exists at this position. So how we are accessing it? With the help of two indices. See here, and if you will print this, then it will return us the number 49 over here. So you will see that it has returned us number 49. So that is what the definition is saying. So this is about the definition of the dimension of an array. But here the question is, how do we get to know that what actually the dimension of a particular array? So to get it, you need to use a method which is provided within NumPy with the array. So for example, suppose that if you are having a 1D array, you just take it, copy it and paste it, and there is a method called ndim. But prior to using this, you should make sure that you are going to convert it as a ND array, because it is a list over here. I have just created a list. I haven't converted it as an array, which you supposed to convert it first into NumPy array and then you will use it. In the last session I have showed you. So to create the list as an NumPy array, so what you need to do, you need to specify over here. I'm going to create a variable 1D array, and over here I will specify np.array, and within that I am going to specify the name of this list and what kind of value it is going to store. It is going to store dtype equal to int16. It is a 16-bit. I am going to cover this one in the stride section, the int16 in more proper manner, as it is basics of computer, but still I will cover in this session. So let's do shift enter. I forgot to mention over here it should be np.int16. Shift enter. Now it has taken. Now if we will apply over here, just take this one and put it over here. Shift enter, then it will return us the dimension is 1. That means you can access the element with one indices as per the definition of dimension of an array. Now moving further, Suppose that if you are having this and you want to get to know about this array, what actually the dimension is, you can easily know it with this property and dimension. Sorry, earlier I have mentioned about it is a method. It is not a method, it is a property. So I apologize for that. So it is a property. So now to get to know about what actually the dimension of this, so it is pretty much straightforward. I have already mentioned, so you can copy this one, put it over here, and here you need to specify the name of an array and it will return the dimension. Shift enter and you will see that it is a 2D array because we are accessing the element with 2 indices. Now let's proceed further. The next thing is what actually the shape is. What is shape? So shape is nothing but a number of elements exist within each dimension. So let's understand with an example. For example, earlier we are having a 1D array, and if you want to get to know about the shape, then let's look into that, how to get the shape. So there is another property available that is called shape. So let's write it, array 1D array dot shape, and shift enter. Then it will return that we have 3 elements at row level. So if you will look over here, it is a list. We have converted it into a 1D array with the help of np.array function, and now it is telling that we have a single dimension array and which contains 3 elements. Now let's proceed further. Let's look into the shape of array 2 dimension. So here we will mention 2D dot shape. Now let's look into the output, what output it is returning, and you will see here it has returned 2 elements at row level and 2 elements at column level. So this way you come to know about what actually the shape is. So now we have understand about what actually the dimension is and what actually the shape is. Now I am moving further and we will look into a stride. A stride is little bit complex concept. If you are not understanding in a first instance, that is perfectly fine, but I will try my best to make you understand. So first understand with some basics. Suppose that if we are having an array, a stride array, I can tell it, and over here, and we are having 2 lists. I am going to create an array with 2 lists, and within that over here I will specify 2 lists over here. So over here I will specify 1, 2, 3, and then we have another array that is 4, 5, 6, and that is also inside to another list. And now I am telling that the D type should be np.int16. Shift enter and make sure that you are specifying comma over here, else you will get the same error. So now over here I am telling that the element will occupy 2 bytes of spaces within the memory. Why it is 2 bytes? So let's go back to the basics. Over here you already know that 8 bits equal to 1 byte, and here what we are specifying, we are telling that int16, that is if you divide 16 by 8, then you will get 2 bytes of information. So here we are telling that each space within the memory, within the data buffer is basically the term which is used within NumPy where we keep the actual data. So here we are specifying each space, each element will take the space of 2 bytes, that is called np.int16. Now this is one part of the story. Now the second part, first of all I will reiterate the point where I mentioned that within the memory the array is stored like this. That is actually wrong. Basically within the memory the data is being stored as homogeneous and the contiguous block. So how does it look like? Let's look into that. So it will look something like this. So all the array will be look within the memory as a contiguous block. So see here within the memory it will be stored as like this, how you are seeing in this diagram. Now the question over here is how you can access the element from one position to another position. For example, if we are at position 0 0, if we consider if the first place is 0th position and you want to access this element, then how much byte you have to traverse from this position to this position. So that you need to calculate like this: 2 byte plus 2 bytes, 2 bytes plus 2 bytes. So 8 bytes you need to traverse to access this position. So that means you need to traverse these number of strides to access this element. So now you understand that what actually strides is. So now you understand the definition of strides. Strides are the number of bytes you need to step in each dimension when traversing the array. I hope I make you understand what actually the strides is. So now let's look into in Jupyter Notebook how we can get the strides information about an array. So to access the strides, it is pretty much straightforward. So what we need to do, we need to specify the name of an array, and there is a property called strides. And if you will press Shift Enter, then you will come to know that what actually the strides value for the given array. As we are having 6 elements, so to traverse this entire array to the last element, we need to traverse 6 bytes in each dimension. For example, the last element we are having 3 over here. To access this 3, you need to access 6 byte. 2 plus 2 plus 2, that is 6 byte. Same is the case if you are traversing in this dimension to access the last element, so you need to traverse 2 plus 2 plus 2. So that's the reason it is telling that to access the last element of each dimension, you have to traverse near about 6 bytes. I hope I am able to make you understand what actually the strides is. If you have any question about strides, you can write me down. I will help you again to understand this concept. So on this note, I am stopping over here. This is what I wanted to demonstrate in this session. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another session. In this session we are going to look into data types and casting within NumPy. So let's start our discussion. If you are unfamiliar about the casting, then in simple term I can tell that casting is nothing but changing an expression from one data type to another data type. So in this aspect we are going to look into two types of casting. One is the upcasting and another one is the downcasting. But prior to discussing about the casting, we have to understand that the data types I have already covered in the part 1 of this course of Python refresher. But again I will iterate some of the point about data types. So whenever we are dealing with the numeric value without decimal, then we are referring it as an integer value. And when we are dealing with the decimal digit, then we are calling it as a float value. So now the question over here is why we are using 16, 64 and different kind of number over here. So to answer your question, these numbers are representation of the bits, how many bits we are going to occupy for a particular number. If we are telling it as a float 16, so that means 16 bit of a space we are going to occupy, that is bits representation within the memory. Same is the case with float 64. Here we are telling that we are going to occupy 64 bits of memory spaces. So here we are going to discuss about two kind of casting. One is the upcasting, another one is the downcasting. So what does it mean? So to understand it better, if you look into this diagram, then you can see that upcasting calls for a higher level of precision, while downcasting is causing us to lose data by reducing the precision. We will better understand with an example. So let's jump into the Jupyter Notebook where we will understand this. So we are into the Jupyter Notebook. Now we will look into example where we will create two different array, and when we concatenate two different data type array, then you will find that NumPy automatically upcasts the lower precision data type to higher precision data type, and this process is called upcasting. So let's understand with an example. Suppose that we are having an array, int array, and I am going to generate with the method which we have learned, that is np dot arrange. So this will give me integer array. Shift enter. We forgot to mention over here the numpy package, so we need to import it. Import numpy as np. Shift enter, again do it. Now it has generated it. Now let's print it. So let's look into that, what it has given us. Array. Shift enter. Now if we will look into the types, then you will find it over the array data type. So we will get it through int array dot dtypes. Shift enter. Dtype it is, sorry. So it is int32. Now let's create the float array, and we will get the help of np dot random dot uniform, and we will tell that from 0 to 5, and this will give us the float array. Shift enter. Let's print the array. So to print it, print float array. Shift enter. Then you will find that it has given us the decimal digit. Now let's look into what kind of data type it has. Float array dot dtype. Shift enter. Then you will find that it is a data type of 64. So now what we will do, we will concatenate these two arrays, and we will look into the third array is being automatically upcasted this array values into float 64. So let's do it. So to concatenate two arrays, we are going to use the numpy concatenate function, and over here concatenate, and within that we will specify float array comma, and this we are going to assign with concat array equal. Shift enter. Throws an error. I know what actually the error is. You should pass the tuple over here, so make sure that you have provided extra set of parentheses, then only it will take. Now shift enter. Then you will find that it will concatenate it. So let's print this array, what value it has occupied. So we will tell that concat array. Shift enter. Then you will find that it has both the values, the integer values as well as the decimal values. But let's look into what kind of data type. So all the values now stored as float 64. So let's look into that. So to do that, we will tell concat array dot dtype. Shift enter. Then you will find that it has automatically upcasted the concatenated array to float 64, and this behavior is called upcasting. So here you will see that we have extra precision added to the integer value due to upcasting. So that means there is no data loss. But whenever if we are going through downcasting, then there is a chances that from higher precision to lower precision we have chances to lose the data. So let's understand with an example. So what I am going to do, I am going to downcast this concat array to integer 64 so that it will lose the precision. Currently it has precision 64, float 64, and that is giving us the precision 64. So if we are converting it into integer 64, then it will lose the decimal points. So let me prove my point. So let's create a array called downcast, and I am going to store this concat array, which I am going to convert it as a integer 64. Earlier we have seen that numpy automatically converted it into from lower to higher casting, that is upcasting. Now I am going to decrease it from higher precision to lower precision, and to do that we are going to use as type. So there is a method called as type, and here I will specify I want to convert this from 64 float 64 to int 64, and the moment I will run it, then you will find that it will lose this precision values. So after decimal you will find that the data will be lost. So that is what I am referring. So let's print it. Downcast. Shift enter. Then you will find that the first value, the decimal value is gone. second value also we got only 2, third value also this, and remaining you will find that this is the same value. Here we have lose all the precision. Same is the case with this one. We are not having any decimal values, we are having the integer values, and that is of type integer 64. If you will look into the type D type, then you will find that it is a type of integer 64, and the process is called downcasting. So earlier we have seen that implicit casting, where we are going through lower precision to upper precision automatically, that is called upcasting. And when we are doing the downcasting, we need to explicitly do it with the help of as type. So just remember that as type we will use it for casting from one data type to another data type. Here we are casting from float 64 to int 64. So this is what I wanted to demonstrate you in this session. On this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another session. In this session we are going to look into slicing and indexing in NumPy arrays. So let's jump into the Jupyter Notebook to understand this concept. So we are into the Jupyter Notebook and we are going to learn first the slicing concept on 1D array, that means array with one dimension, and then we will also look into the slicing on multidimensional arrays. Once we understand that, then we will look into the indexing part. So first we have to understand that what actually the slicing is. So if you go by definition, then slicing is nothing but a way by which you can extract the sub-arrays from the given arrays. This we have already seen in the Python refresher section. Now over here we will look into how to do this in NumPy array. So let's start by writing some code. So we are going to import first NumPy as np, as it is one of the important steps. Now let's generate an array 1D equal to np dot. We are going to use a range method, and where we are going to create a one-dimensional array with 10 elements. So let's look into that, what it has generated. So print it array 1D, shift enter, then you will find that it has generated 9 elements. Sorry, I told 10 and I mentioned 9. So let's write it 10 over here, shift enter, shift again, then you will find that it has given us from 0 to 9 10 numbers. So now let's understand slicing with one example by performing one simple task. Suppose that if I will tell you to extract the even numbers from this list, or say from this array, so how do you can extract it? So here the slicing technique comes in very handy to extract the even numbers. So let me write that task is extract even number from one dimensional array ar1d, shift enter, and over here what we will tell that, we will tell that even is an array, and within that I am going to mention array 1d. Now to extract I am going to use colon and number 10. So this means that I want from 0 to 10th element, and I want second number after each number. So I will specify 2 over here. So let's look into the output, what output it gives us. So if you will try print even, then you will find that it has returned us the even numbers from this list. So here you saw that how we have sliced this array and extracted out the required numbers with the help of slicing. In this scenario I have extracted the even numbers. So here the point to remember is, you should remember the syntax. If you are specifying the square bracket, and over here you can specify that from which element to which element you want to extract. If you are specifying like that, that means you are telling that from beginning to the element 10 you want to extract the element after 0 you should extract 2, after 2 you should extract 4, then after 4 you should extract 6, and after 6 you should extract number 8. Suppose in case if you want to extract the element after every 3 numbers, then how do you do that? You just need to replace this number with 3, shift enter, then you will find that it has extracted the number after every 3 digits. So this is about one-dimensional slicing. So now let's discuss about indexing, one-dimensional indexing. So to extract the particular number from the given array, so how do you do that? So you need to specify the position. For example, if you want to extract this number 3 over here, so how do you do that? You need to specify over here 0, 1, 2, 3. So you need to specify over here array 1D, this is square bracket, and within that you need to specify the position of the element. Shift enter, then you will find that it has returned us the number 3, and the position of the number 3 is the fourth position. As it is started with the number 0, so we need to specify that. So this is about the indexing. Now in upcoming session you will find that negative indexing. So what does it mean? So negative indexing means reversing your given array. So let's look into that. Suppose that if you have a requirement to print the array in a reverse order, so that means it will start with 9 and it will print till 0. So to reverse the array, what you need to do, you need to specify array 1D and then you need to use double colon and -1. So this is the syntax of reverse your array. If you do shift enter, then you will find that the last element come to first and the first element went to last. So with the help of negative indices, you can easily reverse your given array. Now suppose that if you want to access the last element or second last element, so how do you do that? So again we will use the negative indices. So I am going to tell that I want to access the last element. So you need to specify -1 over here. Shift enter, then you will find that it has returned us the number 9. Same is the case. Suppose if you want to grab the second last element, you need to specify -2. Then you will find that it has returned us the second last element. You can do the same thing for third last, and however you want and how many you want from the last, you can just reverse it with the negative indices. So to extract the element, you should use the negative indices. So far we have seen that how to do slicing and indexing on one-dimensional array. Same we are going to do with multi-dimensional array. So I am going to create 2D array. So here first I am going to that is going to be multi-dimensional slicing and indexing. So over here I am going to generate a multi-dimensional array of 2 by 2 matrices. So to do that I am going to tell that array 2D, and over here I am going to take the help of a random module, random dot randint, and within that I need to specify the range from which to which I want to generate the array. So from 30 to in between 30 to 50 I want to generate the array, and the size I want is 2 by 2, 2 comma 2. Shift array, shift enter, and then if you print it, then you will find that it has given us a 2D array. So if you will check the dimension, then you will find that ndim, shift enter, it is a two-dimensional array. So now to understand the slicing on multi-dimensional, what we are going to do, we are going to perform some task like, so the task which we are going to perform, we are going to extract the rows information. First we will extract these values and then we will try to extract through the column wise. So that means 42 and 33 we will extract with the help of slicing. So how we will do that? We will specify the name over here, and within that I am going to specify colon and 1. So over here you will see that we have extracted the first row. Same if we will specify over here 2, then it will return us all the rows. Now to extract this this part of the array, so how do we do that? So you need to put the 1 over here and shift enter. Then you will find that it has given us this part of information from the array 2D. Now suppose if you want to extract the information as column wise, so how do you can use the slicing? So you need to specify array 2D over here, and within that you need to specify I want the element from 0 to 2, and over here we need to specify comma, and then you need to specify 0 colon 1. Then press shift enter, then you will find that it has returned us the information as column wise. So this is about slicing on multi-dimensional array.
So now here we will also talk about the indexing. Indexing we have already discussed that. Suppose that if you want to access the element 42 which resides at the 0th position, so how do you will access it? You need to specify array 2D, and over here you need to use two indices. The position of element 42 is 0 0. So if you press shift enter, then you will find that it has returned us the element 42. So now can you tell me that how we can extract the element 34? So the easiest way is, so we need to use the minus indexing, that is negative indexing. So I am going to tell that in the last dimension go and extract the element 0, and element 0 is 34. So here you need to specify the negative indexing. That means you are telling that in the last dimension you go there and give me and return me the element 0. So it will return us element 34. So here you will see that it has returned us number 34 from the last dimension, which is a 0th position within this array. So one of the easiest way to learn this indexing and slicing is that you should experiment it. So now suppose you want the last element from the last indexes, so you need to specify the negative number over here, shift enter, then you will see that it has returned us the last element, that is 44 from the last dimension. So this way you can easily learn with the trial of many experimentation. So on this note, I am stopping over here, but prior to closing this session, I want that you should generate the three-dimensional array and perform all these exercises whatever we have done over here. So how you can generate the three-dimensional array? So you should come here, and here you should specify 2 3 4, and just increase the range over here. You should tell that I want to generate the number between 30 to 100. So this will give us three-dimensional array, and over here if you will check now, you can print that, then you will find that it has given us the three-dimensional array. You can check the dimension as well. As I already mentioned that why it is three-dimensional array, because we need to access the element, we need to use three indices. So you can try all this slicing and indexing technique on this bigger dimensional array. Once you do that, then it would be easy to understand all these concepts. So try to apply these concepts on bigger arrays. With these exercises, you can easily learn the concept of slicing and indexing on NumPy arrays. So now I am stopping over here. See you in the next session. Till then, bye bye. Take care.
Hello guys, welcome to another session. In this session, we are going to discuss about NumPy array operations. So let's jump into the Jupyter Notebook, where we will understand all those operations which we can do on NumPy array. So we are into the Jupyter Notebook. Now let's start with creation of new axis. That means how we can create a new dimension on NumPy array. And we can achieve this with the help of np.newAxis. So we can tell that there is a method which we use, that is called np.newAxis. This we will use to create new dimension of size 1. So here first let's import it. Import NumPy as np. Now next we will create a list. For example, we are going to tell that list1 equal to, and we will provide some value over here, 1, 2, 3, 4. So this is the value we are going to keep in this list. So as we already know that to convert this list into an array, what we need to do, we need to use the np.array. Here we will specify NumPy array equal to np.array, and within that I will pass the list1. Shift enter. Now to check the type, what we will use type method, and over here we will specify NumPy array. Shift enter, then you will find that it is a NumPy ND array, and list1 is the list. So that also you can check it, type, and here you need to specify list1, shift enter, then it will return as a list. This we all know about it. Now suppose if you want to get the shape of this array, so how do you check? So you need to specify NumPy underscore add dot shape, then it will return us this shape. Now suppose if our requirement is to convert this as a row vector, so how we can do it? Then how we can do that? So to do it, what we need to do, we need to use something called np.newAxis. So let's create the row vector and then we will check the shape. So row vector, and what we need to do here, we need to specify the numpy dot add square bracket, and we need to specify colon over here and comma, and then here we need to specify np.newAxis. So that means we are telling that we want to create an axis over here of dimension size 1. So let's put shift enter, press shift enter, and now check the shape, what shape we got for row vector. So if you will do row vector dot shape, then you will see that it has created a new dimension, and that is row vector. So let's print both of the array. One is numpy array as well as row vector, and let's find is there any difference. So let's print numpy array, shift enter, and now let's print row vector. So let's look into the difference. Then you will find that it has created each element as a row. So this is about row vector. Now suppose if you want to create a column vector, so that each element of this particular array is represented as column vector. So how we can do that? We will use the same syntax, but this time what we are going to do, we will change the position of np.newAxis. I will call it as col vector, and this should, we will remove this one and it should come over here. If you will come, and then over here you need to specify comma and then colon, shift enter. Now let's check the shape of this column vector dot shape. Now this time you will find that we have one row and 4 column. Earlier what we were having, 4 rows and 1 column. So now let's print it. Let's look into the difference. So over here, if you are going to print, then it will give us this output. Shift enter. Now you will see here we have 4 column 1, column 2, column 3 and column 4, and over here we are having 4 rows. So this is about new dimension creation within numpy array. Now next we will look into reshape. So reshape is very important whenever if we want to change the shape of particular array. Suppose if you are having an array with one dimension and that we have created with a range function, and we are telling that we have 15 elements over here, and if you will print that, then you will find over here we have this one dimensional array. Now I want to change it as two dimensional array. So how we can do that? So I can tell that array 2d equal to array dot reshape. There is a method called reshape, and here we need to specify that I want to create 3 rows and 5 columns. Over here I need to specify, shift enter. Now let's print array 2d, shift enter. Then you will find it over here we have 3 rows and 5 columns. If you check the dimension of this array, then let's look into that, what it is returning. Just print it over here, print array dot ndim, shift enter. Then it has returned us one dimension. If you will print array 2d dot ndim, then it will return us 2 dimension. So this way you can easily manipulate the shape of an array. So now we will discuss about the arithmetic operation on numpy array. So let's first create two arrays. Array 1 equal to, we are going to use np dot random dot rand int, and over here we are going to tell that we want in the range of, I want to generate number between 1 to 10 and of size 3,3. Shift enter. It throws array because I forgot to mention equal to, shift enter. Now let's print it, array 1, shift enter. So it has returned us this number. I am going to generate another array as well. So array 2, and this time I want in between 10 to 20. Shift enter. This also we will print it. Array 2, shift enter. Then it has given us this number. Now let's start with addition. Now suppose if you want to add these two arrays, so how you can do that? It is pretty much simple. Use np.add, and over here you need to specify array 1 comma array 2. Shift enter. Then you will find that it has added all the elements with their respective position and given us this output. So how does it perform the operations of addition? From the array 1, it has taken the element which exists at position 0. So it has added to the array 2 the element which exists at position 0. So the output is over here 15 plus 4 is 19. And with their respective position they have added each element. Same way you can use something called np.subtract. Then you will find that it has returned the output. Now let's apply the multiplication. Same way we are having a multiply function. So here you need to specify array 1 comma array 2. Shift enter. This way it has returned the output of multiplication between two arrays. There is another method available, that is for division. So let's use it, divide, and over here you need to specify array 1 comma array 2. Shift enter. Then it has returned the decimal digit, and it is the result of the division. Now let's talk about the other operation, that is dot operation. Dot operation is mostly used operation within NumPy when we learn machine learning. So there is dot operation you can do, dot, and over here you need to specify array 1 comma array 2, and now you will do shift enter. Then you will see that it has calculated the dot product on two arrays. So this is about arithmetic operation. You can also evaluate the expressions on array. So let's look into that. Suppose that if you are having an expression x1, that is our one array, x2 minus 5 multiplied by x2 plus 30. This is our expression, and we want to evaluate this expression. So how we can do that? And I want to evaluate on these two arrays. So given this equation, so what we will do, here we will specify for x1 I am going to use array 1 multiplied by array 2, and over here minus 5 multiplied by array 2 plus 30, and this value I am going to call it as answer array. I am going to store over here. Now this way you can evaluate as well. So let's print the output answer array. Shift enter. Then you will find that this is the result of the evaluation, and this formula is being applied on each of the individual elements in both the arrays. So such kind of operation you can also perform on NumPy arrays. And on this note I am stopping over here, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another session. In this session we are going to look into broadcasting concept within NumPy. So let's jump into the Jupyter Notebook to understand this concept. So we are into the Jupyter Notebook. Let's start our discussion. In our earlier session we have discussed about arithmetic operations on array, and where we have performed various operations like addition, subtraction, multiplication, division, as well as dot operation. And when we are performing these activities, or say these operations, we are making sure that the size of both the array should be similar. If you will not keep the size of both the arrays similar, then you will get the broadcasting error. So what does broadcasting means? So broadcasting is a technique which NumPy uses. Suppose if you are having a bigger array and a smaller array with a scalar value, then what NumPy do internally, it should replicate the scalar value into a smaller array and make the scalar value as the similar size like larger array, and then perform the arithmetic operations. So let's understand with an example. Suppose that if you are having an array called A, I am going to make it simple with a single dimensional array, and here if you are specifying range 5 and print that array, shift enter, and size we can also print size and shape as well, shift enter, then you will find that it has returned both. So let me print this as well, print, shift enter. Now suppose that if you are having another variable called b and which is a scalar value. Now as per definition, when we try to add the array a with this scalar value, it should fail, but you will find that this is not going to fail in case of numpy. Why? Because numpy takes care of broadcasting internally whenever such operations comes in place. So let's look into that. So let's try to do the addition of two different size of variables. One is an array, another one is the scalar value. So let's do it, and over here you will pass a comma b. A is an array, b is a scalar value. Shift enter, then you will find that it has added to each of the element this value 2. So what happens internally? So the thing what happened over here, internally numpy created another array. For example, what it does, it has taken this value and internally it has converted it into something like this. It has repeated 2 comma 2 comma 2 or 2. So it has 5 elements, so it has also replicated the same value within the memory as a single dimensional array and make it of the similar size, and then afterward what it did, it has performed the addition operation over here. So what it does, it has, so let me control set so that, and over here what it did, it has converted into something like a0 plus b0 comma a1 plus b1 comma a2 plus b2 and so forth. So this way it has done the addition and then it has returned the result, and this technique is called broadcasting. So numpy automatically do the broadcasting, but there are certain limitations when using the broadcasting. It will not work with every cases. So there are certain rules which must be satisfied for broadcasting to be performed, and the rules are: broadcasting can only be performed when the shape of each dimension in the arrays are equal, or one has the dimension size of 1. So here one point to remember, whenever you do the broadcasting, so internally numpy first matches the columns part and then check for the row part and then do the broadcasting. So what does it mean? So let's look into an example over here. So this time we are going to use the two-dimensional array. So over here we need to specify a equal to np dot random dot randint, and over here I'm going to use 1 to 10, size equal to 2 comma 2. Shift enter. Now another array a comma np dot random dot randint, and 11 to 10 20, make it 30. Size equal to, this time I am going to keep it as 1 comma 3. Now let's try to add it. So we got error due to typo. Shift enter. So now let's try to add it and let's look into the output. What output we are going to get? Shift enter, and the moment you will do that, you will get the broadcasting error. Why? Because the dimension is not same, and as per rule the last dimension should match. That means the column part must have to match, then only it will work. Now if we will change from 3 to 2, and when you try to run it, then you will find that it will run. Why is it so? Because this is the broadcasting rule which NumPy supports. The column part should match always, then only broadcasting will work, even though it is having one row and two columns. That is not similar to the size of the array A. So let's print it. Print a dot shape, shift enter, and also we will print the size, a dot size, and here you will find that we have different shapes, and for this also we have different shape. So let's take this and paste it over here, and this time we are going to use B over here, B, shift enter. Then you will find that we have different shapes for both the arrays, but this time it worked. Why? Because this is the rule where size of the column vector should match, and this time it is matching it. This one is also 2 and this one is also 2, so it is satisfying the broadcasting rule which NumPy performs while executing the broadcasting. And this is what I wanted to demonstrate you in this session. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another session. In this session we are going to discuss about vectorization concept. So let's jump into the Jupyter Notebook, and there we will discuss about the concept, and we will also do some example, and with the help of that example we will understand the vectorization concept. So we are into the Jupyter Notebook. Now let's start our discussion. So what is vectorization and what is the purpose of vectorization? Why should we can use vectorization in NumPy? So guys, basically vectorization is used to speed up the Python code without using loops. So what does it mean? So let's understand with a simple example. Here I am going to first import NumPy as NP, and now I am going to generate two arrays. One is called A, and here I am going to take help of a range function, and over here I need to specify a range over here. For example, I'm going to specify 0 and 5, and there is another array which I am going to generate, and I want to add both of the array. So how do I can add it? So if we will go through the loop, then what will happen? It will iterate through all the elements from array A and from array B, and then do the addition operation. So let's do it with the normal way of addition. So how do you will do that? So let's create an array for holding the result, and over here we need to do a loop. For that we are going to use for I in range, and over here we need to specify the length I want. It will execute till the all the element is being read. So length of an array A, and over here we need to do the addition, and that result will be kept inside the result array. So that we will tell that res append, and over here we need to specify over here then B. Within that I'm going to specify I, so all the same position element is being added. After that, this is basically a Python list, so we need to convert it as an array. So we need to tell that np.array, and within that we need to pass this list. So now it becomes the array which is of NumPy. So now let's execute it. Shift enter, then you will see that it has added both the array with their respective position. For example, at the 0th location it is having 0, and 0 plus 5 is 5. So let's print it so that it will confirm print A, and over here print B. Now shift enter, and if you will add both the array, then you will get this result. But the problem with this operation, it is very time consuming. This array is very small, but when you are going for data operation, which is basically in machine learning or any of the data analysis which you are performing on any of the array, then this operation is very costly affairs. I will show you the performance difference, but first let's look into how we will do the same operation with the vectorization technique. So NumPy offers us various methods and that we can easily use to perform such kind of calculation. For example, if you want to add two arrays which is of similar size, then you just need to add A plus B, and it will perform the same activities whatever you have done with the help of this loop, and you do that. And over here let's print the result also. So first let's shift enter, then you will find it over here. It is returning the same value, and the execution time is drastically different. So let's compare it. So to get the execution time, we are going to use some magic function which I have discussed about earlier, that is called time it, and shift enter. Then you will find that it will return us this is the amount of time it has taken to execute this program. And now let's look into what is the time it is being taken to execute the vectorized operation. Shift enter, and you will see the difference that is drastically lesser than this loop 1. And here you will see that the loop 1 is taking 1.87 microsecond, and instead of that It is just taking 738 nanosecond. By the way, if you are not aware about the microsecond and the nanosecond, the microsecond is 1000 times of nanoseconds. That means 1 microsecond equal to 1000 nanoseconds. So we can perform any kind of mathematical operations on two arrays without using the loop. Earlier we used to do this operation with the help of loops, and that is very time consuming. But within NumPy it has given us the flexibility so that we can directly use the normal operator on the arrays, and that will perform the required operations. Suppose if you want to perform the multiplication of two arrays, then you will get something like this. So what it did, it has multiplied the zeroth position of A array with the zeroth position of B array, and same for the other element. So it multiplied 0 into 5, that is 0, 6 into 1 6, 7 into 2 14, 8 into 3 24, and 9 into 4 36. And if you see here, it has returned the result. Same thing, you can apply the division operation, and this is all the vectorization technique, and that is being used within the NumPy. And if you try to do the same operation in normal Python, then you will find that instead of doing the addition and all this, what it will do, it will just concatenate the list. For example, suppose that if you are having a list called C, and here you are having some element 0 1 2 3 4, and the same if you are having C and D, let's paste it D, and this time you are having 5 6 7 8 9. And now if you try to add these two lists, then you will find that instead of doing the mathematical operation, it is just doing the concatenation operation. So let's look into that, and you will find that it did the concatenation instead of mathematical operation. So that the reason it is very much powerful. NumPy is very much powerful because it offers us vectorization concepts implemented within the NumPy, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to part 3 of this course. In this part we are going to learn about pandas, that is basically pandas for data analysis. So let's look into the topics. What are the topics we are going to cover in this part? So we are going to discuss about how to create data in pandas. Then we will also learn about how to read data in pandas. At step 3 we will look into how to do writing of data in pandas. Once you are comfortable with the step 3, we will proceed further and we will discuss about data indexing in pandas. Once you learn the data indexing in pandas, we will also look into the selecting technique as well as assigning data in pandas. At step 6, we will look into how to do various mapping on data to get the data insight within the given data. And this is really going to be very important topic, as we are going to do all these insight technique while doing the exploratory data analysis, which we will look into further part of this course. At step 7, we will look into some other data insight techniques like grouping and sorting that we will discuss thoroughly. We will learn about how to do grouping and sorting in pandas. Once you are comfortable with that, then we will learn the technique of handling missing values within pandas, as it is one of the important topic you must have to learn while doing the exploratory data analysis. Once you learn that, then we will proceed further. At step 9, we will discuss about renaming technique as well as how do we can perform combining operations in pandas, that we will learn through an example. And after finishing all this topic, I feel like you are pretty much comfortable with pandas, that we can use it for exploratory data analysis. So guys, one thing I wanted to tell you, that why I am following all this sequence, like we have started with the Python refresher, then we have learned about the NumPy, and now we are learning about pandas, as all these tools is the key tools for data analysis within Python. And I want to give you end-to-end knowledge so that you will get comfortable while doing the real-time data analysis. So on this note, I am stopping over here. In the next session, we will start with how to create data in pandas. So see you in the next session. Till then, bye bye, take care. Hello guys, welcome to the another session. In this session we are going to discuss about what actually pandas is and why do we use pandas. So basically pandas is open source library which will be used for data analysis that can also be used for data manipulation along with the data visualization. So you must be wondering that all these things is being possible earlier within Python, then why this pandas comes. So to answer your question, I would say that pandas makes lives easier for data scientists as it offers us various methods, various functions that was not so easy while working with data in a normal core Python. And this is where pandas helps and makes lives easy whenever we are working with data. And this is the course about data analysis, so that means pandas is must for learning the technique of data analysis, as pandas offers various inbuilt functionality to perform the data analysis task. And one of the major benefit of using pandas is it is being very good community support, and if you got stuck somewhere then you can easily ask within the community about your problem, and there are many people who are using pandas for data analysis. Pandas is also in active development. That means you are getting various new features going forward as well, and the best part is you get various documentation on pandas. And one of the benefit of using pandas is it is built on top of numpy, which we have covered in our last part. So that means whatever you have learned in numpy session, that is going to be applied over here, such as broadcasting, vectorization, all these concepts is being applied within pandas. Pandas also go well with the scikit-learn package that we will look into some other course while discussing the machine learning. Scikit-learn is also a Python package or say libraries which will be used to do the modeling in machine learning, and that will be really very helpful while designing the data modeling of structured data. If you're not aware about data modeling is a next step after data analysis within data science. So it is must to learn pandas if you are dealing with data on a day-to-day basis within Python. So now the next question is, you must be asking that how do you get install the pandas? And the good news is that if you have installed the Anaconda distribution, then it is coming with that Anaconda distribution. So you don't need to take any step to install pandas. And within this course, we have followed the same where we have installed the Python using Anaconda distribution. So on this note, I am stopping over here. In the next session, we will start with the labs where we will create the data within pandas, and we will learn some important concepts like data frames and series. So see you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session we are going to discuss about creating data frames in pandas. So let's jump into the Jupyter Notebook, and from where we will discuss about the data frame concept, as well as we will also know about how to create data frames. So we are into the Jupyter Notebook. Now the question over here is what actually data frames is. So data frame is one of the common way by which you can bring the data in the pandas context. So in this session, we will look into how we can create data frames with different mechanisms. First, we will look into how to create data frames using JSON data. Then we will look into how we can create the same data frames using list. Once we understand that, then we will look into how to create multiple column data frames. Then we will also look into the example where we will use list of JSON data, and that we will use to create the data frames. And at last, we will look into how we can brought in the CSV data within pandas with the help of data frame. So in that aspect, we will create data frame from CSV. So now let's start the exercise. So first we are going to do import of pandas library. To do that, I am going to insert by clicking B over here. It will give us this line to provide the input. So I am going to write import pandas as PD shift enter. This is one of the standard approach. Whenever you are importing pandas, you have to specify PD. How we were doing for numpy. When we are importing numpy, we were using NP. So for pandas case, we are going to use PD. So now it is being imported. Now let's look into how we can create the data frame using JSON. So here again I will press B, then I will get this line over here, and I'm going to first create the JSON data. So I'm going to use my favorite example, fruit ball. If you have been following my course, I'm very fond of fruits, so I'm using this as an example, and over here I'm going to keep a column called fruits, which will contains different list of fruits. So here I will specify within the quotes, I need to specify apple, comma, oranges, grape, banana. This is one of the column. Again, I am going to specify another column called price, and over here I will specify apple price is 100 rupees, orange price is 150 rupees kg, and grape, right, 200 rupees kg, 60 rupees. Now the next step, we need to use this JSON to create the data frame. So to create the data frame, we have to follow this syntax. So first click B over here, and then you need to write data frame. One variable we need to create, df JSON equal to, and over here we need to specify that pd dot data frame, and over here you need to specify the fruit ball JSON which you have created. Now shift enter, it throws an error, so we will specify the single quotes as it is a requirement from the JSON side. So you should keep the key value within the quote. Here I did a mistake in the spelling name. Shift enter. Now you will find that it has created the data frame. So let's verify it. Let's print the data frame over here. Print df JSON, shift enter. Then you will find that it has created a data frame. Let's check the type over here. Type df JSON, shift enter. So you will see it over here. It is a data frame. So this is one of the way by which you can create the data frame using JSON data. Now we will do the same thing, and we will create the data frames using list. So let's do it. Select this one, press B, then it will give us this one, and over here we will specify a list. We will call it fruit list, and we will tell that apple, orange, and grape. Shift enter, and here you should write data frame list equal to pd dot data frame, and within that you can pass fruit list, and over here you can print it so that we will look into what actually this data frame list contain. And you will see that here we have created a data frame, and this data frame doesn't contain any column name, but it contains the same tabular structure. Now suppose if you want to introduce another column in this data frame, so how do you can do that? To do that, you need to create another list. I'm going to tell that price equal to, and over here you need to specify 100, 200, and over here you can 300. And this time, instead of one list, I'm going to pass two lists over here. I'm call it as price, but you should make sure that you should zip it, else you will not get the multi-column data frame. We will tell that it is a list, and now do shift enter. Then you will find that it has created a multi-column data frame with the help of list. So here we have created a multi-column data frame with the help of lists, but here you will find that this 0 and 1 is not very intuitive, and we are not getting what actually it is. So we want a mechanism to specify the custom column name whenever we are creating data frame with the help of list. So to do this, pandas offers us different kind of data frame method, that is overloaded method, and this contains two parameter, and we will call it columns, and here we will specify the list where we can tell which column is having what name. So for example, 0th column I am going to tell that fruit, or say fruits, comma, and over here we will tell that price. Now press shift enter, and you will find that we have specified the custom column name whenever we are creating data frame using list. So now let's proceed further. So we have covered this exercise, creating multiple columns data frame. Now we can directly proceed to number 4, and we will look into how we can create a data frame using list of JSON data. So let's first create list of JSON data. So press B, and now over here we will specify list JSON, and within list I am going to create JSON. So to create JSON, we need to specify the curly braces. So you can specify some multiple curly braces. I am going to create 3 JSON data over here. So first one, fruit, and over here we will specify again apple, and this will contain also the price. So let's specify price, tell it 100, and take this data. I'm going to copy paste it and specify over here orange, and here specify the price 200 and again paste the same over here, and this time I am going to specify grape. Price is 300, take it any value. Now once it is being done, shift enter. So we have created list of JSON. Now the next step, we need to create the data frame and where we will use this list JSON. So press B over here, and now here we will tell that df list JSON equal to pd.dataframe, and within that I am going to pass list JSON. Let's print this data frame as well. Print df list JSON, shift enter, and you will find that we have created the data frame using list of JSON data. So this is one of the mechanisms by which you can create the data frame. So now we will look into how to create data frame from CSV. Suppose that if we are having some data and which is residing into the CSV, so how we can bring into pandas context. So let's look into that. So guys, to create data frame from CSV, what we need to do, we need to use read underscore CSV method of pandas. So how we will use it, let's look into that. Press B over here, and prior to writing any code, I wanted to show you where I am having the data. So guys, this is the location where I am having this file, which I am using it for the demonstration, and within this folder, exercise folder, we are having a data folder, and within that I am having this fruitball.csv. If you will look into that, then you will find that we have three entries over here, and the entries is same which we were using earlier. We are having two columns and their respective data, and I am going to bring this data within the pandas context with the help of read underscore CSV method. So let's close this one and let's jump into the Jupyter Notebook. So let's specify a variable name called dfcsv, and here write pd dot read underscore CSV, and here we need to specify the path. We are having the CSV file within the data folder, so you need to specify data, and within that we are having fruitball.csv, and here we can print the data frame dfcsv. Shift enter, then you will find that it had read this CSV data and it has made a data frame. If you will check the type, then you will find that it is a data frame. So let's check it type, and here you need to specify dfcsv. Shift enter, then you will find that it is also a data frame. So this way you can create data frame using CSV, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to this session. In this session we are going to learn about data frame basics. So let's jump into the Jupyter Notebook to see the topics what we are going to cover. So in this session we are going to load the data into the panda context, and after that we will check that how we can identify the shape of data frame. Once we know about this, then we will look into how we can check the top n rows within pandas. Same we can look into how we can identify the last n rows from the loaded data. Then we will proceed further and we will look into how to get the range of entries from the pandas loaded data. Once we understand that, then we will proceed further and we will look into how to get the column information from the loaded data. That we will look into the topic number 5. Then we will proceed further and look into the technique how to get only the specific columns from the large data set. Then we will proceed further and we will look into the type information about each of the column from the data which we have loaded. Then we will proceed further and we will discuss about some of the common operations on columns. Once we understand that, then we will proceed further and we will discuss about the describe method. It is one of the most important method while doing the data analysis. That we will also discuss. Once we understand that, then we will discuss about the conditional operation on column. Then we will proceed further and we will look into how to set index, and at last we will look into one of the important concepts for accessing the data within the data frame, that is LOC and ILOC, and we will also discuss about the difference between them. So now let's proceed further and let's load the data first, and then we will perform all these exercises. So let's load the data. So first we will select this cell and press B, then it will give us another cell, and here we will first import the pandas as PD. Shift enter. Now again here first we need to select this cell again and press B, and now I am going to create a data frame
called df equal to, and I am going to create a data frame with the help of read underscore csv method, and here I am going to specify the name of the file, and it is stored in a data folder, and the name of the file is wine.csv. So this is one of the data set which I am using. So this data set contains the information about different wine, and this information is representing the quality of the wine. So let's press shift enter. So it has loaded the data into the memory. So let's look into that, what actually the data is. Shift enter, then you will find that it has these number of columns, and which is representing a feature, and with the combination of these number of feature, it represents the quality of the wine. For a time being, you just forget about the problem statement, you just think about these are the data which represent the quality of a wine. So guys, from here onwards, now you will start getting the feel of some of the data analysis. So let's start our exercise. So select this cell, press B, and now to check the shape, we are going to use a property called df.shape and shift enter, and you will see it over here. It has returned this tuple which contains two information. One is 178, another one is 14. So this 178 represents the row information. That means the data, how many number of record it has total number of 178 rows. Now the number 14 represent the how many number of columns, that is the column information, and which is wine, alcohol, malic acid, ash, ACL, and all others. So now this way you can check the shape of data frame. Now let's proceed further. Select this exercise 2 and over here press B. Now to get top n rows, so you need to use a method called df.head. Shift enter, then you will get the top 5 record. By default this value is 5. If you want more than 5 value, then you can specify the number of record. For example, I want only 1. Shift enter, then you will get only a single record. Same is the case if you want only 10 records, then shift enter, you will get only top 10 records. So now let's proceed further. Now how we can get the last n rows, so let's look into that. Press B again over here and it will give us new cell. So to get the last n rows, we are going to use another method called tail method. Similar to head, tail is there, so you will get the last sum record. If you will write like this, shift enter, then it will give us last 5 records. If you want more than that, then you can specify the number. If I want only 10 record from the last, then it will give us these number of record, that is 10 record. So now let's proceed further and we will look into how to get range of entries. Suppose if you want to check what actually the entry in between from range 40 to 50, so how you can do that? Select this cell, press B. To do that, you need to write data frame name and the square bracket and specify the range over here like this, 40 is to 50. So that means you want the data from this range. Shift enter and you will see that it has returned us the record from 40 to 49. So to get the 50th record, you need to specify 51 over here. Shift enter, then you will get the record from 40 to 50. So now let's proceed further and we will look into how to access individual columns. But first of all, we need to understand that what are the columns available within the given data. To do that, we need to write something called df.column and it will return us all the columns which exist within this data. And now we want to extract only a specific column. So how we can do that? We can do like this. You need to specify over here something like this. First select this one, press B, and now here you need to specify df.column name. I want to access wine, so shift enter, it has returned us this column. Same way you can access with other notation, that is a square bracket notation, and over here you can specify within the quotes. Now shift enter, it will return the same value. So this is about selecting only a single column. How about if you want to access only these 3 or these 4 together? So how you can do that? So you can do that with this syntax. So over here you need to specify the square bracket, and again you need to use another set of a square bracket, and within that you need to specify the column names which you want to extract. In this case I am going to extract only these 4 columns and just do shift enter. Then you will find that from the given data set we have extracted only these columns, and if you want to do analysis on these 4 columns, you can do that as well. So now let's proceed further and let's look into how to check the column type. So to do that, we will first select the cell and press B over here, and over here we need to specify type and the name of the data frame and select the column. I'm going to select wine, shift enter, and you will see that it has returned us pandas_series. So basically each individual column is a type of series, and series is nothing but a list. You can consider it as a list, and within pandas context it is called as series. So now let's proceed further and we will look into some of the common operations which we perform whenever we do data analysis. This is just an example which I am going to give you because I wanted that you should aware about the method, which method we are going to use in the upcoming session while doing the exploratory data analysis. But with this example, I wanted to give you feel about the data analysis. So let's look into the data which we are having within the memory, and over here you will see that we have, so suppose that if I am telling you I want to get to know about which wine is having more alcohol content, or instead let's start with the simplest one. I want to know about what is the maximum value of the alcohol content. So how we can do that? Let's look into that. So we will also identify the minimum value of alcohol content, and I will also show you how to calculate the mean and the standard deviation of the quantitative value, or say of the quantitative column. So don't worry about if you are listening some new word like quantitative column and all this. I am going to cover all this in exploratory data analysis. For a time being, quantitative column is nothing but a numerical column. Wherever you are having the numeric value, that will be called as a quantitative column. So let's look into how to get the maximum value of a given alcohol content as well as minimum. Then we will look into mean and the standard deviation. So to do that, you should come here, select this cell and press B. So it will give us a cell. Now over here we need to write the data frame name, and here you need to specify the column name alcohol, and then you need to specify a method called max. Shift enter and it will return the value that is the maximum value within this particular column. So that means we are having a wine which is having the maximum value of alcohol content, that is 14.83. So now we got the maximum value of alcohol content, but we don't know which actually wine is maximum alcohol content. So how do you come to know about this? So let's look into that. We will press B over here, and within data frame I am going to check that df.alcohol double equal to, I am going to pass this condition, and I will take this statement and put it over here, and once I will execute this, so it will give us the name or say the number of the wine which is having this value, that is the maximum value. So do shift enter and you will see that, or say row number A is having the maximum alcohol content. So this is about the maximum. So how about the minimum? Suppose that if you want to check the which wine is having minimum alcohol content, so you specify min over here, shift enter, and you will see that the wine which is having the entry at 115, that is wine 2, which is having minimum alcohol content, that is 11.03. Same way you can perform many statistical operations like finding the mean. So what is the mean? So you will see that on an average it is having 13.006% of alcohol content. Same way we can check the standard deviation with the help of std method. Shift enter, then you will see that this is the standard deviation for alcohol column. So now let's proceed further and we will look into one of the important method, that is called describe, which will give us information in more descriptive manner. So let's look into that. So select this cell and press B, and this time I am going to use df, and here I will specify the name of the column alcohol, and then I will use describe. Shift enter, and then you will find that it has given us many information like how many number of rows we have, 178, what is the mean, what is the standard deviation, what is the minimum range, and what is the percentage detail, how many of the value 12 is falling in 25% range. Within 50% range we are having near about 13% of alcohol content wine, and same is the case with the 75%. It has also returned the maximum value. What is the maximum value within the alcohol column? So guys, while doing the data analysis, these information is very much important to answer many of the questions surrounding that feature
feature over here I am representing this column that is called alcohol. Same way, if you want to know about the malic acid is another column. So let's try with the malic acid over here. Press A. Let me get the name of that columns, shift enter, and there is called malic acid. Take this one, and instead of alcohol you can provide the malic acid. So the describe will provide the information about the malic acid column and these statistics from the malic acid column. In the upcoming part of the course, where we will discuss about exploratory data analysis workflow, where we will know about significance of these information while doing the data analysis. So now let's proceed further. Now we will look into how we can grab the information from the data frame with the help of conditional statement. For example, if you want to grab all the wine whose alcohol content is more than 12%. So how you can do that? Let's look into that. Select this cell, press B, and over here you need to specify the data frame name. And within that I'm going to apply the condition over here. I will tell that df dot alcohol equal to, and over here I will specify that, or we are performing greater than equal to. So we can tell that alcohol content which is greater than equal to 12. And now let's press shift enter. Then you will find that it has returned all the records whose alcohol value is more than 12%. So this way you can easily grab the information, and you will find that out of 178 rows, it returned 159 rows whose alcohol content is greater than 12. Suppose if you want to grab the information which is less than 12, so you should specify less than 12. Then you will find that it has returned us these number of rows whose alcohol content is less than equal to 12. So this way you can apply the conditional operation on data frame of pandas. Now let's look into the example for set index. Set index, I'm going to use another data set to explain you the set index. So over here I will press B, and this time I am going to use df1, and I will load the data from with the help of read underscore csv method, and this time I am going to use data fruit bowl dot csv. Shift enter, and it has returned the following information. So we are having these number of fruits whose price is this much, and it is also giving us information which fruit is in stock or not. So by default the index is the numeric value. Over here you will see that index is numeric value. Suppose if you want to make fruits as a index, so how you can make it? As it is a categorical value, but I want to make it as an index. So how we can do that? With the help of set index method. So let's do it. So over here press B, and this time I'm going to tell that df1 dot set index, and I'm going to provide the name of the column, and I want fruits should be the set index column. So over here you will see that fruit column is an index column and the numeric value went away. Now you can understand that we can easily set the index within pandas with the help of set index method. But you must wondering what is the use of this, and the benefit we will look into next example. In this example, suppose if you want to access the index with the name, so how do you access it? With the help of loc method. Here you need to specify that def dot loc, and here you need to specify the name of the row, which row you want to access. So you can directly access through the name of that particular row. So here I will specify apple. Shift enter. I got an error. That is because I have used wrong data frame. We need to specify df1. Shift enter. We again got an error. You know why? That is because whenever if we are performing set index operation, it given us this view, but it is not being applied. To apply it, we need to tell that in place equal to true. So here you will specify true. Now shift enter and then try to execute this cell. Then you will find that it has returned the index apple and the price of the apple is 100. Whether it is in stock or not, yes, it is in stock. So this loc property helping us to get the information from the named index. Now there is another property that is called iloc. Iloc, if you want to access the index with numeric value, then we will use the property called iloc. So for example, df1, I want to access the same apple index, but this time I am going to use the numeric value. I know that the apple index resides at 0th location, so I need to specify like this. Shift enter. then you will find that it has returned the same information, but this time we have access through this property ILOC with index 0. And here you will see that the name of the index is Apple and the price is 100. Whether it is in stock or not, yes, it is in stock. So this way you can easily access the information with the help of indexes, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session we are going to look into handling missing data technique. So why we are talking about this technique? Because in real world scenario most of the data comes with missing values. So it is really very important to understand what actually the way by which you can handle the missing data whenever you will get the raw data with missing information, because we can't do any kind of data modeling without handling the missing data. So let's jump into the Jupyter Notebook, and where we will discuss about all these techniques in detail. So we are into the Jupyter Notebook. Now let's start our exercises to understand the handling of missing data. But first of all, let's look into what we are going to cover in this session. So once we load the data into the data frame, then we will look into how to check the missing data. Once we understand that, then next we will move further and we will look into the example how to get the count of missing data by each column. After that we will proceed further and we will look into various techniques to filling the missing data, where we will look into how to add missing data to the individual columns with the help of some technique called forward fill, backward fill. Once we understand that, then we will proceed further and we will look into how to interpolate the missing value so that missing data will align with the given data. And at last we will discuss about when to drop the missing value, in what scenario you can drop the missing value so that it will not affect our analysis. So let's start by loading the data. So first you need to click cell and press B, and then you will get this cell. You can write import pandas as PD. Shift enter. Now once it is being loaded, select this one again and press B, and this time I am going to create a data frame over here with the help of read CSV. I am going to call it read CSV, and here I will pass the file name of the CSV, and that is resides in a data folder which I have already shown in one of my session, and the data is wine.csv. So this is again the information about the wine, and it contains all the required details for calculating the quality of the wine. So let's load it by pressing shift enter. So it is being loaded. Select this again, press B. Let's look into the data. So again this is the same data which we have used earlier, but this time we are going to work with missing data. So now let's proceed further and do this exercise. So in the first exercise we will check that missing data in columns. First we will look into the alcohol column, and here I need to specify DF and the name of the column alcohol, and over here you need to use a method called isAnA. So let's press shift enter, and then you will find that it has given the information record wise. So over here you will see that at row number 27, 28, 29 and further also it has some record which is having null value. So that means the data is not available. But this way of checking isAnA is very drudgery task, and it is not giving us the complete information, and it is specific to this individual column. If I want to check and I want to use isAnA on the entire data frame, so how we can do that? We can do that as well. So over here, so select this cell, press B, and this time I am going to apply isAnA on entire data frame. Now do shift enter, then you will find that it has returned true and false. If you closely monitor it, then you will find that some value exists in alcohol column that is null. That's the reason you are getting true over here, and wherever null value is there you will get the true value. But this is again, it is not very much helpful. So how we can identify how many value is having null value, so that it will give me the information column wise count. So that means how many value is null value in the column wine, as well as alcohol, as well as malic acid, and whichever phenols. So how do you identify this? So let's look into that. So let's select this cell, press B, and over here you need to specify df dot is null. There is another method, and over here you need to specify sum. Now do shift enter, then you will find that it will give us the information how many number of null value in alcohol column, it's 20, and how many in other column. For malic acid there is no null value, for ash there is no null value, wine also we don't have null value. But if you closely look into phenols, then you will find that it contains 16 null values. So this way you get the count of all the null value and how many null value exist within a column. So this is about getting the information about the null value. Now let's proceed further and we will look into how to fill this missing value and what are the techniques that is mainly used for filling the null value, so that we can use our pre-processed data for data modeling. Data modeling is another topic which comes after data analysis that I will cover in separate course. When I will come up with machine learning course, then I will discuss about how to do data modeling. So now let's proceed further and we will look into the third exercise where we can see that how to handle the missing data, how to fill the missing data. So basically we are going to look into two techniques. One is the forward fill and another one is the backward fill. So let's discuss about forward fill first. So here I will specify B, select M, and this is going to be the forward fill. So forward fill you can write over here, shift enter, and let's discuss about this, and it should be more, shift enter. Now press B again. So let's understand first what actually happens in the forward fill. So within forward fill method, what will happen, whatever the value which exists in the earlier column, so it should be replicated. For example, suppose if you are having this NaN over here in the 27th record and above that it is having the number 26 record, it is containing 13.39, so it is being replicated. Once this value is coming over here, again this value is being replicated to 28, then 29, and so on so forth. So how do we can apply the forward fill? So let's look into that. We should come over here, and over here you need to write df.fill_na, and within that you need to specify the method. So you need to write it over here, method equal to ffill, that is for forward fill. Now do shift enter, then you will find that at the 26th record we were having 13.39 and the same value is getting replicated for this one, 27, 28. It contains the same value. One thing you should remember that the value which you have applied it over here, it doesn't retain till the time if you will not apply over here in place equal to true. So if you want to verify this, I will show you. If you will come over here, currently if you will see the record number 26, it is coming with 13.39, 27 13.39, 28 13.39, as well as 29 13.39. But if you come here and write df and shift enter, then you will find that for record number 27 it is null, and for 28, 29 also. So if you want to apply this, so you need to make sure that you are placing over here in place equal to true. So let's do it, in place equal to true, shift enter. Now come here, do shift enter, then you will find that it is being applied. But I need to show you the demo, so I need to reload it again so that I can show you the backward fill also. So let me reload it, because we have chosen in place equal to true, so it has filled all the null value with the forward fill. So now let's proceed further and we will discuss about backward fill. So select this cell, press B, and this time I will press M for markup. I am going to write backward fill, shift enter, again select this cell, press B, and this time I am going to use backward fill. It is similar to forward fill, but this time I am going to use bfill instead of ffill. So method equal to bfill. So this time what it will do, it will take the backward data and fill those value. So let's do it. So if you will do shift enter, then it will fill with the backward value, and this time you will find that it has some different value. Instead of 13.39 it has 13.90, which it is picking from the below rows. So now let's proceed further and we will discuss about the interpolate missing value. So first we will understand that why actually it is needed. When we are already having forward filled and backward fill method to handle the missing data, then why do we need another technique to handle it? So to answer this question, I would tell that the problem with forward fill and the backward fill, if the number of missing data is high, then forward fill and backward fill make our data set very biased. If biased is new term for you, don't worry, you are going to understand this term in the upcoming session. For a time being, you just consider that inclination towards certain set of information. That means if we are closely look over here, we are repeating 13.90 for most of the record over here, even though it is not the case. So that means we will not get very good output from the data modeling. So to resolve such kind of biasness, there is another method to fill the missing value, that is called interpolate missing value. So how we can achieve this? Let's look into that. You should select this cell and press B. Then we will get some input cell over here. So let's look into that, what actually we are having in the data frame first. So currently we are having over here the NaN value. Now let's do the interpolation. So how we can do that? We need to use the interpolate method. So press B over here. So it will give us an input cell. Now over here I will write df.interpolate. So it will apply the linear interpolation in each of the column, and wherever missing value is there, so it will apply the linear interpolation. So now press shift enter over here, and now you will look into over here. Then you will find that at row 26 we have this value already. Now 27, 28 and 29, it contains different value, but it is based on the calculation of linear interpolation. So you must be asking that what actually the linear interpolation is. So I would suggest that you can visit the wiki over here. I would like to tell you that there is something called linear interpolation. On first link, if you will go there, you will find that it is based upon the linear algebra. So whatever the calculation which happen, which is based upon this mathematics. So I would recommend that you can visit this page and just look into this mathematical calculation. It has given very good information. You can see it over here. So it has given like linear interpolation as approximation. So all these formula is being given over here, and this pandas, if you will look at over here, and the maths which is being applied over here, which apply the same formula. So this interpolate function is basically under the hood applying the same mathematics. So you can go through it. So this is about linear interpolate method. So now there is other method also available to calculate the missing value with the help of interpolation, and that interpolation method is called pchip. If you write method equal to pchip, shift enter, then you will find that here instead of linear method it has applied the pchip method for interpolation, for filling the missing value with the help of interpolation, and you will see that it has updated the null value. And same is the case with phenols, that NaN value is also being filled with interpolated data with pchip method. So now let's proceed further and let's discuss about when to drop missing value. So first let's delete this one. So there is another way by which you can handle the missing data by dropping that particular row from your analysis. So how do you perform that? You need to identify that which actually row is having a single null value. For example, in our case, if we will load this, then you will find it over here. We are having null value for row number 27, 28 and 29. And in this record, we have two null value. And wherever I find a single null value, that record we will not consider for data analysis. So what you need to do, you need to come here and directly tell that df.drop NA. So let's run it. So if you will run it, then you will find that it will drop all the records after 14. Why it is so? If you will look it over here, then you will find that after 14, from 15 onwards, there is no value for this column phenols, and it is repeated till 29, and after that 29 some record is also not available. Some value for this particular column alcohol is not available. So that's the reason what it did, it has removed, or say it has dropped that particular record. That's the reason you will find that 33 record is not considered for analysis, as one of the column is containing null value. So it has dropped that particular record. So this is the another way by which you can handle the missing value, by dropping the record which contains the null. But this is not the ideal solution to handle the missing data. It should only be applied whenever if your data contains single record missing value, then only you can drop it from the raw data. If you ask me, then it is always recommended to go with the interpolation technique, as interpolation helps us to remove the biasness from the data. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session, we are going to look into group by functionality within pandas. So let's jump into the Jupyter Notebook to understand this topic. So we are into the Jupyter Notebook. Now we will look into the topics. What are the topics which we are going to cover over here? So first we will look into how to create group object within pandas. Once we understand that, then we will move to the task number 2, where we will look into some of the common operations which we generally perform on group by objects. Once we understand that, then we will look into how to iterate the groups. Once we understand the iteration of groups, we will proceed further and we will look into how to get information about a specific group. Once we understand that, then we will proceed further and we will look into the topic number 5, that is getting detailed view of the groups. Once we understand that, then we will look into a way by which you can identify all the functions which is being associated with the group by object. Once you understand that, then we will proceed further and we will discuss about how to get the length of a particular group. And at last, we will also look into multi-indexing in group objects. So let's start our exercise. So first of all, what we are going to do, we are going to import the pandas and then we will create the data frame using read_CSV method. And in this exercise also, I am going to use wine dataset. So let's do it. First, select the cell, press B, and then you need to specify import pandas as PD. Shift enter, which is getting loaded. You see here a star mark. Once it is being done, then you will get it over here 1. So we get 1 over here instead of a star. A star means the program is still running. So now you can press B again, and this time I am going to create a data frame equal to pd.read_CSV. So we should write CSV over here, and then you need to specify data, and I'm going to use wine.csv. So within our current working folder, we are having a subfolder called data, and within that this wine.csv file is residing. So press DF also, so that we will look into the data and we will understand that what kind of data we are having over here. So shift enter. So we are having variety of wine with different quality and which is being ranked on the basis of these features. So these column is containing the information about what is the percentage of alcohol available, what is the malic acid, and all these feature is actually deciding what kind of or what is the quality of this wine is. So now what we will do, we will group the data set as per the wine quality, and then we will learn whatever we have discussed earlier. So all these topics we are going to perform on the wine column. That means we will group this data set on wine column. So let's perform our first exercise. Come here and select this cell, press B, and to create a group object on wine, you need to follow this syntax. So I will give it a name, df_wine equal to, and here I need to specify df.groupby, and within that a square bracket and the name of the column, and I am having wine, that is the name of the column, and over here you need to specify df_wine. Let's look into the output. So here you will find that it has returned this object. That means this object, group by object, is being created, and that is represented as pandas.core.groupby.generic.dataframe group by object. So now let's proceed further and we will perform some frequently used group by operations in the second task. So select the cell, press B over here, and now we will start with the first operation, that is called df_wine dot first. So this will return the first entry from the each group. So let's do it. Shift enter. Then you will find that it has returned us the first entry from each group, and we are having 3 quality of wine, that is 1, 2, 3, and these are the first entry from each of the categories. Same way you can perform another operation, that is the last operation. So if you write df_wine dot last, it will return the last entry from each group. Shift enter, and see here it has returned us the last entry from each of the group. Now let's perform some other operation. Now suppose if you want to identify highest alcohol quantity from each of the group, so how you will do that? So for that you need to select this one, press B, and this time you need to select the specific column which you want to get the maximum value. So over here I want the alcohol quantity, which one is having the highest alcohol quantity from each of the group. I need to specify that, and then I will specify max method. Shift enter, and you will see that it has returned that from each of the group it has returned us the highest percentage of the alcohol. Same way, if you want to check that which alcohol or say which wine is having minimum quantity, so you can check it. First press B over here, and the same operation you are going to apply, but this time you need to specify the min operation. Shift enter, and see here these are the entries which contains minimum alcohol percentage. in the wine. Same way you can calculate the average percentage of alcohol within the wine group. So you can select this one, press B, and this time you can use the same thing, but this time here you will specify mean over here. Now shift enter. So this will return us the average value of, or say average value from each of the wine category. So this is about the simple operation, but under the hood how it is working we need to understand that. So let's jump into a diagram and let's look into how all these things happening internally. So let's jump into a diagram. So internally, how does it work? Let's understand with an example. To make it simple, I have kept it very simple example where we are having 4 different columns, and this time I'm having only 2 groups. One is the fruit, another one is the vegetable. So first we will get the input which is being read from the CSV file. Then afterwards what is happening when we are trying to create the group by object, so it basically split these data into multiple groups as per the given criteria. For example, if I have given that pd.read CSV and read this input file, afterwards I have created a data frame df equal to and then df dot group by, and within that I specified I want to grouping on type column. So it will return us 2 groups. One is for fruit, another one is for vegetable. And then we told that we want the total value for fruit group as well as the vegetable group. Then it has returned the result after applying the operations onto the group data. And this is what we did over here. Over here, what we told that please return us the average value, that is mean, for alcohol groups. And that's the reason it has returned us 3 values to their respective groups. For wine quality 1, it has returned 13.7. For wine quality 2, it has returned us 12.2. And for wine quality 3, it has returned us 13.15. That was our wine example. Over here I have given with the simple example with fruit ball example. And then once it is being applied, then what it did had combined with the data set. This combine operation we will look into some other session. For a time being, just you consider it. Group by operation is nothing but getting the input, splitting the data, and then applying some function or say some mathematics on the group data. In this case it is doing the summation of all the price value, and this is the addition of all the prices of fruits and vegetables. And at last what it is doing, it has merged with the original data frame, and later these value is going to be used to identify how much percentage of expense we have done for each individual fruits. That exercise we will do in some other session when we learn about transformation within pandas, as it is one of the complicated topics. So I have kept it separate session for that, where you will get more information. So now let's proceed further. So now we will look into how we can iterate the group. So let's select this cell and press B. But first of all, we have to understand that how many number of groups available. How do you check? So you need to specify the name df underscore wine dot groups. Shift enter, and then it has returned us these values. And what we found that it is a dictionary, and we are having this group 1. Group 1 is one of the key. Then we have group 2, and then we have group 3. So with the help of this, we identified that we have total number of 3 groups. Now I want to iterate this groups. So how we can do that? So let's look into that. So to iterate it, select B, and this time I'm going to write it for, and over here you need to specify the wine comma, and here we need to specify wine df, so that it will contain the columns which is being returned in df underscore wine. And here we will also print wine when it is looping, as well as the columns which we will get in this data frame wine underscore df. Now do shift enter, and you will find that quality 1 wine, it has returned these information. Same way if you will look into quality 2, it has returned these information. Same way it has returned the information about quality 3, and this contain these number of information. So this way you can iterate each of the groups which exist within this group by object, that is over here df underscore wine. So now let's proceed further and look into some other exercise. Now the another task, suppose that if you want to grab the information about particular group, then how you can do that? So you will do it like this. You can press B over here, and the group object which we have created df wine dot get group, make sure that you are specifying underscore over here, and within that I'm going to specify 1 over here, and you will see it over here. It has returned the group 1 information. That means the wine quality of 1 and all these information from that particular group. So you will see it over here. It has returned us 58 records which falls into wine quality 1 group. So this way you can grab the information from a specific group. So now let's proceed further. So we are going to look into another task, that is getting detailed view of groups. So how we can get it? So if you remember, we have seen describe method in one of our sessions. So we can apply the describe method in the group object as well. So let's look into that. Press B over here, and here you need to specify df underscore wine and then describe, and it, so now you will see it over here. It has returned a very good information from each of the groups. So here you will see that how many number of items contained for group 1 it is 59, for group 2 it is 71, and for group 3 it is 48, and that is for alcohol column. And you will closely look into that. For each of the column it has returned the mean, max and the percentage information for each of the columns, and that is for each respective groups. So now let's proceed further and we will look into what are the methods available for group object. So you can check it by using dir function. So let's look into that. Press B over here, and here you need to specify dir, and the name of the group object over here is df wine. Shift enter, and you will see it over here. It has returned all the method which is being available for this particular group object. So you can use any one of them or all of them, whichever you want as per your need. So now let's proceed further. Now we will look into how to check the length of particular group. So you can do it by this way. Press B over here, and here you need to specify len, and within that you can specify df underscore wine dot get underscore group, and here you specify which group length you want to check. You can press 1 over there, and it has returned the length. So how many number of entries it contains. But suppose if you want to check how many number of groups exist, so you can check it like this way. Press B over here, and directly you can specify length and specify df underscore wine. Shift enter, then it will return the length of, or say how many number of groups exist within this group object. So now let's proceed further and we will look into how to create multi-index group object. And to understand this topic, we need to use other dataset, because this dataset doesn't contain multiple categorical variable. So categorical variable means the type of data which may be divided into groups. For the current example, we are having a single data that is called wine, which we can use to divide it in a group, as it is a categorical variable. So to use the multi-index, we need a data which have multiple categorical variables, so that we can create multi-index grouping. So let me create a data frame with another data set. So here I will press B, and then I will create a data frame called df fruit ball, and here I am going to use pd dot read underscore csv, and I will call it data, and we are having fruit ball dot csv, and then we will write dffb. Shift enter. So let's look into that. So here you will see that we have two type of categorical variable over here on which we can apply grouping. First one is the type, another one is the in stock. So let's now create the multi-index grouping on this data. So here I will tell that df multi-index equal to, then you need to specify over here dffb, that is our data frame, and over here you need to specify set underscore index, and within that you need to specify your list, and this list contains the name of the categorical column. First I will use type, and then I will use in stock column. So you will see it over here. We have type and in stock column, that is a categorical variable. On the basis of these column I can do the grouping, and then over here we will specify df underscore mi. Shift enter, and you will see that it has created a multi-index grouping. So you will see it over here, fruits, then we have in stock, and within that it is specifying that which of the fruit is available or which of the fruit is not available within the stock. Same is the case with the vegetables, and this is what I wanted to demonstrate you in this session. So see you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session, we are going to look into aggregation in pandas. So let's jump into the Jupyter Notebook to understand this topic. So we are into the Jupyter Notebook. So now let's understand that why actually we use the aggregation and what actually the aggregation is. So basically, whenever you do the analysis, one of the essential piece of analysis of large data is efficient summarization, and that is where aggregation comes into picture. So whenever you compute the aggregation, it will return us the single value. So let's understand with an example. So first what we will do, we will import the pandas library. So let's select this one, press B, and here we will write import pandas as PD. Shift enter. Once it is being done, so select again this cell, press B, so that it will insert a cell over here. And this time I am going to create a data frame with the help of pd.read_csv method. And here I am going to use dataset called grocery.csv. Shift enter. Let's write df also, so it will return us the dataset, and we are having this dataset which contains the information for fruits and vegetables along with the prices. So next step, prior to applying the aggregation function, we will first create the group by object on the column type. So to create the group by object, select this cell, press B, and this time I am going to tell that df group by equal to, and here we will tell that df dot group by on which column I want to create on type. Shift enter. So you will see that it has created a group by object. So now we will start our exercises. So we have understand that aggregation, what actually the aggregation is. As I already mentioned that aggregation is one of the technique by which you can summarize your large data set. For this example, I am having very simple data set, but when you are going for large data set analysis, on that time it is very handy to summarize your information, which we will look into when we will do the project. For a time being, I am just giving you information about how to use the aggregation function on group by object in pandas. So let's start with the first exercise. Press B over here, and I am going to use the size function of group by object. So here df.gb, and here I will specify size. So it will return the item counts from each group, df_gb.size method. Shift enter, and you will find that we have two groups. One is for fruit, another one is for vegetable, and each have 10 items. So this is about count of items. Now suppose if you want to calculate the mean, so how do you do that? So you want to calculate the mean for the price, so you can do it like, you need to specify df_gb, and over here you need to specify the price dot mean method. Shift enter. So it will return us the mean value from each of the groups. So this is one of the way. But now here some of the scenario where you want to calculate multiple aggregation function in a one go. So how you can do that? But prior to that, I wanted to import numpy so that I can use the numpy methods. So over here I will tell that import numpy as np. Shift enter, and now I come over here and I will apply the multiple aggregation function in a one go. So let's look into that. We will first select this cell, press B, and here I need to specify the group object, group by object gb dot, and there is a method over here agg, and within that we need to pass the list, and here I am going to use numpy sum method, then numpy mean as well as numpy standard deviation. So these three aggregation function I want to calculate in a one go. So how I can do that? I need to do it like this way. Now do the shift enter, so it throws the error. So instead of that, we need to use small agg. Because of that reason, it throws an error. Now do that, shift enter, and you will find that it has given us these value on price column, because we are having this price column is the continuous variable, and that is only the continuous variable. Continuous variable is the variable, or say is a column on which we can do the mathematical calculation like plus, minus, mean, average. That is continuous in nature, and for this example data set we are having a price column that is only the continuous variable. So that's the reason it pick only the price column, even though you haven't specified over here any specific column. It just picked the price column where it has applied all these aggregate functions. So now let's proceed further. So over here you will see that there is no control on the naming of these columns, which is being returned from this agg function. So how do we can apply the custom column name over here? So let's look into that, and that is our third exercise. So copy this one. So now select this cell, press B over here and paste the copied thing, and then over here you need to use rename method, and this will accept columns, and that is going to be a JSON value. So you need to write something like this, curly braces, and over here you need to specify the default name is sum. So instead of sum, we want it should be called as count. So we can specify our custom name over here. Instead of mean, I'm interested in it should be called as average, and instead of std, I want to call it as standard deviation. That's it. Shift enter, and you will find that it has picked up the custom column name. And this is what I wanted to demonstrate you in this session. There are other two topics which I will cover when we will do the project. On that time, I will show you the usage of named aggregation and the custom AGG function. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Hello guys, thanks for joining this session. In this session, we are going to look into transform. So let's jump into the Jupyter Notebook to understand this concept. So we are into the Jupyter Notebook. Let's start our discussion. When we are working with group by object, Pandas offers us various functions that makes data analyst life easy. So far we have seen the aggregate or AGG function, which we have used on group by objects. For example, we have seen that how to calculate the count. That means how many number of items exist within a particular group. Then we have also seen that how to calculate the mean along with the standard deviation. So in the same aspect, Pandas offers us another type of operation that is called transform that we will understand now. But one thing I wanted to tell you that transform functionality is little bit complicated to understand it in a first instance. So in case if you are not understanding the functionality of the transform at the very first instance, that is okay. So to make you understand the functionality of the transform function, I'm going to introduce a data set that is a sales data set for a fictitious company. So let's look into the data set and then we will understand the problem. So the first step is you have to import the pandas. So select this cell, press B again, and here this time you need to again write import pandas as PD. And this time I am going to use a data set. I'm going to create a data frame over here with the help of read_CSV. And this time our data is going to be the sales data for a fictitious company. Let's look into the data, what we are having inside that. So df, then you will find that we are having this information. This is the sales information for a company and it contains the order information. So if you closely look into that, this company has sold some of the product and it contains the information about 3 orders, and within these 3 orders it contains different products. For example, the first order which contains 3 products, the second order also contains these number of products, and the third order which also contains these number of products. So now understand the problem. So what actually the problem and what we want to do and what kind of analysis which we want to do. So we want to do calculation of what percentage of total order does each product represent. Let me write it so that you can understand it. So this is our problem statement where we want to identify that what percentage of order total does each product represent, and we need to calculate by summing the exit price over here. So that means we need to create group by object that is based on each order and then do the calculation. But the tricky part of this calculation is that we need to get a total for each order and combine it back with the transactional level detail in order to get the percentage. So to do this, I am going to show you two solutions. One is without transform method and another one with transform method. So the first step, what we will do, we will create a new data frame with the totals by order, and then we will merge it back with the original data frame. So let's do it. So I am going to tell that order total O total equal to df dot group by, and we need to group by on the basis of order, and then we need to specify it should sum the exit price. So we need to specify over here ext price over here, and then over here I am going to use the sum method, and then we need to specify it. It is going to be called as order total column. So we need to specify here rename, and within that we need to specify that order underscore total, and so we need to specify the reset index over here, and then we need to do shift enter. But prior to that we need to print O total also. Shift enter. So this has returned us the sum total value for each order. So now the next step, we need to calculate the percentage of the order total that each product represents. And to do this calculation, we need to do at the transactional level. So to do that calculation, first we need to merge this data frame which we have created just now, which contains only 3 entries and which we want to merge with this transactional information. So this is our second step. So let's do it. So what I am going to do,
I will create another data frame, and that is a merge data frame, df underscore merge, and this is going to be merged with df dot merge. So merge is a method from the data frame, and here we need to specify this order total data frame, and this is going to be O total. So O total, and once you do that, you need to write here df underscore merge, and it will return us the merge data frame where you can have this data is being merged with this data, and you will get the transactional information. So shift enter, and then you will find it over here. This order total is merged at the transactional level. Now still we have one step away to do the calculation of the percentage. So to do the calculation, so we need to write it something like that, df merge dataset, and I'm going to introduce column with the name percentage of order by product, and then here I will do the calculation on df underscore merge, and the name of the column I want to divide it. First I will tell that exit price divided by df underscore merge, and I want to divide it with the order total column. So I need to make sure that you are using the quotes over here, else it will throw an error. So here we should mention over here order total, order underscore total. Check the spelling. Yeah, it is correct. And now let's do the shift enter, but prior to that let's print this one as well. Now do shift enter, then you will find that it will return us a percentage of order by product, and this is what I wanted to calculate. So you will see it here, the product over here P1 20,000 is having 40% of contribution within order total. Same is the case with S1, that is also having 40% of contribution within the order total. If you closely look into this product B1, that is having only 18% of contribution in this order total, and this is what we wanted to calculate it. But we have solved this problem by performing various steps. So first we have calculated, we have created a group by object, and then we did over here, we merged the data frame, two data frame, and then it will be merged with the transactional data frame, and after that we have calculated the percentage total over here, and then we got the required information which we were looking for. So now let's look into the transform method. With the help of transform method, we are able to get rid of these two steps. So let's look into that, how we are going to achieve this. So this time I'm not going to create any additional data frame. So let's look into the data frame which we were having earlier, and we are having this data frame, it is intact. Now I'm going to perform all the activities whatever we have performed over here on the same data frame, and here we have created another data frame to do the merge operation, but this time I am going to perform all this in this data frame itself. To do that, first we are going to calculate the order total. So I am going to introduce a column called order total, and here we need to specify df dot group by, and I want to create the group on order column, and I want to do the sum of exit price. So far we have seen this. Now here the transform function comes into the picture. So here I will specify transform, and within that, what kind of transform I want to apply? I want to sum the value of, or say, on the group by object as per the group basis. Let's do it, and now do the shift enter. Then you will find that we have get rid of these two steps very simply without performing any kind of operations that we did for the merging. So you can see it over here, it is pretty much neat over here. Now the next step would be the same. I'm going to perform the same thing what we have done over here. So we are going to introduce another column which will do the percentage calculation. So let's do it. Percent, you need to specify within the double quotes percentage by product order, and the calculation is going to remain same, and here we need to specify that the data frame exit price divided by our order total, and we need to specify over here df order total. Now do the shift enter, but prior to that print this as well, shift enter, then you will find that it returns the same output what we have achieved earlier, but this time in a much neater way. And now you can imagine how powerful is the transform function is. And one of the beauty of this transform function is that it is not limited to only sum operation. You can apply mean operation as well. So you can provide the mean over here, shift enter, and you will see it over here, it has calculated the mean. Same way you can provide the standard deviation over here and do the shift enter over here, then you will find that it has calculated the standard deviation as well. And this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care.
Hello guys, thanks for joining this session. In this session, we are going to discuss about window functions. So let's jump into the Jupyter Notebook to understand this concept. So we are into the Jupyter Notebook. Now let's understand what actually the window function is. So whenever we do the time series analysis, on that time it is very much important to do the analysis on periodic data. So what actually the periodic data is? So the periodic data is nothing but the data which is based upon dates. So on that time, to analyze the periodic data, we generally use window functions. And in pandas, we got two kind of window functions. The first one is the rolling and the second one is expanding. And in this session, we will look what actually the window is. So to understand it, let's generate some periodic data. And this time I am going to randomly generate daily periodic data for one of the Fixious stock. And this periodic data contains the stock price of that particular Fixious company. So let's do it. So we will start again with importing first pandas as PD, and we are going to generate some of the Fixious data. So we need NumPy. So I'm going to use NumPy as NP and shift enter over here. So now let's generate the periodic data. So to do that, first I'm going to create a price, a stock price. To generate the stock price, I'm going to use random np.random.randn, and I want only 10 price and only one column. So I'm going to specify over here 1, and then I'm going to also generate days that is going to contain the date range. So I'm going to use pd.date underscore range, and over here I will specify some Fixious date for which it is being generated, and I want 2010, and over here I will specify periods. I want only for 10 days. Once it is being done, the next step I'm going to create the data frame. So I will tell it over here df equal to pd.data frame, and within that I'm going to specify price, that is here, and index is going to be our days. So I will specify over here index equal to days, and we will also tell that columns. So column I am going to have only single column, that is going to be a stock price. Now do shift enter, but prior to that let's print this data frame as well, and you will see that we have generated a periodic data on which we are going to do analysis, or say basically we understand the functionality of Windows function. So first of all, let's understand what actually the window is. So basically window is nothing but the range between the day. For example, if I'm telling that window 1, so that means the price between this date to next date. So that is a window 1. So let's understand it with a diagram. So let me take the snapshot of this. So I'm going to take the snapshot and let's understand it over here. So suppose if I am telling that window 1, so that means it is going to be this range. If I am going to tell that window 2, so this is going to be window 1, and if I am going to tell window 2, that means it will take these two values, and same way if I will tell that window 3, then it will keep 3 value, and the fourth one is this is the range window 3. So now we understand that what actually the window is, but what actually the usage of this window functions is. So basically window functions are majorly used in finding the trends within the data graphically by smoothing the curve. So as we most of people know that whenever we do investment by identifying their trends. So Windows function will help us to identify those trends. And as I already mentioned that pandas offers us two variety of, or say two flavor of window function. One is rolling, another one is expanding. So let's understand that. But prior to learning the rolling and expanding function, so let's understand some of the data analysis which we do on stock price. So here I want to calculate daily change in the price for this particular stock. So how we can do that? So to do the calculation, we need to identify previous day's price. So let's introduce a column which will hold the information about previous day price. So how we can do that? Let's look into that. So here I'm going to introduce a column called previous price. So let's do it, prev price, and then I need to specify df dot, there is a method called shift. So this shift method will gives us the previous stock price from the given column. So here you should specify the column name over here. So I'm going to specify that is going to be stock price, and here within shift I'm going to mention 1. Now do shift enter. So now let's look into the data frame, shift enter. Then you will find that it has given us the previous day's price. Now let's calculate the change within the price. So how we will do that? So let's look into that. To do that, I am going to use over here, I will tell that daily return.
So df, I'm going to introduce another column that will hold us what is the change in the price. So I will call it as daily underscore return, and within that I will specify the stock price that is being divided with the previous price which we have calculated. We will mention over here, and the name is rev price, rev underscore price minus 1. So this formula will return us the daily return. So let's look into that. I will specify df again over here, and you will see it over here. This is the daily return, and this is the change of the price which we will calculate it with the help of these operations. So first we have calculated the change in the price, or say calculated the lag. Then afterwards we have calculated the change with the help of this formula. Now it has returned the daily return. So now let's proceed further. So now we will use the expanding window function as well as rolling window function. So how we can use it? So let's do that. So this time I am going to calculate the expanding mean. To calculate the expanding mean, I am going to first introduce a column called expand mean, and over here I am going to use data frame, and this I am going to do the expanding mean, which we will do the calculation on daily returns. So let's do it. I'm going to specify over here the column name on which we are going to do the expanding operation. So daily return dot, there is a method which is being offered within pandas called expanding. You should specify over here, I want to calculate the mean over here. So let me specify that mean, and now do the shift enter. Then you will find that it has calculated the expanding mean. So this way we have calculated the expanding mean. If you are confused about the expanding term, don't worry, I am going to introduce another course where I am doing exclusive time series analysis. Then on that time I will explain this concept expanding. For a time being, you just consider that it is one of the Windows operation, or say Windows function of pandas, which we generally use with the date dataset. And here in this session I just want to introduce the concept of Windows function, and I don't want to confuse you initially with these jargons, as it is falling into some advanced concept that I am going to cover in time series data analysis. That is a separate course. Same way you can do the calculation of rolling mean. So how you will do that? Let's look into that. So over here you need to specify, I am going to calculate rolling mean. So I will specify over here, I want to calculate mean for 3 days. So I need to specify over here df, and then I need to specify the column name on which I am going to apply the rolling mean. Return daily return dot rolling on 3 days. So that means it will calculate the price, whatever daily returns. So all these value it will be calculating over here. It will sum this value and divide by 3, because it is a 3 days rolling data. So that's the reason I have specified over here 3. So I want to calculate the mean of these 3 values, and here I need to specify mean. Now specify df, shift enter, and you will see that it has calculated the rolling mean. And here you are seeing that the nan value, because we are taking the 3 values and which is not available, earlier days value is not available. That's the reason it is returning nan over here, and after these 3 values it is calculating. So this is all about window functions of pandas, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session we are going to discuss about filter function in pandas. So let's jump into the Jupyter Notebook to understand this functionality. In our earlier one of the session, we have discussed about lock and iLock filtration method, which we generally use to filter the content of the data frame. Then you must be asking that what actually the use of this filter method of data frame. So to answer your question, I would tell that lock and iLock functionality is basically used to filter the content of the data frame. But this method, that is data frame filter method, it is being used to filter the column as well as rows with their labels. So what it means, let's understand with an example. So first I'm going to import pandas library as pd, and we need a data frame to understand this. So I'm going to create a data frame, and this time I am going to use data set called grocery.csv. Shift enter. But prior to that, specify the data frame. So this is the data frame we are having. So now let's understand the filter operation, or say filter function. So earlier we have seen that the LOC and ILOC to filter the content of this data. But my requirement is I just want to filter the column with their names. So how I can achieve this? So we will use over here the filter method. So let's create a data frame and it will hold the filtered value. So I'm going to tell that filter, and this method is having a parameter called items, and within that I'm going to tell that I want type column as well as I want the items column. And now in this data frame, filter enter, then you will find that it has returned us this filtered column on the basis of the level, and this is the level name this data frame contains. Now next I want to filter the data frame with the column name which is ending with the letter E. So it will select only those column which is ending with the letter E. So how I can do that? So we will use over here the filter method with regex. So how we can use it? So let's look into that. So I will tell that df regex equal to df.filter, and over here I will specify there is another argument of this particular method called regex, and over here you need to specify the regex. So it should be ending with E. So any end character in the regex we need to specify the $sign. So over here you need to specify comma, and I want which is on the column. So column is represented with axis equal to 1. So you need to specify that, and this time I am also going to print it regex. Shift enter, it is running. There is a typo error, sorry for that. Shift enter, and you will find that it has selected only those column which is ending with E. These two column label is ending with E. So this is about applying the filter on the basis of regex. Now suppose I want to filter out only the vegetable rows. So how I can do that? So first we need to convert it the type column as an index. So let's do it. So I'm going to tell that df dot set index, and over here I need to specify and the name of the column, and that is going to be within the quotes, and over here you should specify in place equal to true. Shift enter. Now you will execute the df, and you will find that it has converted the type column as a index. So to filter by row, what I'm going to do, I'm going to create another data frame df row filter, and over here I will specify df dot filter, and this time also I'm going to use regex equal to, and I want all the vegetable rows should be selected, and over here you must have to specify axis equal to 0 as it represents the row, and here once it is being done I will print it. I will tell that df underscore row underscore filter, shift enter, and you will see it over here. It has filtered the row and that level which we are selecting through the regex. And this is what I wanted to demonstrate you in this session. I hope you enjoyed this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to the another session. In this session we are going to look into join, merge and concat operations. All these three operations used to do the same thing, that is joining one data frame to the another data frame. But prior to that we have to understand that how many types of joins we are having, because it is important to understand that how many types of joins we have. If you are coming from the SQL background, then you must be aware about this join operations, but if you are from the non-SQL background, then you must have to know about types of joins. So let's jump into a diagram where we will first understand what actually and how many types of joins we are having. So we are into the diagram. So first we will discuss that what actually the join operation is. So join operation is nothing but it is an operation to join two data frames. But why do we use it? We use it because in real world scenario we get the data in a splitted manner, and to perform the data analysis sometime we need to merge these data frames in a single data frame. And within Pandas offers three flavors of join operation. One is with join, another one is merge, and the third one is concat. And we are going to look into all the three in this session. But prior to that, let's understand what actually the join types is. So how many types of join we are having? So basically we are having 4 types of join types. So you must be wondering that what actually the join types is. So join types is a mechanism by which you can decide that how to merge these two data frames together. For example, if you want to join with the left mechanism, then in this case what will happen, the left data frame with the, in this example we are having data frame 1 which is residing at the left and data frame 2 which is residing at the right. So here you are telling that it is a Venn diagram. If you are closely look into the Venn diagram, whenever you perform this join operation between these two data frames, so it will take all the records from the left data frame and it will merge the column as well over here. So see here, when we merge these two data frames, then we found that it has taken the A data frame 1 here we are having a common column name, and here we have specified that this is called suffix, which we are generally specifying while creating or say performing the join operation. On that time we are specifying the suffix. So with left operation, it has taken the index value x and y. That is because it is the nature of the left join type, where it has picked the information from the first data frame. So let's perform this exercise in the Jupyter Notebook so that we understand it clearly. So we are going to perform the same exercise in the Jupyter Notebook. So we are into the Jupyter Notebook. I'm going to import pandas as PD, and I'm going to generate the data. So now let's create two data frame over here. So I'm going to create a data frame called df1 equal to pd.dataframe, which we have already know that how to create it, and within that I'm going to pass a dictionary, and here I'm going to specify key, and over here we need to specify a list. So I want x comma y, that is going to be our index. Next I want another list which contains over here the column, that is going to be a column, and some value it contains a1 comma a2. Next we need another column b, and over here I will specify b. Let's replace this value over here, b1 and p2. So we have this data set. So now next we need to set the index. I want key should be the index, so I will tell that set index, and over here I need to specify which column I want to be index. It should be key, and I will tell that in place equal to true. df1 shift enter, and you will see that we have created the first data frame, and which will look something like this. So we have created the first data frame. Now we will create this data frame 2, which contains a column A, which is similar to this one, but value would be different, and instead of B we are having column C. So let's do it, and if you closely look into that, here we are having the index Z instead of Y. In both the data frame, one index is common and one column is common. That means we are having a common label. So let's jump into the Jupyter Notebook. Now let's create data frame 2. I will copy this one, paste it over here, specify a name df2, and here I will tell that we are having column C, and key we are having Z, and this is also going to be 2. Remaining thing would be same, and here I will tell that 2. Shift enter. So this is our second data frame, which is similar to this diagram with this diagram. So now we will perform left join type. To do that, let's look into it. So I want to perform left join. To do that, I need to specify df1 dot join, and over here I need to specify I want to join with data frame 2, and there is a parameter which you can specify over here, l suffix equal to, and here I am going to tell that for the left side suffix I need to specify df1, and then I am also going to tell that r suffix, that is for right data frame, that is for second data frame. So here I will specify underscore df2, and how I want to perform, I want left operation. So how I can make sure that this join should perform the left join? So here we are having a parameter called how, and here you need to specify left, and now do shift enter. So then you will find that we get the same output. So it has taken all the records from the first data frame. You will see it over here, x and y is the index from the first data frame, and if you closely look into the Venn diagram, then you will find the same representation. So you will see it over here, we are having the same output, and this Venn diagram, that means our data frame 1, all the record comes from the data frame 1, and it will also display the columns from both data frame. Now let's proceed further, and we will perform the right join, and this time I am going to pass the parameter right, so that it will pick the record from the data frame 2. That means it will pick this index x and z with this operation. So let's jump into the Jupyter Notebook. So to perform this, I'm going to copy the same statement and paste it over here, and this time I'm going to specify right. So this is the value for this how parameter. Now if we will do shift enter, then you will find that it has picked the record from data frame 2, that is residing at the right side. So that's the reason it is taking the record, or say taking the index from the data frame 2, and it has also taken all the columns from both the data frame. Now let's jump into the diagram, and within this diagram you will see the same output. Now next we will proceed further, and we will perform the inner join. Within inner join, it will take the common values. If you see into the diagram, wherever there is an intersection between the data, it is picking those values only with the inner operator. So let's perform it. So let's jump into the Jupyter Notebook again. So now come over here, copy this one, paste this one, and instead of right I'm going to specify inner. Shift enter, then you will find that it has returned the same output which we have seen in the diagram, and this time it has taken only the common index, and the common index is x. It has taken both the columns. So now let's proceed further and let's discuss about the outer join. So within outer join, it means that you have to take all the data from the left data frame as well as right data frame, and this is what this Venn diagram is representing. So let's perform it, and if you look into this output you will see that it has taken all the columns as well as all the rows from both the data frame. So how we can achieve this? Let's look into the Jupyter Notebook. You should come again, copy this one and paste it over here, and instead of inner I am going to tell that outer. Shift enter, and you will see that we got the same output which we have seen in the diagram, where it has taken all the record. This is the common record, and over here this is from the both the data frame. Y is coming from the data frame 1 and Z is coming from the data frame 2, and it has taken all the column, and this is about the join operations. So here you must be asking that how do I remember all these parameters? So you don't have to worry about this thing. So if you want to know about what are the parameters and what is the usage of it, pandas provide very helpful documentation. So you should come here and specify df1.join and a question mark, and the moment you will do question mark and shift enter, then it will open the documentation and it will give you the detail with an example over here. So you can look into these examples if you are having any doubt, and you will also understand that what actually these parameters are. So you can refer the documentation as well. So now let's proceed further and discuss about the merge operation. So now we have seen join operation, so let's discuss about the merge operation. So merge operation is similar to the join operation. It also combines all the columns from the two tables or say two data frame with the common column rename. However, merge provides three ways of flexible control over row-wise alignment. The first way is to use on parameter, where you will specify the column name which is common between both the data frames. So how to do this? So let's look into that. So I'm going to tell that df1 dot merge. This time instead of join I'm going to use merge, and here I will specify data frame 2 and I want to merge on column A which is common, and if you will do it like this then you will find this output. So see it over here. Here it haven't taken the indexes which we have created, and if you want to on the index then you have to specify it. So here you should tell that left underscore index equal to true. Shift enter, then you will see it over here. It has taken the index. Now let's proceed further and discuss about some other parameter, and over here it also offers how parameter you can specify over here. So if you want the left operation, so you should specify left. If you want right operation, you should specify right and verify the out. If you see it over here, we haven't provided the how parameter, so by default it applied the left only. So left join it has applied. So if you do shift enter, then you will find that both the output would be the same. Same way you can change it over here right, then it will do the right join, and over here you will see that it has returned this output. You can apply some other parameter as well. So right index equal to true. Now verify the output, what output it is returning. We forgot to mention comma over here. Shift enter, and you will see it over here. It has given us this output. So to understand the parameter of the merge, you can use the same technique. Use df1.merge question mark shift enter, and you will see it over here. These number of parameters available. You should go through it what actually it is. That is on the basis of join types. Over here this how parameter represent the join types you can specify within this method. So here I would tell that if you are having any doubts, you can get your hand dirty, do the same exercise and try to on all these parameter and make a combination of these parameters and see the output and compare the output. Then you can have a better understanding of these parameters. So this is about the merge operation. Now we will proceed further and we will discuss about the concat operation. So let's discuss about the concat operation. Pandas concat operation is also used to merge two data frame or say join two data frames, but with concat operation you can perform either on column or on rows. So let's look into the diagram so that you will understand it better. So to understand the pandas concat
I'm going to use the same example. We are going to use the same data frame, and when you are performing the concat operation on column, you need to specify axis equal to 1. And when we are performing this, then your output looks something like this. If you are performing inner join on axis 1, then you will see it over here. It has merged the columns and it has taken the common index. So how to do it? Let's look into it. So here we need to specify pd.concat, and within that we need to pass the list. So here you need to specify which two data frame you want to concatenate. I'm telling over here df1 and df2, and over here you can directly run it and it will pick up the default values from the parameter. And if you will do it over here, then you will see that it has performed the outer join and it has merged both the data frame and taken all the columns as well as all the indexes. But with this behavior, it is giving you the warning that you can't sort it. If you want to remove the sort, you need to mark it as a false. Then you will not get this warning. So let's do it. If we are doing this outer join, you need to specify false, shift enter, then you will see that warning went away. Now if you want to perform inner join, so here you need to specify a parameter over here that is called join equal to inner. Now do shift enter, so you will see it over here. It has taken the common column. By default it is merging on the axis 0. So if you will specify axis parameter equal to 0, then you will find that it will return the same output. So let's do it, shift enter, and you will see it over here. There is no change. Now I want to merge on the basis of axis 1, that is column. So what we have to do, we need to specify over here axis 1, shift enter, and you will see it over here. It has taken all the columns, and from index it has taken only the common value because we are performing inner join. Now if you will specify over here outer join, shift enter, then you will find that it has returned all the information from both the data frame, and that is what mentioned in the diagram as well. So let's look into the diagram. If you closely look into the diagram, and this is the same output which is being returned after performing this operation. We have performed the outer join on axis 1, and this is the output we got. So this is about the column join, or on the basis of axis 1 we have joined. Now if we want to perform join operation on indexes, so we need to specify axis 0, which we have already seen. So you will see it over here. It has taken all the rows, but from the column side it has taken only the common column, and this is what this intersection operation representing. It has taken the common column from both the data frame. And if you closely look into the diagram of outer join on axis 0, then you will find that it has taken all the data, but this time it is on the basis of indexes. So all this concatenation happened on the basis of indexes. So let's perform these two into the Jupyter Notebook. First we will perform inner join axis 0, that is our indexes, shift enter, then you will find that we got the same output, that is the intersection operation on axis 0, that is indexes. Now over here you will specify outer, and axis is going to be the same, shift enter, then you will find that it has returned this warning, but this time it has returned this out, where it has taken all the indexes from both the data frame and over here the common column. And if you look into the output, it is the same output which we achieved through this outer operation, and this is about outer join on axis 0. So now let's proceed further. So we have seen all variations of join operation. We have started with the join operation, then we have seen merge, and at last we have seen concat. For concat also, if you want to know about what actually the documentation it provides, so you can come it over here and write like this, question mark, shift enter, then you will find the detail about the concat method of pandas. So I would suggest that you should go through all these documentations. It has very good example as well, so you can try those. So on this note, I am stopping over here, and I would tell that please try to perform all these exercises by your own, then only you are able to understand the difference between all these operations, that is join, merge and concat. As I know that this is little complicated topic, sometime you will be confused if you are doing it first time, but after going through 2-3 times, I'm 100% sure that you are able to make the difference between join, merge and concat. So on this note, I'm stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session we are going to learn about apply method of pandas. So let's jump into the Jupyter Notebook to understand this. So while doing the data analysis, we required some time to perform certain calculation on the features which is being given in the raw data, and that is one of the required steps within data modeling life cycle. So to perform this pre-processing, we required a way where we pass the feature or say column from the raw data
and in return we will get the new feature or new column on the basis of some calculation. So to achieve this, pandas offers us apply method. So let's understand with a simple example to know the power of apply method. So to understand it, I'm going to use first import pandas as pd swift enter, and I'm going to generate a data frame. But prior to that, I'm going to generate some of the range value. For that, I'm going to use numpy as np swift enter, and the program which I'm going to write is for calculation of Celsius temperature from the Fahrenheit temperature. So I'm going to generate some of the Fahrenheit temperature over here with the help of np.range method, and over here I want the temperature it should generate from 90 to 150. Shift enter, and you will see that here it has generated these number. And now I'm going to create a data frame with the help of this number. So I will tell that data frame equal to pd dot data frame, and over here I will pass temp, and I am going to specify one column, that is our Fahrenheit. I will specify over here, shift enter, then you will find that it has given us this data frame with this number. Now I want another column that will give us the Celsius information against these Fahrenheit values. So how I can do that? So here you will see that I need to perform some calculation. So to calculate the Celsius value, I need to create a function. So let's create it, and I will tell that convert to Celsius, and over here it will accept the Fahrenheit temperature, F temperature, shift enter, and over here I need to specify return, and here I'm going to tell that I want, this is the formula of the Fahrenheit. If you want to calculate the Celsius, you need to specify this formula, temperature minus 32 multiplied by 5 by 9. So if you want to convert from Fahrenheit to Celsius, you need to use this formula, and this is our function. If you don't know about the function, you should go through my course Learn to Code from Scratch with Python 3, where I have covered the basics of function creation. Now let's proceed further. Now I need to create a calculated column over here called df Celsius. So I will specify Celsius over here, and here I need to specify the column on which I am going to perform this calculation, and that is our Fahrenheit. And here I need to use apply method, and this apply method contains the reference of the method which we have created, that is the argument, and this is being called for each individual values. So here I will do the shift enter, and then you will find that it has given us this calculated information on the basis of each Fahrenheit value. So now you can imagine the power of this apply method. Wherever we want to perform any kind of a calculation to generate a new feature, we can use this apply method, and this is very useful whenever we are doing data analysis as well as data modeling. And this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session we are going to discuss about data frame reshape. So let's jump into the Jupyter Notebook to understand this topic. So we are into the Jupyter Notebook, and let's start our discussion. But prior to learning about what are the ways to reshape your data frame, we have to understand that why do we actually need the reshaping. So to answer your question, I would say that while doing the data analysis, we need to extract the information from the raw data. So we need to perform various operations on raw data to grab the information about the problem domain. So in that aspect, reshaping is one of the technique that will also contribute to get the information from the given data. So now we understand that why we actually use the reshape. Let's now discuss about what are the ways available within pandas to reshape your data frame. So within pandas, we are having majorly two types of reshaping operation. The first one is the melt, and the second one is stack. So let's now discuss about the melt operation. So to understand the melt operation, I can demonstrate you one example. So let's create a data frame first, and then we will apply the melt operation. So for this, I am going to import pandas as pd, shift enter, and now I am going to create a data frame. I will call it as df, and over here I'm going to first create a dictionary with employee name, emp name. This contains a list. I am going to specify 3 employee name. First one is Jacob. Second one, I am going to give a name called Marcus. Third one can specify Dane. Now the next column I am going to create is employee ID. So I will tell that
that emp id, and over here I will again pass a list, and this one is contain a employee id. We will give some employee id over here for each of the respective employees. And now next, employee title, and over here I will specify it's a banking application. I can tell that first employee title is banker, another one is team manager, third one is analyst. So this way we have created a dictionary, and I am going to use this for creating data frame. So just I will give it diff, and this is going to be used for creating the data frame. So I will tell that df equal to pd dot data frame, and within that I will pass this one, so I will call it as text diff. Now press shift enter. So we have created a data frame over here. Press df, so type df over here, shift enter, and you will see that we have created a data frame with this dictionary. So now the next step, I am going to reshape this data with the help of melt function. So let's do it. The melt method, we are going to use pd dot melt, and here we will put it into one of the data frame. I will call it as df underscore melted, and within that I am going to pass the data frame which we have created, and here I need to specify a parameter for id underscore var. So that means which column you want to specify as a id underscore var. So I am going to tell that I will use employee id. So let me provide it over here, employee id. There is another parameter which we have to specify. What are the value vars? So this is the representation of the values within the melted data frame. So that I need to specify over here, and that I am going to use emp name as well as emp title. You can look into now. I will specify df underscore melted, shift enter. Then you will see that this is the representation of reshaped data which we have achieved through the melt method. And if you closely look into that, it's converted these information into row wise. So here first three rows is representing which employee, these id, and what is the name of those employee. If you look in closely, then you will find that from the row third onwards it is representing the employee id and what kind of title each employee is having. For example, employee id 111 is a banker, 222 is a team manager, 333 is an analyst. So this is one of the way to reshape it. Now you will be asking that can we have multiple id var? So I can tell that yes, you can have, and it will give us more meaningful information. So this time I am going to use employee name from the raw data to the id. So here I will remove this one as it is not required because I have used this one as a id var, id underscore vars. So now let's look into the data, how it is representing now after reshaping with this structure where we are having multiple id var and a single value vars. So let's do shift enter. Then you will find that it has given another representation of the same data set, or say same data frame, by reshaping our data frame. Now the next question you might be asking that can you skip any column which you don't want into this representation? Then I can tell that yes, you can. Suppose that if you don't want employee id should be involved in this reshaping operation, so you can remove it. Now let's look into the reshaping of this information. Then you will find that it haven't considered employee ID for this reshaping operation. So this example gives us an idea that we can skip the columns which we don't want within the reshaping operation. So now let's proceed for the next technique which we are going to learn about reshaping is stack. So what actually a stack is? So let's do it, then you will learn about that. So this time I am going to tell that df underscore stack, and I will tell that df dot stack method and do the shift enter, df underscore stack, shift enter. Then you will find that it provides us this representation of the given data frame. That is again a reshaping technique, and with the help of a stack reshaping we are getting this representation. So now you must be asking that is there a way to get my data frame into the original form? Then I will tell that yes, there is a way. So this time we are going to use unstack. So let me specify over here. There is a method also available called unstack, shift enter, and that will revert our stack data into unstack into the original form. So I will tell that df stack should be unstack, shift enter. Now let's look into the unstack data, shift enter, and you will find that we get our original data frame in shape. Let's compare it and see that this is our original data frame. So this is all about reshaping of the data frame, and this is very useful technique while doing the data analysis. So you should know about this thing, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to another session. In this session we are going to learn about how to calculate frequency distribution in pandas. So let's jump into the Jupyter Notebook to understand this. So we are into the Jupyter Notebook, and in this session we are going to learn one of the most important technique for data analysis, that is identifying the
frequency distribution of columns. If you are not aware about the frequency distribution, then I would like to tell you about some information about frequency distribution. This is very common in a statistic. Perform the frequency distribution, and within a statistics it is known as cross tabulation. This cross tabulation is mainly used in a problem like survey research, business intelligence, engineering and scientific research, and many more domains. So you must be asking that what kind of information it provides. So to answer your question, I would say that it provides a basic picture of the interrelation between two variables, and it also gives us information about the interaction between the variables. So to understand it better, let's do an example. So here I am going to use import pandas as PD, and I'm going to create a data frame with the help of using read_csv, and this time again I am going to use the grocery dataset grocery.csv. Let's look into the data frame, and we are having, sorry for that, we had a typo, csv, and we are having this data available within this data frame. Now suppose I want to do a calculation of the frequency distribution of fruits and vegetable, how many fruits is available within the stock and how many fruits is not available within the stock. Same is the case with how many vegetables available within the stock and how many vegetable not available within the stock. So how we can do this? So here I am going to use pd.crossTab. So pandas offers us a method called crossTab, and here we need to specify I want check for types, that is our this one type, it should be type. This column I want to check against in stock column. So here I need to specify another column against which I want to see the interaction. So here I will specify in stock, and now let's run it. Then you will find that it has given us a frequency distribution table where it is telling that we have fruit that is not available within the stock and the count of it is 3, and how many available? 7. And for vegetable we are having 1 vegetable which is not available and 9 which is available within the stock. So now you can understand that what is the power of this particular method. It gives us a very nice information about the frequency distribution within pandas, and this comes very handy while doing the data analysis. And this is again one of the method which you can keep in your kitty while doing the data analysis. And this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome to the another part of this course. In this part, we are going to learn about data analysis core concepts. So let's look into the topics. What are the topics we are going to cover in this part? So in this part of the course, we are going to learn about the following topics. So first we will discuss about what actually the data is and how we are getting the information about the problem. Once we understand that, then we will proceed further and we will discuss about what actually the data set is. Once we understand that, then we will discuss about what actually exists within the data set, that is variables, how many types of variables we are having, and what is the significance of each type of variables, and how do we analyze those variables in the data analysis process. So to get the information from the different types of data types, we have to understand some of the core concept of descriptive statistics. So in this aspect, we are going to learn about various topics. So we are going to learn about how many types of statistics we are having. But for this particular course, we are mainly discussing about the descriptive statistic. What is the significance of descriptive statistic? Why we are using it? In that aspect, we are going to learn about what actually the normal distribution is. Why do analysts prefer to have the data in normal distributed manner? Once we understand that, then we will proceed further and we will discuss about central tendency theorem. That is one of the important aspect of any data analysis. So we must have to understand what this theorem is. Once we understand that, then we will proceed further to the concept 3, where we will look into some of the measures of variability, which will be really very important while doing the data analysis. Once we understand that, then we will proceed further. At the concept 4, we will discuss about what actually the variance is, what actually the standard deviation is, why it is important to measure the variance as well as the standard deviation within the given data. Once we understand that, then we will proceed further. At concept 5, we will learn about what actually the Z score is, or say a standardized score is. Once we understand the significance of Z score, then we will proceed further and we will discuss about modality. Once you understand that, then we will look into what actually the skewness within the data, or say what is skewness concept. Once you understand that, then we will look into the last topic but not the least one, that is kurtosis.
So these are the topic which is very important. You must have to understand to perform the data analysis. So on this note, I am stopping over here. See you in the next session. From the next session onwards, I am going to discuss all these concepts one by one so that you will be comfortable with these topics. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome back. In this session, we are going to look into each of the topic which I have introduced in our earlier session. So let's start our discussion with a question called what is data? So in general term, data is referred to the fact that some existing information which is being coded in some form of suitable format. The data which we are directly receiving from the various source of input channel and that is being kept as is, that is called raw data or say unprocessed data. And that data we generally use to find the answer of the various questions from the problem domain. So you must be asking that how do we get the data for each of the domain? Then I would say that we are living in a digital world and we are using various devices or say various applications to access the information from the internet or from the any application which we are using in our daily life. So the input or say the question which we are providing by using the application or any input medium, so those information is being archived somewhere by the service provider. So to make you better understand, I am going to take an example of house pricing. Suppose that a company wants to decide the price of their building or say flats which they are constructing in the new area. So how do they decide the actual price of the home which they are constructing? So to decide the actual price of the home, we need to do some data collection for different property of that particular location. So they need to get the information about their competitors on what price they are selling and what are the features they are offering. So to collect this information, they either need to visit their competitor site, their websites, they need to conduct some of the survey within the given area. So all these information which they are collecting, that is nothing but a data. So you must be asking that why do we need data? So to answer this question, I would like to show you one diagram. Now with this diagram, you can easily make out why do we need data? Because data gives us the knowledge and as per the given knowledge, we take the right action. So in our case, if we are taking the right data and we are getting the knowledge from that data, then we can easily decide upon the price of each home in the new area. So now we have understand that what actually the data is, what is the use of the data is and how data becomes knowledge and how knowledge will be very helpful to take the right action. So on this note, I am stopping over here. So let's look into the things which we are going to cover in the next session. In the next session, we are going to discuss about the data set. When we receive the data, how we are going to organize the data, that is about the data set. We will also understand that what actually the cases are, what are the variables inside the data set. So these three topics we are going to discuss in detail in our next session. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back to the session. In this session, we are going to discuss all about data set. So let's start our discussion. So once we collected the data from the different source, then we must have to keep it in some places. Sometime it is being kept into the Excel file, sometime it is being kept into the other file format. In our example, we have kept the data inside a CSV file. So let's look into that. So I have kept the data at this location, which is a GitHub location of this particular course. You can download this data as well, and this is the data about the house price, the example which I am quoting, and this data I have collected from the Kaggle website. If you don't know about the Kaggle website, Kaggle is a company which actually organizes the data science competitions. Once you get the understanding about the data science, then you can also participate in that competition, and the data analysis which you are doing right now is the first step towards learning the data science. Let me show you how the Kaggle website look like. So this is the Kaggle website where you can apply your data science knowledge in their various competitions, which you will get it over here. If you click on the compete, it will take you to the competitions, and it organizes various competitions, some of the monetary competition and some of the knowledge based competitions. So we are using the same house price data set to understand various concepts of data analysis. So now let's look into the data which is being collected within the CSV, which I have extracted from this competition, and I have kept it into my GitHub that you can directly access. So this is the raw form of the data for the housing price competition. For that competition, somebody has already been collected the information and provided the information into the CSV file. And you can see that all the data is in comma separated format. So these information is nothing but a data set. So this is one of the example of the data set where data is being collected in CSV format to further do the analysis. Now let's proceed further and load this data into the pandas, and then we will discuss about what are cases, what are variables within this data set. So here we are into the Jupyter Notebook, and what I did, I have imported the pandas, and over here I am referring the data which I showed you. So over here shift enter, and once it is being done, let's look into the information, what the information it contains. Data set dot head, which you already know, shift enter, then you will find that we are having these informations. So the top 5 records it is returning us with the help of head method. So now the next topic is what are the cases in dataset and what are the variables in dataset. In this example, the each record is nothing but a cases, and each column whichever given over here is nothing but a variables, and these variables are also called as attributes of the given data. So now you want to know about how many cases are given in this dataset and how many variables is given in this dataset. So to know about, you need to use this dataset.shape. So this property will return you the information about how many number of cases we have. That means how many total number of observation for this particular dataset we are having. That is 1460 for this example. And we have 81 number of variables, or say we are having 81 attributes we are having for this particular dataset. Now you must be wondering that it is returning us 81 number and you are getting only these number of columns over here. So why is it so? So to represent this data in this UI, Pandas has truncated some of the information. To know about what are the variables it contains, so you have to write something called dataset.columns. So this will return you all the columns which exist within, or all the variables which exist within this data set, and all these variables help us to determine the right sell price for a house. And determining the price from the given data belongs to the predictive analysis, and that is out of scope from this course because it is the next steps after learning the data analysis in the next upcoming course, as predictive analysis contains various machine learning concepts which falls after data analysis course. So you must be asking that what we are going to cover in this course then. So in this course we are going to learn about techniques to determine which are the variables over here is contributing more to determine the actual sales price from the given data. That means we have to know all the technique to analyze the given observations, or say given data. Along with that, we have to also understand that how many types of, or say how many different types of data we are having, and for each of the different data type, what are the mechanisms to analyze those data. And that are the topics we are going to cover in the upcoming session. So I am stopping over here. In our next session, we are going to discuss about types of variables, or say types of data type, and we will also learn about why data types are important. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care.
Hello guys, welcome back. In this session, we are going to discuss about types of variables, and these variables also known as data types. So I will be using interchangeably the variable sometime and sometime data type. So don't get confused whenever I am telling that variables, or say if I am telling data type, both are representing the same thing. So let's start our discussion. So guys, data types are important concept of a statistic which we must have to understand correctly to apply the statistical measurement to our raw data set. And with the help of these statistical measurement, we will get the knowledge about the problem domain, and then we can take the right action to solve the given problem. So that's the reason it is always very important we must have good understanding of different data type, and that is very important prerequisite to perform the data analysis. So why it is important to know your data types? So if you know your data type, then you can easily apply the correct statistical measurement to your specific data types. So to perform the correct data analysis, we must have to know which data type we are dealing with, and we must have to decide upon the right visualization classification method, which we are going to look into next part of this course. So guys, this is about the significance of the data type. Now let's discuss about types of variables, or say types of data type exist within the data analysis domain. So in the data analysis domain, we are having two types of data type. First one is the categorical, another one is the numerical. Categorical data is also sometimes called as qualitative data, and numerical data is sometimes called as quantitative data. That means the data which we generally measure. In some of the books you will find that sometimes categorical data type also called categorical variable, as well as numerical variable is also called as continuous variable. So there are further categorization between these data types. We are having two types of categorical data. One is the nominal, another one is the ordinal. So you must be asking that what actually the nominal data type, or say nominal categorical data type, or on the other hand, what is ordinal categorical data type? So to answer your question, nominal categorical data type means the data type which doesn't have any orders, whereas ordinal data type we have some order. For example, here you will find that these type of information is nominal data type, where there is no order defined over here, like are you married. If such question is coming, then you keep the order in any manner. Same is the case with this example, where we are having what language do you speak, you can keep the answer in any order. So this is the example for nominal data type. But here we are having a order over here. For example, what is your educational background? So here the answer is represented in a particular order. So now let's proceed further and let's discuss about other type of data types, that is numerical, which is also known as quantitative data type, as well as continuous variable. So numerical data type is also having two types of bifurcation. First one is interval and the second one is ratio. So guys, before understanding the interval and ratio data type, we have to understand that why numerical data type is also known as continuous data type. That is because numerical data type represent the measurement, and therefore their values can't be counted but they can be measured. An example would be the height of a person, which you can describe by using the interval on the real number line. So now let's discuss about interval numerical data type and ratio numerical data type. So guys, let's start our discussion for interval numerical data type. So guys, basically interval values represent ordered units that have the same difference. Over here you will see that the temperature is having over same difference, that is +5 in each of the option. That means here we are having ordered unit that have the same difference, and that is difference of +5 in each of the options. Therefore we can tell that interval data, when we have a variable that contains numeric values that are ordered and where we know the exact difference between the values, and this is what we are representing over here for this example. So this is about the interval numerical data types. So here I would like to discuss about one problem with the interval data type, or say interval numerical data type. The problem with the interval numerical data type is that they don't have a true zero. So what it means? That means in regard to our given example that there is no such thing as no temperature. So it means with interval data we can add and subtract, but we can't perform any multiplication, division, or we can't calculate any kind of a ratios on interval numerical data type, because there is no true zero, and because of that we can't perform many of the descriptive and inferential statistic operations on interval numerical data type. So it is very important to identify your variable. Once you identify the variable and that variable belongs to the numerical data type, you must have to identify whether it belongs to the interval numerical data type or ratio numerical data type. So on the basis of that you can apply the correct statistical measurement. So now let's discuss about ratio numerical data type. Ratio values are also ordered units that have the same difference. Over here we are representing the length as an example, where we are having +5 difference in each of the options. Ratio values are the same as interval values, but the good thing is that they do have an absolute zero. So that means we can apply the operations of descriptive as well as inferential statistic. Anyway, inferential statistic I already mentioned that is out of scope for this particular course, as inferential statistic mainly related to the data modeling, which is the next step after this course where we will learn about the predictive analysis. So guys, this is about the ratio numerical data type. Now let's proceed further. So guys, we have seen different types of variables or say different type of data type now in this session. So now let's proceed further and discuss about why data types are important. So guys, I already mentioned about these points at starting of the session, but I would like to reiterate the same point why data types are important. Data types are important because when we are doing the data analysis, we analyze the data on the basis of some of the statistical operations or say some of the statistical method, and we use these methods to analyze the data. If we don't know about these data, then how do I can apply the correct measurement scale or say correct measurement tool to acquire the correct knowledge? And if we will not acquire the correct knowledge, then we will take the wrong decision or say wrong action. And in the upcoming session, after part 3, there is a part 4 where we are going to understand that how to perform the exploratory data analysis. We have different technique to analyze categorical data, and we have different technique to analyze the continuous data, that is the numerical data. So if we don't know what actually the data type of a particular variable, then we can't perform right analysis on the given data. So therefore, knowing the types of data we are dealing with enable us to choose the correct method of analysis. And that is the reason why data types are important. So guys, you must be asking that how do we come to know that which variable is continuous data type or numerical data type and which variable is categorical data type. For example, if we are talking about the housing price example where we have near about 81 columns and we want to identify which column or which field or say which variable is a numerical variable and which variable is a categorical variable. How do we come to know that? So to answer your question, I will take you to the Jupyter Notebook and where I can demonstrate that how you can identify which of the variable is the numerical variable and which of the variable is the categorical variable. So let's jump into the Jupyter Notebook. So guys, we are into the Jupyter Notebook and I am using the same example which I have demonstrated earlier in one of the session called all about data set, and over here we have near about 81 columns or say 81 variables, and I don't know which variable is a numerical variable and which variable is the categorical variable. So how do you come to know that? So let's look into that. So when we are using the pandas, so pandas data frame, here we are having a data set as a data frame. It offers a method called select underscore d type. So here in this method you can specify what kind of d types you are looking for. So here first I am going to grab all the numerical data type. Numerical d type, I will tell that equal to, and here I will tell that include, and within pandas it is known as number. So we need to specify over here, we should tell that you should include all the number variables, and the moment you will tell that, so it will include it. Now I want to also include the categorical variable. So how do I can use it? I can change it to categorical variable data type, and for this there is something called object. In pandas it is represented as object, and you must have to use the underscore over here. Now let's look into that. Take the length of each of the data type. So here I am going to tell that numerical d type dot columns, and I will print it so that it will return me how many number of columns which is belongs to numerical data type, and the same is the case for categorical data type. So here I will specify categorical d type, control V and shift enter. Then you will find that we have 38 columns which is numerical data type, and out of 81 we have 43 columns or say 43 variable which is a categorical data type. So this is about identifying the which variable belongs to which type of data type. Same way you can also look for the Boolean data type which doesn't belong to these category. So you must have to specify over here bool d type, and here you need to specify bool and make sure that you are using the underscore over here. Copy it, and this time I'm going to paste it over here, bool d type, shift enter, and we have 0 columns which is of Boolean type. So this is the way by which you can identify which variable belong to which data type. So now we come to know that how many numerical column we are having and how many categorical column we are having. We are not having any kind of a bool data type, that is boolean variables. So if you want to check that what are those columns which belongs to the numerical data type, you just copy this one, paste it over here, shift enter, then you will come to know that these are the column which actually holding the numerical variables. Same way you can check for the categorical data type. So this will represent that which of the variables or which of the column is holding the categorical variable. So now let's proceed further. So guys, now we have understand that what are the types of variables we are having, or say what are the types of data types we are having, why data types are important, and how do we come to know that which column is holding the categorical variable and which column is holding the numerical variable within the data set. So on this note, I am stopping over here. In the next session, we are going to thoroughly discuss that how do we collect information for different data types. So in that aspect, we are going to learn about the descriptive statistics. So in that, we are going to learn about what actually the types of statistics we are having and its usage. Then we will learn about what actually the descriptive statistic is. We will learn about the concept of normal distribution, central tendency, measure of variability, variance, standard deviation, z-score, that is also known as a standardized score, modality, skewness, kurtosis. So these are the techniques which we are going to apply on the variables to get the information from those data, or say from those variables. So guys, I'm stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. In this session, we are going to start our discussion on descriptive statistic concepts. So let's start our discussion. So far we have already seen that what actually the data is, what is data set. We have also discussed about types of variables, where we have come to know that how many types of variable we are having, how many types of categorical variable we are having, how many types of numerical variable we are having. And we have also discussed about why data types are important. After understanding all these things, we are now proceeding further and we are going to identify that how do we can collect the information for different data type. For example, if we are having nominal data type, what is the way we can access the information in the given data. We will also look into how to get the information from the ordinal data, how to collect information from the continuous data. So all these information we are going to collect with the help of descriptive statistic concepts. So in this session onwards, we are going to discuss about various topics that will help us to identify or to grab the information from the given data type, whether it belongs to the nominal data type or whether it belongs to the ordinal data type or whether it belongs to the continuous data type. So all these descriptive statistic concepts will help us to grab the information from the given data. So let's start our discussion. So basically we are having two types of statistic. The first one is descriptive statistic, another one is the inferential statistic. So guys, if you talk about the descriptive statistic, then descriptive statistic actually used to describe the data with the help of some chart or some graph, and that is what we are going to learn in this course. Now if we talk about the inferential statistic, that basically used to make the predictions from the data which is being provided to us, and then we have pre-processed the data and then we will apply the inferential statistic technique to do the prediction within inferential statistic. And this topic is out of scope for this particular course because we are just starting to know about the data sciences, and data analysis is the first step towards learning the data science. But prior to moving to the descriptive statistic concept, I would like to tell you that how inferential statistic works. So to make you understand, I am going to use one of the diagram that will help us to understand how actually inferential statistic works. So we are into the diagram, and this is very generic diagram. It is applied to any of the problem. Suppose that if any company, and that company is constructing houses, and they wanted to know about actual prices of the house which is they are constructing after 2 years. So how do you approach for this problem? So the first step, get the data. Then we need to understand the data, how the data is, by identifying each of the features which is coming with the sample, and that we will achieve through the descriptive statistic. Once we get the idea about the data, then we generally proceed to the next step, that is called predictive analysis. In that part of data analysis, we basically apply different types of algorithm to identify the future change information, and on the basis of that we will take the decisions. And there are various techniques to do the predictive analysis, and one of the branch of predictive analysis is the inferential statistic, which will help us to identify the future change information of the given domain. In this case, we are going to apply various inferential statistic operations, and with the help of these inferential techniques we will identify the actual price of our constructing house. And all these inferential techniques I will cover in next course of this series. Now let's proceed further and let's discuss about some of the points of descriptive statistics. So guys, as I already mentioned that descriptive statistical analysis help us to understand what actually the data contains, and to collect the information from the data we are going to use various concepts, and the concept which we are going to learn about: normal distribution, central tendency, measure of variability, variance and standard deviation, z-score, modality, skewness and kurtosis. So we will be going to discuss all this useful concept one by one, and then we will apply the knowledge into the exploratory data analysis. So when we are going to do the exploratory data analysis, then we are going to apply all the descriptive statistic concept which we learn over here while doing the exploratory data analysis. So on this note, I am stopping over here. In the next session, we are going to thoroughly discuss about what actually the normal distribution is and what is the significance of normally distributed data. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care.
Hello guys, welcome back. In this session, we are going to discuss about normal distribution. So let's start our discussion. So guys, normal distribution is one of the most important probability distribution in statistics. So basically, it is a probability function that describes how the value of a variables are distributed. So now the next question is, how do we identify that the given data is normally distributed? So to answer your question, I would tell that one of the mostly used technique to identify the normally distributed data by plotting the data. And once you plot that, the kind of a structure normally distributed data is having like this bell curve image, where most of the observation reside around the central peak and making this bell curved unimodel. So here guys, we have used one term called unimodel. That means within our data we are having only one peak, but it is not the case every time within other problem domain. So the peak of the data distribution is varied from data to data. So you must be asking that how does look like when we are having two peak as well as more than two peak, and what are these called? So to answer your question, I would like to show you one diagram, and it will look something like unimodel, bimodal and multimodal. So we have already seen the unimodel, which is having a central peak. If we are having the bimodal data, then we have two peaks, and when we are having more than two peaks, then it is being called as multimodal, where we are having multiple peaks. So what does it mean? So that means that for most of the data is belonging into two of the groups. So let's understand with an example. Suppose that if you are analyzing a data set for exam score, when you plot the data set of the score, then there might be chances that we will get this bell curve, because most of the student score belongs to a certain range, and the distribution of the score which will look like this bell curve shape. And on the other hand, if you are plotting the data of the grades, then there might be the chances that you will be getting the bimodal shape on the plot. So it means that most of the student will get A grade or B grade, and count of those grade mainly gives us this bimodal structure. Or there might be chances that we will get multimodal structure as well. So this is about the structure of the data on the plot. Now let's proceed further and discuss about the parameters of the normal distribution. So guys, as with any probability distribution, the parameter for the normal distribution is basically used to define the shape and probability. And the two parameter which basically defines the shape and the probability distribution is, the first one is the mean, and the second one is the standard deviation. So guys, mean basically defines the location of the peak for normal distribution. That means where the most of the data belongs to in the given problem domain, and it is sometimes referred as average values. So now if we talk about standard deviation, so this parameter actually used to measure the variability. It basically defines the width of normal distribution. So what it means? It means that standard deviation determines how far away the average value or the mean value tend to fall. In a more simpler term, I can tell that standard deviation represents the typical distance between the observation and the mean value, or say average value. So this is about the parameters of the normal distribution. Now let's proceed further and discuss about the properties of normal distribution. So guys, basically we are have properties of normally distributed data. Property number 1, the mean, median, mode are all equal. Property number 2, when you plot the data distribution, then you will find that the curve is symmetric at the center, that is around the mean, and exactly half of the values are left of the center and exactly half of the values are to the right of the center. So this is about properties of normally distributed data. So now let's proceed further and discuss about some more point of this bell curve shape. So if you closely look into this bell curve shape, then it would look something like this, and you will find that this bell curve has a small percentage of the point on both the tails, and the bigger percentage of the inner part of the curve, 68% of data, belongs to this range, and the variance within this 68% of data is having only one standard deviation, whether it is a positive side or within the negative side. And now if you closely look into this diagram, then you will find that it contains 95% of the data which has two standard deviation, either from the positive side or from the negative side. That means 95% of the data belongs to this range. And if you further look, then you will find that almost 99.7% of data belongs to the 3 standard deviation. That means most of the data either belongs to the +3 standard deviation or -3 standard deviation, and that covers almost all the range. So guys, initially you might be feeling it very much confusing. What is the use of it? Why to use it? But don't worry, when you proceed further and if you perform various analysis, then you will come to know that what is the significance of these percentage. And if any of you is not able to understand this concept, then I would suggest that you should refer some of the basic elementary statistic textbook, or you can also refer the Wikipedia for further understanding. So on this note, I am stopping over here. See you in the next session. In the next session, we are going to discuss about what actually the central tendency is. And on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care.
Hello guys, welcome back. Now in this session we are going to discuss about central tendency and the tool for measuring the central tendency, that is mean, median and mode. So let's start our discussion. So guys, what actually central tendency refers to? So basically central tendency refers to the idea that there is one number that best summarizes the entire set of measurements. That means a number that is in some way central to the set of given data. So to measure the central tendency, we basically use three things. The first one is the mean, the second one is the median, and the third one is the mode. Many of you must be knowing about these concepts, and if any of you don't know about these concepts, I'm going to brief about these concepts. So let's start our discussion with the mean. So mean is also known as average. So it basically used to calculate the central tendency of the data, that is a number around which a whole data set is spread out. So in a way, it is a single number which can estimate the value of whole data set. Now the second question comes over here is, how do we calculate the mean or an average? So to calculate it, basically we use the formula where sum of values of each number divided by the count of number. Over here we are summing up 8 digits and the value is being summed up, and then it is being divided by 8. Why it is being divided by 8? Because we are having 8 digits in this calculation, and the mean value we are getting it is 55.75. So now let's proceed further and let's discuss about the median. So median again used to calculate the central tendency of the given data. So how does the calculation of median happen? So basically median is the value which divides the data in two equal parts, that is number of terms on right side is same as number of terms on the left side, and the number which remains within the middle, that number becomes median value. Now you must be asking that, suppose if you are having even number, then how do this calculation will happen? So over here the given example is having the even number. That means we are having 8 digits. So how the calculation will happen? The first 3 number will fall into the left side and the last 3 number fall into the right side, and the remaining number which remains over here, that is 51 plus 67, is the center. So it need to be added, and which is being divided by 2, and the number which we will get, that becomes the median value. And over here if we will calculate 51 plus 67 divided by 2, then you will get the number 59. That is the median value. Another way of calculating the central tendency, that is mode. So let's discuss about mode. So mode is another way to calculate the central tendency within the given data set. So how does it calculate the central tendency? So mode calculation is based upon the occurrence. So mode will calculate how many number of times a given digit is being appeared, and that digit will be considered as central value within the given data set. Over here in this example, you will find that number 67 is having an occurrence of 2, and that is the highest occurrence, so the mode is 67 for this given data set. One point you should remember that there could be a possibility we don't have any kind of mode exist within the given data set. So if there is no mode at all the values appear same number of times. Now you must be asking that, suppose if any digit is having multiple occurrence, for example, consider in this scenario, if we are having another 51, not 41, then we are having two mode over here. One is 67, another one is 51. Then this data set represented as bimodal, which we have already looked into. So it will look something like this if we are having multiple mode exist within the data set. So this is about the central tendency of the data, and on this note I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. In this session, we are going to look into how to measure the variability within the given data set. So let's start our discussion. So before starting the discussion about the measure of variability, we have to understand that what actually the variability is. So guys, in a very simple term, I would tell that variability is another set of measurement which actually used to describe the amount of variation we are having within a given data, whether our data is containing low variability, whether our data is containing medium variability, or whether our data is containing high variability. So how do we come to know that, or say how do we can measure those variations within the given data set? So now let's discuss about those techniques which will help us to measure the variability within the given data set. So basically there are four techniques we basically use to measure the variability within the data set. The first one is the range. We need to identify the highest value and the lowest value within the given data set, and then we will calculate the difference between the highest value and the lowest value to identify the range. So how do you calculate the range? So you should calculate something like this. So here in the given example, we are having 11 numbers, and out of these 11 numbers, the highest value is number 11 and the lowest value is number 1, and we have subtracted from highest value to the lowest value, then we got the range. So this is about the calculating the range. One thing you should make sure that whenever you are doing such calculation, you have to first sort the data and then pick the first value and the last value for applying the range calculation. Now let's proceed further and discuss about another technique to identify the variance within the given data set. So the another technique we are having is called interquartile range. So let's discuss about this technique. So in interquartile range, what we actually do, we actually divide the data set in 3 quarters. In the first quarter, we have 25% of the data. In the second quarter, you will see that it contains the 50% of the data, and in quartile 3 we are having 75% of the data. Quartile is nothing but a range of percentage distribution. Over here we are having 8 number, so the first 2 number is the representation of the 25% of the data. Another first 4 number is the representation of 50% of the data, that is called Q2 or say quartile 2, and the next 6 number is the representation of Q3, that is 75% of the data. Now to get the variation within the data set with the help of interquartile range, we have to use this formula Q3 minus Q1. So now the question over here is, how do we calculate the Q3, quartile 3 and the quartile 1 for this example? So for this example, we are having over here Q3 at 6 and 7. So we will pick this number and calculate the average of these two numbers. In the same way, we will calculate the quartile 1 by taking the number 2 and 3 because it is falling over here, and the average value will be the result of Q1, that is quartile 1, and then we will minus the value of quartile 3 to quartile 1. So let's look into the example how this entire calculation will look like. So to calculate the interquartile range, we need to first take the Q3 value, that is 6 plus 7 divided by 2. Then we will get the number 6.5. Same way, we have to take 2 plus 3 and it will give us the result, and it should be divided by 2 and it should give us the result 2.5. And now if you minus 6.5 minus 2.5, then we will get the result 4. So that means our interquartile range is 4. So this is one of the method to identify the variations within the given data set. Now let's proceed further and let's discuss about another method to calculate the variations, that is called variance. So let's discuss about this. So to calculate the variance, we use this formula. Over here, sigma is the representation of the standard deviation, and if you square it, then you will get the variance. So basically this formula represents that in a population, variance is the average square deviation from the population mean. So what it means? So it means that we have to first identify the mean value, or say average value of the given data set, and then we will subtract with each data point with the mean value, and then we will square the result. And once we get the result for each of the data point, then we will sum them up, and then we will divide it with the total number of data points. So this is about the variance calculation. Now let's proceed further and let's discuss about another method to calculate the variability, that is standard deviation, and this is also pretty much straightforward. Once you have done the calculation on variance, then the same formula you will see it over here, but this time you are having the square root. So that means if you calculate the square root of this variance, then you will get the standard deviation. And what a standard deviation tells us? Tells us how much deviation we are having for a given data point from the mean. As I already mentioned that if we are having a normally distributed data, then 68% of the data which belongs to one standard deviation, either from the positive side or from the negative side, and 95% of the data is having two standard deviation, and at last almost 99.7% of the data of a normally distributed data, it has a standard deviation of 3. So now we have seen all the four methods which is used to calculate the measure of variability within the given data set, and this is what I wanted to discuss in this session. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. Now in this session we are going to start discussing about the Z-score, that is also known as a standardized score. So let's start our discussion. So guys, so far you are now comfortable with this diagram, what this diagram represents. So it is a representation of the normally distributed data. If our data is normally distributed, then we will get this bell curve shape when we will plot the data, and this diagram we plotted on a standard deviation unit. So guys, let's start our discussion with a question called what actually this Z-score tells us. So to answer your question, I would tell that this Z-score describes the position of a raw score in terms of its distance from the mean when we measured in standard deviation units. So what does it mean? It means that suppose if you are having a data point within a data set and you want to measure your data point how far it is from the mean, then how do you measure that? So we must need a mechanism by which you can measure each of your data point and their distance from the mean. So to measure such distance, Z-score will be used. Now proceeding to the another question, you must be asking that in this scale, why this negative number is given over here? And why this positive number given over here, and what is the significance of this negative as well as this positive numbers? And suppose if you are getting the Z-score in a negative term or in positive term, what is the significance of those positive negative Z-score? So to answer your question, I would tell that when our data point distance is above the mean, then we will get the positive Z-score, and when we get the negative Z-score, that means that our data point is lesser than the mean value. So let's now discuss about how do we calculate the Z-score. So to calculate the Z-score, we will be using this formula. In our earlier session, we have already seen that how to calculate the mean value, how to calculate the standard deviation, and this is our data point. So to calculate the Z-score, we generally minus the data point value with the mean value, and we will divide the value with the standard deviation, and this will return us the Z-score for that particular data point. And if it comes negative value, then that means data points is lower than the mean value, and if it is positive value, the Z-score is positive value, then that means data points is more than the mean value. So now let's proceed further. Now you must be asking that if you will get the value 0, then what it means? So it means that our data point is residing at mean. And on this note, I am stopping over here, and this is what I wanted to discuss in this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back to the another data analysis core concept session, where we are going to discuss about three main important topics, and the topics are modality, skewness, and kurtosis. So let's start our discussion. So guys, you have already seen this diagram, but I haven't introduced the term modality on that particular time. Now you can easily make it out what actually the modality is related to. So basically, modality used to describe the number of peaks within a given data set, and these number of peaks will define what kind of data distribution we are having within a given data set. If we are having a single peak, so that means it is a unimodal, and if we are having two peaks within a given data set, then it has become bimodal. And the third category of modality is the multimodal, where we are having the multiple peaks. So I'm hoping that you already know about what actually the significance of these peaks are, but if you don't know about the significance of these peaks, I will reiterate the point. So when we are getting the single peak, that means our data is normally distributed, and our 68% of the data which belongs to one standard deviation, and that standard deviation might be positive or it might be negative as well. As we already discussed about what standard deviation represent, it will tell us how far our data point is from the mean. In more simple term, I can tell that our most of the data point is near to the mean when we are having the unimodal. Now if we talk about the bimodal, that means we are having two peaks and most of the data points belongs to two different ranges, and such kind of shape you will get when you try to analyze count of categorical data. For example, if you want to identify that how many number of students gets grade A and grade B, and when you try to plot the data, then you will find that belongs to the bimodal. So guys, this is about the modality concept which I wanted to discuss. So now let's proceed further and discuss about another concept called skewness. But prior to discussing about skewness, I just wanted to tell you in this part of the course I am just focusing upon the concepts, or say core concept of data analysis, so that you should be aware about the terms which is being used while doing the data analysis. In this part of the course I try to avoid writing a single line of a code, because I want that you should first aware about the concept, then you can easily write the code and you can easily interpret what actually the significance of these concepts when you are getting the diagram within the plot. And now if you talk about how to draw these graphs or these plots of the given data set, then don't worry, we are having a separate section for data visualization within this course, and that section comes in next part. So now let's proceed further to the next topic, that is skewness. So guys, when we receive the data set, so our data, it doesn't generally comes into the normally distributed form. Most of the time we will get the skewed data. But prior to discussing about what actually the skewed data is, we have to understand that what actually the skewness concept is. So guys, skewness is the measure of how much the probability distribution of a given data set that deviates from the normal distribution. So now you must be asking that how normal distribution comes into the picture of skewness. So to answer your question, I would tell that if we are having the normal distributed data, then skewness should be 0, and their mean median mode belongs to the same point, and their left of the center and the right of the center looks symmetric. Now this is about the symmetrical distribution. Now let's talk about types of skewness and their significance. So basically we are having two types of skewed data. One is the positive skew and another one is the negative skew. So how do you identify that whether the given data set is positive skewed or negative skewed? You can identify with the help of plotting. If you plot the positive skew data, then you will find that most of the point belongs to the left side of the point. Another point you will notice over here in the positive skew data, where the tail is skewed on its right side, this portion I am talking about. Another properties you can check within the positive skew data is that when you calculate mean median mode of the positive skew data, then you will find that mean is greater than median and median is greater than mode. So now let's discuss about what actually the negative skewed distribution. So guys, a negatively skewed distribution is the distribution with the tail on the left side, like this image, and the value of skewness for a negatively skewed distribution is less than 0, and you can see it over here. Mean value is lesser than median value and median value is lesser than mode value. So to identify the negatively skewed data, you must have to remember this pattern. So when you plot your data set, then you will get such kind of histogram as well as KDE plot. KDE plot mainly refer to the kernel density plot, which will be generally used to identify the distribution of the data, to get the idea about how this data is distributed, whether the data is positive skewed or negative skewed, or it is normal distributed data. So guys, this is about the skewness of the data. Now you must be asking that how does it matter if my data is positive skewed or negative skewed? Then I would tell that when we proceed to the next step where we are doing the data modeling with the help of predictive analysis, and if we provide this skewed data to our data model, then our data model will give the wrong result. And if it will give the wrong result, then we will take the wrong decision. So now you must be asking that, so what is the next step once we get the skewed data in our data set? So how I can make our data set to remove the skewness from the given data set? Then I would tell that there are certain mechanisms, or say there are certain transformation techniques available. With the help of that, we can remove the skewness from the given data set. And those transformation techniques are, there is something called power transformation. We can convert our given data set with the help of power transformation. There is another mechanism that is called log transformation, and the third way is exponential transformation, that is used to convert our given data set to remove the skewness. But on top of these three, there is one of the powerful transformation technique is available, that is called Box-Cox transformation. With the help of that technique, we can remove the skewness and we can get our data ready to feed into the predictive model. And all these things are out of this course, as we are just learning the data analysis, where we are in a process to understand how our given data set is, what is the distribution of our data set is, what is the skewness within the data set, whether our data set is positive skewed or negative skewed. We are just learning those techniques. In the next part of this course, that is going to be predictive analysis course, where we will learn about all these transformation concepts in more detail. So now let's proceed further and discuss about another concept, that is called kurtosis. So guys, before discussing about the kurtosis, we have to understand there is a term called outlier. Then we will understand that why we are using kurtosis and what actually the kurtosis is. So guys, what is outlier? An outlier is an observation that lies an abnormal distance from other values. So suppose that if we are having a data set and if we are having some of the unusual observation that are far from the mass of the data, that point is often referred as outliers. So let's understand with an example what actually the outliers is. If you closely look into this diagram, then you will find that it is the representation or a scatter plot for XY data point. And here you will find that some of the observation residing very far from the mass of the data. Over here you will find that we have near about 5 outliers, which is very far from the actual mass of the data. So these data points which is far from the mass is called outliers, and outliers always affect the data analysis process. So it is always rule of thumb is that if any of the observation which belongs to the outlier category, we should remove from the data set, and then we will perform the data analysis, and then we will perform the predictive analysis. Because if we will feed the outlier data to the predictive model, then it will give us the wrong result. So that's the reason we have to perform the data analysis to identify the outliers. Now the question comes over here is, how do we can identify these outliers data point? Then kurtosis comes into the picture. So kurtosis help us to identify the outlier data point. We have three types of kurtosis. First one is the leptokurtic, second one is the mesokurtic, and the third one is the platykurtic. Mesokurtic is the representation of the normally distributed data. So that means our data set doesn't contain any outliers. Now if you talk about the leptokurtic, then this kind of shape will tell us that it contains the outliers. So if you go by formal meaning of the leptokurtic, then lepto means thin or skinny, and the leptokurtic distribution means there is a small change or less frequent data exist within the data set. Less frequent means the outliers, which is happening very rarely. In this case you will find that this data is happening very rarely, certain points occurring very rarely. In this case we are having two instances of those points. So now let's discuss about the platykurtic. So platykurtic distribution shows a negative axis kurtosis. So this kind of kurtosis reveals a distribution with flat tail, and the flat tails indicate that a small outlier in a distribution. And one thing I would like to tell you, platykurtic is very helpful for investors who wanted to invest. They also refer this kind of distribution, platykurtic distribution, while purchasing the share. If they find that kurtosis belongs to the platykurtic, then they will not do the investment in that particular share, because there is a very small chances that the investment would experience extreme returns. And on this note, I am stopping over here, and this is what I wanted to discuss about in this session. See you in the next session. Till then, bye bye, take care. Hello guys, welcome to the another session. In this session onwards, we are going to learn about matplotlib library, and this library is basically used for data visualization. Matplotlibs makes scientific plotting very straightforward that we are going to see in a various examples in the upcoming session. In this matplotlib journey, we are going to learn about important aspects of matplotlib, as well as we will look into various types of graphs like point graph, bar charts, multiple bar chart, a stacked bar chart, pie charts, histograms, box plots. So all these type of graphs which we are going to learn, and we will look into how to draw all these type of graphs, and more importantly in what scenario we are going to use what kind of graph, so that we can get the information about raw data, input data, and that graphs help us to take the informed decision while applying the data modeling. So let's jump into the Jupyter Notebook to start our journey of matplotlib. So we are into the Jupyter Notebook. Now we will do some exercises to understand how to use matplotlib for data visualization, and we are going to learn all this by doing some exercises so that we will get our hands dirty and we will have better understanding. So for this exercise I am going to import two libraries. The first one is the NumPy library, which we will use to generate some raw data, and on that raw data we are going to do the visualization. And the next library I am going to use the matplotlib for the data visualization. So let's do it. So the first I am going to import NumPy as np, and then I am going to import matplotlib, and there is a module called pyplot that basically we use for plotting. So we will write it something like this. This is the industry standard, so you should follow the same standard. Whenever you are importing NumPy, you should use np, which I already mentioned. If you are using matplotlib, then use alias you have to create a plt. So now let's proceed further, and over here we are going to do the first exercise where we will look into how to draw curve in matplotlib. So to draw the curve, first we will generate the data. So how we will generate the data? We will use NumPy linspace. So let's generate it. So here I will press B, and I'm going to generate a point called x, and I will tell that np.linspace. So what is linspace? So basically linspace is a function in a NumPy which we generally use to generate the numeric sequence, and that is very handy tool to generate the raw data. For example, we are using over here to generate some raw data, and I want it should generate from 0 to this formula. I am going to use np.py, and then I need to specify that I want 100 values, and shift enter, select this one, press B. Now I am going to generate y, and this time I am going to generate the data point which is being related with this data only, and this time I am going to generate with sine function. So let me write it, np.sine, and here it is going to be generated on the basis of these generated data, so that we will check the relationship between x and y. So let's do shift enter. So now we have generated the data x with the linspace and y with the sine in function. Now let's press B again, get new cell. Now I am going to do the visualization on these generated number. So how I will do that? Let's look into that. So I will write plt, that is the alias which we have written over here, dot, and there is a method available called plot, and here I need to specify two values. The first value which we have generated x, and then I need to specify y. Now let's look into the output, what kind of output it is generating, and you will see it over here. It has generated a sine curve very beautifully without doing any much extra work. If you are doing the same thing in JavaScript or any other language, then you need to do so many pre-processing while generating such kind of a graph. But with matplotlib, it is very powerful. It gives us the capability to generate complex graphs very easily. So this is about the single graph generation. Now suppose if you want to generate multiple graphs in the same plot, so how you can do that? So now what I'm going to do, I'm going to generate some more data point in some other variable, and that also I will draw it over here. So I'm going to use the same data point, but this time I'm going to generate on the basis of cost function. So here I will select this cell, press B, and this time I am telling it as some z variable, and I am telling that np.cost, and this is again going to use the same x data point which we have generated with the help of np.linspace, and here I have specified that. Now shift enter. Now let's plot it. So first we will plot it with y, and I will tell that plt.plot, and over here the x data point and the y data point. Same I will specify plt.plot, and this time x data point with z, which we have generated with the np.cos function. So let's do shift enter and you will find that it has generated the multiple curve on the same plot, and that is also very easy to draw without writing much code. So you can imagine the power of matplotlib, how easily it has drawn multiple graph on a single plot. So on this note, I am stopping over here. In the next session, we are going to look into various types of graphs, and we will also discuss about in what scenario of data analysis you should use that kind of graph. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Hello guys, thanks for joining this session. In this session we are going to discuss about matplotlib architecture. So let's jump into a diagram where we will start our discussion. So guys, the architecture of matplotlib is logically structured into three layers which are placed at three different levels. And the communication between these three different levels is unidirectional. That means each layer can communicate with the underlying layer, with the lower layer cannot communicate with the top one. So see here, you will see that it is a unidirectional communication that is happening through top to bottom. So if you will look into this diagram, then you will find that the layer which we are having over here is scripting, artist, and backend. So let's start discussion about each layer one by one. So we will start with the lowest layer, that is called backend. So backend layer is the lowest layer of matplotlib architecture. As it is the lowest layer, so that means it contains various APIs as well as classes that play the role of implementation of graphic elements at a lowest level. So basically backend layer contains three objects, that is figure canvas, renderer, and event. So these three objects which is working at the backend layer. So figure canvas is the object that embodies the concept of drawing area. So what it means? Let's look into the example. If you remember our first example where we have drawn some curve graph by generating some XY points, on that time we have used this plot to draw the curve, and this is the graph which we have generated with the help of matplotlib. So here the figure canvas is providing this image drawing area. So the area which is defined over here, that is basically being generated with the help of figure canvas. Now the second object which actually draw the graph on figure canvas, that is a renderer object. And the last object which is the part of backend layer, that is event object, that actually takes care of user input. What input is user is providing, on the basis of that input it draws the graph. So now let's proceed further. So this is about the backend layer which uses three objects. So now let's discuss about the another layer, that is the artist layer. So to understand the significance of the artist layer, you have to understand this figure. So this is the figure. We are having three objects over here. The first one is the figure, the second one is the axis, and the third one is the axis. So if you closely look into this image, you will find that this is the same image which we have earlier generated. And if you are talking about the single axis, whether it is x-axis or y-axis, so it is called as axis. Axis is one of the object, and overall it is called axis, and the complete thing is called figure. So all these elements which we have seen it over here, that is an instance of artist layer. So that means all of the things which you are seeing it over here, like figure, axis, axis, all these are instance of the artist layer. There is another point which I wanted to discuss over here, is that artist classes is two types. The first one is the primitive class, and the another one is the composite class. Or you can say that primitive artist class or composite artist class. So you must be asking that what actually the primitive artist class and the composite artist class is. So the primitive artists are individual objects that constitute the basic element to form a graphical representation in a plot. So let's look into the example. So in this example, we have drawn a line in XY axis. So this line is an individual object. So this is nothing but a primitive artist class. Now if you talk about the composite artist class, then it is nothing but a combination of all these primitive artist class is a composite artist class. Over here we are having two axes. One is that x-axis, another one is the y-axis, and overall it is called axis, and together it is composite artist class. So now let's proceed further. So in summary, we can say that artist class is responsible to draw the entire graph together with the help of different elements, and these element is nothing but the instance of artist class. So now let's proceed further and discuss about the first layer, that is the scripting layer. So the scripting layer provides the API
to call the visualization modules like we have used earlier called pyplot. So let's look into that example again. So over here we have used this matplotlib.pyplot. So this is nothing but a scripting layer which we are generally using to access the artist layer by providing the data points, and this way it actually work together to form this graph where with the help of a scripting layer we are passing the input, and that input is received by the artist layer, and artist layer draw the object accordingly like xy axis, line object, and on the basis of these data points backend layer will draw the figure image or say figure canvas, and on that canvas all these object is being drawn, and at the end we are seeing this beautiful graph which is drawn on notebook over here. So now let's proceed further. So now we have discussed about various layers which actually defining the matplotlib architecture, and this is what I wanted to discuss in this session. See you in the next session. Till then, bye bye, take care.
Come back. In this session, we are going to look into parameters of plot. So let's start our discussion. So guys, whenever we are working with plots, then we have to handle various parameters which actually make the plot complete. So if you closely look into this diagram, then you will find that there are near about 7 parameters which actually help us to define the plot. So let's discuss about these parameters one by one. Suppose that if you want to handle the size of the plot, then we have to handle with a figure parameter within the plot object. Same way, if you want to change the look and feel of axis of the plot object, that you have to handle through the axis parameter. And if you want to specify the text within the plot, then you have to use the text parameter. Now next, suppose if you want to change the range of x-axis and the y-axis, and that you can handle through the x-axis and y-axis parameter. So guys, if you want to manipulate the plot object, then you have to handle it through all these parameters. So to see all this thing in action, let's jump into the Jupyter Notebook and we will draw a plot, and then we will look into all these parameters. So guys, I am going to write the code, and I will start with importing the pandas first, and then we will also import matplotlib library. Once we import that, then we will import the seaborn library. So here we will import pyplot as plt, which we have already seen. Then we will import seaborn as sns. You already know about this thing. Now we have imported all the libraries. Now the next step, we will get our data into a data frame, and then we will draw the plot. So let's press shift enter. Now let's grab the data. So I am going to grab into a data frame, and this time I am going to use pd.read_csv, and the data which I am going to use it over here is this one. This data exists at my GitHub location. You can also use the same raw data and put it into your notebook if you are writing along with me. And now you will do the shift enter, then you will find that we will get the data into the data frame. So this data set contains the information about the different vehicles, more specifically different cars and their mileage detail along with their cylinder detail, and these are the specification of their engines along with the name of the car and their model. So now let's proceed further and let's look into how to define the figure size of the plot. So to do that, I'm going to use plot.figure method. There is a method given, and within that I'm going to specify the size of my plot, and the parameter I'm going to use is fig size, and this requires to provide the tuple. These parameters represent height and width of the given plot along with DPI detail. DPI means dots per inches, which actually determines how many pixels the figure comprises. The default value is 100, but here I want DPI should be 80, so I should mention 80 over here. Shift enter. So guys, for this example I am going to draw a heat map which will actually give us the correlation information about each variable with each other. So basically we are drawing the correlogram. So now let's do it. So how we can do that? We are going to use seaborn plot, and I'm going to write sns.heatmap. And what does heat map will take? It will take the correlation information that we will grab it through the data frame method CORR, and here you need to specify this method. Now the next parameter we need to specify tick level, x tick level we want to specify. So again I want that it should print all the variable name to x tick level as well as the y tick level. So how we can do that? We need to tell that we will get the data frame, we will get the correlation, and then we need to also grab, there is a property called columns which we need to specify. So this is about x tick levels, and what it will do, it will print all this level at the X level as well as the Y level. So to make it Y level, we are going to use the same thing, but this time we are going to tell that it should be Y level. So here I can mention Y tick levels. Now next we need to set the C map. C map is the representation of the color map, which basically gives you various color combination as per the correlation strength. So let's provide CMap over here. I'm going to write CMap, and here I need to specify something called BUPU. So you must be asking that how I get this value. So I will show you now. So there is a site called pythongraphgallery.com where you will get such information, and it will give you these color combination with these codes. So I have been using BU and PU. You can use other one as well, and these color represent the correlation strength between two variables. So let's go back to the Jupyter Notebook. Another parameter I'm going to specify over here is center equal to 0, and annotation I want it should be true. Now let's do shift enter and see the result. It is very crumbling plot, which actually doesn't help us to get the information from this plot. Now the question over here is how we can beautify this plot so that it should be more readable and more useful. Then here it comes all the parameters we should handle to make this plot more readable. So now let's do it. So I am going to start with some of the constant declaration. So I am going to tell that I'm going to have some value large equal to 22, medium equal to 16, and small equal to 12. Once we have declared the constant, the next step, I'm going to create a parameter dictionary which basically holds the initial configuration of this plot. I'm going to tell it as parameters, and this is going to be a dictionary, and I need to tell what are the keys I'm going to handle. So I'm going to handle the access, the title size I want to keep large. I need to specify large over here. The next key I want to handle is the legend. So I will tell that legend dot font size, and what kind of font size I am going to have. It is going to be the mid value. So I will tell that mid. Another parameter I want to handle is the figure size. So I will tell it over here figure dot fig size, and I will tell that in a tuple I will tell that I want 16, 10. So this contains the height and width. Another parameter I want to handle is the access level size. So I will tell that all the information which is going to be printed on access, it should be of mid size, that is of 16. Now another one I want to keep it the X tick. I want the X tick level size should also be a med value. So I will tell that med over here. Now coming back to Y tick. Y tick also have the same kind of a size. So I will tell it over here med, and then next I am going to tell that the figure title size. So the figure title size, as it is going to be the heading of the plot, so I will tell that title size is large. Once it is being done, I need to update these parameter for this particular plot. So for that I am going to use a method called rcparams.update, and here I need to specify all these parameters which I want to update. And next, one thing, currently we are using the matplotlib grid over here, so I want that should be the seaborn grid I want to use. So I need to specify the style for that. So for that I am going to write plot style dot use, and over here I need to specify what kind of style I want. I want seaborn hyphen white grid. Once it is being done, we need to set the style. So I will tell that sns dot set underscore style, and it should be white. Once it is being done, let's do shift enter. We have a typo error. Yes, we did a mistake over here. It should be dot, and if you closely look it over here, we have done level size, shift enter. Now we have set the parameter. Now again I will go back to this particular line and do shift enter and see what actually it is doing, and you will see that it has beautified our plot and it is more readable now. So now you can imagine how important these parameters are and how you can easily manipulate the size and the color of these parameters with the help of the parameter which we have discussed. One thing we are missing over here is the title, so we can set the title as well. We need to tell plot dot title, and here you need to specify whatever the title you want. Tell that heat map for empty cars. Shift enter and you will see that it has printed the title for this particular plot. So guys, this is about the parameters of plot. The significance of this particular plot I will discuss in some other session, as the intention for this session is to not explain why to use this plot. I just wanted to show you how you can manipulate the plot parameters or say plot information with the help of different parameters which we have access through all these parameters. So guys, this is one of the best practices whenever you want to change the parameter. So you should create the dictionary, and where you need to specify those parameter as a key, and whatever the value you want, you can create the constant for that, and then you will specify that. And suppose if you want to do a change within the global configuration, you just come here, and here you need to specify, for example 25 I want the size of the access title. Then I just come here and I will change the title. Now if you will run it, then you will find that it will increase the size for the access title. Shift enter and you will find that it has increased the size for the access title. So now let's proceed further. So guys, we have seen that how to manipulate the plot object with the help of these parameters, and this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care. Hello guys, thanks for joining this session. In this session we are going to learn about Seaborn plot. So mainly in this session I am going to give you the overview about the Seaborn plot. So we will come to know about what actually the Seaborn plot is, how it is different from the matplotlib, and why should we use Seaborn plot on top of matplotlib. So let's jump into the Jupyter Notebook where we will start our discussion. So we will start our discussion with the understanding of what actually Seaborn is. So in a very simple term, Seaborn is also a data visualization library within Python, and Seaborn library built on top of matplotlib. It gives us the capability to create amplified data visuals, and those visuals helps us to understand the data by displaying it in a visual context that will help us to understand the correlation between different variables which exist within the raw data. One point I wanted to tell you over here is Seaborn has a high level interface as compared to the low level of matplotlib. So here low level means matplotlib API is relatively low level. That means it is doing sophisticated statistical visualization, requires you to write some code and then perform the visualization activity using the matplotlib. But if you are going to use the Seaborn library, that is a high level libraries which provides an API on top of matplotlib that offers to plot various style, color, simple high level function for common statistical plot type, will be achieved without writing extra line of code if you are using the Seaborn plot library. So to understand the difference between the data visualization of matplotlib as well as the data visualization of Seaborn, what I am going to do, I am going to write a program where I will generate some random number and then I will plot it with matplotlib, as well as the same generated number I will plot with Seaborn library. Then you will easily make the difference between which library is giving more visual appeal and which data visualization library you should choose on top of other data visualization library. So let's start writing the code. Over here I am going to write first import numpy as np as usual. I am going to use the data frame. So for that I need to use pandas as pd, which you already know that. Next I am going to create a data frame on the basis of the random state. So there is a function or say method available within the numpy which we will use to generate the data range, and the name of the method is random state, and which is into numpy random module, and the method I am going to use random state, and I will tell that 0 over here. And then I am going to generate the x with the help of linspace, which we have already seen in one of our example. And here we will specify that I want from 0 to 10 and I want 500 values. Next I am going to generate the y point, and that is also going to be based upon, there is another method of numpy that is comsum that is used to generate the cumulative sum. So let me write it over here. I am going to use the range over here, range dot randn, and over here I need to specify 500, 6, 0. So this will give us 2 points, that is for data for x and data for y. So 2 array we will get 2D array. Now using this data I am going to visualize the generated data on matplotlib.
So to use it, I'm going to use matplotlib. So let me import it, matplotlib.pyplot as plt. And now I am going to visualize the generated data on the pyplot. So let's write plt.plot, and here I need to specify the generated number x and y, and this time I am also going to print the legend. So let me write that. I can tell that a b c d e f number of column equal to 2. loc where I want to print, I want upper left, it should be printed the detail about the legend. So now do shift enter and let's look into the output. We did a mistake over here, comma, shift enter, and then you will find that the data which is being generated, it has drawn into the matplotlib data visualization library. So if you look into this particular data visualization, there is nothing wrong in it. But the thing is, it looks very old way of representation and it doesn't look very appealing. So now I am going to generate the same graph using Seaborn, and then you will see the difference between the matplotlib data visualization versus Seaborn data visualization. So the first step, you need to import Seaborn library, import Seaborn as SNS. So this is the industry standard practice. Whenever you are using Seaborn, you should use alias as SNS. So it is industry wide, most of the people are using the same alias, so you should also follow the same pattern. Now the next step, you need to set the Seaborn library as a default library to display the graphs. So how you will do that, you need to specify sns.set. So that means you are now onwards you are going to use Seaborn as a default library for data visualization in this Jupyter Notebook. So now let's plot the same thing, but this time with the Seaborn library. So I haven't done any changes. Now let's do shift enter. I have just copy and pasted over here. Now do the shift enter and then you will find the visual difference between Seaborn plot as well as the matplotlib. And you will find that this looks more appealing than this matplotlib. If any of you doing the data analysis with R programming language, then R programming language offers us something called ggplot. There we use ggplot for data visualization, and this Seaborn looks exactly the same like ggplot data visualization. For some of you people think that, okay, so what actually the difference? You are getting some of the grid instead of some of the background is not coming for matplotlib. Then I will tell that it is just not limited to the visual appealing. There are various internal methods which will be very helpful for data visualization using Seaborn library. In the upcoming session, I will show you various graphs, types of graphs by purpose that will be very handy to visualize the data and get the information about the data, which is very tough if you are using matplotlib. To achieve such kind of a visualization, you need to write some of the initial code, and then only you will get the representation of that particular data visualization. And with the Seaborn, we will achieve those functionality by writing single line of code. So now let's proceed further and we will discuss about variety of plot types that we can easily generate with the Seaborn by writing a single line of code. So now let's take a look some of the plot types that is available in the Seaborn. So the first plot we are going to look into is the histogram plot. So let me write it over here, histogram, shift enter. Now let's generate some data. So for that I am going to tell that data D, and this is going to be multivariate, and that is from the random package. There is a method called multivariate normal distribution. So it will generate the data which is normally distributed. So here I need to specify the range. So this will give us the normally distributed data, and that is going to be numpy array. So I want it as a data frame, so I will tell that df equal to pd dot data frame, and here I will pass the numpy array. So this line of code will give me the data frame. So it has generated the data frame. Let's look into the data frame, what it has generated. So you will find that it has generated this data. So it has generated 2000 records over here, and which is being distributed between these given range, and that is normally distributed. So how do we confirm that the data which it has generated that is normally distributed. So here I am going to use histogram plot to verify the distribution of the data, generated data. So let's generate the histogram plot. So here I am going to generate histogram with kernel density estimation plot, that is KDE, for plotting the smoothness. So to draw the histogram I am going to use seaborn dist plot method, and this will generate histogram as well as KDE plot. KDE stands for kernel density estimation. It will give us the smooth graph. So let's look into that, and here I will specify data frame and the column which I want to plot. Same is the case with this one, SNS dist plot. Again I need to specify the data frame and which column I want to use. So here I am going to use Y. Now do the shift enter, and then you will find that it has generated the histogram plot with the KDE, that is kernel density estimation plot, and you will find that the data which we have generated with the help of this multivariate, that is a normally distributed data, because it is making this shape that is called bell curve shape, and this kind of shape of data represents that in a real world scenario your data is not having biased value. In the upcoming session we are going to discuss about all these concepts, the shape and the size of the data, what actually the significance of this kind of a shape. For example, this shape is coming little left side of the graph, then what it means. If the same data is coming extreme right of the graph, then what it means. Why it is always good to have the normally distributed data. These things we will learn about when we discuss about data analysis core concepts. So this is one of the graph which you can also generate with the help of Seaborn library. So on this note, I am stopping over here. In the next session onwards, I am going to discuss about various types of graphs with their purpose. That means which graph is going to be used for what purpose. So see you in the next session with more in-depth discussion about the types of graph with their purposes. So see you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. Now from this session onwards, we are going to discuss about various types of plot and their usage. So let's start our discussion. So guys, we already know about that plot is being used for data visualization, and we can use these plots for different purposes. So let's discuss about what are the purpose we are having in data analysis. So majorly we are having 6 type of purpose for which we are using the different kind of plot. The first thing, we want to identify the relationship between two variables, and the plots under correlation is used to visualize the relationship between two or more variables, and correlation plots gives us information like how does one variable change with respect to another variable. Now proceeding to the another purpose, that is deviation. We want to identify how much variance we are having within the given data set, then we use various kinds of deviation plots. Now let's proceed further and discuss about another purpose, that is ranking. Sometime it is required to get the information about the ranking within a given data set. Information like what is the maximum range, what is the min range. So there are certain plots which help us to identify the ranking of the data within the given data set. Now let's proceed further and discuss about distribution. So guys, while doing the data analysis, sometime we require to know the distribution of the data within the given data set, how the continuous variable is distributed within the given data set. Same way, if we want to identify the distribution of the categorical variable, we will be using various type of plot to identify the distribution within the given data set. Now let's discuss about another purpose, that is composition. Sometime within data analysis it is required to identify the composition detail within the given data set. So to get the information about the composition, we will be using various plots that we will look into. Now at last but not the least, we will be using various plots to identify the changes within the given data set. And when we are dealing with any kind of time series data, then on that time we will be using various plots which will be capturing, or say which will be visualizing the changes within the data set. And this is one of the important purpose when we are dealing with the time series data. So guys, this is about the purpose of the data visualization, or say purpose of the plotting. Now let's discuss about what are the plot which falls into each category. So let's jump into the Jupyter Notebook and we will discuss one by one in this session, and next session onward we will write the code for different types of plots. So guys, the first purpose we have discussed about correlation, and the plots which belongs to this is the scatter plot. We are going to write the code for a scatter plot in the next session. In this session we will discuss about what are the plots available in each of the category one by one. So with the scatter plot and other plots which belongs to this category, like a scatter plot with line of best fit, counts plot, marginal box plot, parallelogram, heat map, pairwise plot. So all these plot is used to identify the relationship between two variables and more than two variables, which we will look into. But remember that whenever you want to identify the relationship between two variables, then these are the plots is going to be very helpful to visualize the relationship. Now let's proceed further. There is other purpose which we have discussed is the deviation. Within deviation, there is something called diverging bars and diverging dot plot. So this is very helpful to identify the deviation within the data set. That means suppose if you want to identify the variance within the data set, then it is going to be very helpful, these two plots. Then next we have discussed about ranking. So identify the ranking within the given data set. We are going to look into ordered bar chart and dot plot. So these two plot is very helpful to identify the ranking within the given data set. Now let's proceed further. And we have also discussed about the distribution. Distribution generally we use very much within data analysis. We need to identify the distribution of the data within the given data set. So for that reason, you will find there are various plots we will be using. Two major things we generally do. First one is the correlation identification when we do the data analysis, and the second one we generally do the distribution, where we want to identify the distribution of the continuous variable, then we want to identify the distribution of the categorical variable, then we are going to use histogram. Histogram is one of the old methods and very effective way to identifying the distribution within the given data set. Along with that, we will also discuss about density plot. We will look into how to create density plot. We will also look into density curves with histogram, and at last we will also discuss about the box plot. Box plot is very helpful also to identify the distribution within the given data set. For the next purpose, we have discussed composition, where we want to identify the composition detail within the given data set. So for that reason, we are going to use pie chart. Pie chart is also an old methodology which you have seen many places, where you want to know the composition of different kind of a data within the given data set. So we use pie chart. There is another method which we use for composition, that is tree map. Tree map is also very useful way of identifying the composition within the given data set. The third category of chart we are going to look into, or plot we are going to look into, is the bar chart, which you already aware about. Most of the places you have seen the bar chart. That is also very useful method to identify the composition. And the last purpose we have discussed, that is very useful when we are dealing with the time series data set, and on that time basically we are using time series plot. We will look into how to create time series plot. We are also going to discuss about time series decomposition plot. It is very effective plotting technique to identify the trend within the given data set, that we will look into. So overall, these number of plotting technique we are going to look into, or these number of plots we are going to look into, and we will look into the best practices to write the code for data visualization. So on this note, I am stopping over here. Next session onwards, I am going to start writing the code for each of the plot. If you want to follow along, you can follow with me. So see you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session, what we are going to do, we are going to understand that how to write code for plotting, code for data visualization. I basically divide the code into 5 steps. So in the first step, what we are going to do, we are going to initialize the parameters. Parameters, we have already seen that in one of the session, where we were initializing various parameters for the plot which we are going to design now. And those parameters is the global setting for the different parameters. The parameters like the axis title size, legend font size, figure size, axis level size, then axis title size, X tick, Y tick, figure title size. So all these parameters we will set globally, and this part of the code is applicable to each of the plot which we are going to write. So that means we are writing it once and we are copying and pasting it many times, as it is going to be the static code in each of the scenario. Now coming to the step 2. In the step 2, we generally perform importing the data set which we want to visualize. This step is also very much straightforward, as we are going to get the help of pandas read CSV method if our data is in CSV file, and in most of the cases the data comes into the CSV file, or any other format data comes, pandas will take care. So we are going to use the pandas library to import the data and create the data frame. Now the third step, in the third step we are basically focused upon the preparing the data. So this data will vary problem to problem as well as plot to plot. So basically we design our data, or we prepare our data as per the plot what we are wanted to get the information For this case, if you are drawing the scatter plot, so I want to identify the relationship between two variables, or say two continuous variables. Then next step, in the step 4, we draw the actual plot with the help of plotting library, either might be a matplotlib or seaborn data visualization library. Once we done the plotting, then to make it more meaningful, we decorate the plot. Decoration means giving the right label to the right axis so that we can get the meaningful information while analyzing the data with the help of data visualization. So guys, this is about how to write the code for data visualization. So now let's start writing in the same way how we have discussed. So the first step, I am going to write some import command along with the some parameter setting, which is going to be same for each of the graphs which we are going to learn, or each of the plots which we are going to learn. So here you can select this cell and press B so that it will insert a new command line over here, and I'm going to write some import command. The first import command is pandas as pd. Then I am going to use the matplotlib.pyplot. It is sometimes referred as plt. Most of the time I can say that it is an industry standard practice. Then I am going to use seaborn. This is another data visualization library, and here I should mention as SNS. This is also pretty much straightforward. Another library we need is the NumPy library, as sometime we need to massage the data to make it ready for the data visualization. So we are going to use the NumPy library as well, and as np. Now this is about the importing. So we have done the importing part. If needed, we will import some other library as well, but basically these number of library we generally use. Now moving further, now setting up the parameter. For to set up the parameters, I am going to create some constant so that we will apply the same constant. So I am going to use it large. We will give some value like 22, then medium, then a small. Now next let's write the parameter. So parameter over here is going to be the dictionary, which contains a key value pair. So we are having some key value, and that key is nothing but the parameter of the plot. So the first key we are going to have is the axis title size, and title size is our large. So I will tell that large so that this value will sit it over here. Now the next parameter is the legend. So let's write it legend dot font size. So it will represent the legend of the plot, and I will tell that it is going to be the medium size. Now the next would be the figure size, and it is going to be the tuple. So I'm going to tell that 16, 10, and here we will be specifying height and width. Now proceeding further, another parameter which we are going to write it axis dot level size. So this will represent the size of the level, and that is also going to be the medium value. Now the next is xtick. We are going to write xtick dot level size, and over here I will specify medium value. Same is the case with for ytick. So it will represent the tick size medium. Now talking about figure, the figure title size, so that we will get the larger value. So here I will mention the large. So we are done with the parameters. Now by default, whenever we are creating a plot, so it comes with the default parameters. So we need to override those parameters with the help of these values. So how do we can do that? So I will tell that override default parameters of plot. So how we can achieve this thing? So we need to tell plot dot rc param. This is one of the module within this plot module, and within that we are having a update method. So I will tell that update, and what I want to update, I want to update parameters, and this is our custom values we are passing. So this will update the default values of the plot. Now I am going to tell that, so basically it comes with the matplot styling, but we want it should use the seaborn styling. So I should tell plot style.use, and here I should tell that I want seaborn white grid. So we are almost done with the parameter. Now we do the shift. Now we have applied the configuration which we have written over here, and we have imported all those libraries. Now the next step, we are going to import the data set, and what we are doing, we are plotting the scatter plot to identify the correlation between two variables, and the data set which I am using over here is the Midwest population data set. So let's grab the link of the data set. So to grab the data set, you need to visit this site, and over here you will find a folder called data, and where we are having Midwest.csv. You need to click on this, and then you need to click raw over here. If you will see it over here, the raw button you will find, you need to click on this raw button and you need to grab this link. Once you grab this link, just copy it, come to your notebook, select this cell and press B, and over here you just paste it. Now I am going to create the data frame. So to create the data frame, I am going to write df equal to pd dot read CSV, and the CSV, which CSV I want to use, the CSV which we have grabbed just now, so that it will read the data from here. So now do shift enter, we got the data. So let's look into the data, what data we are having. I will select this cell, press B, df, shift enter, and you will find that it contains the information about the Midwest, population information, as well as area information of the Midwest. So we are going to visualize the data area versus population. So what it means, I want to represent how the population is spread across the area in Midwest. So now let's proceed to the next step. To plot onto the scatter plot, we have to look into what are the variables which we are going to use for a scatter plot. So the first variable which we are going to use is the pop total. So this variable is representing the population total. The category contains the area code and it is a repeated value as this area contains various counties. So now let's prepare our data. Select the cell, press B. So first step, we need to identify the unique category. So how we can do that? So we are going to use the numpy method to identify the unique areas. So over here I am going to tell that categories, and here I need to specify np.unique, and within that I want to get the unique value of category variable. So it will return us the unique categories. We can also check the length of the categories, how many categories we are having. So we can tell that clen, and here I will specify len categories. Shift enter, then you will find that we have 14 unique categories. That means we are having 14 unique areas. Now we got the unique values of the area. Now the next step, I want to represent it into the plot. What I can do to represent the uniqueness of these values. So I am going to generate some of the color map for each of the unique values. So for that I am going to write a small piece of code that will generate 14 unique colors. So let's look into that, how we can generate the unique color. So we are going to generate some colors. So I am going to tell that colors, one variable, and this is a list comprehension, and over here I am going to specify for I in range, and the range is which we have calculated clen, and over here once we get the values of each of the values, and over here I will specify this is plot, that says matplotlib, and there is a cm color map, and there is a method within that color module, color map module, that is tab 10, and I will divide this value with the float value. So I need to convert float value. Over here I will get the data, and clen, which we got it over here, -1. So this is the formula. So this will give us value that we will use for unique color for different area on the graph. So let's run it, and you can look into what the value we will get in the color. So you must be asking that what this number is and what actually it is representing. So as our requirement is to represent the 14 unique values, then to represent that data we need some base color, and over here tab 10 is providing those base color for 14 categories. So this is about getting the unique color to represent different areas. Now we are going to another step, and we will draw the graph on the basis of area versus population density, and it will color each of the area as per the category. So let's do it now. Now let's proceed to the fourth step to draw the plot. Select this one, this cell, and press B, and now we are going to first create the figure. This will define the figure size, and over here I am going to define the figure size, and the figure size is going to be a tuple, that is having 16,10 for height and width, and DPI is going to be 80, and there is other parameter which we have to pass in, that is face color, that is going to be W, and the edge color we need to specify over here K. So here the face color W means it is white and K means black. If you look into this chart, then you will find that it is K for black, this is W over here, that is representing white, and K over here representing black. So now let's proceed further. So now the next step is I need to iterate each of the data point, or say each of the categories, and grab the data by matching those category, and then draw the area over population. So how I will do that? So I need a loop. I will tell that category, and here I need to enumerate the categories which we have grab. Here I will tell that category, and within that I am going to draw the scatter plot. So to draw the scatter plot, I am going to use the matplotlib scatter method, and two variables which I want to use is area and the pop total. If you remember, I showed you pop total. I will show you again. If you will come here, then you will find that I want to draw area versus pop total. So these two values on the basis of the categories which we have generated and which we have identified the unique category, and we have also grabbed the color combination. Now the next step, we need to get the data according to the category. So how I will get it? So I am going to use some of the pandas method to identify it. So I will tell that the data is going to be my data frame, and I am going to use LOC method, which I have already explained in our earlier part when we were understanding the tools for data analysis. On that time I have explained this, so you can go and have a look. And I'm going to use LOC over here, and within that I'm going to access the category, and I want to compare each of the category which I am iterating over here if it belongs to that category, so that it will grab only those information. So this is a slicing technique I am applying. If you want to know about the slicing technique, then you can visit my earlier part for this course, and over here I will specify the colors which we have generated, if you remember. So these base color value we have generated over here, so I am using these color values so that it will represent that the common area which belongs to that particular code. So it will represent those values and the level I need to specify the category. So over here I will tell that str category. Now once it is being done, let's run it. Shift enter. So ignore these warnings, and you will find that we got the plot population versus area, and you must be noticed that it has drawn the graph, but it is not giving any meaningful information if we are giving this graph to any person. So to make it meaningful, I need to correctly label it, then we need to give it to other person or show it to other person for reporting purpose. So to handle this, we need to proceed to the step 5, where we need to decorate the plot with the right level so that it will represent the correct information and what actually the plot is representing. So let's start the decoration. So I will select this cell, press B. So the first step, to get the current axis. How we can get the current axis? We are having two axes. One is the x-axis, another one is the y-axis, and I want to set the range for this, or say I want to set the limit for this x and the y-axis. So how I can do that? So first I will grab the current axis. So GCA, get current axis dot set, and I want to set x limit. Here I need to pass a tuple. My starting point should be 0 to 0.0 to 0.1. Now the y limit I want to set, that is going to be 0 to 90,000. Next I want to tell that within the current axis, the x level should be representing the area. So here I will tell that area. Now my y level should represent the population. So I will tell population for y level over here. Now I have set the current axis value. Now the next step, I am going to set the size for x tick, and here I am going to tell that font size equal to small, which we have created earlier, and for the y tick I am going to tell that font size equal to small, the constant which we have created, if you remember that. Now the next step, I am going to specify the heading for this particular plot. So I will tell that Midwest area versus population plot, and the font size should be large. So I will tell that large over here, and next I'm going to specify the legend font size, and over here I will tell that font size equal to small. Now you have done the decoration. Take this one, cut it from here and come here and place it over here so that it will execute together. Control V. Now let's do shift enter, and once you done the shift enter, then you will find that it has given us this meaningful graph where on the y-axis it is representing the population, on the x-axis it is representing the area. So this is about plotting the scatter plot. I know guys, this session went very long, but next session onward it is going to be little short, because we are going to leverage the step 1 and step 2, as both the step is going to be repeated same. So in the next session onwards, we are mainly focusing upon how to prepare the data as per the plot requirement, and to decorate our graph we are going to leverage this code as well, as we understand that whenever we are creating a plot we need to set the axis value, and with the help of GCA is the method. It is very important, you have to note it down. Whenever you want to set the axis information like x limit you want to set, then you can first access this GCA and then you can access the set method, and here you have to pass these properties, these parameter to these function. So it will set the value for x limit, y limit, x level, and whatever the level which we are getting over here, which we are passing from this place. So it is one line statement, but it is very powerful. And remaining one is setting the size. You can put the right size, and the size you can define into the constant, so you can change it accordingly. Whenever you want the bigger size you can use bigger size, whenever you want medium size you can use medium, and whenever you want a small size you can use a small. So prior to wrap up this session, I would again reiterate the point. We have started with the step 1 where we have initialized the global setting, and this is going to be the fixed for each of the graph. Second one is the step 2 where we have grabbed the data within the data frame. In the third step we have prepared the data and we have grabbed the information which we want to use within the graph or within the plot, you can say. In the fourth step, we have seen that how we have drawn the scatter plot on two variables, as a scatter plot is used to represent the relationship strength between two variables, which I already mentioned. And this was the fourth step. And at fifth step, I kept it as fifth step because you should remember it. There is a decoration step is also available, and at fifth step we have done the decoration for the plot so that it would be more readable. So on this note I am stopping over here. In the next session we are going to look into some other plot. We have seen the scatter plot. Now we will look into a scatter plot with line of best fit. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. In this session we are going to look into another type of correlation plot, that is a scatter plot with line of best fit. So let's start to write the code for this plot. So as usual we are going to follow the same steps which we have learned in our earlier session. So in the step 1 we are going to initialize global setting. In the step 2 we are going to import the data set and create the data frame. In the step 3 we are going to prepare our data set according to the plot. In the fourth step we are going to draw the plot, and fifth step is the part of the fourth step where we are going to decorate the plot with right level so that we will get the meaningful information. As I already mentioned that the step 1 and step 2 is almost similar. So let's leverage the code. So let's go to the earlier example, and over here I am going to copy and paste this code which we have seen earlier. So here I am going to copy all this code. So let me copy this and then I will go back, and over here in this Jupyter Notebook I am going to select this cell, press B and paste the code. Do shift enter. So it will load all the required library which is required to draw the plot, and over here we are going to set the parameters as well. Now proceeding to the second step, that is importing the data set. But prior to importing the data set, I wanted to let you know that what kind of data set I am going to use for this particular session, so that you should aware about the data set and the problem statement. So how do you get the data set? It is again the same location from where we have grabbed the data in our earlier session. So this is the GitHub repository for this course where you will get all the content of loan data analysis from scratch. And over here you will find that if you will go over here, then you will find that there is a data folder, and within that we are having a mpg.csv. So basically this data set is containing the information about the miles per gallon information. We are having car by manufacturer and the model of the car, and it will also contain the information about the displacement and when the car is manufactured, and how many cylinders used within this displacement, and what is the gear transition mechanism is, whether it is a auto gear shift, manual, along with the mileage information. If it is running into the city, then what is the consumption of the fuel, and if it is traveling in highway. So guys, this is about the data set. So let's grab this. So I have copied the CSV file over here, and let's go to the Jupyter Notebook. In the step 2, select this cell, press B, and over here I am going to create a data frame, and here I am going to tell that pd dot read underscore CSV, and within that I am going to specify the CSV file location, and let's print it as well. So shift enter. So we got error, and the error is because we are not grabbing the raw form. So let's grab it through the raw form of the data. So how we can get the raw form, let's look into that. So guys, instead of this location, you have to click on this raw button so that we will get the data in raw form, and you should grab this link, not the earlier one. Sorry for that. So grab this, copy this link and go to the Jupyter Notebook, and over here you should specify this, and now do the shift enter. Then you will find that we will get all the data from that particular CSV file in the form of data frame. So this is about the data set. Now let's discuss about the problem statement, what we are going to analyze with the help of data visualization. More specifically, what we are going to analyze on a scatter plot with the best fit line. So guys, the problem statement is, does number of cylinder is affecting fuel consumption of a vehicle if it is running on highway? And for this study you have to use the vehicle which is of 4 cylinder and which is of 8 cylinder. So you have to use these two vehicles and identify that whether the cylinder is affecting the fuel consumption on highway or not. So you should plot it and draw the best fit line. So guys, let's proceed to the third step to prepare our data for this particular problem. So guys, let's prepare our data set. So here I am going to select this cell, press B, and I am going to give some other data frame name, DFS, that is data frame selected, equal to, and here I need to specify the data frame, and I am going to tell that I am going to use the LOC method to slice our data set so that we will get only those specific record where we are having the cylinder 4 and 8. So how we will grab it, I am going to specify the condition over here within LOC. So I will tell that df dot cylinder dot is in. So this method is going to check that wherever our cylinder is having 4 value and 8 value, it will return only those records, and it is a slicing technique which we have already seen in one of our earlier session. So this will return us the record where we are having 4 cylinder as well as 8 cylinder. So let's look into that. DFS, shift enter, and you will find that we got only those record wherever our vehicle is having 4 cylinder and 8 cylinder. Now proceeding further, and now let's prepare this data for plotting. So I am going to first set the seaborn style over here. So the next step is we need to tell that SNS dot set underscore style, and here I am going to tell that white over here. So this is the first step. Second step, now we are going to draw the plot. So this time I am going to use the LM plot of seaborn. LM is the linear model plot. So I can tell that some plot obj we can tell equal to SNS LM plot, and for X I am going to tell that which column I am going to use. I am going to use the displacement column. So why I am using displacement? So basically displacement is the container for these cylinders. So here we are verifying if our cylinder is 4, then what is the displacement value. So on X axis I want to draw displacement. So I will tell it over here, X I want displacement. So let's write dispel. In Y I want to put highway variable. So I will tell it over here highway HWay, and for U I am going to use cylinder, and I will tell that CYL, and the data which we have just selected, that is DFS. So I will tell that this will be performed on the base on data which we have selected, DFS. Next parameter we need to pass is the height. So we will tell that height equal to 7, aspect I'm going to tell that 1.6, and robust equal to true. So these are the some of the parameter which you need to specify, and this time also I am going to use the palette tab 10. If you remember, we have discussed about the tab 10 in our earlier session. Now next we need to specify the configuration for the best fit line. So over here there is some of the parameter which we need to specify for that, that is scatter underscore KWS equal to, here we are going to specify the dictionary dict, and within that we need to specify s equal to 60. So these are the parameter which we have to specify over there. I will tell you how you will get these information, so you just remember it. Here we are doing the decoration for the best fit line over here. So here I will specify another thing, the edge color what the color I want to keep it. So over here I will specify black. This is it for the best fit line. So you will see that here we are having various configuration. Now you must be asking that how do I remember all these? So I will tell that no need to remember all these things. You will get the information at this site. So this is the Seaborn plot site. Over here you will find the information about various plots, and here you will find that we are using the LM plot. So you will get all the parameter detail over here. There are various parameters. You can use it as per your plotting requirement. So now let's proceed further. So guys, in the next step we are going to decorate our plot. So I'm going to write that I will tell that plot object which we have created, and I want to set the limit, and the limit which I want to set it over here, that is X limit, and the starting is 0.5 to 7.5. So this is the limit I want to provide it over here. And now I'm going to specify the Y limit, and I will tell that Y limit is going to be the highway fuel consumption detail. So over here I will tell that 0 to 50. Now I will specify the plot title. I will tell that plot title, and over here I will specify scatter plot with line of best fit group by number of cylinders. So I will specify that, and the font size I am going to keep it large. Now I am going to take this fifth step and paste it into the fourth step, so that we will run it together and it will give us the meaningful information. So let's run it. Do shift enter, and once you run it, then you will find that we will get the information over here, the consumption, fuel consumption information. So here the color orange is representing the vehicle which is having 8 cylinder, and blue color is representing the vehicle which we are having 4 cylinders. So here you will see that we are having a strong relationship between the displacement and the highway. So over here you will see that the fuel consumption is getting reduced if our displacement is having more than 4 cylinder, and in the x-axis we have represented the displacement value. So you must be asking that what actually this displacement is. So basically within a car, displacement holds the cylinders. It is a chamber. Within that we are having the cylinders, and those cylinders will actually get the fuel for car engines. So in this study we have analyzed that we are having more cylinders within the displacement, then the fuel consumption is being reduced if it is going on highway. So we clearly see that it has the negative correlation. So how it is getting decreased if cylinder value is getting increased, and because of that displacement is also getting increased. So guys, this is what I wanted to demonstrate you in this session. In the next session we are going to learn about count plot. That is also very useful to identify the correlation. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome back. In this session, we are going to discuss about counts plot and the significance of counts plot. So to write the code for the counts plot, we are going to follow the same pattern which we have been following from the last two sessions. And the pattern is same, where we have 5 steps. In the first step, we are initializing our global setting. In the second step, we are importing data set. In the third step, we are preparing our data. In the fourth step, we are drawing the plot. And fifth step is also part of the fourth step, where we are decorating the plot with the right levels. So to make our work easy, what I did, I have copied the first step and kept the same global setting which we are using. Now let's proceed to the second step. And this time also, I am going to use the same data set which we have used in our last session. So let me import that. So select this cell, press B, and the data frame we are going to create, we will tell that pd.read_csv, read_csv, and within that I am going to paste the same URL which we have grabbed earlier, and this is the same URL. I will show you again. So this is the same URL. We are using the same data set, that is mpg.csv. So now let's proceed further. So now let's load this data set. Shift enter. So now we have loaded the data into the memory. Now next, let's prepare the data for plotting. But prior to that, let's understand what we are going to analyze. So for that, I'm going to load the data set into the Jupyter Notebook. So over here, you will find that we have two categories of information for the fuel consumption, the city wise and the highway wise. And here we are performing very simple analysis. We are just identifying if the number 18 is there, then we will get the count for city as well as highway, and that we will represent through the count plot. So let's proceed further and prepare our data set for plotting. So I'm going to do the group by operation over here on highway as well as city. So let's do it. Select this cell, press B, and here I am going to create another data frame which will contain the counts. And here I am going to tell that df group by, and this time I'm going to use highway data as well as the city information. So here I will tell that city. Now I will get the size and I will also reset the index. So I will tell reset index, and here I will specify name equal to counts. Let's print the data set. What kind of information it is printing? Let's look into that. Shift enter. We got error over here. Make sure that you are specifying within the quotes. Shift enter. Then you will find that it has returned the count of values. Now the next step, we need to plot this data frame into the plot. So to plot this count, we need to use a kind of a plot that is called a stripe plot. But prior to that, we need to specify the size of the plot. So let's do it. Select this cell, press B, and first we need to specify the figure size and the axis. And this time I am going to tell that plot subplots, and here I will specify fixed size equal to, and here you need to specify the tuple for height and width, and DPI it is going to be 80. Once it is being done, then I'm going to create a stripe plot of Seaborn. So write SNS dot stripe plot, and here I'm going to specify the x-axis. For the x-axis I'm going to use city counts dot city, and for the y-axis I'm going to use the highway. So I will tell that counts dot highway, and there is a size we need to specify. We will tell that size equal to df underscore counts dot counts multiplied by 2. So it will look little beautiful, and here we need to specify the axis. Once it is being done, next we need to decorate it. For this time there is nothing much in the decoration, so we will just provide the title over here. So plot title, and we will tell that counts plot, and copy this one and paste it over here, and now do shift enter, and then you will find that it has given us this beautiful graph for the count of fuel consumption on highway as well as city. So here the bigger circle represent that many values falling into this range. So this is about the count plot which I wanted to demonstrate you in this session. So in the next session we are going to look into marginal box plot. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. In this session we are going to look into another type of plot that is called marginal box plot. So first we will understand that why we are using this plot, but prior to that let's have a look how this plot look like and what we are going to design in this session. So guys, this is the plot which we are going to design in this session. So if you closely look into this figure, then you will find that it is giving us two kind of information. The first information is represented into the scatter plot, and the second kind of information we are having is the box plot. So you must be asking that what kind of information it is giving. So as you already aware that whenever we are using the scatter plot, so it means that we wanted to identify the strength between two variables, and in this example we are using the same problem which we have seen earlier, where we are identifying that if our displacement value is high, then does it affecting the fuel consumption if it is running on highway. So you can clearly see over here in this graph, the fuel consumption is getting reduced if our displacement value is high, and displacement value is depends upon the cylinders, how many cylinders we are having within the car. So guys, this is about the scatter plot. Now you must be asking that what actually this box is representing over here in the x-axis and the y-axis. So guys, then I will tell that it is another kind of plot which we generally use for univariate analysis. Univariate and bivariate analysis, which we are going to discuss in our next part of the course, where we are discussing about the exploratory data analysis. For a time being, you just consider it. If we want to analyze a single variable, then on that time we want to use this box plot. So this will give us the distribution information within that particular variable. So that means how our data is being distributed within the given data set. For this example, here it is representing that our displacement value, how it is being spreaded across, and with the help of box plot we are representing the quartile information. So it is representing the middle line is actually representing interquartile value, which we have already discussed in one of our earlier session. So guys, box plot we haven't discussed yet because it falls into the distribution category, which is in our list, and that is the fourth category which we are going to discuss in our upcoming session. So that means this graph is giving us two kind of information. The first one is the correlation information, another one is the distribution information. So guys, you are seeing it over here. We are having three kind of a graph over here. The first one is representing the relationship between two variable, and the second one is representing the univariate analysis of the x-axis, which is displacement over here, and the univariate analysis of the y-axis, that is the highway, and it is representing the data distribution. So that means we need to divide the big figure into three sub areas with the help of subplot, and this is going to be really very interesting. So guys, enough of discussion now. Let's move to the Jupyter Notebook and write the code for this particular data visualization plot. So guys, we are going to follow the same approach, however we are following through the earlier session, but this time in the third step we have introduced something called prepare drawing space for plotting. So what it is doing, if you closely look into this diagram, then you will find that it contains three graphs, or say three plot. I need to set up my figure like it should divide the space into three areas. In the first area we are representing the scatter plot, at x-axis we are representing the box plot for x-axis, and at y-axis we are representing the box plot for y-axis. So to make it ready, we need to prepare the drawing space. So let's do it. But prior to that, I will tell you the same point. Step 1 is a repeated one, so I copy pasted, and step 2 is the same data. So I have taken the same URL to grab the data for the data frame. Now proceeding further to the step 3, select this cell, press B, and now we will get the cell to write the code. So first I will create a figure object, and over here I will tell that I'm going to create a figure with the help of this method, and here I will specify that what size I want to keep for this particular figure. It is going to be the same 16,10, and DPI is going to be the same. So you will find that this is also the repeated information, so you can use it directly. Now another thing, I want to divide the diagram. If you have seen that our plot is having three plots, so to make the space for those three plots I need to divide my figure. So how I can do that? So there is a method within the matplotlib which will help us to divide our figure, that is called grid spec. So we should write grid spec over here, and we will tell that I want 4 by 4 comma h space equal to 0.5, w space equal to 0.2. So with the help of this we can divide our figure into three regions. Now we have drawn the grid spec. Now next we need to assign each of the plot in the respective area. So for that, let's define the axis now. So first I am going to define the main axis, and here I am going to add figure in this object, or there is a method called add subplot, and now I am telling that which region is going to be the main region. So here I am telling that grid, and I need to specify like this -1 comma colon -1. So this will define the main region, that is our this part of the plot. Now let's define the right and the bottom. So let's write it over here. Axis I am going to create for right, and again figure object add subplot. You should remember this is the method which we use to add the subplot, and over here we need to specify grid, and here to access the right portion you need to slice it like this way. So you need to specify -1, and here for x tick level I am telling that I don't want any level, so I will pass the blank array. So here you need to specify the blank array. Same is the case for y level. I am going to tell that I don't want any levels for y level for this particular graph. So here you should specify the blank array. Now we have created the right part of the plot, that is this part. Now let's define the bottom part. So to define the bottom part we are going to use ax bottom, and here I need to specify figure, again add underscore subplot, and this time the slicing which we are going to specify over here, I can access the bottom part -1 comma 0 colon -1. So this will access the bottom part, and again I am going to copy and paste this line of code because I want it should be blank. So no x tick will be represented and y tick should be represented. So this is about the configuration for each of the area. Now I just sketched out our figure and told that my figure is divided into three parts.
the main part, right part, and the bottom part. Now let's proceed further. In the next step, we are going to specify that in each of the part what kind of plot we want to draw. So let's proceed further. At step 4, select this cell, press B, and here I am going to specify in my main I am going to draw the scatter plot, and over here I will tell that in the x-axis I want displacement, and in the y-axis I am going to keep highway, and the configuration, other configuration which I want to keep for S, that is df.city multiplied by 5. This parameter S basically defines the size of the marker. Now the next parameter which we need to define is the color sequence, that is represented as C. So let's write C over here, and the unique sequence we will get it from the variable, and the variable is manufacturer. So we are having within data frame, we are having a variable called manufacturer, and I'm going to use as type, and within that I need to specify category dot cat codes. So this will give us the unique sequence as per the car categories by manufacturer. Now there is another parameter which we need to specify is the alpha. So here I am going to tell that 0.9, and now we need to specify the data, from where the data will come. So it is going to be our data frame which we have created over here. Now the next we need to specify the color map, C map. I am going to tell that it is going to be the set 1. Next we need to define the edge color, and that is again I am going to use black. And at last line width we need to specify. What would be the line width? I will tell that 0.5. So now we have defined the specification for the scatter plot with the help of these parameters. So these parameters again I will tell that you will get this information from the documentation of matplotlib, which you will get it from here. So this is the same plot we are using, and you will see that all the parameter and what actually this parameter is representing, you will get the information from over here. So you can visit it once. Okay, so now let's proceed further. Next I am going to draw the box plot. So this time I am going to use the Seaborn, and Seaborn is having a method which help us to draw the box plot, and this box plot I am going to discuss in the distribution section when we discuss about the distribution data visualization. Then on that time I will discuss in more depth, but for a time being you just remember that to draw the box plot we are going to use Seaborn library, and within that we are going to use this method, box plot method. So here we need to specify data frame, and I want to take this variable, that is displacement, and where I want to draw it I need to tell that bottom. So here axis I need to specify, which we have already created, axis bottom, and what kind of orientation I want to keep. I need to specify that I want it horizontal. So for horizontal you need to specify H. Next let's create another box plot for our highway variable, and here we need to specify data frame dot sway comma axis, and here this time I need to specify it right, and orientation we need to keep it vertical. For that I am going to use V. So this is it for the drawing plot. Now let's decorate with the right level. I don't want any level for the bottom, so I will tell that axis bottom dot set x level equal to blank. Same is the case with right dot set y level equal to blank. Now for main I am going to specify the title, so I will tell that axis main dot set title equal to, I will specify scatter plot with box plot. That's it. And now cut this from here and paste it over here. So this step I have kept it so that you should aware that why I am performing this step. It is for decoration, but we will run it together. So now we have created all the steps, so let's run it. So we will run it the first step first, then the second step. We got the data. Now let's draw the figure, and this is what I wanted to show you. Whenever you are creating multi-plot data visualization, then on that time we are using the grid spec, and with the help of grid spec we are getting such kind of a design. So that means it has divided our figure into 3 parts. In the first part we have already discussed that here we will put the scatter plot, here we will put the x-axis box plot, and here we will put the y-axis box plot. Now let's run it together. So for that I am going to grab all these code and put it over here so that we will get the complete output. So now let's run it together, shift enter, and then you will find that with the help of all these steps we are able to draw this beautiful plot, and this is what I wanted to demonstrate you in this session. So guys, in the next session what we are going to do, we are going to learn about heat map and parallelogram, which we have already seen in one of my session but we haven't discussed much. So this time we are going to draw it and we will discuss about the significance of parallelogram, that is also called as heat map. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. Now in this session we are going to look into another type of correlation plot, that is parallelogram, which is also known as heat map. So guys, parallelogram or say heat map is one of the powerful tool for data visualization. If you want to visualize the relationship between two or more variables with the help of this plot, you can easily identify how does one variable change with respect to the another variable. So now let's look into the plot, how the plot will look like, and then we will design the same plot. So let's jump into the diagram. So guys, this is the plot we are going to draw now. So if you look into this plot closely, then you will find that we have all the variables over here in the y-axis as well as in the x-axis, and against each variable it is giving us the correlation value. Let me increase the size and you will find that if you are comparing MPG with MPG, over here we are having MPG, then that means you are comparing the same variable, so it is the strength is 1. Same if MPG is compared with the cylinder, then you will find that it is very much strongly correlated in the negative side. That means if our cylinder size is having more, then our car is consuming very less fuel. Same way, if you compare MPG with displacement, then you will find that this is also very much strongly correlated, and the negative value represent that whenever if our displacement value is high, then fuel consumption, that is mile per gallon fuel, it is consuming very less amount of fuel by the car. So now you can imagine with a single plot you can easily identify what are the important variable for you, so that you can consider it for predictive modeling. That is the next step after data analysis. So it is really very powerful if you want to identify the relationship between your variables, and you will find that all these values are the continuous values. So guys, this is about the output which we want to achieve with this particular plot. But how do we can achieve this output? So now let's look into that. But prior to that, let's understand which data set we are going to use for this particular example. So guys, for this session we are going to use another variation of MPG dataset, that is mtcars.csv, and which resides at this location. This is my course repository, learn data analysis from scratch. Within that we are having a data folder, and within that we are having mtcars.csv, and this CSV contains these number of variables, and most of the variables are continuous value. Only two variables is the categorical variable, and we are doing the correlation data visualization, so we are going to use continuous variables. So guys, let's move to the Jupyter Notebook and we will perform the same steps which we have been following from the earlier session. So for that I'm going to grab this link, the raw link, so that I will grab the data set into data frame. So copy it. Now go to the Jupyter Notebook. So we are into the Jupyter Notebook, and here we are also having the same steps which we have been following. First step I already copy and pasted. Now the second step, let's select this one and press B, and over here let's create a data frame with the help of pd.read_csv, and here we will specify the link. So now do shift enter. Let's look into the data. So here you should specify data frame, and you will find that we got all the data from the CSV and it become data frame now. So guys, let's prepare the data next step, and this time I am going to calculate the correlation. So how do you calculate the correlation between the variables? So there is a method available within pandas which will calculate all the correlation from each of the variables. So we need to specify that, and it will pick only the continuous variable. So you should specify df.core and do shift enter. But prior to that, let's print it as well so that we can see the output. Shift enter, and you will find that it has given the same information how we have seen in our parallelogram or heat map diagram which I have shown you. And here you will find that it has given us this table where it has picked all the continuous variable and it has calculated the correlation between each of those variables. Now we have prepared the data. Now let's proceed further and prepare our plot. So to draw the plot, the first step, you can tell me, yes, it is right. We need to draw the figure first. So we need to tell that plot dot figure, and here you need to specify the size of the figure, and we are going to specify 16,10. You can keep it as a standard size, and DPI equal to 80. So we need to specify 80 over here. Now to draw the parallelogram, we are going to use seaborne heat map plot. So you can write SNS dot heat map, and here we need to specify this data frame, that is core over here, and after that you need to specify what X tick level you want to keep. So you should tell that X tick levels, and you want to keep the columns of this particular data frame. So you will tell that core dot columns, and now in Y tick level I am going to keep the same thing. So copy paste it so that we will save the writing time, and over here you need to specify Y, and again this is going to contain the same information. There is a color map, so which I have already shown you, so you can use it. So another variation of color map, we can keep it over here. We have variety of color map, so you should mention over here first. We will look into RDYLGN. This is one of the color map you can use. So it will give the combination of yellow, red, green, all these combinations. So you can also specify center equal to 0, annotation I want true. So this is about the plotting the correlation data. Now the next step, let's decorate it. I want title, so let's provide the title. You can specify the name of the title, parallelogram, or say heat map of empty cars. Next, I want the size of my tick should be little small, so I will tell that plot X tick, and the font size equal to small. If you remember, small is the constant which we have created over here. So I am specifying that. Now let's write for Y as well. Plot Y ticks, and the font size equal to small. You can write plot dot show. Now grab it and paste it over here so that we can run it together. Fifth step, I am doing it separately because I wanted to show you that at last we need to decorate it, so that you should know about this step, but at last we need to run it together. So we are ready now. So let's run it. Shift enter, and then you will find that we got a beautiful graph, and over here you will find all the various combination of correlation information which we have already discussed. Now here you can specify various types of color scheme. For example, if you want to change some color scheme, you can specify BU, PU. There is another color scheme. If you do shift enter, then you will find that this is another color scheme, but this color scheme is not very intuitive compared to earlier one. So let's replace with the earlier one, Control Z, and do shift enter. Then you will find that this will give you more information compared to the earlier color combination. So this is what I wanted to demonstrate you in this session. So on this note, I am stopping over here. In the next session, we are going to learn about pairwise plot. This is again another variety of correlation plot which will help us to identify the relationship between various variables. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another type of plot that is also used for correlation identification, and that is called pairwise plot. So let's look into what actually the pairwise plot is and how we can create the pairwise plot. So guys, first discuss about which data set we are going to use for this particular example. So for this example we are going to use, there is a very renowned data set that is called iris data set. Iris is a kind of a flower which has 3 variety, and it looks something like this. So this is the iris flower which has 3 variety. One is versicolor, another one is setosa, third one is virginica. And if you closely look into this picture, then you will find that it contains 2 information. One is the sepal and second one is the petal, and in each 3 category the length of the sepal and the petal is varying, and these sepal and petal length helps us to identify in which category of iris flower belongs to, whether it is a versicolor, whether it's a setosa, and whether it is a virginica. And it is one of the mostly used data set that is used for learning purpose. Whenever you are starting your journey with machine learning, this is the first data set you are going to learn, and that is used to explain many concepts of machine learning with the help of this data set. So now let's proceed further. So now we have understand what actually the data set we are going to use for this particular example. So let's proceed further and load the data set and create a data frame. So here we are going to follow the same steps which we have been following. So now here I have already copied and pasted the first step, shift enter. In the second step I am going to use seaborne library. Now to get the data set, Seaborn offers us iris dataset inbuilt. So whenever if you are installing Seaborn library, so it will come along with Seaborn library. To create the data frame, you need to tell that SNS dot load underscore data set, and here you need to specify iris, and to shift enter, then you will find that it has given us these 5 variables where we have sepal length. Sepal, I already mentioned that this part of the flower is called sepal, and this variable holds the length of sepal, and sepal width, this contains the width of the sepal. Another variable we are having the petal length. Petal I already mentioned. So the leaves of this particular flower is called petal, and this variable contains the petal length, and this variable contains the petal width. And on the basis of their length and width, it identifies that whether the flower belongs to setosa or whether it belongs to virginica, and whether it is belongs to versicolor. So guys, let's look into the plot which we wanted to draw it over here. So let's look into the picture. So for this particular example, we are going to draw this plot, and it will give us the complete information about the correlation information of sepal length, sepal width, petal length and petal width. So with the help of this, you can easily identify that how the distribution of the sepal and petal length for each of the iris flower. And here you will find that the setosa is represented with the blue color, and with orange color we are representing the versicolor iris flower, and with green color we are having virginica. So guys, this plot is very useful to identify all possible pairs of numerical variables, and it is one of the mostly used tool while doing the exploratory data analysis and when we are performing the bivariate analysis. So now let's proceed further and let's write the code to generate this plot. So for this example, we don't have much requirement to prepare our data, as our data is pretty much straightforward. If you will see it over here, all the variables is the continuous variable, and species we are having the categorical variable. So for this, I'm going to skip the third step as it is not required for this particular example. So let's proceed to the fourth step, and for this we need to write the code. So we need to press B, and over here we need to specify first step, get the figure. We will tell that figure plot dot figure, and here we need to specify the size, and here you need to specify the size of the plot, and DPI it is going to be 80. Now next, to generate the pairwise plot, we are going to use Seaborn pair plot, and the data which we wanted to use is the data frame which we have created, and here we need to tell that df. Then we need to specify that what kind of plot I wanted. Within that pair, I am going to tell that scatter, and hue I wanted to specify my column would be the species, and here there is another variable I need to specify. There is another parameter I need to specify, plot underscore kws, and it contains the dix, that is dictionary, size equal to 80, edge color equal to white, and the line width I want to keep 2.5, and at last dot show. So here for this particular example we don't have much thing to decorate, so we will skip the step 5 as well. Now do shift enter. I did a typo over here. It's typo errors, just remove it, sorry for that. Now do shift enter, and you will find that we will get the same plot which we have seen. So this way you can easily generate the pair plot with the help of Seaborn library, and this is what I wanted to demonstrate you in this session. So in the next session onwards, we are going to look into deviation plot, and we will discuss about the diverging bars and their significance. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session onwards, we are going to look into data visualization to identify the deviation within the data set. So in this category, we are going to look into first diverging bars, and then we will look into diverging dot plot. So in this session, we are going to look into diverging bars, and we will also look into how to create diverging bar to identify the variance within the data set. As I already mentioned in one of my earlier session, this kind of data visualization is used to identifying how the items are varying based on a single metric. It helps us to visualize the order and the amount of the variance our data set contains. So now let's proceed further, and let's look into a diagram what actually we are going to produce in this session. So in this session, we are going to plot this graph in Jupyter Notebook. So if you closely look into this graph, then you will find that at the x-axis we are representing the mileage information, and at y-axis we are representing the model of the car. So with the help of this plot, you can easily identify that how much mileage variance we are having within the given data set. You can also easily identify that which car is giving more mileage. So let's now proceed further and let's write the program to generate this plot. So to generate the divergent plot, more specifically diverging bars, we are going to follow the same pattern which contains the same 5 steps, which has little bit of variance at step 3 while preparing the data, as well as step 4 where we will see a new type of a plot that is called H lines for plotting the diverging bars. So let's start. So I have created a separate Jupyter Notebook, and over here the first step and the second step I kept it already filled, as a step 1 is the same step, repetitive code it is, so I have copied and pasted it. And the second step, we are getting the same data set which I already mentioned, that is empty cars.csv, and this is the location from where you can get the data. Now let's proceed to the step 3. Select this cell, press B, and over here let's prepare our data. So over here I am going to specify X, and X I am considering it over here is the MPG, that is miles per gallon, and that is residing into the data frame, and I will tell that df.loc. Again I am going to use the loc for slicing. So this time I want to select mpg, so I need to follow this pattern of slicing, colon, comma, and over here you need to specify a square bracket, and within that you need to specify the column name, and over here we are having mpg. I will show you. Over here you come and specify the data frame, shift enter, then you will see it over here, this mpg. So I am telling that I am considering it as a x, and that is the column I am just extracting. So now let's proceed further. The next step, I am going to calculate the z-score for this x. Z-score I have already discussed in the part 2 of my Learn Data Analysis from Scratch course. So in this part of the course, I have discussed over here in the descriptive statistic concepts, I have already been discussed the z-score or a standardized score in detail. So how we can calculate the z-score? So I will tell that over here I need to specify in the data frame, I am going to create a column which will hold the z-score for mpg. So I will tell that mpg z equal to, and over here I will mention the formula, and the formula is going to be x minus x dot mean. So it will calculate the mean, and over here it will be divided by standard deviation. So this is the formula, will give the value within this particular column that will holds the z-score value. Now let's proceed further. The next step, I need some colors, and for that I need to generate those color on the basis of some condition, and that color I am going to hold into the column of the data frame, and I am calling it as a colors. And over here I am going to use the list comprehension operator, and here I will specify for x in df, and we have used this mpgz. It will iterate all the value of this, and it will now compare. It will check if x is less than 0, then it become red. So we should specify over here red, else it should be green. So we need to tell that else make sure that this red should be coming in front. I am hoping that you already aware about this kind of iteration. This is called list comprehension, which I have already covered in one of my course, Learn to Code from Scratch with Python 3, where I have discussed about this particular list comprehension in more detail. For a time being, you just consider it. It is one way by which you can iterate the data frame. This column we are iterating one by one and checking the value whether this particular value is less than 0. If it is less than 0, then we are telling that it should be red, and if it is greater than 0, then it should become green. So this is what we are doing, and we are assigning it into a column. Now let's proceed to the next step. In our diagram, you have seen that the data is being in sorted order. So now the next step, we need to sort the data. So now let's write the steps for sorting. So here I am going to write df dot sort value. This is the method we are going to use, and I want on the basis of mpg z, the z-score which we have calculated, and we must have to tell that in place equal to true. Once it is being done, we need to reset the index, df dot reset underscore index in place equal to true. So now we have prepared our data, Now let's move further and draw the plot now. So select this cell, press B. Now we have to start writing the code for draw plot. So if you remember, the first thing we need to do is to create the figure. So with the help of this method, we are going to create the figure, and the figure size is going to be our standard size which we have been using, that is 16, 10, that is for length, height and width. And then we need to specify the DPI is going to be 80. Now the next step, we need to draw the diverging bar, and this time I am going to use the method HLines, and here we need to specify some of the parameter. We will get the details of the parameter from the matplotlib documentation, and the URL for this plot is this one. You should remember it. And to draw the diverging bar, we are going to use this method, and here we need to specify all these parameters. So let's do it. So the first parameter, we need to specify y equal to df.index, then x mean equal to 0 and x max equal to our df.mpzz. And here we are going to use these colors which we have generated earlier with the help of this list comprehension, where we are iterating each of the value of the z score, and then we are deciding whether it is a green or red as per the z score. If it belongs to the negative number, then it become red, and if it belongs to the green positive number, then it's become green. So here we need to specify that df.colors, and then we need to specify alpha equal to 0.4, and line width I am going to keep is 5. Now we have drawn the plot. Now next step, we need to decorate this plot. So let's do it. Select this cell, press B, and the first step, we need to grab the current axis. So how we can grab it? plt.getCurrentAxis GCA, and here you need to specify I want to set y level, and it is going to be the model $model, and then I need to set x level with mileage. So x level is going to represent the mileage $. So let's proceed further and let's create the y tick level. So let's look into that, what we are having at the y tick level. So at y tick level, you will find that we are having all the cars name. So how we can achieve this one? So let's look into that. So to access the y tick, we need to specify plt.y ticks, and with the help of this method we can access the y tick level and specify what we want to print it over there. So we want that this car values should be printed at the y tick level. So we need to access first df.index df.cars. So this will access the y tick and specify all the cars name over there, and the size I want to use is the size 12. Once it is being done, then I need to specify title. So title we can specify over here, and here we will tell that diverging bars of car mileage, and here this time we are going to use the font size. For that I am going to use font text equal to size 20. So I need to specify 20 size. Another decoration I want to use, my grid should be presented with the line. So how we can do that? We need to specify plot.grid, and here I need to specify the line style I want to keep is dash dash, and here we need to specify something called alpha equal to 0.5, and at last plot.show. So we have done all the decoration over here. Now let's cut it and put it over here so that we will run it together. So now it is being done. So we have already executed till step 2. So to execute it, we need to first execute the step 3, and then we need to execute the step 4. Shift enter, and once you run it, then you will find that this graph is being plotted. And with the help of this divergence bar, you can easily identify the variance between the cars model, and this is what I wanted to demonstrate you in this session. In the next session, we are going to look into another deviation plot that is called diverging dot plot. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another variation of deviation plot, that is divergent dot plot. So that means the purpose of this particular plot is same as earlier plot, that is to identify the variance within the given data set. So let's look into the plot. what we are going to design in this particular session, and then we will write the code. So in this session we are going to design this plot, and it is based on the same data set which we have used in our earlier session, that is emptycast.csv. So if you closely look into this diagram is almost similar to our earlier one. The only difference is that this time we are plotting the dots, which is basically a scatter plot, but it is also giving the same information, that is how much variance we are having in terms of mileage. So now let's jump into the Jupyter Notebook and let's look into how we can design this plot. So we are into the Jupyter Notebook, and here the step 1 to step 3 we are having the same code which we have used earlier. So that means the global setting is going to be the same, importing of the data is going to be the same, and the third step, that is preparing our data, which is also going to be the same, because we are going to represent the z-score value on mpg, that is miles per gallon, and on which we are going to draw the plot. Now at step 4, let's start writing the code for diverging dot plot. So click on this cell, press B, and the first step, as usual, we need to create the figure. So here we need to tell that plot figure, and here we need to specify the figure size, and this is also going to be the same 16,10, and over here DPI is going to be 80. So this is pretty much straightforward. Now the next step I'm going to use the scatter plot, as we wanted to represent it as a dot. So for that we need to specify the plot as a scatter plot, and we will use the z-score of mile per gallon. So we have stored in this column mpzz. Next we need to specify df underscore index. Now the size of the dot is, over here I am specifying 450. Alpha is going to be 0.6. Color, again, if you remember that how we have calculated the color, where we have checked the value. If it is below 0, then it is become red, and if it is more than 0, then it become green. So I'm going to use the same information over here to specify the colors. Now next we need to iterate each of z-score value, and that value should be printed on dot, like this image. If you closely look into that, then you will find that we have the value printed on each of the dots. So this we have to achieve now. So let's look into the code how we will achieve it. So to access the value of each of the score, z-score, how we can do that, we need to iterate it. So let's iterate it. We need to tell that for x comma y comma tex in zip, and here I am going to take that df dot mpzz comma df dot index comma df dot mpzz again, and here we need to specify t equal to plot dot txt. We need to specify the text, and over here we need to specify x and y, and we want to round, and over here we need to specify text comma 1, and then we need to specify horizontal alignment equal to center. Next parameter, we need to specify the vertical alignment as well, vertical alignment equal to center, that is also center. Next we need to specify the font color. So how we can specify the font color? So we need to tell that font dix equal to, this is going to be the dictionary, and over here I need to specify color colon, and the color I want white. So with the help of this code, we are able to print the text on each of the dots as I shown you earlier. That looks something like this. Now let's proceed further and let's do the decoration to the plot. So before decorating it, let's look into the diagram to observe some of the information about the plot decoration. In this particular plot, if you closely look into this, then you will find that this plot has the boundary at bottom, left and right, and top as well, but their opacity is little less. In Matplotlib, this is called spines. So how we can set this boundary in Matplotlib? So let's do it first in our decoration step. So to access the boundary, what we need to do? We need to specify plot dot get current axis GCA, and over here we need to tell that dot spines, and within that, which spines I am going to access first? I am going to access top, and alpha I am going to set alpha dot 3. Copy all this thing, and we will do it for all the 4 areas, that is top, bottom, left, right. So I have set the boundary for each of the sides, top, bottom, left, right. Now next I need to specify the y-ticks. If you closely look into our diagram, then you will find that our y-ticks contain the name of the car. So how we can do that? We have already seen this in our earlier example. Correct. We need to access the ytick method, and within that we need to pass the index of the data frame as well as the column which we want to put into this particular y-axis. So let's do it. So here we need to specify plt.ytext, and here we need to specify df index comma df.cars. So this will print the all the cars value to the y-axis tick. Now next we need to specify the title. Title you already know about it. We need to access the title method, and over here we need to specify diverging dot plot of car mileage, and we need to specify the font size. How we can access the font size? With the help of font dict parameter, and this will accept the dictionary, and here we need to specify the dictionary size is going to be 20. Now next I need to specify the x level. So for that I will type plot x level, and I will call it as mileage $mileage. Once it is being done, the next thing I wanted to set the grid line style. So how we can do that? I need to tell plot dot grid, and the line style is dash dash, and we will set the alpha equal to 0.5. Next we need to set the x limit, that means the below range. Over here you will see that center 0, and it is starting with -2 and it is reaching to the 2. So this is called x limit. We need to specify it. So let's do it. So we need to tell that plot dot x lim, and here I want the range -2.5 comma 2.5, and last we need to tell that plot dot show. Now cut this code and paste it over here. Why? Because we wanted to execute it together. So you should write it separately, but this code will be executed together. So let's run it. So let's start running from the step 1. Select this one, shift enter, shift enter, shift enter. Third step, shift enter. Now let's run it, shift enter. So it is executing. There is an error, typo error, that is df underscore index. It should be df dot index. Sorry for that. Shift enter, and then you will find that it has plotted this graph, but this plot look very cluttered. So we need to increase the size of the figure. So here I will come and I will tell that I want to increase the size. So let's do it. Shift enter again, and then you will find that it given us very beautiful graph after increasing the size of the height. So here the first part is the width and the second part is the height. So we have increased the height, and because of that we are getting very beautiful plot. And this is what I wanted to demonstrate to you in this session. In the next session we are going to look into another type of graph that is basically used to visualize the ranking. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to discuss about ranking plot. So with the help of ranking plot, we basically identify the data range within the given data set, and in this session we are going to discuss about the ordered bar chart that falls into ranking plot category, and it is used to visualize the data for identifying the ranking within the given data set. So let's look into a diagram how this particular plot will look like, and then we will write the code to generate the same kind of a plot. So the ordered bar chart will look something like this. So with the help of this plot you can easily identify that which car is giving more mileage and which car is giving less mileage if they are consuming 1 gallon of fuel. So let's jump into the Jupyter Notebook and design the same kind of a plot. So to draw the ranking plot we need to follow the same process which we have been following from the last many examples. That is, we need to follow these 5 steps. The first step is going to be the same one. Second step, we need to import the data set. Third step, prepare the data. Here we have some work to generate that data so that it will give us the ranking information. At step 4 we will also draw the plot, and this time we are going to use the V-line plot to represent the order bar chart. And fifth step, you already aware about that. This is used to decorate the plot figure with the right level so that your plot will look more meaningful. So let's start writing the code over here. So over here I have already written the step 1, and which is nothing but a copy paste operation which I did. Now the next step, we need to import the data, and the data I am going to use over here. Press B, and this time I am going to use miles per gallon data set, and you will get the data set from this location. So this is my course GitHub. Over here you will find that learn data analysis from scratch. Within that we are having the data folder, and over here we are having the mpg.csv. So this is the same data set which we have used earlier in one of the session. So it contains another variation of the data, and we need to click on this button raw, and then we will get the link, and that link we will specify. So now let's create the data frame over here. So we need to specify df equal to pd.read_csv, and here we need to specify the link which we have copied. Let's load it, and I will specify df over here. You run it and run this as well. Now let's run step 2 shift enter. Then you will find that here we have given the manufacturer name, the model, the cylinder detail, transition detail, who is driving, male or female, city, highway, all these details. So now let's proceed further, and what we need to do, we need to prepare our data to draw the ordered bar chart. So how we can do that? So let's prepare our data. So first we need to calculate the mean as per the city mileage. We are going to work on city mileage so that we can identify that which car is giving more mileage in city. So let's do it. So here select this cell, press B, and over here you need to specify that processed df. I will tell that df equal to, and here I need to specify df, and the two column which I am going to use for group by is the city and the manufacturer. So I need to tell that manufacturer, and we need to group by it, and I want to group by on the basis of manufacturer, and then we need to apply to calculate the mean. So here we are going to use the apply method. So apply method accepts a anonymous function, and that we can create with the help of lambda. An anonymous function is also known as lambda function in Python. So we need to create that, and over here we need to specify that x dot mean, so that it will take each of the value from the group by object and calculate the mean. Once it is being done, the next step we need to sort the value so that our data will be sorted, and within the plot you will get this kind of data visualization if you are sorting your data. So to sort the value, we need to tell that processed df dot sort underscore values. This is the method within the data frame, and here we need to specify that the column on which I want to sort. So I will tell that city, and I will make sure that it should be in place equal to true, so that it will apply to the data frame, and make sure that after sorting and making it in place true, you should reset the index. So we need to tell that processed data frame dot reset underscore index in place equal to true. Once done, let's proceed further. Now we are ready with our data. Now let's proceed further to draw the plot to identify the ranking. So select step 4, press B, and the first step, you know, in this step what we have to take to create the figure. But if you closely look into our diagram, our plot figure is not very much straightforward this time. At x-axis level, we are doing some formatting, like some of the thing we are representing in green, some of the thing which we are representing in red. So to create such kind of a diagram, we need to create the subplot, and that subplot return two kind of information. First one is the figure, and the second one is the axis. So let's do it. So here we need to specify figure comma axis equal to plot dot subplots, and here this time we need to specify the figure size is going to be the standard one which we have been using, 16:10, that is width comma height comma face color equal to white, and DPI as usual we need to specify 80. Next we need to draw the plot. So to draw the plot, I am going to use another matplotlib plotting method that is called vlines. So here I need to specify ax dot vlines. So for this plot, I am going to specify some of the parameter. So first parameter, the x-axis, and over here I need to tell that processed df dot index, then y mean equal to 0, and y max I want my processed df dot city, and the color I want to tell that, let me give a color called wire brick, and alpha equal to 0.7, and line width I'm going to keep it 20. So that's it for the plot. Now the next step, we need to decorate it. So let's look into the diagram once again. So if you talk about the decoration, you will find that we have annotation over here where we are specifying the values of each of the car fuel consumption, and this is the mean value which we have calculated. So how we can do this? So let's look into that. So as there are various values, so that means we need to first iterate each of the city, and then we can specify the text. So how we can do that? We need to tell that for I city in enumerate, and over here I need to specify processed df dot city, and now we need to get this object access object dot text, and here we need to specify I comma city plus 0.5 comma we need to round it city comma 1. Once it is being done, we need to specify horizontal alignment equal to center. Now with the help of this part of the code, we are able to achieve text on top of each of the line. Now let's specify the figure title. So how we can specify that? We will tell that ax dot set title set underscore title, and here we need to tell that bar chart for city mileage, and we need to specify the font, and for that I am going to use the font dictionary, and over here we need to specify within the dictionary, and I want to access the size, and I want to set the value 22. Make sure that this should be coming outside of this loop. We have a typo also over here, so make sure that it should be one single T. Next we need to set the y level. So how we can set the y level? We need to specify that ax dot set, and over here we need to tell that level equal to miles per gallon, and we want it should show y limit from 0 to 30. For that I need to specify limit equal to 0 comma 30. So this is about the y level. Now let's look into the diagram what we have done so far. So far we have specified the title to this plot. We have also written the y level miles per gallon, and we have also specified at y limit we want to show from 0 to 30. Now let's work on the x-axis. So here you can see that we have a name of each brand. So how we can do this? Let's look into that. So to achieve that, we are going to use the xtick method, and over here we need to call xticks, and over here we need to pass the parameter. So the first parameter I need to specify processed df dot index, and over here we need to specify the manufacturer name, that is our car name. So here we will tell that manufacturer name. So let's write processed data frame dot manufacturer dot str, and I want that all value should be in uppercase, so we need to specify this, and I want it is little tilt, and so we need to tell that rotation I want 60 and horizontal alignment should be right, and the font size I am going to keep the small equal to a small. Why it is a small? As I already mentioned that we are having some constant value over here in the first step, so that's the reason I have mentioned over here small. So now let's proceed further. Now cut this code from here and put it at the fourth step so that we will run it together. So once it is being done, let's run it now. So let's run it step 3. Now run the step 4, and you will find that it has given us the graph which is our ordered chart. Now let's look into the diagram which we have seen and see over here what thing is remaining. If you closely look into this diagram, then you will find that this plot is giving us some other kind of information with the help of red-green box. So what does this information mean? It means that manufacturer, which is represented in green, is giving us more mileage compared to the manufacturer which is represented in red. So this kind of representation still we need to do in our plot. So let's do it. So to achieve such kind of a visualization, the first thing we need to import something called patches. So over here we need to come and we will tell that import matplotlib dot patches as patches. Shift enter so that we can load this library into our memory. Now let's come over here. Now the next step, we need to create two patches, first for red and second for green. So how we can create that? So that is a rectangle shape. So we need to tell that p1 equal to patches dot rectangle, and over here we need to specify something called 0.57 comma minus 0.005. Next we need to specify the width of the rectangle. So we will tell that width equal to 0.33, and then we need to specify the height. I am going to keep it equal to 0.13, and alpha I want to keep equal to 0.1 comma base color equal to, this is for green configuration, so I will tell that green, and I will tell transform equal to figure dot transfigure. So this is the configuration. Make sure that you are specifying the correct spelling over here. So we are missing L over here. If you want to know more about this particular patch library, so you can visit this site. This is the matplotlib documentation, and over here you will find that information about the rectangle method and their parameters. So now let's proceed further and let's create patch 2, that is P2, and that is red rectangle. Now let's copy this line so that we can use this line with change of some of the configuration by changing some of the parameter. And we should come here and we will tell that it is going to be P2, and over here we need to specify 0.124, and here it is going to be the same, and width I'm going to keep it 446, and height is going to be the same. Alpha is going to be the same. Base color we need to change it to red, and remaining thing is going to be the same. So now we have created the patch, but this patch is not applied till now to this particular figure. So how we can apply that? Let's look into that. So for that we need to specify figure dot, there is a method called add artist. So we will use this method and we will tell that apply to this figure. Same is the case with this one, figure dot add underscore artist, and we will tell that apply P2 as well, plot dot show. Once it is being done, let's select this one, cut it and put at step 4 so that we will run it together. So now let's run it together and see the output. Shift enter, and then you will find that we got the same kind of rectangle. For some of the manufacturer it is giving us green, and for some of the manufacturer it is giving us the red, and that is based upon the how much mileage each of the manufacturer car is giving. If it is giving more, so it falls into green category, and if it is giving less, then it is falling into the red category. And this is what I wanted to demonstrate you in this session. In the next session we are going to discuss about the dot plot, that is also falls into the ranking plot category. That also helps us to identify the ranking within the given data set. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another type of ranking plot, that is dot plot. So let's look into a diagram. So in this session we are going to design this plot, and to demonstrate this plot I am going to use the same kind of a data set which we have used in our earlier session. So now let's discuss about this plot. Over here you will find that at x-axis we are having miles per gallon information, and at y-axis we are having the car manufacturer's name, and on plot we are having some little dots. So what actually these dots represent? If you read this plot, then you will come to know that it is giving the same information which we have extracted in our earlier session, that is which manufacturer's car is giving more mileage and which manufacturer's car is giving less mileage. So over here you will see that Honda is winning the race, and it is giving mileage of 24 miles in 1 gallon fuel. So with the help of this dot plot you can easily identify the ranking within the given data set. Now let's proceed further and let's go to the Jupyter Notebook and let's draw this plot. So again, for this plot also we are going to follow the same step. You must be asking that why I am coming back into the same Jupyter Notebook and I am showing the same steps. So to answer your question, I want that you should remember all these 5 steps, as most of the steps is repetitive steps with some differences at step 3 and step 4. And when you are doing the actual data analysis, on that time you should remember this workflow. So that's the reason in every session I wanted to showcase this particular steps so that your mind get trained with these steps. So now let's proceed to the ranking plot dot plot. So over here we are going to have the same steps, and from step 1 to step 3 we don't need to do anything, as we have already performed the same thing in our earlier session. So this one is the constant one, it is going to be the same which we have been using in all of the plot. At step 2 we are having the same data set, that is our mpg.csv. If we will run it, first run the step 1, then you have to run this one, step 2, and you will find that it contains the same data set which we have used earlier. Now proceeding to the step 3. The step 3 is nothing but grouping of the information on the basis of the manufacturer, and here we have sorted those values and then we have reset the index. Now coming to the step 4. So from here we need to do plotting exercises. So let's start. So select this cell, press B, we will get the new cell, and over here the first step we need to create the figure and the axis. It is also the trickier one, so we need to create the subplot and it will return us the figure
as well as the axis. So we need to specify figure comma axis equal to plot dot subplots, and here we need to specify the figure size. So far you are aware about this figure size, so we need to specify the width and the height 16 comma 10, and the DPI is going to be 80. Next, here if you closely look into our diagram, then you will find that this plot contains two kinds of plot. One is the horizontal line, that is H lines, and another one is this dot, and this dot is coming from the scatter plot. So that means we have to use two plots. One is H lines, another one is the scatter plot. So let's do it. So first write H line AX dot H lines, and here as usual we need to specify the parameter for Y axis. So we need to specify Y equal to processed data frame dot index, and over here X mean equal to 11, X max equal to 26, and this time we need to specify the color equal to gray, as our line color is gray, and here we need to specify the alpha equal to 0.7, and line width we are going to keep it only 1, so we need to specify 1 over here, and line style I want it should be dashed, so it should be dash dot, we should tell that dash dot. So this is the configuration for the H lines. Next we need to specify the scatter plot. So for that I am going to tell that AX dot scatter, and over here I need to specify Y, and that is processed df dot index comma X equal to, I want to specify the processed df dot city, and size I want to keep for that particular dot, that is a scatter. So dot I want to keep it 75, and color I want again the same one, fire brick, and alpha I want to keep it 0.7 to 0.7. So we have drawn the plot. Now let's proceed further and let's decorate our plot with the right level. So select the step 5, press B, and here I am going to set the title first. To set the title, you already aware that we have to use a method called set underscore title, and here we need to specify dot plot for city mileage, and we need to specify the size of the font. So how we can provide it? With the help of font dex. So we have a parameter called font dex, and over here we need to specify the key, and what I want to access the size, so I will tell that size, and this is going to be large. If you remember that we are using the constant as well, so here we are having the constant, so you should specify the value large over here. Now next I need to specify the X level. So X level, if you see into our diagram, then you will find that we are having miles per gallon. So let's specify that. So here you should tell it should be AX dot, here we need to specify dot set underscore X level, which you already aware that, and here you need to specify miles per gallon. Next you need to specify the Y text, and for that you need to specify AX dot set underscore Y text processed df dot index. Now we need to specify the level. If you remember, our Y level is having the car manufacturer's name. So let's look into the diagram. So over here you are seeing that the level we are having is the car manufacturer's name. So let's do it now. So here we need to specify AX dot set Y text level, and within that I am going to specify processed df dot manufacturer. If you remember, we are having a column over here that is called manufacturer. So that is the thing I have mentioned over here, and this I am going to tell that str, and it should be in title case. So we need to specify over here. Another thing, I want my font should be right aligned. For that I need to tell that font text. With the help of this I am accessing the font, and over here I need to pass the key, and I wanted to access the horizontal alignment. So there is a property that is called horizontal alignment, and I want it should be aligned right. So I need to tell that right. Once done, now let's set the X limit. So over here we are having the X limit from 10 to 27. So let's do it. So to set the X limit we need to tell that AX dot set underscore X lim, and here you need to specify the range from 10 to 27, and at last you should tell that plot dot show. Now grab this code, cut it and paste it over here. Now we are done with the plotting and the decoration of the plot. Now let's run shift enter. We have done some typo, so there is a typo error and it looked like this one. Now do the shift enter
and then you will find that we got the same beautiful graph which we have seen in our diagram. And this plot is helping us to identify the rank. For this case, we are able to identify that which car manufacturer is winning the race of fuel consumption. That means by consuming less number of fuels, it is giving us more mileage. For this case, it is calculating which car is giving more mileage if they are consuming 1 gallon of fuel. So for this particular scenario, Honda is winning the race and it is giving us 24.2 miles in per gallon. So on this note, I am stopping over here. In the next session, we are going to look into another type of data visualization that is basically used to identify the distribution. And this type of data visualization is mostly used within the exploratory data analysis. So all these plots are going to be very useful tool in your data analysis journey. So see you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to start looking into the distribution plot. So guys, the main purpose of distribution plot is to identify the distribution of the data within the given data set. So in this aspect we are going to learn about various type of distribution plot. So we will be starting with the histogram for continuous variable. Then we will look into histogram for categorical variable. Third, we will look into density plot. Fourth, we will discuss about density curves with histogram. And at last we will discuss about the box plot. And in this session we are going to learn about histogram for continuous variable. So guys, let's look into the plot. What plot we are going to design in this session. So guys, in this session we are going to design this plot, and with the help of this plot you are able to identify the distribution within the given data set. In this particular example, here we are checking that how the displacement variable is spreaded across on the basis of the class. So here the class is representing that whether the vehicle is two-seater, it's a compact vehicle, mid-size, minivan, pickup, subcompact or SUV. Now if you closely look into this particular plot, then you will find that at x-axis we are having the displacement value, and at y-axis it is telling that how many number of cases available in this category. So how do you read this plot? So for example, if you talk about this point, then it is telling that we have one case which is of class 2-seater and whose displacement value is 7.0. Now how do you read if you are having more than one class and their displacement value is same? For example, over here 2.7. So here you have the representation of the orange color is the compact. You have compact vehicle whose displacement value is 2.7 and it is almost 7 number of cases we have. In the same bar we are having mid-size vehicle whose displacement value is 2.7. In the same bar we are having another class that is called pickup class, and which has near about 13 cases that belongs to 2.7 displacement. Now let's proceed further and write the code to generate this plot. So to generate this plot, we are going to follow the same 5 steps. In the first step, we are having the global settings. In the second step, we are importing the data. In the third step, we are preparing our data. Fourth step, we are drawing the plot, and in the fifth step we are decorating the plot. So I have already written the step 1 and step 2, and the data set we are using the same data set which we have used in our previous session. So now let's proceed further and prepare our data for this particular plot. So I will select this cell, press B, and over here I am going to specify the x variable, that is our displacement if you remember, and over here I need to specify that I want to group on the basis of the class. So we are having a variable that is called class. So let's look into that. Run shift enter, and over here you should specify data frame and then run the step 2. Once you run the step 2, then you will find that we are having a variable called class, and that I am going to tell that. So I should tell I want to group by on this variable. So here I will specify group by var equal to class. Now next I need to perform group by operation, group our data. So over here I will tell that df dot aggregation equal to df dot loc. This is for slicing, and here I am selecting the column. So I want to select the displacement which I have stored in this variable. Along with that I want to select the class variable. So I will tell that group by var which we have stored class over here, and then I will tell that I want to group by on the basis of the class variable. So I will tell that group by variable over here. Now let's store the values of these. So how I can do that? I will tell that vals. So this is a variable, and within that I will get all the values of the group data. So let's do it. How we can do that? We use list comprehension operator, and over here I need to specify that this value x var, and over here I need to get all the values which will be converted as list with the help of this method to list, and over here I will iterate it for I comma df in df underscore aggregation we have created in this line. So we will get all the values. So now we have prepared our data set. Now let's proceed further and let's draw the plot on the basis of this data which we have generated. So in the step 4, select this cell, press B, and over here the first step we need to create the figure. So here we need to mention plot dot figure, and within that I am going to specify the figure size, and over here we need to tell that 16 comma 10. 16 is our width and 10 is our height, and over here we need to specify DPI equal to 80. Now next we need to specify the colors. So for colors I am going to use the color map. Here I will generate those colors. I will tell that plot dot cm for color map dot. There is a method called a spectral to generate the different color. I will tell that a spectral, and within that I am going to generate some of the color with the help of this common formula which we generally use. So here I want how many number of colors to generate. So I want it should generate how many number of values we are having. So let's calculate it. So here you need to specify float to do the conversion, and then we need to tell that len the values minus 1. So it will generate these number of different colors. First it is calculating how many number of values you are having, and then it is doing the minus 1, and then it is converting it into the float, and then it is dividing with the number I. So for I am going to write the code for I in range len, and over here we need to specify the values which we have generated over here. So here we are iterating the loop till the length of the values. So how many number of item we are having, so it will iterate till that number and it will generate those number of colors. In a more simple term I will tell that it will generate those number of color how many number of classes we are having, and class is a variable within the data set, so it is generating those number of color combination. Now the next step, let's generate the histogram. For that I need to tell that, and we need to specify 3 variable beans patches. Whenever we are calling this hist function, so it will give us these 3 information, and over here we need to specify the parameter, and the parameter I want vals which we have generated over here, that is a list, and I want 30, and stacked, it should be stacked. I want that the data should be stacked, and I will tell that true, and density I don't want to show here, so I will tell that false, and the color I want the color which we have generated. So this way we will draw the histogram. So now let's proceed further and let's do the decoration on the plot so that it would be more meaningful. So let's decorate the plot. So I will start decorating with the legend. So let me write the code first, then I will explain. So over here I will tell that plot legend, and over here I will mention group colon call for group comma call in zip. I will get the unique values of all the classes. So here I will tell that np unique, and here we will specify df group by underscore var. This is the class information, and I want to convert it as to list. So this code will help us to get the legend, and over here we are getting all the colors, and as well as we are getting all the classes, and we are identifying the unique value of those classes and zipping it, and then we are iterating it one by one and making a key value pair, and that is used as a legend. And this legend will look something like this. In this plot you are seeing it over here. So this is the legend is representing the class. So now let's proceed further and do the further decoration. Next we need to specify the title. So we will tell that plot title, and over here I will tell that tag histogram of our variable, that is x underscore bar dollar dollar colored by dollar dollar, and between that curly braces. Here we will specify the variable group by underscore var, and the font size I am going to keep it large equal to 22. Next we need to decorate our x level. So here I need to tell that plot dot x level, and we will specify the x var. Next we need to decorate the y level. So here we will tell that y level, and here we will tell that it will represent the frequency, and at y lim we need to specify the 0 to 25. So here I will tell that plot dot y lim, and here we need to specify 0 to 25. Then I want to specify the x tick. So for that I am going to specify plot dot x tick, and here within text parameter, I need to tell that I can use the bin which we have received over here. So I will use it over here. I will tell that beans. Next, I need to specify the levels. So here I will tell that levels, and it should be round. I'm going to round the value, and over here b comma 1. And how does we can get the bean? So here I am telling that for b in all the beans which we got over here. So you must be asking that what is happening with this line. So I will tell you, in this diagram you are seeing it over here 1.6, 2.1, 2.7. So these values is x-tick values, and this value we are printing it on the figure with the help of this particular line. And at last, plot dot show. Now we have done the decoration. Select this one, cut it from here, come to the step 4, paste it over here, so that we will execute it together. So now let's execute this. Do shift enter, and then you will find that we got the histogram which we are going to use to identify the distribution of displacement on the basis of the class. And this is what I wanted to demonstrate you in this session. Now in the next session we will discuss about histogram for categorical variable, and that plot is used to identify the distribution of the categorical variable within the given data set. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to discuss about histogram for categorical variable, and the purpose of this graph is used to identify the distribution within the categorical variable. And you feel very astonished if you find the similarity between this particular plot and the earlier plot which we have used for the continuous variable is almost 99% similar. Why I told 99%? Because we are going to change the application from continuous variable to the categorical variable. So let's look into the diagram what plot we are going to design in this session. So in this session we are going to generate this particular plot, and here you will see that at x-axis we are having manufacturer instead of displacement. Earlier we were having the displacement over here, and this time we are having manufacturer, and that is a categorical variable. Apart from this, everything is same which we have used in our earlier session. So let's write the code to generate this plot. So let's jump into the Jupyter Notebook. So we are into the Jupyter Notebook, and the steps which we have to follow, that is the same step. We need to follow the 5 steps to plot the histogram for categorical variable. And as I already mentioned that for this example, it has 99% similarity between our earlier code. Earlier we have used the same code to generate the histogram for continuous variable. So I am going to leverage the same code, but this time I just need to change one line of code to generate the histogram for categorical variable. So earlier we are having the continuous variable reference, but this time I am going to specify the categorical variable, that is the manufacturer. So let's execute it first. Step 1, shift enter. Now step 2, shift enter, and we will get the data set, and over here we are having the manufacturer, and this is the column I want to identify the distribution. So I will capture this column, I will come it over here, and we need to replace this with the manufacturer, and remaining thing is going to be the same. So displacement we have replaced with manufacturer. Now do the shift enter, so it will generate the data for our plot, and at step 4 and step 5 is going to be the same. Here we don't have any differences. It should be 10, we can mention 16, 10, and now let's run it. Do shift enter, and then you will find that has generated the distribution plot on categorical variable, that is manufacturer, and it is telling that how many total number of cases in each of the category, and it is representing the histogram of manufacturer which is colored by classes. And reading of this particular plot is similar to how we have read our continuous variable plot histogram. It is going to be similar like that. For example, if you take an example over here, our data set has 5 Audi which is 2-seater, then we have 10 mid-size Audi, and then we are having almost 18 number of cases, that is a SUV, and which is of type Audi. So you can easily identify that how our manufacturer data is distributed within the given data set. And this is what I wanted to demonstrate you in this session. In the next session we are going to look into another plot, that is called density plot, that is also used to identify the distribution, and with the help of density plot we are able to identify the skewness as well as kurtosis within our given data set. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another variation of distribution plot that is called density plot. So let's look into the diagram of the plot which we are going to design in this session. So guys, this is the diagram of the density plot and which we are going to design in this session. One important point you should remember that whenever we are talking about the density plot, then it should be applied only to the continuous variable. So let's jump into the Jupyter Notebook and write the code to design this plot. But prior to that, I just wanted to let you know what actually we are going to do. So we are going to use the same kind of data set which we have been using from the last sum session, that is mpg.csv, that is miles per gallon, which holds the information about how much mileage each vehicle is giving. They are consuming 1 gallon of fuel. And with the help of this particular density plot, we wanted to showcase distribution of city mileage by number of cylinders. And over here, the different color combination of this plot is representing the number of cylinders within the car. So let's start writing the code for this particular plot. So we are into the Jupyter Notebook and the steps which we are going to follow is the same which we have been following from very long. A step 1 and a step 2 is going to remain same, where we are having this mpg.csv data. For this example, we are not having much preparation for the data, so we are directly skipping to the step 4 and where we will draw the plot on this data frame. But prior to that, let's execute this one so that we can look into the data set. So over here we will select this cell and do shift enter. Next, select step 2, shift enter, and we will get this data. And as you already aware about this data set, we are going to use in this example the city as well as the cylinder. So this cylinder. So let's write the code to draw the density plot. So here I will select a step 4, press B, and over here I will write first step. You remember we have to create the figure, so we will tell that figure, and here we need to specify figure size equal to 16,10. That is our standard size we have been following. 16 is width, 10 is height, and over here I need to specify dpi, that is 80. Now the next step, to draw the density plot, we are going to use Seaborn KDE plot. So let's write sns.kde plot. And over here I need to tell that the data frame which I am going to use is df.loc, and over here we are now slicing it. So I am telling that I want all the record which is having 4 cylinders. So I will tell that df, and within that I need to specify the cylinder, that is the column name, and over here I need to specify equal to 4, and this is for the cylinder data, and over here I need to specify city. So I will tell that city column, and then we need to specify some of the parameter. Shade I want true, color I want green, so I will specify green, and level I will tell that level equal to, and within the double quotes we need to specify cylinder equal to 4, and I need to specify the alpha equal to 0.7. I will copy this code and paste it 3 times again so that we can access some other cases also. Over here I will specify 5 to give me the record which has 5 cylinder, next which has 6 cylinder, and which has 8 cylinder, and here we need to change the color. So for this one I am going to use something called deep pink. Next I will tell that there is something called Dodger blue, and at last I will tell orange, and make sure that you are changing the value over here. This is for 5, this is for 6, and this is for 8. So we have drawn our plot. Now next we have to decorate it. So this time I am going to use the plot.title. So I will specify over here, and I will tell that density plot of city mileage by number of cylinders. So I will tell that cylinders. The font size is going to be the large. So I will tell that font size equal to large. Large is our constant which I already created over here. You will see it over here. So that is 22. So I should mention over here, and over here I will tell that I want legend also. So I will tell plot.legend and specify this parenthesis. So I'm calling that method, and over here I will tell plot.show. So we are ready. Now just grab this code, cut it from this place and paste it over here so that we can execute it together. So now let's execute this and let's look into the output. Shift enter. We got error because we did a typo blunder over here. So this bracket
should come over here. Sorry for that, guys. So we need to specify over here, cut this bracket and paste it over here. Cut this one, paste it over here. Same is the case with this one. Paste it over here. Same is the case with this one. Sorry for that, guys. So it was a typo. Now do shift enter and then we will find that we got one more error. Legend. What is happening? Sorry, guys. Shift enter again. And over here we will find that we got a plot, and this is called density plot, and with the help of this plot we can identify the distribution within the data, and that is of type continuous. For this particular example we are identifying the city mileage by number of cylinders, and this is what I wanted to demonstrate you in this session. In the next session we are going to look into another variation of the same density plot, but this time we are going to draw histogram as well along with the density curves. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. Now in this session we are going to look into another variety of distribution plot, that is density curves with histogram. So let's look into a diagram how this plot look like. So the plot density curve with histogram looks something like this. Over here you are getting two kind of information. One is with the density curve, another one is the histogram. For this particular example over here, with the help of this plot we are able to identify or visualize city mileage by vehicle type. So let's jump into the Jupyter Notebook, and over there we will draw the same plot. So to draw the density curve with histogram we have to follow the same 5 steps. So over here you will find that the step 1 is the same which we have been following from very long. Step 2, we need to use the same data set which we have used in our previous session, that is mpg.csv. Third step, we don't have any preparation of the data required as this plot is going to be pretty much straightforward. So we will be using the data frame over here. Now coming to the step 4, we have to do some changes in our earlier code so that we can draw both the density curve as well as the histogram. So what are those changes? The first change, we have to do the plot type. So over here we are using KDE plot. Instead of that we have to use the dist plot. So first thing, we need to change it from KDE plot to dist plot. Copy this one, paste it over here, and this one as well. The last line we don't need it because we want only to have the information about three kind of class. So let's look into the diagram. So over here we are having three kind of class, that is compact, SUV, minivan. So over here we will delete this line. Select this one and delete it. Now the second thing, we have to change from cylinder to class. Over here, as I already mentioned, we have cylinder variable. Instead of that we have to use the class variable. So let's change it. So first we will change it over here, class, and the first class which we are going to get the information, that is compact. Do the changes over here. And the second one, if you remember, we have SUV, and the third one, if you remember, we have something called minivan. So this is the second changes. Now the third thing we have to do here, we need to remove this alpha, and instead of that we need to specify two more parameters. The first one is hist underscore KWS. So this is for the configuration of histogram, and here we need to pass the dictionary that will contains the alpha value. So alpha, and over here we need to specify 0.7. Another configuration I need to specify for the KDE plot. So over here I need to tell that KDE underscore KWS, and over here we need to specify line width 3. Copy this code here to here and replace this alpha 0.7 with this code. Same is the case with the third one. Now make sure that you are changing the level over here. So this is for compact, second one SUV, and the third one minivan. So that's it. So this is the change we have to do in our code, and make sure that you are specifying correct title, and over here we need to specify the mileage by vehicle type. Once done, let's execute it. Let's do shift enter. We got some error here. We have used the KDE plot parameter. This is not there, so remove this one as well, and this one as well. Now do shift enter again, and over here you will see that we got the plot, but it is not looking correct because we did a mistake over here. Make sure that you are using a small c, and for this SUV you are specifying in SUV like this. Now do shift enter again, and then we will get the same plot, and this is what I wanted to demonstrate you in this session. Now in the next session we are going to discuss about box plot, and box plot is very interesting plot that is also used to visualize the distribution. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to discuss about another kind of distribution plot, that is box plot. So let's look into the diagram. How does this box plot look like. So this is the diagram of the box plot. So guys, box plot are a great way to visualize the distribution within the given data set. With the help of box plot, you can easily identify the quartile and interquartile information of the given data set. If you don't know about the quartile and interquartile, I have already covered this in earlier part of this course, that is learn data analysis from scratch. So if you look into this course, then you will find that at part 2 we are having descriptive statistic concepts, and where I have discussed about the measures of variability, and within that I have discussed about the quartile and interquartile range and their significance. So if you haven't gone through it, you can go through it. That would be really very helpful for data analysis. Now let's proceed further. So over here in this plot, what we are observing the mileage by vehicle class. But this time we are using the box plot, and over here each box is the representation of the vehicle class, that is compact, mid-size, SUVs, two-seater class, minivan, pickup, subcomponent. And if you closely look into this box, then you will find that it has some long line on top of each of the boxes. So this means that this kind of data, for example subcompact class variation, exists within the range from 18 to 35. The another thing which you have observed over here, we are having a line within the box. So you must be asking that what is the significance of that particular line. So that line represents the quartile information, more specifically interquartile range. So guys, one thing you should remember, that whenever you want to visualize the distribution of the data and you want to visualize the median, 25th, 75th quartile along with the outliers, then box plot is very useful. But there is a problem with the box plot, is that sometimes size of the box will mislead you. As if you see over here in this two plot, both are having different kind of data, then you will find that the box size is same even though the observation number is different. The orange box contains 47 number of cases and blue box is containing the 5 number of cases. So why is it so? That is because their statistic matching even though their number of cases is varying. So what it means? So it means that their 25th percentile, 75th percentile, their median value is matching. So that's the reason it is showing the similar size, as box plot is used to visualize the distribution in terms of their statistic. I wanted to tell you one more thing. Over here you will find that we are printing the observation so that we will give the complete information about the data distribution. Suppose if you are giving this information without these observation information printed on each box, then other person will think that both the boxes contains the same number of cases in the given data set, and that kind of interpretation mislead the data analysis. So it is recommended that whenever you are using the box plot, it would be always good practice to specify the number of observation within the box. So now let's proceed to the Jupyter Notebook and write the code for box plot. So we are into the Jupyter Notebook, and the steps which we are going to follow is similar to the earlier one. Step 1 is for global setting, which I have already completed. Step 2 for importing the data set, and we are going to import the same data set which we have been following from the last 2-3 sessions, and over here that is mpg.csv. Preparation of the data is not required for this particular plot, so I haven't touched this step. At step 4 I am going to write the code, but over here if you closely look into our diagram, then you will find that we have printed these number of observation on each of the boxes. So to print these values, this method will help us. I have already created this one, and it is pretty much a straightforward function which accepts 3 information. One is the data frame, another one is the column name on which we are drawing the box plot, and the third one is the target variable. Over here it is highway, and once we get the information, we are creating the median dictionary, and then we are calculating the x-tick levels, and then we are identifying the number of observation or number of cases in each of the categories of vehicle class, and then we are printing it into the each boxes. So now let's start writing the code to draw the plot. So as usual, we are going to follow the same pattern. We need to create the plot figure, and here we need to specify the same, and I am going to specify figure size equal to, we can keep it the same specification which we have been following, dpi equal to 80. And to draw the box plot, we are going to use c1 method that is called box plot, and over here we need to specify that at x-axis what we want to keep, and there is a class variable which I have already shown you. If you want to see it again, let's print this one first run the step 1, and for step 2 print df will print us the data frame. Over here you will find that we have a class variable, and that is what I am going to use it over here. I want to print at x-axis, it will represent the class, and then at y-axis I want the highway mileage information, and this is our y-axis highway. Then we need to specify that the data which I want to keep is the data frame which we have created over here. So this is the data frame. Once it is being done, then we need to specify there is something called notch equal to false. So this will create the box plot. So once it is being created, we need to print the observation on each box. So what I mean to say that, so these number I want to print it. Now I will call the method which I have already been created, and where I need to pass the data frame as well as the two variables which we are plotting over here, like class and the highway. So let's do it. So I will call this method. So I will tell that add underscore n underscore obs, and within that I am going to specify I want to pass data frame df group call equal to class. This is our variable, and the y I am telling that highway. So that's it. So this will put the text, that is number of observation, on each box. Now we are done with this step. Now let's decorate it. So to do the decoration, I'm going to specify the title. So I will tell plot title, and this is our box plot. So I will tell box plot of highway mileage by vehicle class. So once it is being done, I need to specify the font size, that is large, as you know that this is a constant which I have declared at top. Now next I need to specify that the y limit. So I want y lim should be in range of 10 to 40. So I will specify 10 to 40, and at last I will tell plot.show. So we are done with the plotting. So now cut this code and paste it over here. So now let's run it and see the output, what output we are going to get. Do shift enter, and then you will find that we got the same plot which we have seen in the diagram. For this particular example, we are identifying the distribution of the highway mileage by vehicle class. So this is what this plot is representing over here, which we have already discussed earlier, and this is what I wanted to demonstrate you in this session. So guys, in our next session we will be starting with the another type of plot, that is for composition. So in this aspect we are going to learn about pie chart, tree map, and bar chart. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another type of plot, that is composition plot. So in this category we are going to learn about pie chart. So let's jump into the diagram, how this pie chart look like. So this is the diagram of the pie chart. So guys, pie chart is a classical way to show the composition of groups. However, it is not generally advisable to use because the area of the pie portion can sometimes become misleading. But if you are very inclined towards using the pie chart, then it is recommended that we should explicitly write down the percentage number for each portion of the pie. So let's jump into the Jupyter Notebook, and there we will write the code for pie chart. So we are into the Jupyter Notebook, and the steps to write the code for pie chart is same which we have been following. That is, it contains 5 steps. Step 1, we are having the global setting. Step 2, we are going to input the data set. Step 3, we should prepare our data. Step 4, we will draw the plot, and step 5, we will decorate the plot. But for pie chart, we are going to write one function which will put the text on each portion of the pie. So let's start writing the code. So over here I have already leveraged the code of step 1. So step 1, it is going to be the same code. So I copied and pasted it. Step 2, we are going to use the same data set over here. So it is also going to be the same. Now coming to the step 3, prepare data. So let's select this cell, press B, and over here we need to specify df underscore processed. So here I am going to group by the data frame on the basis of class variable. So for that I need to write df dot group by, and over here I need to specify the class and the size, and over here I need to reset the index, reset underscore index, and here I will specify name equal to counts. So this is only a step which required to prepare the data set for this particular plot. Now let's proceed further. At step 4, we are going to draw the plot. So for this I am going to select this one and press B, and over here I need to create two variable, figure and axis, and over here we need to specify plot dot subplot. Here we need to specify figure size. Figure size is going to be 12,7. This time I will keep it something different, and over here I need to specify subplot underscore kw. This parameter we need to specify, and we need to tell that dix aspect equal dpi equal to 80. Once it is being done, now let's create the data variable which contains the count which we have created. So here we will tell that data equal to df underscore processed, and this will contain the counts. Now another variable we need to create to hold the categories of the classes. So here I will tell that categories equal to df underscore process, and here we need to specify the class. Now here we need to create another variable which is an array variable and which contains the explode information. Explode equal to 0 comma 0 comma 0. So here we need to mention 60 and 1 is different value, so over here, or 70 over here, and this value I am going to keep it 1. So what this explode will do, I will explain you after running this program. For a time being, you just consider it, there is a explode variable which holds 7 values. Why it holds 7 values? Because it is holding 7 type of class information exist within the class variable. So that's the reason we are having 7 zeros over here. And what is the significance of this? That I will explain you after running the program. So now let's proceed further. Next, we need to write a function which will actually print the percentage information on each portion of the pie. So let me write it and then I will explain. So with the help of this function, we are able to write on top of each portion of the pie. Now we have done all the prerequisite to draw the pie chart. So let's draw the pie chart. For that I am going to use pie method of matplotlib, and when you are using the pie method, it is returning three kind of information. One is wedges, and over here another one is the text, and the third one is the auto text. And we need to specify ax.py, and here we need to pass the data, and then we need to specify the auto percentage. And when we are doing this, we need to call the function which we have created. So how we will call it? With the help of lambda function. So we need to specify the lambda over here, percentage, and here we will call the function, and within that we will pass the first percentage along with data. So we need to specify the data over here. Now next we will pass the parameter that is called text props. Over here we need to specify text, and the color I want it should be white. The next parameter we need to specify the colors. For that I am going to use the color map. So I will call plot cm dot, and I want to keep it dark to dot colors. Next parameter I want to specify the start angle. So I will tell that a start angle should be 140 degree, and then I need to specify the explode which we have created for each of the unique values of the class variable. So I will tell explode set. So we have done with creating the plot. Now the next step, I need to do the plot decoration. So let's proceed to the step 5. So over here the first thing I want to decorate is the legend. So I will call ax.legend, and here I will pass the wedges which we have received from py method. Then after that I need to specify the categories which we have created over here. Next I need to specify the title over here. Title equal to vehicle class. Once it is being done, then we need to specify the other parameter that is called LOC, and over here we need to specify that where we want to keep it. So I will tell center left. Another parameter we have to specify the bounding box. So we need to tell that bbox underscore to anchor, and over here we need to specify the value. I'm going to specify 1 comma 0 comma 0.5 comma 1. So this is the bounding box value, as our legend will be displayed into the rectangle. So that's the reason we have specified these value. With the help of these value, it will put the bounding box surrounding the legend's value. Now let's proceed further. Now we can tell that there is something called plot.setP. So with the help of plot.setP method, we are able to set the object property. So here I am going to specify auto text, and the size I am going to specify 10, and weight equal to 700. Next I need to specify the title. So let's set the title over here. So for that I need to specify ax.set underscore title, and here I need to specify class of vehicles pie chart. Once it is being done, make sure that you are closing the quotes. Now let's cut this one and put it at step 4 so that we will execute it together. So let's do that. Control V. Now let's execute it. So we have done with all the configuration to generate the pie chart. So let's execute it one by one. Select the step 1, shift enter. Step 2 we need to execute, shift enter. Next we need to execute the step 3,
that is prepare data. Now let's execute both step 4 and step 5 together to generate the pie chart. So we got the pie chart, and over here you will see that we have printed the level of percentage on each of the pie chart portion. One thing I just wanted to let you know, I have mentioned that we have used this explode variable and we have used 6 zeros and one value is 0.1. This 0.1 is giving us this representation where one of the pie is coming little out from the center. So that we are achieving through this explode variable which we are using here. You will see that we have a parameter over here, explode, and that's what we are specifying that. And that is being generated on the basis of how many unique values you are having within the given class. For this example, we are using the vehicle class and it is representing that. Suppose if you will remove this, then let's look into that. What will happen if every value is 0? So let's execute it again, and then you will find that that effect went away. Now revert back that effect, specify 0.1, shift enter. If you want to specify more, then you specify 0.2, shift enter. Then you will see that this portion of the pie is representing more far from the center. We can try for other value also. So let's specify fourth one, so 0.1, shift enter. Then you will see that it has taken out this one, which is the representation of the minivan. Minivan is represented in pink color. So this is what I wanted to demonstrate, guys. Now in the next session we are going to look into another type of composition plot, that is going to be tree map. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. Now in this session we are going to look into another type of composition plot, that is tree map. So let's look into the plot, how this plot look like, and then we will design this plot. So guys, this is the diagram of tree map, and tree map also used to visualize the data to represent the composition. But to draw this plot we required to install one package. So let's install that package and then we will draw this plot. So as we are using the Anaconda distribution while installing the Python, so we need to install this package that is called Squarify, and this will help us to plot the tree map. So let's copy this command and open the Anaconda console. So this is the Anaconda console. Now let me paste the command which we have copied. So let's paste it over here and do enter, so that it will install this package, and with the help of this package we will create the tree map. Once you run this command, then you will find that it is asking for your consent. So you need to press it over here, Y, and do enter again, so that it will install the Squarify, as well as it will also update the matplotlib. So now it is being installed. Now let's jump into the Jupyter Notebook and let's create the tree map. So we are into the Jupyter Notebook, and the steps which we are going to follow is the same step that we have designed to plot the data visualization. That is our 5 steps. So you already aware about this, so I'm not going to repeat again, but you should remember that whichever plot you are working upon, you should follow the same process, or say same steps, to draw the data visualization plot, irrespective of whatever the plot you are plotting. Now let's go to the tree map notebook, and over here the step 1 as usual is filled the detail. I have already copied and pasted. At step 2 we are going to use the same kind of data set, and step 3, this is partially completed as I am going to leverage the code which we have generated in our earlier session. But here we need to do some other processing which is required for tree map. So let's do it. So what those steps are, so if you closely look into this, then you will find that we are having some levels written on each of the boxes. So I need to generate this level, so let's do it. So to generate this we need to create a variable called level, so that we can use it further in our step 4. And over here we need to specify df underscore processed, and over here we need to use the apply method, so that we can iterate each of the class variable value and do the required processing. So over here I need to create a lambda function. If you are following along with me, make sure that you are writing the same syntax. Now let's proceed further. And over here I need to create another variable that is called sizes, and over here I need to specify df underscore process, and over here we need to specify the counts dot values dot to list. Next I need to generate colors, and we will generate this color code, whatever the color code we have used over here, these color code we will generate. So let's look into that. So over here first I will specify colors equal to, and over here I am going to use the list comprehension. So use the square bracket, and within that I am going to tell that for I in range, and here I am going to calculate the length of the levels which we are having, that is going to be the unique levels. Once we get that and those number of color code I need to generate. So for that I am going to use plot.cm.spectral. This you have already aware about that. With the help of this method we are going to generate some unique color combination, and over here I am going to generate the color code with the help of this formula, and over here I will specify len and again levels. So with the help of this code we will get different unique color for each of the levels. Now we have done the preparation of the data. Now let's proceed further and let's do the step 4 draw plot. So select this cell, press B, and over here now the first step I am going to create a figure as usual. So I will tell that figure, and over here I will specify the figure size, and I am going to keep the figure size 12, for height I am going to change it to 8. So 12, 8 the figure size I will keep, and over here DPI I am going to keep it 80. Once it is being done, then I will plot, then I will use the squarify. So to use the squarify we need to import it. So I need to tell that import. Over here we need to specify squarify, which we have installed at the very beginning. Now I will use that. So over here I will mention squarify dot plot, and I will tell that size is equal to the sizes which we have generated at step 3. Next I need to specify the level, and over here the levels which we have generated at step 3. Next we need to specify the color. So here also these are the colors which we have generated in step 3. We need to mention that, and last parameter we need to specify is alpha equal to 0.8. So we have done with the step 4, that is draw plot. Now the last step we need to decorate it. So we need to specify plot dot title, and over here we need to specify tree map of vehicle class, and last we should tell that I don't want to show the axis. So for that I need to specify plot dot axis off, and at last we need to tell that plot dot show. Now we are done with step 5. Cut this one and paste it over here so that we will execute it together. So now let's go to the step 1. Select this cell, do shift enter. Once it is being executed, go to the step 2, do shift enter, it gets executed. And step 3, now go to the step 3, select this cell, do shift enter. We have a typo over here, so make sure that you are removing that. Do shift enter. Now we need to execute the step 4. So let's run it, shift enter, then we will find that we've got the same plot which we have seen in the diagram. So this is the same plot, and this plot is helping us to identify the composition within the given data set. And this is what I wanted to demonstrate you in this session. In the next session, we are going to learn about another type of plot that is called bar chart, that is also used to visualize the composition within the given data set. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another type of composition plot, that is bar chart. So guys, as I already mentioned that bar chart is a classical way of to visualize the items based on counts. So let's look into the diagram, how it look like, and then we will plot the same chart in our Jupyter Notebook. So this is the diagram of the bar chart, and if you closely look into this chart, then you will find that it is representing the composition of the manufacturer and its count within the given data set. So now let's jump into the Jupyter Notebook and we will plot the same chart. So we are into the Jupyter Notebook and the steps is going to be the same. The first step is the same one. So I have leveraged the code, and over here the step 2 is also going to be the same. So let's prepare our data to draw the plot, and over here this time I am going to use manufacturer variable to generate the plot, as we need to count the number of cases or say number of rows within the given data set by manufacturer. So let me show you first. So let's run this one and then we will run this one so that I can show you. We have a manufacturer variable over here and I am going to count the number of cases. So now let's write it over here. So we need to specify that df underscore processed, and here I am going to group by on the basis of manufacturer. So I need to specify manufacturer, and over here I need to tell that size, and here I will tell that reset underscore index, and over here I'm going to tell that name equal to count. So count is our index. So once it is being done, I need to create a variable called n. So here I need to identify the unique manufacturer. So I will tell that df underscore processed, and within the square bracket I need to specify manufacturer. So I will tell manufacturer over here, and then here I will call the method called unique. So it will return me the unique record, and over here I need to check the length also. So I will tell there is a inbuilt method. So for that I need to use underscore underscore length, again the same underscore underscore, and here +1. So it will give me the total number of unique manufacturer, and that is being stored within this n. Next we need to generate the colors for different bars. If you look into this diagram, then you will find that we have different color for each of the bars. So how we can do that? Let's look into that. First we will generate the color for each of the bar. So to generate the color, I am going to create a variable over here, all colors, and over here I need to specify list, so that the process data will be stored as list. So here I am going to use plot cm for color map, and over here I will specify colors, and I will specify c names over here, and then I will tell keys. Once it is being done, then I am going to use, there is something called random.seed, so that it will keep the same color combination, and I am going to use over here c equal to random dot choice, and over here I will specify all underscore colors. So this is the list which we have generated in our earlier step, and here I will mention k equal to n. So these two steps is for generating the same color code whenever we execute it. So that's the reason we are seeding with the number 100. If you don't understand this thing, don't worry. Once you do the 2-3 project of data science, then you will get the significance of random.seed. But for a time being, you just consider that on the basis of this seed, I am able to generate the same number whenever I will execute the program. Else we will get the different values, and it will give us different color code in each execution. So let me write it first. At the end of the execution of the code, I will show you the example. Now I have prepared the data. Let's proceed further. At step 4, press B, and over here I am going to draw the plot. So the first step is to get the figure. So I am going to specify the figure, so it will create the figure for us, and I am going to specify the figure size, and here I am going to use 16,10, 16 for width and 10 for height, and over here I need to specify DPI is 80. Once it is being done, the next thing I am going to draw the plot, and this time I am going to use plot.bar. So this is the matplotlib method, and here I need to specify the x-axis and the y-axis value. So I am going to tell that I want df underscore processed, and over here I will specify the manufacturer at x-axis, and at y-axis I am going to specify counts. So I will tell that counts over here. Next thing, I need to specify the color of the bar. So I will specify C, which we have generated over here, and the bar width I am going to keep it 0.5. Now with this line of the code, we are able to generate the bar. But if you look into our diagram, then you will find that each of the bar contains the count number. So let's write the code to generate this number and put the number on each bar. So let's write the code. So what we want the count number. So we need to specify that for I comma val, and I want to enumerate the counts value. So I need to specify df underscore processed, and over here I need to specify counts, and I need to extract the values. So I will tell that values over here. Now, so this is the loop we need to execute. Once we access the value, now we will plot the text. So we will tell that plot text, and over here we need to specify I comma val, and then we need to specify float, so that we can convert the val as a float. Then we need to also specify the horizontal alignment. So we need to tell that horizontal alignment over here equal to center, and we need to also specify the vertical alignment, that is going to be the bottom one, so it should be bottom. Next we need to specify the font dictionary, so that we can specify the weight of the font as well as the size. So how we can specify that, you already aware about this thing. So there is a parameter called font dict, and over here we need to specify the dictionary, and over here you need to specify the key font weight that you want to override. So here you need to specify that 500, and next you need to specify the size. So specify that. So here we will tell size colon, I want to keep it small, and the small is the constant which you already aware that, which is holding the value 12. So now we have done with the plotting. Let's proceed further and decorate it. So first thing I want to specify the x-tick level. So let's look into the diagram. So if you closely look into the diagram, then you will find that all the manufacturer name coming at the x-axis, and if you closely observe that, then you will find that it is little bit tilt. So how we can achieve this? Let's look into that. So as I already mentioned that to do such kind of a manipulation, we need to access the get current axis GCA, and over here we need to specify set underscore x tick levels, and within that what we want to print, I want the manufacturer name. So I need to tell that df underscore processed, and here I need to specify manufacturer. I want to print it over there, and I want it should be little tilts. For that we have a parameter called rotation, and I'm going to tell that 60 degree, and then I need to specify the alignment, that is going to be the right. So I will tell that horizontal alignment equal to right. So that's it. Now next we need to specify the title of the plot. So I'm going to specify plot dot title, and here I'm going to specify number of vehicles by manufacturers, and the font size I'm going to keep it large, font size equal to large. Another thing you have observed in the diagram, we are having y level as well as y limit is having from 0 to 45. So let's do it. How we can do that? Let's look into that. So to specify the y level, you already aware that that is called plot dot y level, and over here we need to specify what level we want to specify, number of vehicles. Next I want the y limit. So let's specify the y limit. How we can specify? There is a method called plot dot y lim, and here we will specify the range from 0 to 45. Once it is being done, the last step we will tell that plot dot show. So that's it. So let's cut it from this place and put it at step 4 so that we will execute it together. Now we are done. Now let's execute the step 3 first. Shift enter. Make sure that you are importing the random library. We forgot to import it, so we need to specify import random. Shift enter. Again run this one. Now try to execute this one. Shift enter. So it executed successfully. Now let's execute the step 4. Shift enter. We have a typo error. It's a manufacturer. Shift enter. We have a small mistake over here. We need to specify df underscore processed. Now do shift enter. Sorry for that, guys. Now you will find that we will get the same plot which we have seen in the diagram. So this is the same diagram which we have seen. So now if you remember that I have discussed about this random seed. Now let's remove this one and let's try to execute it. When you execute it, then you will observe that this color combination is not going to remain. It should be changed. So let's look into that. So over here I'm going to comment this line and I'm going to execute it again. Shift enter. Again run this one. Now you will see that the color combination is being changed, and every time whenever you execute this one, you will find that the color combination is changed. Run it again, run the same, run the step 4 again, and this time also you find that the color combination is being changed. So that's the reason in the data science it is always good practice to seed your random data so that your system will aware that which number should generate next time if we are seeding that data. Over here I have specified that I'm going to use number 100 for seed. So whatever the number which you are going to generate the same number in the next execution. So here I am going to uncomment this one and I am going to run it again. Shift enter and run this one again. Then you will find that we will get our color code back, and if you look into our diagram, then you will find the same kind of a color combination. So let's look into that. So over here you will find that the first color is blue one, you should remember, and the last color is the brown one. Prior to that we are having gray. So let's look into that. So over here we are having the same combination, and that we are achieving through this random dot seed. So it is very important whenever you want to replicate the same kind of a choice value or same kind of a random data, then we need to specify this seed. And this is what I wanted to demonstrate you in this session. Now in the next session we will discuss about another type of plot that is basically used to represent the or visualize the change. So in that aspect we are going to look into two types of plot. One is the time series plot, another one is the time series decomposition plot. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into another type of plot which belongs to the change plot. The purpose of the change plot is used to visualize the data which is based on date and time. So in this category we are going to discuss about time series plot. Time series plot is used to visualize how a given matrix changes over time. So let's jump into the diagram and where we will look into how this plot look like, and then we will design the same plot in the Jupyter Notebook. So we are into the diagram, and this is the diagram of time series plot, and in this session we are going to draw the same plot, and the data set which we are going to use is called air passenger traffic dataset. So guys, the air passenger dataset provides monthly total of US airline passengers who traveled in between 1949 to 1960. So on the basis of this data, we want to draw a time series plot that will give us information about the trend of air passenger travel. So with the help of this plot, we can easily identify that the trend is in upward trend. So this is about the data set which we are going to use to make you understand about the time series plot. So now let's proceed further and let's go to the Jupyter Notebook and we will look into the steps to design this plot. So we are into the Jupyter Notebook and the steps which require to draw the time series plot is same. That means we are going to follow the same 5 steps. And over here, this time we are not having any preparation of data in this particular plot, or more specifically, we are not having any preparation of the data for this particular example, which I am going to show you. Apart from that, every step we must have to design. So step 1, as usual, global setting. Step 2, import the data set. Step 3, we are not going to do any kind of a preparation. Step 4, we are going to draw the plot, the time series plot with the help of plot method of matplotlib, and at last we will decorate our plot. So let's start designing it. So over here I have already completed the step 1. That means we have already done the configuration which is required for global setting. Next, let's talk about the data set. So where do you will get the data set? So to access the data set, you have to visit the repository of this particular course. So guys, this is the GitHub repository for this course. So once you are into the GitHub, then you need to click on this data folder, and over here you will find the airpassenger.csv. So you need to click on this. Once you click on that, then you will find the data in tabular format. But to get the data, you need to click on raw and then you will get this link. So you need to copy this link. Once you copy the link, then you have to go to the Jupyter Notebook and put it into the step 2. So let's do it. So over here, you need to select this cell, press B, and then you need to create the data frame and you need to tell that df equal to pd.read_csv. This you already aware about. Paste your URL. So we will get the data. Now next we need to write df. Now let's execute it. So we will execute both the steps and then we will look into the data. Select the step 1 and do shift enter. Once it is being done, select the step 2, do shift enter. So you will see that we have 144 rows and 2 columns. So now let's proceed to the next step. Next step, we are having prepared data. For this particular example, we don't have any preparation for the data. So let's move to the step 4. Select this cell, press B, and over here I am going to start writing the code to draw the plot. So first step, as usual in this, we need to create a figure. For that I need to write plot.figure, and over here I need to specify the size. This you already aware about, so you can write like 16,10, and then you need to specify the DPI equal to 80. Now the next step, let's draw the plot, and to draw the time series I am going to use the plot. So this method will help us to draw the time series data, and over here we are having a date column and I am going to use that date column. So I will specify over here date. We have another column that is called value over here, so we will specify the value. So let me specify that. So I will tell value. Next I need to specify the data source. For that I am going to specify the data frame which we have created, and then we need to specify the color. Over here I am going to specify tab red. Once it is being done, we are done with the step 4. Now let's proceed further and do the step 5. Select this cell, press B so that it will give us the new cell. So over here, if you closely look into the diagram, then you will find that we have some limit information on y limit. So we need to specify that. Along with that, we are having also x-tick levels. So let's create it. So over here, I will tell that plot ylim 50, 750. This is the range we need to specify. Next, we need to specify x-tick underscore location. This is the variable we need to create. And over here, we need to specify data frame df index.toList. And over here, we need to specify 12. So over here, we have mentioned 12. That means that we want to observe the yearly data, and we want to identify the trend between 1949 to 1969, and the data is given in a monthly basis. So with the help of this slicing syntax, we are able to grab the information for each year, as we are having 12 months in a year. So with the help of this syntax, you are telling that skip the record till 12th record and then pick the value and convert it as a to list. So this is what it is doing that. Now let's create the xtick level. So how we can do that? We need to specify xtick underscore levels, and over here we need to specify this syntax x. Within that we need to tell that -4 colon, and this is a list comprehension, and over here we need to specify for x in df dot date dot to list, and here we need to specify 12. So this way we can create the xtick levels. Now let's print that. So over here we need to specify plot dot xticks, and tick is going to be the xtick location which we have created. Make sure that it is ticks. So over here we need to tell that xtick underscore location, and levels we are going to specify the level which we have created in the above line. So we need to tell xtick underscore levels, and rotation I don't want any rotation, then I will tell that 0. Font size I am going to keep it small. You know that why it is, because we have created a constant at the top. If you will see it over here, we are having the small as a constant. So now the next parameter we need to specify the alignment. So horizontal alignment we need to specify horizontal alignment equal to center. Next we need to specify alpha equal to 0.7. So that's it for this. Now let's proceed further and now create for ytick. So we will tell that plot dot yticks. First parameter we will specify the font size. This is also going to be a small, and alpha equal to 0.7. That's it. Now next we need to specify the title. So we need to tell that plot dot title, and here we need to specify air passenger traffic formation. We can tell that 1949 to 1969, and then we need to specify font size. We want it should be large, that is 22. And next we need to specify the grid. Plot dot grid equal to axis equal to both. We want it should print both axes, x and y, and alpha we want to keep it 0.3. Now let's grab this code and run it. So over here, cut it, paste it over here. Now do the shift enter. We have a typo over here, shift enter, and you will find that we got the plot, but we are having some typo also. So let's fix that. Font size, not font size. Now do shift enter. Sorry guys. So over here you will get the same kind of a plot which we have seen in the diagram. So with the help of this particular plot, time series plot, we can easily identify the change information within the given data. And this plot is very useful whenever we are doing the time series analysis, whenever we are working with any financial data, whenever we are working with the stock data. We want to identify the trend within a given stock, then we will use this data visualization plot, more specifically time series plot, to identify the changes within the stock price. So this plot is very useful whenever we are having the data that is frequency based and we want to identify the trend within the given data set. And this is what I wanted to demonstrate to you in this session. In the next session we are going to look into time series decomposition plot. That is going to be very useful as it gives more information compared to the time series plot. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into time series decomposition plot. So let's jump into the diagram and we will look into how this plot will look like and what kind of information this plot will give, and then we will design this plot in our Jupyter Notebook. So this is the diagram of time series decomposition of air passengers, and it is based on the same data set which we have used in our previous session. If you closely look into this plot, then you will find that it is giving us various information like the observed. So the first plot, which is referred as observed, which is actually giving us the time series information which is based upon the date. Now if you will look into the second plot, you will find that it is representing the trend. Where is the trend? So it is in upward direction. Now coming to the third plot, that is representing the seasonality. So whenever we are working with any kind of a time series data, then we have to also check the seasonality within the given data set. So with this plot you are able to identify that whether our time series data also contains seasonality or not. To talk about this example, then you will find that our data contains the seasonality. That's the reason sometimes you will find it uptrend and then you will find downtrend, and this is the pattern it is following. And whenever we are having such kind of a pattern, that means it is representing the seasonality within the given time series data set. Don't worry if you are not understanding any of this. I am planning to create a course on time series data analysis, because time series data analysis is different than normal data analysis. For this particular course, you just focus upon the core concept of the data analysis as well as data visualization along with the tools which is being used for data analysis. Once you are comfortable with all these things, then you are easily able to do the time series data analysis. Anyway, this is about the future plan. Now let's proceed further. There is another plot which is representing the residual. So what do you mean by residual? In a more generic term, residual is nothing but a difference. Suppose that if you are having the change within the data set, then how much that change is from one year to another year. So that change is being represented with the residual plot, and this is what it is representing over here. So this contains the change information by which you come to know that how much changes happened whenever we move from one year to another year, and that difference is represented on this plot, and that is called residual plot. And overall this plot is called decomposition plot. That is one of the powerful tool to do the data analysis for time series. So now we will jump into the Jupyter Notebook and we will look into how we can generate this plot. So to generate this plot, we are going to follow the same steps, but this time we need to include a library that will help us to generate the seasonal decomposition plot, or say decomposition plot. So let's import that library. So the library name is stats model. We need to tell that from statsmodel.tsa.seasonal, import seasonal underscore decompose. So this is the library and this is the module. From this library I am importing the seasonal underscore decompose module. So once it is being done, let's run it. Now at step 2, as usual, we need to import the data. So let's run the step as well. At step 3, we have some preparation step. So let's look into that. Dates equal to pd dot date time index, and over here we need to specify something like this. It is going to be list comprehension, and we need to specify parse d dot strf time, and the format we need to specify over here %y minus %m minus 01. So this is the date format we want, and over here we need to specify for date in data frame date. So this line of code which we need to specify to get the dates in a specific format. So once it is being done, then we need to specify data frame dot set underscore index, and over here we need to tell that dates in place equal to true. So here we have created the index and we told that this dates is going to be the index for this data frame. So now if you will see it over here, we don't have any index. So now let's run it. Select this cell, press B, and over here you should specify df shift enter. Then you will find that with the help of the previous step, with these two lines, we are able to create the index which is a date. Now after creating the new index, let's proceed further and let's generate the seasonal decomposition plot. So how we can do that? We need to select the step 4, press B, and over here we need to specify result equal to seasonal underscore decompose, and over here we need to specify the value data frame, and the value, this is the value I am talking about. We need to specify this field name. Once it is being done, we need to tell that I want model equal to multiplicative. So we need to specify over here multiplicative. Now after creating the seasonal decompose, we need to override the figure size. So how we can do that? So over here we need to specify plot.rc_params.update, and over here we need to specify the which key I want to update. So I will tell that figure.figure size key I want to update, and over here I need to specify the value. I want to keep it 10,10. Next we will plot it. So after getting the result, we need to plot it. We will tell that result dot plot, and over here we need to specify that subtitle, and here we need to tell that time series decomposition of air passengers. Once it is being done, we will tell that plot dot show. In this particular example, we are not having anything for step 5. So let's execute it and let's look into the plot, how it will look like. Do shift enter, and then you will find that we got the plot how we saw in the diagram. So here we got the observed, which we have already discussed. We also get to know about the trend, so it is in uptrend. We got the seasonality information, and at last we got the residual information. So with the help of this stats model library, we are able to get the seasonal decomposition chart very easily, and that is one of the powerful tool to visualize the time series data. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session onwards, we are going to discuss about exploratory data analysis workflow. So far whatever we have learned because we wanted to understand the exploratory data analysis. So in that aspect, we have already covered many of the things in this course. We have started from the Python refresher, then we have seen NumPy, then we have discussed about the pandas core concept, then we have done the data visualization. We have also discussed about the data analysis core concept, where we have understand that mean, median, mode, z-score. Then we have looked into various type of plot that is specific to the particular task which we have seen. So those are the prerequisite to understand this workflow. So whatever the term which we will use in this session, so you must be very much comfortable by listening those terms. I am going to introduce what are the steps required to do the exploratory data analysis for a problem domain. So let's jump into the Jupyter Notebook, and where we will look into how this part of the course is being segregated and what are the things which we are going to cover in this particular part of the course. So guys, we are into the Jupyter Notebook, and this part of the course is segregated like this way. So first we will understand that what actually the big picture is. So I want to give you 10,000 feet overview where you will understand that where this particular exploratory data analysis falls into when we are talking about analytics complexity. Once we understand the big picture, then we will proceed further and discuss about what actually the exploratory data analysis is and why it is important. Once we understand that, then we will proceed further and we will discuss about value of exploratory data analysis. Once we understand that, then we will proceed further and then we will discuss about the data exploration and preparation steps. So what it means, in this session we are going to discuss about all the required steps to do the data exploration as well as preparation of the data for the next step. So basically we are having 7 steps that is pretty much required while doing the exploratory data analysis. So it will be a start with step 1, variable identification, where we will understand that how we can identify the categorical variable, how we can identify the continuous variable, what is predictor variable, what is target variable. More specifically, we will discuss about types of variable, data type of that particular variable, and at last we will discuss about the variable category in the variable identification process. Once we understand that, then we will proceed further and we will discuss about what actually the univariate analysis is, how we can do the analysis for continuous variable, how we can do the analysis for categorical variable. So all these concepts we are going to learn in step 2, that is univariate analysis. Once we understand that, then we will proceed further. At step 3, we will look into how to do bivariate analysis and what are the tools and what are the plots available, which we have already seen some of the plot which we are going to look into in more detailed manner. At step 4, we are going to discuss about missing values treatment, which we have already seen in our pandas session, but I want to reiterate the same point over here, but more specific to the problem domain. After handling the missing value, then we will proceed further and we will do the analysis on outlier detection and their treatment. So in this aspect, we will learn about what actually the outliers is, how we can identify the outlier is, and how we can take care of outliers while doing the data analysis as well as within the data preparation steps. Once we understand that, then we will proceed further and we will discuss about the variable transformation. So in this topic, we are going to learn about various techniques to transform our variable so that we can provide more valuable data to our model. Once we understand that, then we will proceed to the step 7, where we will discuss about various techniques to create the variable that will help us to do a better predictive analysis, because at the end of the process, all these variable is going to be used by predictive analysis. So guys, this part of the course is going to be very interesting. On this note, I am stopping over here. See you in the next session. Then we will start our discussion with the let's understand the big picture of data analysis. So till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to discuss about the big picture of the data analysis. So let's jump into the diagram and where we will discuss about the big picture. So guys, this is the picture of the analytics complexity, and if you closely observe this diagram, then you will find that the data analysis falls at the second stage in this analytics complexity. So what it means? So it means that irrespective of any domain, if you are working upon, we will get the information in the form of reporting, and on the basis of that report, we will proceed further and take the report data and start analyzing it. So what actually we analyze, we will discuss about that. But first we have to understand that why actually we do the analysis. So to answer your question, I would tell that we do analysis because we want to know the current state of the particular problem domain. For example, if you are working for a client and the client is a construction company and who is looking for better sales price in their upcoming project. So for that, they have given some information regarding the house price of existing project along with the information like how many number of bedrooms are there, in which area the houses belongs to, what is the size of the houses in a square feet. So all these information which client is shared with you. Now on the basis of these information, you want to analyze the current state of the problem, and to know the current state, we apply the data analysis techniques. And what are those techniques? Those techniques are descriptive statistic, which will be very helpful to describe and summarize the data. And with the help of these maths, you can easily identify that what happened. You also understand that why did it happen, and more importantly, you will come to know that what is happening now. In our housing price example, we will apply the same kind of descriptive statistic, and we will come to know that which variable is affecting the price, and then we will pick that variable for further processing, and that variable is used within the predictive analytics. So as you see it over here, once we have done the analysis in the further stages of the analytic complexity, we are having these number of layers. So over here, monitoring, forecasting, predictive and perspective is out of scope for this particular session or this particular course. But you can understand that after analyzing our data, we need to prepare it, and once we prepare the data, that data is being used for further processing, and that will be used within the predictive analysis. And predictive analysis I am going to cover in next course, where we will discuss about the predictive analysis in more detail, where we will discuss about what actually the predictive analytics is, how machine learning algorithm is fitting into the predictive analytics is, what actually the mathematics and the statistic which we will use, where we will learn about different technique or say different algorithm for machine learning, which will be helping us to design the predictive model that will help us to predict the future state of our domain. If you talk about our example, housing price, then in that case, we will look into regression technique for forecasting the housing price. There are various algorithms available within the machine learning for a structured data like regression technique, nearest neighbor, random forest. So all these are different type of algorithm that is used for various purpose, that is majorly categorized into two tasks. One is the regression task, another one is the classification task. So all these topics are part of the predictive analytics, which I will create after this course, after seeing the response, how the response is coming for my this particular course, learn data analysis from scratch. If people are liking it, if I am getting more response, then I will create the predictive analytics course. So on this note, I am stopping over here. See you in the next session. In the next session, we are going to discuss about what is exploratory data analysis is and why it is important to do the exploratory data analysis. So on this note, I am stopping over here. See you in the next session. Till then, bye bye. Take care. Hello guys, welcome back. Now in this session we are going to discuss about what actually the exploratory data analysis is, as well as we will also look into value of exploratory data analysis. So let's jump into a diagram where we will discuss about what is exploratory data analysis is and the value of the exploratory data analysis. So guys, this is where we have stopped our earlier session where we have discussed about the predictive analytics, and predictive analytics is entirely depends upon the data from the existing system. But the challenge with the predictive analytics is
that it entirely depends upon the data, what input we are providing, and on the basis of that input, it will forecast the information for the problem domain. So here the question comes, how do we ensure that we are ready with the correct input? And the next question is, how do we ensure that which variable is the right variable for the predictive model? So how do we ensure that? So to answer your question, here our topic of discussion comes, that is exploratory data analysis. Exploratory data analysis is the answer for all the questions which we are having for data modeling. It helps us to answer all these questions, ensuring the best outcomes for the project. Exploratory data analysis is an approach for summarizing, visualizing, and help us to identify the important characteristics of a data set. As we have already seen in our previous part where we have learnt about data visualization tools. So in that part of the course, we have learnt about what are those plots are, how many different types of plots we are having, and each plot is having different purposes. So guys, all those plots which we have learned is the tool to perform the exploratory data analysis. In the upcoming session, we will look into all the steps which we generally perform when we are doing the exploratory data analysis. More specifically, I am talking about these steps which we are going to look into in the upcoming session, where we will discuss about all these 7 steps which is must for the exploratory data analysis steps. So now let's proceed further and let's look into another diagram which will give us more information about the exploratory data analysis. So guys, when we perform the exploratory data analysis, we generally perform it for identifying the knowledge. But to get this knowledge, but to reach to this knowledge, we have to go through various steps. And the process starts with the getting the data. And once we get the data, then we have to do the problem specification with the help of that data. And you will see that this is an iterative process in each of the stages. That is an iterative process. That means once you do that, it doesn't mean that you will get the result in a very first instance. You have to perform various iteration in each of the steps while working on the project. So guys, this is the diagram of the data science project where we will follow these steps, but within these steps, the 3 steps is the part of the exploratory data analysis and remaining 3 is the part of the predictive analytics. More specifically, I would tell that. So these 3 steps, if you talk about this one, these 3 steps is the part of the exploratory data analysis and these 3 steps is the part of the predictive analytics that we are going to cover in the next course. Currently our focus is to get the data, process the data, and we will do all the processing to identify the right variable that will help us to do the predictive modeling. So guys, now with the help of these discussion, I am hoping that you must have understand that what is the value of exploratory data analysis. So guys, with the help of our discussion, we come to know that exploratory data analysis is valuable to the data science project since it allows to get closer to the certainty that the future result will be valid. So that means if we analyze our data correctly, then we can get the correct set of input that will be used by our predictive model, and that predictive model help us to get the accurate forecast for our future state of the domain. So guys, on this note, I am stopping over here. In the next session onwards, we are going to discuss about all the steps which we generally perform while doing the data analysis. More specifically, we are going to discuss about all these 7 steps. So guys, see you in the next session. Till then, bye bye, take care.
Hello guys, welcome back. Now in this session onwards, we are going to discuss about data exploration as well as the preparation of the variable for the predictive analytics. But our more focus would be the data exploration. So in that aspect, we will be starting with the step 1, that is variable identification. So variable identification is the first step while doing the data exploration. So basically we perform 2 types of tasks. The first task, we need to identify that types of variable, whether the variable belongs to predictor variable or whether it is a target variable. This is the first task. Second task is whether our variable is a numerical variable or a categorical variable, or you can say whether our variable is a continuous variable or it is a categorical variable. I hope you already aware about continuous variable and categorical variable as I have discussed in one of my session. If you haven't gone through that session, I would request you can visit that session and finish it, then you come back to this session. Anyway, now the next question is, how we can identify that whether the variable belongs to the predictor variable or whether it is a target variable. So to answer your question, we can identify the predictor variable and target variable based upon the problem definition, and problem definition is given by the client. For example, if you are talking about the house price problem, then the requirement was, with the help of some variables, we need to identify the sales price for a house. So here the sales price is the target variable, and the variable which help us to identify the sales price, those variables are predictor variables. So let's understand through the code. So let's write the code for the same, then you will have better understanding. So let's jump into the another notebook, and over here we will write the code. So the first step, as usual, we need to import some of the library. So in that aspect, I am going to import our favorite library pandas as pd, another one is the numpy as np, another one is the matplotlib.pyplot and it is called as plt. Another one of the interesting library is the cbon, that is another data visualization library, so we will call it cbon as sns. Now we are done with the library import shift into. Now the next step, we need to import the data set. So how we can do that? We will tell that df equal to pd dot read underscore csv, and here I am going to grab the link for my data set, and you will also grab the link and you will grab it from my GitHub location, GitHub repository for this particular course. So once you access this link, then you will find that learn data analysis from scratch repository, and over here we are having the data folder, and within that we are having the house price, and we need to access train.csv. You need to click on this and then it will take you inside, and over here you need to click on raw. Once you click on raw, then you will get the link. You should copy the link and go back to your Jupyter Notebook, and over here you should paste the link, and now next you need to run it. But prior to that, you write df shift enter, then you will find that you will get the data set that is for housing price, and with the help of this CSV file you have created the data frame. Now let's discuss about how do we come to know that which variable is the predictor variable and which variable is the target variable. So as I already mentioned that this is the data set for house price, that is one of the Kaggle competition, and if you look into that, then it is mentioned over there you have to design the model which will helps client to identify the price of the houses which they are constructing. So guys, this is the Kaggle site and this is the competition which I am talking about. So this is about house price advanced regression technique. So over here it is already mentioned that predict the final price of each home, and here it has already mentioned that it has given 79 explanatory variable, and these 79 explanatory variable is nothing but the predictor variable. So here the problem statement itself telling that which one is the target variable and which one is your predictor variable. As it is a competition, so it has mentioned that, but in a real world scenario we have to decide upon according to the problem, because client will come to you with a problem and what thing he want to improve he will tell in a statement or in a requirement document. So considering that we have already gone through their requirement and we understand that, and we have decided upon what we want to achieve. For this case, we want to predict the final price of each home on the basis of 79 predictor variables. So this is about the problem as well as the data set. Now let's proceed further and let's write the code to get all the column names. So let's jump into the Jupyter Notebook. So over here it has given all the information but in a truncated manner, but I want to get the column name. So how I can get it? I will tell that df dot columns shift enter, then it will give us all the columns name in an array. If you want to convert it into list, you need to tell that columns dot to list shift enter, then it will give you the information in a list. So here if you notice that it is telling that 81 columns. Why it is telling 81 columns? Because here it is also having the id and the target variable is sales price. So remaining we are having 79 predictor variable. So on the basis of these predictor variable, we need to identify the sales price. So that is what the problem statement is saying. So over here, it is saying the same thing with 79 explanatory variables describing every aspect of residential home in Ames, Loa, and with the help of these 79 explanatory variable, we need to predict the final price. So now we come to know that for this particular problem, what is the predictor and what is the target variable. So this now we identify those. Now next we need to identify the data types of the variable. So how we can do that? So let's write the code for this. How we can identify which of the variable is numerical variable and which of the variable is the categorical variable. So for that, let's write the code. So let's do it. Let's jump into the Jupyter Notebook. And over here, we are going to write the code to identify the data type. So over here, I'm going to tell that data underscore dict. This is the variable, and I'm going to create a data frame so that we will hold these information. I will tell that pd.data frame, and over here, I will specify df.dtype, and then we will run it collectively. Now let's do shift enter, and you will find that we get the information about each of the variable information, which types it belongs to. Wherever you are finding int64, that means it belongs to the numerical category, and wherever you are seeing object, so that means it belongs to the categorical variable. So now with the help of this code, we are able to get the information about the data types of the variable. So now we are done with the step 1. That is, we have identified predictor variables, target variable, and we also come to know that what actually the data type of each variable. So guys, we got the information about that, which column belongs to the which data type, or say which variable belongs to the which data type. Now the next step, what I am going to do, I am going to bifurcate the categorical column separately and numerical column separately, so that we will come to know that how many numerical column we are having and how many categorical column we are having. So let's do it. So the thing which we needed first, we need to specify categorical column, and over here I need to select those column which is of categorical type. So how I would select that? So I need to specify data frame df, which we have created, and here we need to specify a method that is called select underscore dtypes, and within that we need to specify a parameter, and here we need to tell that include. So I will specify I want to select all the object types, so I will specify over here object. Next step, I want to select the numerical column. With this line I am able to select only the categorical column. So let's run this so that you will come to know that it is selecting only the categorical column. So here I will tell that columns. Shift enter. Then you will find that it has returned us only the categorical column which is of type object. Now the next step, let's create the numerical column. So I'm going to copy this line and I will create it over here, and instead of categorical column, here I will tell that numerical column, and this time I'm going to specify the array over here, because we are having two type of information. One is the integer, another one is the float. So both are the numerical column. So we need to specify over here int64 is also considered as numerical value, and float is also considered as numerical value. Once it is being done, let's copy it, Control C, and over here we will specify that dot columns, and now let's run it. Let me print it so that it would be easy for us. Print, and over here we can also print this one, print, and now run it. Then you will find that we have bifurcated categorical column over here and numerical column over here. Now if you want to get the count of categorical column as well as the numerical column, how you will do that? So let's do it. I am going to create a variable total count categorical column equal to, and here I will use len, and I will specify categorical columns, copy this line, and over here I will also use the copy paste operation. So I will tell, and over here I will specify numerical underscore column. So it will return me the count of those number of columns, and over here I will specify print categorical column, and here we will tell that categorical total count, and for numerical column I am going to specify over here numerical column. So this will give me the count of how many number of numerical column we are having. Shift enter, and you will find that we are having categorical column 43 and numerical column we are having 38, and with the help of this code we are able to identify that which of the variable belongs to categorical column and which of the variable belongs to the numerical column. And over here we have completed the first step, that is variable identification, and this is what I wanted to demonstrate you in this session. In the next session we are going to look into univariate analysis. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into step 2, that is univariate analysis. So in this aspect we are going to analyze our target variable as well as the predictor variable. Within the univariate analysis we are going to analyze various things based upon their type. If it is a continuous variable, then we are going to analyze that how our data is distributed, or say how our variable is distributed, whether it is positive skewed, whether it is negative skewed. We will also analyze the kurtosis for our variable, and then we can identify that whether it belongs to mesokurtic, lepotokurtic, platykurtic. If you don't know about these concepts, then I will request you to please visit part 2 of this course, where I have explained in the descriptive statistics session all these concepts. Anyway, so let's proceed further, and we will start the univariate analysis with the target variable. So first we will analyze our target variable, that is sales price, and see all the required statistics of the target variable, that is sales price. So we are into the Jupyter Notebook, and here I am going to mention that we are going to do univariate analysis. So let's start with the sales price, that is our target variable. So here I am going to specify that data frame, and over here I will mention sell price, and then I will use, there is a method called describe, which will give us the information about count of sales price, what is the maximum value, what is the minimum value. It will also give us the mean information, standard deviation information, along with the percentage distribution information. So let's run it, do shift enter, then we will find that we have total number of record, that is 1460, and we are having the minimum value is on which the house sold, that is $34,900, and the maximum price of the house is $755,000. Along with that, it is also giving us information about the mean as well as the standard deviation about the sales price. So guys, this is about the count and the range information about the target variable. So guys, let's proceed further. Next we need to analyze that whether our target variable is normally distributed or not. We will also check that whether our target variable is positively skewed or negatively skewed. Once we draw that plot, then we will discuss about the significance of each of the things which I have told you, that is significance of normally distributed data within the target variable, significance of the skewness within the target variable. So let me write the custom function to draw the plot, and then we will discuss. So this is the custom function I have written, and it is based on the same concept which I have taught you in the previous part of this course, where we have learned about data visualization. So I have written comment over here also, you can go through it. So this line, you are already aware that whenever we are going to create any kind of a plot, we first need to create the figure. So this is the line, it is creating the figure. In the second line, we are creating the grid space, that is for 3 columns and 3 rows, as we are going to create 3 plots in a single figure. Then this line, you are also aware that we are going to add the subplot so that we can draw the histogram. This is for the second figure. There is another type of plot which we are going to look into, that is QQ plot. That is very important. This QQ plot will help us to identify that whether our data is normally distributed or not. Now coming to the axis 3, in the axis 3 we are going to plot the box plot, and this is the generic function which we can use for any kind of univariate analysis for any of the variable, whether it is a target variable or whether it is a predictor variable. We can use this function for any of the variable type, but currently we are using it for the target variable, that is our sale price. So now let's proceed further, press B, and over here we will get the new cell. So this is about the function. One thing I can also wanted to let you know, that is I have also imported some of the library to do the plotting. Over here you will find that I have imported matplotlib.gridspec, which you know that it is used to specify the grid specification. And then here we are using the SciPy library, and from there we are importing the stats model. And at last here we have used the style that is called 538 to display our plot in this style. So now let's run it. So to run it, we need to go to this cell. Let's load this function into the memory, and then we will write the code to call this. So we have loaded it. Now let's call this function, copy this one, and over here I will specify data frame, comma, and here I will pass the feature name. Feature is nothing but a variable. So here I will specify the variable name, that is sale price, and I will do shift enter. and once we run it, then we will get the output. And over here it is giving us three kind of information. The first one in the form of histogram, the second one is this is the QQ plot, and the third one is the box plot. So now let's talk about what is the significance of all these three diagram, or say all these three plots. So these three plot is giving us three information. The first, our target variable sell price is not normally distributed. Second, our target variable is right skewed. And third, our target variable have multiple outliers. So guys, you must be asking that how do I come to know that our target variable is right skewed, our target variable is not normally distributed, and our target variable contains the outlier? So to answer your question, if you closely look into this plot, then you will find that here the histogram is right skewed. So that means our target variable is positively skewed. So you must be asking that what do you mean by positively skewed, and how my target variable is related to the positive skewed data, how I will read it. So to answer your first question, in positive skewness, the mean and the median will be greater than the mode, similar to the plot which we are seeing it over here. Now coming to your second question, your target variable is positive skewed means within the given data about the houses, company has sold more houses in lesser price compared to their average price. Now this is about the histogram. Now coming to the QQ plot, so this will be used to identify the normal distribution within the given data. So over here within the target variable, if it is coming on the line to the red line, then it means that our data is normally distributed, and here in within histogram the shape will be in bell curve, which I have already explained in one of my session. But within this example, if you will see that this blue line is deviating from the red line, so it means that our data is not normally distributed. Now if you talk about the significance of the normally distributed data, then I need to discuss about one of the predictive model, that is linear regression, which we generally use to solve such kind of a problem where we want to do some forecasting on the basis of the dependent variables, or say predictor variables. So this predictive modeling technique, that is linear regression, expects that the dependent variable, or say target variable, to be multivariate normally distributed data. If this criteria is not fulfilled, then linear model will not give us the correct result, and because of that we will not forecast the correct sales price for this particular example. So now the next question you must be asking that, okay, my data is target variable is not normally distributed. So how I can make this data as a normally distributed data? Then I will tell that is another part of the story, but I will cover it over here. So in that scenario, we need to transform. So let me transform it, and then we will draw the same plot. Then you will get the difference between normally distributed data and not normally distributed data. So I need to transform the target variable sell price into natural log. So how I will do that? Here I will specify df, and here I will tell sell price, and then I will tell np.log1p. This is the numpy method, and over here I will specify df sell price. So once it is being done, let me copy paste this code to draw the plot again. So over here I will specify it. Now let's run it. Now let's look into the difference, and over here you will find that with the help of this natural log, we are able to convert our target variable into a normally distributed form. And over here you will see that our QQ plot is aligned with this red line compared to the earlier plot. If you will see into the earlier plot, our data is rightly skewed, that means it is positive skewed, and our QQ plot is deviated from the red line, and this box plot contains a very large dot, that means it is representing the outliers. We are having some cases which is deviated from the normal data range, and with the help of this transformation we are able to make our data normally distributed. So guys, now I have done with the target variable univariate analysis. Now we will proceed further and we will do the predictor variable analysis. So as we already aware that we are having two types of predictor variable in this case, where we are having categorical column and the numerical column. So first we will analyze the numerical column predictor variable, then we will analyze the categorical column. So if you go by the analysis for predictor numerical column one by one, then it is very much space consuming. So we are going to look into another approach by which we can draw all the plots for each of the predictor variable, numerical variable category. So let's do it. So we are going to grab the index of the numerical column. So I will tell that numeric underscore column, and over here I will specify df.dtypes, and here I will specify the condition df.dtypes not equal to object, and then I will mention index. Once we get that, then we will tell that I want to remove the cell price. So for that I will tell numeric call, and I want to remove the cell price as it is a target variable. So here I will tell numeric underscore call dot drop, and within drop method, which thing I want to drop? I want to drop cell price. So I got all the numerical column without cell price. Next, we need to also get the index of the categorical column. So how we can do that? We need to specify categorical underscore call index, we can tell, and over here we will specify df.dtypes, and this time we need to select the object type. So df.dtypes equal to object and grab the index. So we are done with this step. Now the next step, we need to draw the plot for each of the numerical predictor variables. So how we can do that? Let's look into that. First run is shift enter. So many typo we have done. Types, here it is types. Shift enter, done. Let's proceed further, and this time I am going to use something called pd melt. So here I will create a variable f pd melt, and over here I will specify data frame, and I will tell all the features that is numerical which we have created, numeric underscore call. So I have a specified value was equal to numeric underscore call. Once it is being done, now I am going to draw the graph for each of the numeric variables, and over here I will specify g equal to sns dot faceit grid, and over here I will specify f comma, and I will tell column I want to tell it as variable call wrap. I want 3. Make sure that this is outside call underscore wrap equal to 3 comma. There is a parameter called sharex. We need to tell it false, and then we need to tell that share y equal to false, and size I am going to keep it 5. Next we need to specify g equal to z dot map, and here we need to specify the plot, that is the actual plot, test plot, and over here we need to specify the value, and at last we need to tell that plot show close it. So now let's run it and let's look into the output. Let's press shift enter. So once you execute it, then you will find that it has given us all the predictor variable information like id. Don't bother about id because it is not useful, but over here you will find that we are having ms subclass, and if you look into that, it is also right skewed. This most of the data is right skewed. You will find that some of the data is at left skewed. We are having bimodal. This is mass van area. We are having rightly skewed data, and if you closely look into that, most of the data is rightly skewed, and you know that how to transform that data into a normally distributed data. Yes, correct. We need to use the transformation. We can use the normal log transformation so that our linear model in the predictive analysis will work properly. So now I hope that you can easily read these plots with the knowledge which we have applied on the analyzing the target variable in the earlier plot. So guys, this is about the predictor variable that is of numeric type. Now let's do the univariate analysis for the categorical column, as we have already bifurcated or segregated the numerical column as well as categorical column, and we have grabbed the index. Now let's draw the plot, and the plot is going to be the almost same. We just copy this one and paste it over here, and instead of numerical column I am going to specify the categorical call index over here, control V, and instead of list plot I am going to use the count plot, as count plot is used to plot the categorical data, and all thing is going to be same. So let's run it. Shift enter, then you will find that it has given us the count plot for all the categorical variable. So this you can analyze that this is the count plot for each of the categorical variable. So guys, the count plot of the categorical data show the number of different categories for each of the variable and their frequency distribution. There are variables where the different categories occur with the similar frequency. For example, if you look into this variable LA, that is almost similar frequency it contains, and there are are categories which is very dominant to the other category. If you talk about that variable, then if you take this example MS Joining, which is very much dominant, this utilities, you will see that it is pretty much very dominant, as other one is not having any data. You can also verify this through the code. Over here you need to specify, for example, I am going to use array, and there is something called value underscore count, so it will tell us which value is having more count or which value is having less count. So that means it will give us the number of values. So shift enter, then you will find that the gravel is having 50 and pave is having 41. Copy the code. Let's check for the utilities. If you will specify over here utilities, shift enter, then you will find that it contains, all pub contains 1459, and for no saver it is 1. So all pub is more dominant. So guys, this is what I wanted to demonstrate you in this session, and this is about the univariate analysis which we have done for target variable as well as predictor variable in both the category, from the numerical data as well as the categorical data. So on this note, I am stopping over here. In the next session, we are going to discuss about bivariate analysis. So see you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session, we are going to discuss about bivariate analysis. So let's start our discussion. So guys, what is bivariate analysis is? So far we have seen that univariate analysis, where we are analyzing our data set on a single variable. But when we are talking about bivariate analysis, then we are talking about analyzing our data set on the basis of two variables. So that means we want to identify the relationship between two variables within our data set. So as you already aware that we are having two types of variable. One is the continuous variable and the categorical variable. Now when we are doing the bivariate analysis, we can perform the bivariate analysis in these three. The first, we can perform bivariate analysis on continuous versus continuous. That means our both variable is the continuous variable. Second scenario, we will perform the bivariate analysis on categorical versus categorical. So that means both variable is categorical variable. And the third one is categorical versus continuous, where one variable is a categorical variable and another variable is the continuous variable. And in this process, we are trying to identify the relationship between the predictor variable with the target variable. So why is it so? It is because we wanted to identify that how our target variable is behaving whenever a predictor variable is changing, so that we can identify the relationship between predictor variable and target variable, and that variable we can consider it for predictive modeling. In our housing price example, we are going to see all these three kind of bivariate analysis. So to perform the bivariate analysis, we have to learn about how it is being performed. So let's discuss about that. So first we will discuss that how we can perform continuous versus continuous, means how we can analyze two variables which is of continuous type, and how do we can identify the relationship between these two variable, if my predictor is also a continuous variable and if my target is also a continuous variable. And this is the same scenario we are having. So to perform the bivariate analysis, you have to use scatter plot. So we will draw the scatter plot, and with the help of a scatter plot we will come to know that which variable is having a strong relationship between the target variable. And the diagram which you are seeing it over here, that is the representation of the scatter plot, and this kind of thing you will get within the scatter plot. And what is the meaning of it? Suppose if you are getting such kind of a plot for two variables, then that means that it is a strongly positive correlation. So if you are changing x, then y is also changing, and this is what it is representing. Now suppose if you are getting such kind of a diagram, so it means that it is a moderate positive correlation. Next, suppose you are getting this kind of diagram or plot, then it means that there is no correlation exist between two variables, that is predictor variable as well as target variable. There no relationship exist. So what it means? It means that if you are doing any changes within the x, then it is not affecting the y. So what it means? If you are doing any kind of a change within the predictor variable, it is not affecting the x. So that means it is not having any correlation. So we can either drop that variable and we will not utilize that variable in our predictive model. So upper three diagram is the example of the positive correlation. Now suppose if you are having below 3 diagram in your plot, so that means it is negatively correlated and it is negatively affecting each other. If you are doing some changes in X, then Y is also affecting, but in a negative manner. One point to remember, I will tell it over here, is that a correlation should be positive or negative. So when you perform the calculation of the correlation, you will get the result either in positive value or negative value. So it means that your X and Y is related with each other. In some scenario, the relationship is in positive manner, and in some scenario it is negative manner. So that means if you are doing certain changes in X, so Y is completely behaving differently, but some changes is happening. And if you are having a strongly negative correlation, then you will get this diagram. And if you have curvilinear relationship, then you are getting such kind of a curve within the diagram. So guys, this is about the plot to identify the relationship between continuous versus continuous. But there is a formula by which you can calculate the correlation, and with the basis of this correlation formula, you are able to identify the correlation value. And within pandas, it offers us core method to identify the correlation, which we will look into when we do the lab. So guys, this is about the continuous versus continuous. There is another type of bivariate analysis that is called categorical versus categorical. So that means we want to identify the relationship between two categorical variables. So how we can do that? So to perform that, we are going to use frequency table, where we will compare the occurrence of one group versus the occurrence of another group. And to analyze this, we will be using the bar chart for categorical versus categorical bivariate data analysis. Apart from bar chart, there is certain test that is called chi-square test, that is a statistical way of performing the bivariate analysis on categorical versus categorical data. And the formula for chi-square is this one. Now this is about the categorical versus categorical. There is last category which we perform the bivariate analysis, that is categorical versus continuous. For this we are going to use box plot, and where if you look into this diagram which we have already drawn in one of our session, and here you will see that here we are identifying the different types of vehicle class and their number of observations. And if you remember this plot, this is the plot of highway mileage consumption by vehicle class. So to do the bivariate analysis between the categorical versus continuous, then we use this box plot, where you can easily identify that the relationship between the continuous variable with the categorical variable, or say categorical variable with the continuous variable. And if you want to mathematically perform the bivariate analysis on categorical variable versus the continuous variable, then you have to perform the Z test and the T test. Both tests are similar, but the difference between Z test and T test are how many number of observation or how many number of cases you are having. If you are having less than 30 cases, then you will perform T test. And the formula to perform the T test and the Z test is this one. And the best part of Python, using Python, is that we are having a stats model library that will help us to provide all this Z test and T test. So this is how you perform the bivariate analysis on categorical versus continuous data. And this is what I wanted to let you know in this session. In the next session, what we are going to do, we are going to perform all the thing what we have learned over here in a lab, and we are going to perform all this thing in the same example which we have been following from the last session, that is housing fries. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to understand bivariate analysis, but this time we are going to write the code. So let's start writing the code for bivariate analysis, where we are going to analyze continuous versus continuous variable, where I will select all the numerical value, or say continuous value, which belongs to the predictor type, and then we will compare with the target variable, that is a continuous variable as well. And to do this analysis, we are going to plot the scatter plot, and with the help of a scatter plot we will identify what kind of relationship exists between each of the variable with the target variable. So let's go to the lab Jupyter Notebook. So over here we are going to start writing the code, as we have already seen that univariate analysis, and where we have generated this plot, we are going to plot in the same manner how we have drawn this, where each of the variable is being plotted in a single figure. So for this analysis I am going to perform the same thing, but for that I am going to create a function over here. So for creating a function I am going to write def, and here this function will draw the reg plot, that is called regression plot, and over here I will mention x and y, two variable, and here with the help of this we are going to pass a number of arguments to this method, and over here I am going to specify sns.regplot. Regplot is the method inside the Cbon, and here I am setting that whatever I will pass as an x, that will be set as x-axis, and for y I am going to mention the y, and then over here I will tell that x equal to plot.xtick. You remember that how we can specify the xtick? I have already covered this in our one of the earlier session where we have discussed about the data visualization. So over here I am going to mention rotation equal to 90 so that it will be printed vertically. Here I am going to mention that I want to print all the variable in a single figure. For that I am going to write the code like this: f equal to pd.melt, and over here I will specify the data frame and id vars. Here I am going to mention the target variable, that is our sale price. If you remember, we are having a sell price, so we need to mention over here sell price. Then we need to specify the value underscore var, and over here I need to specify the numerical feature which we have created. If you go there, then you will find that we have created the numerical column. Copy this one and you should specify over here. Once specify that, then we are done with this line. Next we need to create the facet grid so that each plot will be drawn in the same figure. So here I need to tell that sns.facet grid, and over here we will pass this f which we have created over here for each of the variable, where we have specified id var as a sales price, that is our target value, and value vars is the numerical features and where we are reshaping it. And over here we need to specify call equal to, and I will tell that variable, and over here I need to specify call wrap. This is another parameter. I want three columns, and over here I will specify share x false. Then we have to specify share y equal to false, and size I want to keep 5. Once it is being done, then let's plot it. So over here, whatever the things which we have created over here, g, we need to pass it to the function which we have created over here. So let's write it. I'm telling that z equal to z dot map, and over here I need to specify the function which we have created over here, reg plot double quotes value comma sale price, then enter and write plot dot show. That's it. Once it is being done, do shift enter, and once it is being executed, then you will find that the scatter plot is being drawn against each of the variables, and over here you will find that variable year built is having relationship with the sales price. So this way you can identify the relationship between one variable, continuous variable, with other continuous variable. In this case we are comparing sales price with the continuous variables, all the continuous variables. If you look into this, the greater living area, so over here you will see that greater living area is having a strong relationship with the sell price. If the size of the house is getting increased, the price is also getting increased. With the help of this example you can identify that. Check other example as well. This garage year built is also having some relationship. So this way you can easily identify that how two continuous variable is related with each other. In our example, this greater living area is affecting the sell price. If it is getting increased, the size of the house is getting increased, the price is also getting increased. So it is clearly we are seeing it over here. So this variable we will definitely keep for further processing, that is part of the predictive analytics. So this is how you can do the continuous versus continuous relationship bivariate analysis. So guys, this is one of the way by which you can perform the bivariate data analysis on continuous versus continuous. Now let's look into another way, that is to identify the correlation values on each of the numerical feature compared to each other, and then we will plot it on heat map. So how we can do that? Let's look into this. So we need to calculate the correlation. So how we will calculate? There is a method available within the pandas library, and over here we need to specify the data frame. For data frame we are going to specify df, this is our data frame, and here we need to specify core. So this will return the correlation data frame. If we will run this core, then you will find that it has generated this correlation data frame where each of the numerical variable is compared with each other, and then the formula which I have shown you earlier, it is calculated on the basis of that formula, and you will find that some of the value is negatively correlated and some of the value is positively correlated, and this is the formula which is being applied to identify the correlation between two continuous variable, and this data frame holds the same. Now once we understand that, but it is not very much intuitive to understand which variable is strongly correlated and which variable is having no correlation. So how we will identify that? So we will plot this data frame on heat map, and with the help of color code we will identify that whether it is positively correlated or it is negatively correlated or there is no relation at all. So I am hoping that you are having the understanding about what actually the correlation is. Correlation means relationship between two variables that is of continuous type. If there is a change in x value, then y value is also gets affected. If such behavior is there, then that means it is strongly correlated. And how we are identifying the strength of that relationship or say correlation? With the help of that formula which is being applied, and on the basis of that formula these correlation is being calculated. Anyway, let's proceed further and let's draw the heat map. So for that I am going to create figure and the axis, and over here I will tell that plot subplots, and over here I will specify figure size. We can use 16:10, and then here I will tell that sns.heatmap, and over here I will specify the data frame core, and vmax there is one parameter which we need to specify .8, and then we need to tell a square equal to true, and then we will tell plot.show. Once done, do shift enter, then you will find that we got the heat map. If you look into this, then you will find that the strength of the relationship between two continuous variable is represented with the color code. Wherever you are having positive relationship, then you will find that the color code should be orange. For example, we are having very strong relationship between sale price, and over here you will find second floor SF, and you will check that the color is orange, and orange color over here represented that it has the relationship with positive correlation, and wherever we are having negative correlation, then you will find that the color is getting more darker. So this is another way of performing the bivariate analysis, where you can perform bivariate analysis in one shot, and you can easily identify that which of the variable is strongly correlated with the sell price, that is our target variable, and that variable you can keep it for further processing when you are going to design the predictive model, and that discussion is out of scope for this course. So guys, let's proceed further and let's do the bivariate analysis on categorical versus continuous variable. So guys, as I mentioned that perform the categorical versus continuous variable bivariate analysis, we have to draw the box plot. So let's draw it. We will select all the categorical variable and we will draw the plot against box plot against sales price. So let's do it. So to draw the box plot, I am going to leverage the same code which we have created over here, and we will do the modification within the code as it is 80% similar. So let's copy it and paste it over here, and over here instead of rect plot I am going to tell that I want box plot, and instead of regression plot I am telling over here box plot I want to draw. Remaining thing is going to be the same. This one is also going to be the same. The difference over here, instead of numeric column I am going to select the categorical column, and if you remember we have already selected the categorical column. So we need to come here and we need to select this categorical call index, and this one we need to specify over here. Once it is being done, the next thing we need to change is the, instead of rect plot I will call box plot. That's it. Now let's run it. Do shift enter. We got a typo. Instead of box we need to specify over here it should be box plot. Now run it, shift enter, and then you will find that it has plotted the box plot against sales price. So with the help of this plot you can easily identify that in each of the categorical variable how many groups exist. For example, MS zoning we are having 1, 2, 3, 4, 5 groups, and which has more value? This RL, and it contains some of the outliers also. Over here in the street you will find that PAVE is having highest frequency and it contains some outliers as well. Same is the case with LI. it contains the similar distribution. Gravel is also having the similar distribution, but it contains some of the outliers, and for pave also it has contains some outliers. Now if you will look into utilities, then you will find that most of the value falls into all pub, and there is no value for no seva, or say single value for no seva. So this way you can do the bivariate analysis on continuous versus categorical variable, or say categorical versus continuous variable, to perform the bivariate analysis. And this is what I wanted to demonstrate you in this session. So in this session we have understand that how to do bivariate analysis. So on this note I am stopping over here. In the next session we are going to discuss about how to check for missing values, and we will also learn about how to handle missing value. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to discuss about missing values treatment. So in this aspect we are going to analyze that how to identify the missing values within the given data set. Once we finish the missing value identification, then our next step would be handling the missing values. Handling of the missing value, which I have already covered in one of the session in pandas part. That session was more of pandas aspect, where I have shown various approach to handle the missing values. In this session we are going to cover the same thing, but that is more specific to the problem and how it is going to fit into the exploratory data analysis, and why it is important, we will discuss that. So let's jump into the Jupyter Notebook where we will perform the missing value analysis. So we are into the Jupyter Notebook where we will perform the missing value analysis, and this is the same Jupyter Notebook which we are following to understand our exploratory data analysis workflow. So guys, to perform the missing value analysis we can perform with the help of two ways. The first way is the visualization way, where we can identify that which of the variable is having missing values on the plot, and there is another way by which we can identify the missing value on the basis of maths, where we will calculate that how much percentage of missing information each of the variable contains. Once we identify that, then we will proceed further and we will handle the missing value as per their missing percentage. So let's start writing the code. So the first step, we need to import some library for performing the exercise. So over here, the first thing I am going to do, I need to install an Anaconda library that is called missing number, and with the help of that library I am going to plot the data visualization for the missing number. So let's look into that. So the first step, we need to visit the Conda site to get the detail about the package, how to install it. So let's go to the Anaconda site. So this is the Anaconda site, and you will see that we are having a library missing number, and we need to take this command and we need to execute this command into the Anaconda console. So let's jump into the Anaconda console, and where we will run this to install this library. So we are into the Anaconda library, and over here I will paste the command which I have copied and do enter. So it will install this missing number library. So once you execute it, it will ask for your consent. You need to specify Y over here and then enter, so that it will start the installation. So once installation is being completed, then we will proceed further and import this package, or say library, in our program. So now we are into the Jupyter Notebook. We will go to top and import the library which we have installed now. Let's go there, and over here we need to specify import missing number as MSNO. Shift enter, so that we will load the library. Now the next step, we need to visualize the missing number. So how we can do that? So there is a method available within the missing number library that is called metrics, where we can pass the data frame and it will visualize the missing number. So how we will do this? So let's write MSNO dot, and over here we need to specify metrics, and within that we need to specify the data frame. So we need to pass the complete data frame which we have created over here, if you remember, and this is the data frame. Once it is being done, do shift enter. Now we got the plot, and this plot is the representation of the data frame, where it has plotted all the rows as well as all the columns, and wherever we are having the data, you will see that black vertical bar, and wherever we are not having the data, you will see the white spaces. So this way you can get the overall picture of your data frame, and you come to know that there is some missing value and some of the variable is having many missing values, but we don't know which are those columns and what is the percentage of the missing value. So to get the answer of these questions, we have to proceed further and design a method that will help us to identify the percentage of the missing information for each of the variable. And this is our second approach by which we can identify the missing values. So let's start writing the code. So I am going to create a function called missing value scanner, and over here I will tell that it will accept a data frame as a parameter, and then I will start writing the code. So over here I need to specify total. I want to get the total, and I want to calculate the missing value on each of the variables. How I can do that? I need to specify data frame df dot, and I will tell that is null. This we have already seen in one of our session, and over here I will tell sum, and then I will tell that sort the value, and we need to specify the order. So over here I am going to tell that ascending equal to false. That means it should be printed in a descending order. Now the next thing, I need to specify the filter criteria by which we can filter out all those variable which is not having null value. So how we can do that? So let's look into that. So to filter those variable, I need to specify the square bracket over here. Once we have specified the square bracket, copy the same line of code over here and paste it over here, because the condition is going to be the same, but here I am going to filter out all the variable which is not having the null value. So I will specify not equal to 0. So it will filter out those variables which doesn't contain any kind of null value. Once it is being done, let's proceed further and calculate the percentage. So how we will calculate the percentage? We need to create another variable called percent, and over here we need to specify the formula for the percentage calculation, which is based upon this thing only. So I will tell that round, and over here I will specify the same thing. I will take all these values. So better we can keep this thing into a variable, and that variable we will use it. So cut it from here. I am going to create over here that sorted null value, and over here I will specify the same thing. Now I will take this variable and I will put it over here, and instead of this I am going to cut this one and I will paste it over here. Next, to calculate the percentage, I am going to perform the same thing. Now to calculate the percentage, I am going to use the same formula which contains this. I will tell over here len, and then I will specify I want to calculate the length of the data frame multiplied by 100, and I want to display the 2-digit decimal number. Once it is being done, I want to filter out whichever the variable is not having null. It will not be considered over here. So copy the same thing. It is going to contain the same thing but with the filter condition. So you will specify the same formula, and this time you need to specify not equal to 0, so that it will filter out the variable which is not having null value. Once it is being done, we can merge it and we will create the another data frame which will contain both the total and percent. So over here you should specify return pd.concat, and over here you need to specify total comma percent, and on the basis of axis 1 I want to concatenate, and over here I will tell key is equal to total comma percent. Make sure that you are using quotes over here, percent. Let's proceed further and call this function to check the missing values within the data frame. Do enter over here, and let's call this function missing underscore value underscore scanner, and I want to check the missing value within this data frame. So let's run it. Shift enter. We got an error over here, that is because of typo, so let's correct it. It should be values. Now do shift enter. So over here you will find that total number of missing values along with the percentage, and over here on top of the table we are having pool QC. Next is the miscellaneous feature, then LA coming next. Hence we are having fourth in the table. So guys, now we understand that how to get the information about the missing data. So what's next? So to handle this missing value, we will proceed further and we will handle the missing data so that our data set will be ready for further analysis. Our data set is available for further processing, that is, it should be used within the predictive analysis. But prior to proceeding further, we have to analyze each of the variable one by one. So over here you will find that some of the value, or say some of the variables, is intentionally left blank because that thing doesn't exist within some of the houses. For example, if you take this example LA, some of the house has LA and some of the house doesn't have LA. Same is the case with pool QC. Some of the house has pool, some of the house doesn't have pool, and most of the houses doesn't have pool. So that's the reason these number of null value we are having. So we can go directly and specify the none value in those kind of column. I have already listed out what are those columns in an array, and then we can fill with the none value. So how we can do that? Let's look into that. So guys, these are the features which exist in some of the houses, and some of the houses it doesn't have. So wherever we are not having this feature and whichever record which is having a null value, I am going to specify none over there. So once we have identified those features, in the next step we need to fill the value with none value. So how we can do that? We need to tell that for I in missing underscore val underscore column. So these are the column, these are the variables, and over here I will specify data frame I variable, and each time one of the variable gets picked up, and then over here it is being set with the none. So I will specify df I over here, and then I will tell that fill na, and then I will specify none. Once it is being done, then all the values wherever null we are having for these features or for these variables, so it will be put with none. Now let's run it. Shift enter. We are done with this step. Now over here, whatever we have handled, that is a categorical variable, and that then we have mentioned none. Within the data set, we are having some of the variables which is of numerical type and need to specify 0 instead of null. So how we can do that? Let's look into that. So these are the features which we are having. These are the columns, or say these are the variables we are having which is of numerical type. So to handle null value in such of the column, we will fill with 0. So I'm going to copy the same line, and over here I will specify this, and make sure that you are specifying the variable name call2, and over here instead of none we are going to specify 0. Once done, let's do shift enter. Now let's proceed further. Once we handle these number of variables, the next variable which we are going to handle is lot frontage. So there is a variable called lot frontage. If you will see it over here, lot frontage contains 259 null value and lot frontage variable based upon the neighborhood. So we will be handling the null value for lot frontage on the basis of the neighborhood area, and we will fill the mean value to the missing value of lot frontage variable. So let's do it. So over here I will specify data frame, and I will select the lot frontage, and then over here I will group by the data frame on the basis of neighborhood, and I will tell over here neighborhood. So neighborhood is one of the variable within the data frame, and over here I will specify lot frontage, and then I will apply the mean. How I can apply the mean to each of the null value? With the help of transform method. So I will tell transform, and within that I will specify the lambda function. Lambda is an anonymous function which we can create on a fly. So here I will specify lambda, and then I will specify x, and then I will tell x dot fill na, and I want to specify the mean value to each of the missing data, and over here make sure that it is a method, so we are calling this mean method. Once done, do the shift enter. So far we have handled many of the variable where we were having the null value. Now let's run again this method, so that we will check that how many other variable remain to handle. So let's do it. Control V. Let's run this again, shift enter. Then you will find that we remain with the one variable, that is electrical. So how we will handle this? So to handle this, first we will check that what are the values exist and which is having the highest frequency. So how we can check that? We need to specify data frame over here, and we will specify the column name electrical, and over here we will need to tell value underscore counts. So this will give us the count of all those values which is exist within this variable. Shift enter. We did a typo, electrical, it should be electrical. Shift enter. Then you will find that the highest value we are having is the SBRKR. So we will specify this value. So how we can specify over here? We will tell that df double quotes name of the column over here we need to specify electrical, and over here fill na. So wherever we are having null value, I am going to specify that it should be SBRKR, as it contains highest number of frequency. That's the reason we are considering that this value, it might be fall into this value only. So let's again run this. So I'm going to copy this code and I'm going to execute it again, so that I will check that whether any null value exists or not. Do shift enter. it is returning the same because we haven't assigned this value. So let it assign that. Control C, and over here Control V, and do Shift Enter again, and now again I am going to run it. Then you will see that we don't have any kind of null value exist within our data set or within our data frame. So now we are done with the handling of missing null value, and our data set is ready for further processing, and we can utilize this data set in predictive analysis. And this is what I wanted to demonstrate you in this session. In the next session we will learn about outlier detection and its treatment. That means how to handle the outliers. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to look into outlier detection and treatment. So basically we are going to perform outlier analysis, where we will understand that how to identify outlier within the given data set. And once we identify the outliers, then we need to handle those outliers. So let's jump into the lab Jupyter Notebook, and where we will perform all these exercises for outlier analysis. So we are into the Jupyter Notebook. Let's have discussion about outliers, why it is important to handle outliers, and if we will not handle it, then what will happen. So in that aspect, we will first understand what actually the outliers are. So guys, outliers are uncommon data points which exist within the data set, and because of that uncommon data points, it will affect your analysis completely. So what it means, let's understand with an example. So guys, to understand the outliers, you have to look into this table. Over here we are having the name of the person and their height, and over here I want to know the average height of the person within this group. As this is a small group, you can directly calculate the average, but that average value is not correct because we are having two outliers value over here. Two-person height over here is 7 and 7.5, and if you will perform the sample analysis on this, then you will find that the average value is 7.25. That is not correct. So that means our analysis is going to affect if you are taking the outlier points. So how we can handle this, that we will see into the Jupyter Notebook. So this is about the understanding of the outliers, what actually the outliers is. So outliers is a data point which is having uncommon value compared to the other values. Over here we are having an example of height. Every person is having height in the range of 5 and 5.5, but two person is having the height of 7.5. So that is the outlier within this particular data set. So now let's proceed further and let's look into the Jupyter Notebook, how to identify outliers within our given data set. So to identify the outliers, we have already drawn some of the plots. Over here, if you will come, then you will find that we have drawn this scatter plot. And if you closely look into this, then you will find that some of the point is deviated from the common data point. For example, if you take this example, greater living area, where we are having two data points whose values is more than 4000, and there are two data points which falls into this category. So if we will use these data point in our predictive analysis, then it will affect our predictive model, and that will affect the forecasting. So we must have to handle this outlier prior to sending it for further processing, that is predictive analysis. And within the predictive analysis, we are basically using this variable for training our model, and that discussion is out of scope from this course. That we will discuss later. Over here we are going to discuss about how to handle this outlier. So to handle this outlier, we are going to remove these two outliers from our this variable, that is grlib area. So how we can do this, let's look into that. So we will come over here and we will remove those 2 points which is greater than 4000. So how we will do that, we will tell data frame equal to, and over here data frame, and I am going to tell that data frame, and I will select greater live area. So this is our column name, is less than 4000. So select all those records whose greater living area is less than 4000 and left those records whose greater living area value is greater than 4000. Now let's run it, shift enter. So let's confirm it whether it has selected those record or not. So how we will confirm that, we are going to draw the plot again, and we will see that whether any data point exists greater than 4000. So how we will do that, I am going to specify SNS, that is C1 library. Again I am going to draw the reg plot, that is for regression plot, and over here I will specify the x point, and x point is our this variable name greater live area, and the y point I am going to draw it against the sell price, that is our target variable. So I will specify over here sell price, and the data is going to be the data frame. Once it is being done, let's draw it. Plot.show. Let's run it, shift enter, and you will see it over here. All the data point is falling within the range of 4000. So that means with the help of this step, we are able to remove the outliers. So this way you can handle the outliers. Whenever you are getting the outliers, you must have to remove it from the data set if the outlier count is less. And this is what I wanted to demonstrate you in this session. In the next session, we are going to discuss about variable transformation, what actually it is and why to do it. And we will also learn about how to do variable transformation. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now in this session we are going to discuss about variable transformation. So in that aspect we are going to discuss about what actually the variable transformation is and why it is required, and we will also learn about how to do variable transformation. So let's jump into the Jupyter Notebook where we are doing the lab. So guys, what is variable transformation? So when we perform the data analysis, at that time sometime we require to transform our variable so that it will be used by predictive models. So what it means, let's understand with an example. If you look into our earlier plot which we have drawn over here, we have drawn this plot, if you remember. So over here this is the distribution plot which we have drawn with the help of sns.distplot. This is actually the representation of the distribution of the variables, and where you will find that most of the variable is skewed, that is at the left side, that is a positive skewed. So what it means? It means that the mean and the median will be greater than the mode. So you must be asking that, can you be specific to this particular example? If I'm taking this example where we are having the variable that is greater living area, which is written as GR live area, to read this plot, then this plot means the houses which is having near to the range of 1800 square feet, that is being sold more compared to the others. So guys, this skewed data is very problematic if we are using it in a regression model. As our regression model will be trained on such kind of skewed data, then it will give the biased result. So every time it predict that whichever house will be sold, and that is going to be falling into 1800 square feet range, and on the basis of that it will forecast the wrong price. Same is the case with other skewed value. Over here if you will see that the first floor SF, this is also skewed data, and this kind of skewed data brings us biasness within the model, and that becomes very problematic if we are training our predictive model on biased data. We will get wrong forecasting from the predictive model. So here the question is, what is the solution for this? So the answer is variable transformation. So here we need to do some transformation to these variable, and then we need to send these variable for further processing. Now let's proceed further and fix this skewness with the help of variable transformation. But prior to doing that, let's understand, with the help of visual representation we come to know that this data is skewed, or this variable is skewed. But how do you come to know that our variable is skewed without the visual representation? Then to answer your question, there is a formula available. On the basis of that, you can calculate the skewness within the variable, and the formula is this one, where mean minus median multiplied by 3 divided by standard deviation. On the basis of this formula, if we are getting 0, so that means our data is normally distributed and there is no skewness. And apart from that, if we are getting the result with positive value, so that means it is positively skewed, and if we are getting the result in negative value, then that means it is negatively skewed. So you must be thinking that you need to apply this formula by creating some custom function. Then the good news is that we are having a package called SciPy which contains a stats module, and that module contains the skew method that we are going to use to do the calculation to identify the skewness within the variable, and that is our next exercise prior to variable transformation. So let's jump into the Jupyter Notebook. So guys, you must have understand that in what scenario we can apply the variable transformation. Yes, you are absolutely right. Whenever we are having the skewness within our variable, on that time we can apply the variable transformation. Now the next question is, how do we can identify that we are having the skewness within our data? I have shown you the formula, and now I am going to create a function which will identify the skewness within the data or within the variable, and if there is any skewness within the variable, it will transform it. But prior to writing this function, I want to discuss about what kind of transformation we can perform. If I talk about variable transformation, in one of the earlier session, I have discussed about log transformation. That also help us to remove the skewness from the variable. But over here, I am going to discuss about some other kind of a transformation that is called box-Cox transformation. That is one of the standard mechanism to do the variable transformation. If you want to learn about box-Cox transformation, I would suggest that you should visit this site to get some theoretical aspect of the box-Cox transformation. So this site you can use it, that is statistichowto.com, where it has explained all the theoretical thing about the box-Cox transformation. But in a simple term, I can tell that with the help of this transformation mechanism, we can transform our skewed variable to the normally distributed variable. And the math which is working behind the scene for this particular transformation is this one. One good news is that to perform this box-Cox transformation, we don't need to write the custom function, as we are going to use the SciPy library, and there is a module called a stats module that will offer us functions to perform the box-Cox transformation. So let's jump into the Jupyter Notebook to start writing the code. So the first step is I'm going to import some of the module from the SciPy. So over here I will specify from scipy.stats import skew. The next thing I need to import the functions for box-Cox transformation. So first I will import scipy.special import box-Cox 1p. Next, there is another function I am going to import, that is scipy.stats import box-Cox underscore normmax. These two methods we are going to use for box-Cox transformation. Now we are done with the first step where we have imported the required library. Next we will proceed further and write the custom function. So the function which I am going to write it over here, that will perform two things. The first thing, it will identify the skewness within the variable, and if there is any skewness, then it will fix the skewness with the help of box-Cox transformation. So let's write it. Here we will tell that def fix underscore skewness, and this will accept the data frame. Now we have defined the function. Now what we will write it over here. So over here we will write the code to select the numeric feature, or say numerical variable, which has the skewness. So let's write it. So over here I will create a variable called skewed underscore feat. This will store the skewed feature, and over here I will tell data frame, and I will select the numerical feature. Where do I get the numerical feature, selected numerical feature? If you remember, we have already created in one of the exercise, and if you come over here, we have already performed this exercise and we have selected the numerical variable that is stored within the numeric call. So let's use this one, and over here I will specify this numerical call. Now next I need to select those variable which is having skewness. So how I can select that? I need to write a apply method where I need to pass the lambda function, and over here I will tell lambda, this is an anonymous function, and here I will check for the skewness, and I will tell skew, this is the function within the stats model, and over here I will tell x, and then I will tell sort underscore values. It should be ascending equal to false, so that it will display in descending. So this line of code will give us all the skewed variable, but we want to select those feature which is greater than 0.5. So how we can do that? So let's look into that. That is, I am calling it as a high skewed variable, and we are going to store those feature in this variable, and I will tell skewed underscore fit, and over here I will specify the absolute value, and over here I will tell skewed underscore fit, and that is greater than 0.5. So this will return all the variables which is having skewness more than 0.5. Once it is being done, we need to get the index of those variable. So how we will get that? So we need to write over here skewed underscore features equal to high underscore skew dot index. So this will give me the name of all those variables which is having more than 0.5 skewness. So guys, we got all the skewed feature which is more than 0.5. So now let's fix it with the box-Cox transformation. So how we will do that? We need to tell for fit in skewed underscore features, and over here we need to write the code like this. Df, the feature we are selecting over here, it is iterating each of the feature, and over here we will tell box-Cox 1p and the data frame, and over here I need to pass the variable, and over here I will tell box-Cox underscore norm max, and within that I'm going to specify df feature plus 1. So this will transform our variable and make it normally distributed. So let's execute it. Shift enter. Now let me draw the plot without fixing the skewness so that you will get the difference. So over here I will specify SNS dist plot. I'm going to draw one of the variable, and over here I'm going to choose df. Let's check one variable over here. So I'm going to use, we will look it over here, this one, first floor sf. So let's take this example. Let's draw it separately, and over here I will specify first floor SF. Now let's run it, shift enter. Then you will find that it is having skewness. So now let's perform the transformation, and I'm going to use this fix skewness method over here, and I'm going to pass the entire data frame so that it will fix the skewness in each of the numerical data type. Do shift enter. We got error, we have some typo. Make sure that it should be features. Now do shift enter. We have another typo as well. It should be norm max, so it should be norm max. Sorry guys, sorry for that. Now let's select this one, shift enter. Now let's run this as well. So it is executing. We got some warning, but let's look into the plot whether it has resolved the skewness issue or not with the help of this transformation, box-cox transformation. So let's copy this line of code and paste it over here, run it again, shift enter, and then you will find that it has fixed our skewness issue and everything is normally distributed over here. Let's check other variable as well over here. If you will look into that, then you will find that we are having greater living area is also skewed. So take this variable and come it over here and copy this line and try to plot that as well. So let's write it over here. You will tell that great live area. Now let's plot it, shift enter. Then you will find that this also being transformed with the help of box-cox transformation, and with the help of that we have removed the skewness. And this is what I wanted to demonstrate you in this session. In the next session we are going to discuss about variable creation, and that is the last step in the workflow of the data exploration and the preparation. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care. Hello guys, welcome back. Now we are into the last step of the data exploration and data preparation workflow. So this step basically belongs to the data preparation step, as within this step we generally create the variable on the basis of the existing variables, and these newly created variable is being used within the predictive model for their training purpose. So guys, in this session we are going to learn about variable creation, what actually it is, why we create variables, and we will also look into the example how do we create a variables. So let's jump into the Jupyter Notebook where we are doing the lab. So guys, let's start our discussion with what actually the variable creation is. So guys, to understand the variable creation we must have to understand what will happen once we finish our data exploration as well as data preparation. What will happen next? So to understand that, let's jump into a diagram. What will happen next? So guys, once we collected the information and then we have performed the descriptive analysis and we have identified all those variables, which is very useful for next step, that is the predictive analytics, where we will design some system with the help of some of the modeling technique. It might be the stat modeling, it might be the probabilistic model, it might be the machine learning models, and with the help of these models we can design the system that will perform two tasks. Either it will perform the regression task or it will perform classification task. In our project example which we are doing, that is for regression task, where we are in a process to design a system which will forecast the sale price of a house. So in that aspect we are now learning to analyze the existing data and existing variable, or say existing feature, with the help of exploratory data analysis, as well as we are also learning the technique to create new variables, and those variable is being used within the predictive model so that it will forecast the accurate sell price of a house. So guys, to build the robust system, sometime we require to create variables that doesn't exist within the problem domain, but somewhere within the given variable it is giving those information which will help us to design a robust predictive model that will help us to do the prediction very accurately. So here we got the definition of variable creation. So variable creation is a process to create new features, or say to create new variables for predictive models, so that predictive model can forecast the future state of the problem domain more accurately. Now with the help of this definition we also get the answer for Why do we need variable creation? It is because we want to design a robust predictive model that will forecast our future state of the problem domain more accurately. Now let's jump into the Jupyter Notebook and we will do some example to understand how to create new feature or say new variables. So guys, in our problem domain we are having many variables, so let's look into that. So it is in the form of columns. So let's write it, and here I will tell to list. Shift enter, then you will get that we are getting all the variables or say or features in a list. So guys, these features are deciding factor of the sale price of a house, and there are certain features. If you will look into that, then you will find that there are certain features like pool area, pool QC is also deciding factor in the price. If some house is having pool area, so that means that house is having high price. So here we can design a new variable that will check whether our house is having pool area or not. Same way, if our house is having garage area, that means the price of the house is also high. So we can also check that whether our house is having garage or not. So this feature we can also create, or say this variable we can also create has garage. We can also check for other variable where we have a scope to create new variables with it. So over here you will see that we are having second floor. So suppose if our house is having second floor, so the price of the house is also very high if it contains second floor. So we can create another variable has second floor, and that will contain 1 or 0. If it contains second floor, that means the value should be 1, and if it contains 0, so that means the value should be 0, or it is representing true and false. So now we have analyzed our variable. So let's create new variable with the help of information which we have gathered. So over here I am going to tell data frame I want to create new variable. I will call it as has pool, and over here I will specify df, and from which column I want to create. I want to create through the pool area, and over here I am going to apply a lambda function that will perform the check whether our house is having pool area or not. So I will tell lambda x is to 1 if x is greater than 0, else 0. Now copy this line of code and paste it 3 times as we have decided upon to create 3 variable. One is for garage, so I am going to tell that as garage, and it is based on garage area. So if you will remember over here we are having a garage area, copy this one and paste it over here, and the lambda function is going to remain same. Another variable I want to check that whether it contains second floor or not. Copy this one, come over here and write as second floor, and over here we will specify control V, and remaining thing is going to be the same. Now let's run it, shift enter. So it has returned some warning, but let's look into the columns, and if you will look into the column which is being created, we need to write the name of these column has pool, and over here I'm going to select this column. I will specify has pool, select the another one has garage, so that we will check that what it contains, what values it contains, and over here the second floor, and specify over here to shift enter, and you will find that it has created 3 new columns with this name, and that contains 0 and 1. That is representing whether the house contains pool or not, or garage or not, or whether the house is having second floor or not. So this will also be used as a deciding factor of sale price, and that will be used by predictive model. And how it is being used we will discuss in another course, that is predictive analysis. When we discuss about the predictive analysis, on that time we will discuss about how predictive model is being trained on the basis of these variables, and this is what I wanted to demonstrate you in this session. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care.
Hello guys, welcome back to the last session of this course. In this session, we are mainly going to discuss about what we actually going to do in the upcoming course. So let's understand it. So guys, we are working on a data science project, and the data science project contains majorly these steps. If you closely look into this diagram, then you will find that step 1 to step 3, what we have performed till now, where we have done the exploratory data analysis, as well as we have also understand the methods to prepare our data for next step. Now in the next course we are going to look into various algorithms for designing the predictive model, and where we will use the data which we have prepared in this course. So in the next course we are going to learn about various machine learning algorithms that will help us to design the predictive model.
In that aspect, we will start our journey for the next course with the topic machine learning algorithm overview, where we will discuss about background of the machine learning algorithms. Then we will learn about how many types of different kind of machine learning algorithm we are having. Once we understand that, then we will discuss about what our linear machine learning algorithms are and what kind of problem it helps us to solve that. Once we understand that, then we will proceed further and we will discuss about non-linear machine learning algorithms, and we will also discuss about what kind of problem non-linear machine learning algorithm will solve. And at last, we will discuss about ensemble machine learning algorithm and how to design an ensemble machine learning algorithm for predictive models. So on this note, I am stopping over here. See you in the next course where we will discuss about all these machine learning algorithms. So till then, bye bye, take care.